Great news. One more JavaScript section of pure, plain old JavaScript before we get to the more exciting stuff. We'll be reunited with our old pals, HTML and CSS. In the next section, we're actually going to combine all three and start to talk about something called the DOM. But we've got this section ahead of us first. This section will hopefully be relatively quick. It's just a collection of modern, newer syntax improvements to JavaScript. So these are useful, absolutely, and it's important you understand them because you'll see people using them. And if you don't know what they are, they might just look, well, they definitely will look like complete gibberish and be very confusing. But also understanding them can just make your life a lot better as you write code, at least your developer life. So let's see, what do we have? Lots of green. Nothing that takes a ton of time for you to master. But I still want to rank what really matters here. So default params, I'll say that's important. It's somewhere between important and crucial. Spread in function calls is important. Spread in arrays is crucial. Spread with objects is crucial. REST params, I'll put that in important. And destructuring, I'll put in crucial. Once again, this is the problem of doing these videos at the beginning. These terms may probably make no sense at all. Destructuring and REST and spread, it doesn't really sound like much, but you can revisit this at any point in time. I didn't make anything yellow or red because nothing is terribly crazy. They're just nice syntax improvements to help us do things that we can already do. So take some time to go through this, relax. We've made it through the really tough parts of JavaScript, the array methods, the higher order functions, the keyword this, scope. That stuff can be a little bit like walking through thorny bushes, I guess, and getting cut everywhere and bleeding out and dying. This section should be a lot smoother. All right, so don't try and be a master of all of this. Prioritize the stuff on the left, spread and destructuring. Here we go, one more section, and then on to the DOM. So the first of these newer features we'll look at is default params or default parameters. Often when we write a function, we'll have some parameter, and it may be optional. If a user passes it in, we'll use it, and if they don't, we'd like to give it a default value. For example, let's go back to this good old function we've written a couple of times, roll a die. And let's say that this roll die function accepts a number of sides. So we'll call that num sides. Are we rolling a 6-sided die, a 10-sided, a 20-sided, or whatever number of sides for our die? And we want to return our good old friend here, math.floor of math.random times the number of sides, and then +1 to shift that. So if I pass in num sides of 6, let's just verify over here. Roll die, I'll pass in 6. We should get a number from 1 to 6, and we do. Now if I try that instead with 20, we should get a number between 1 and 20, and it looks like that's working as well. But let's say that I want to allow a user to just default num sides if they don't pass it in. I want it to be 6, because that's the most commonly sized or most common sized die. So if I try that right now, if I don't pass it in, we get our good friend, equally good friend, not a number. And that makes sense because it's undefined. And that means we'd be using undefined here and multiplying math.random by undefined. That always gives us not a number. So that's not good. So in the past, before this syntax improvement I'm about to show you, this is what we would do. We would check to see if a parameter was undefined. So something like right here. So this is a one-line way of doing it. So you do something like this. If num sides equals undefined, then num sides equals 6. So let's try that now. Roll die, you don't pass in parentheses. You don't pass in a number. It defaults to 6. But if you do pass something in, like 20, you can see that it's working. It's not just defaulting to 6 anymore. So this was the old way of doing things, and it's kind of annoying. It's not ideal, especially if you have more than one parameter that's optional. Now, the new way of doing it is using this syntax improvement where we add an equal sign and a default value directly in our parameter list. So in this example, multiply, A has no default value. A will be whatever you pass in as the first argument. B does have a default value. If you leave it off, it will default to 1. So we could rewrite this function right here like this. Roll die, num sides, if you leave it off, equals 6. And that's it. This is easier to read, right? And it's just more compact. It's a nicer alternative. Let's verify. You pass in 20, we get our larger range, 20-sided die. If you pass in nothing, we go from 1 to 6, our 6-sided die. So we can write multiple default params, but one thing you need to watch out for is the order. So if I wrote a very trivial, stupid, honestly, silly, dumb, ridiculous function like greet, and greet is expecting a message that you'll pass in and a person, and it's going to return something very simple like the message, comma, the person's name, and then an exclamation point. So I would call it like this. And actually, instead of returning, let's just print. Okay, so we print that out, and I call greet. I pass in a message like hello. I don't know why I'm doing all caps. And then a person's name. How about Joaquin? Okay. And we get hello, Joaquin, with an exclamation point. Or if I do someone else's name or some other greeting, like up top, big guy. There we go, up top, big guy, Joaquin. All right, let's say I want to make message have a default value. So I want message, if you don't pass one in, just to default to, hey there, just like that, okay? Let's see what happens. So I try calling greet, and I pass in both hello and Joaquin. That works. But what if I just pass in Joaquin? Well, hopefully you can see what the issue is here. JavaScript isn't smart enough to know that this is a person's name and that it should use the default for message. It's going off of the order, and that's it. So this is the first thing we passed in. It's going to be applied to that first parameter here, message. And then person is undefined. So the order matters, and you cannot, I guess technically you can have a default parameter at the beginning before other parameters that don't have a default value, but it's just not going to work. So you should always have your default parameters come second or third or whatever it is. They need to come after any parameters that are not default. And you can also have multiple of them. So we could have a message. Let me just verify and show you that that does work. Greet Joaquin, we get, hey there, Joaquin. But if we pass something else in after, like hi, like that, we get hi, Joaquin. Okay. Lastly, we can put something else in here like punctuation. Let's call it punk. And it will be a default of just one exclamation point. So we'll put that in right there, right after the fact. So if we try calling greets, this time with Rosa, we get, hey there, Rosa, with one exclamation point. But if I pass in a greeting like hiya and punctuation, I want a whole bunch of exclamation points. I don't know why I'm not being consistent with my quotes there. I need double quotes. You can see that we're not relying on any of the default parameters. So that's all there is to default params. Using that equal sign, it's a significant improvement over something like this. New feature, use it, it's nice. Okay. Next up, we get to spread, which is one of my favorite of the newer features in JavaScript. Unfortunately, it's a little bit hard to explain all in one go because it's actually used in multiple situations. It's kind of like a Swiss Army knife in JavaScript. So the official, well, this isn't official, but the definition from MDN at least is that spread syntax allows an iterable, such as an array, to be expanded in places where 0 or more arguments for function calls or elements for array literals are expected, or an object expression to be expanded in places where 0 or more key value pairs for object literals are expected. Did you get that? I'm sure do you even need this video anymore? I feel like that's just a great explanation. We don't even need examples. But really, it's a lot to take in. But the main thing that hopefully you can tell from this definition is the phrase expanding, or just the word expanding. That's really the key. The idea of spread, we're taking something and spreading it out. Now, what we're spreading that iterable into is where the variation comes in. So the first example we'll see is spreading an array or an iterable into a function call, into separate arguments. So let me demo this first. Over in the console, there's this function, it doesn't exist just in the console, but math.max. And max is expecting separate arguments, just values, and it's going to tell us the maximum value here. So it could take 10, 2, 50, 100 arguments. It will find the maximum. We also have math.min, which works the same way, except it shows us the minimum. So I can have, let's just do it with 3 arguments this time. The minimum is 1. So it takes as many arguments as we want, which is a bit different than most of the functions and built-in methods we've seen, where there's a very distinct, you pass this 1 argument, or maybe 2, or maybe 1 is optional. Anyway, now let's say that I have an array. And this array contains a bunch of numbers. In fact, it contains all of these numbers. So I'm going to save that here. Const nums equals that array of numbers right there. Now I want to find the maximum or the min using math.max. So if I try and pass that in, just like that, I'm going to get not a number because it doesn't know what to do. We just passed in a single array full of numbers. It's anticipating separate arguments, each one being a number. So what I can do is use the spread syntax, which is 3 dots, to spread this array into separate arguments. So that looks like this, math.max, and then instead of just nums, I'm going to do ... before. And that's the equivalent of this right here. So that entire array is going to be spread out into separate arguments. First argument, second argument, third argument. You can think of it as just removing those array brackets. So it doesn't actually change nums in any way. It's simply the act of passing it in to max, math.max. We're spreading it, we're separating it into separate arguments as that happens. So we could do the same thing for min, math.min, ... nums, and we get 1. That's the minimum value in that array. Here's another example. Console.log, we've seen, takes as many arguments as we want. I can pass them in separately with commas. I mean, this is useless and meaningless, but if I do that, they are each printed, and they're separated by a space. So if I do console.log on my entire nums array, this is what we get. The array itself is printed. But if I spread that, just like that right there, it's a slight difference, at least what we see printed out, but it's actually a very significant difference in that each element from this array is passed in as a separate argument to console.log. So they're all separated by spaces. Now I can actually do this with things that aren't arrays. There are other iterables, as we've talked about. Anything that we can iterate over with for of, like strings, I can also spread into a function call. So if I console.log this string, hello, it just prints out one thing, hello, nothing crazy. But if I spread that, 1, 2, 3, it's going to spread each individual character into a separate argument. And so we end up with this. Again, it doesn't seem all that crazy. It doesn't seem very different. We're just getting a space between each letter. But that is how console.log works. It's what happens if we had called this right here, H, comma E, comma L. I won't do the whole thing, but you can see that's where those spaces come from when we pass in separate arguments. And that's exactly what happened. This individual monolithic string was passed in as separate characters, separate individual arguments. Same thing here with the array, nums. It was passed in as separate standalone arguments. So that's one situation where we spread an iterable into a function call. Next up, we'll see some other uses for spread. Next up, we'll talk about the second piece here. Spread syntax allows an iterable, such as an array, to be expanded in places where 0 or more elements for array literals are expected. Basically, how we can spread an iterable into arrays. So what this looks like is something like this. Here I have 2 arrays, cats and dogs. Both Rusty and Wyatt, my previous dogs. Rest in peace, guys. And I want to make a third array. I'll call this pets or all pets. And I want it to contain everything from cats and everything from dogs. And imagine these are actually hundreds of elements long. So, it'd be a lot of work for me to type that out myself. The easiest thing to do is use the spread operator. There are other options, right? We've seen how we can copy pieces of an array using things like slice, but we're not going to do that here because spread allows us to spread an iterable like an array, like this cats array, into, in this case, a new array. So if we take a look at all pets, it looks just like cats, right? But they are not the same. It's a copy. So if I change one of them, all pets.push, whatever that is, all pets changes, but cats is unchanged. So we did actually copy the contents over using spread. And I can combine arrays. So I could do this, cats and dogs, just like that. And now all pets is the result of copying over everything from the cats array and everything from the dogs array. And we have now very easily combined them into a third new array. So if I change the order, just to be clear here, dogs, cats, that impacts the eventual order we get when spread finishes doing its thing. And I could also add my own stuff in there too. I could do dogs, comma, cats, comma, I don't know, let's say I have a pet turtle named Speedy. Speedy is added to the end there. I could add whatever I want in here. At the beginning, I can put some numbers. Doesn't make sense, but I can. So spread is working the same way that we saw earlier, where we're spreading an array into a function call, except we're not spreading it into a function call. We're spreading an array into another array, or we're spreading two arrays into a third. We're combining things, we're copying things. So if I just wanted a direct copy, often you'll see this, just a spread like that. If I want to combine, we do something like that, and I can add on, as we've seen. I can put other stuff in there. And remember that we're not limited to working with arrays. We have other iterables like strings. So I could take the string hello and put it in an array, just like that. Or if I wanted to, I could spread it into a new array, just like what we saw with console.log when I spread a string. Each element, or in this case, each character of the string, is spread into its own element in an array. So that's all there is to using spread in the context of an array literal. Next up, we'll talk about objects. The third and final situation where we use spread is in object literals. So instead of curly braces, and we use this to copy properties from one object into a new object. So we can combine objects, we can make a new object based upon an old one, we can copy one, we can tweak one. That's kind of the main idea here. Just like what we saw with arrays, where we can copy elements from one array into a new array, we can spread properties from an object into a new object. So as an example, I've got these two objects here, feline and canine, and they both have a family property in common. Family Felidae, family Caninae. I don't know. I never took Latin. Anyway, if I wanted to make a copy, a new object using one of these, so I'm just going to do it over here to start. I can do something like this, feline. That just makes me a copy. So a brand new object with the same properties as the original feline. But I can also add on. So I could do feline, and then actually I want to add in a property called, how about color, which will be black. Sure. And that makes me a new object with the properties from feline copied over or spread into this new object and color set to black. So we could combine the two, feline and canine, into a new object called cat dog. If you ever saw that show, animated show, Nickelodeon in the 90s or 2000s. Anyway, I want to combine feline and canine, so I'm going to do spread feline and then spread canine. So this is going to copy over properties from both, but remember there is a conflict. They both have a family property. And in that case, the order matters. So feline will be copied over first, and then canine. So when there's a conflict, canine is going to win, quote unquote, because it comes second, and it overwrites family. So if I switch that order up, and just did it this way, canine, and then feline, comma, like that, we end up with family set to Felidae. Okay. And then if I actually wrote something else in here, like family is actually set to the Steele family, then that's actually the winner because it comes last. Okay, so that's kind of the basic idea of copying objects using spread. It's just going to take the properties, the key value pairs from one, and add them into the new object. Also, sometimes I get asked about this. I can't imagine there's many situations you would need to do this, but if you try and spread an array into an object, so let's have the array 2, 4, 6, 8, and I'll try spreading that into an object, so ... What do you expect to see? What's the key and what's the value? The indices are used as the key, so at index 0 we have 2, 1 we have 4, 2 we have 6, and 3 we have 8. Same thing with strings. If I try and spread a string, well, that one sucks, but sure, we have a lot of i's. It's just the index. So not common, but it is a thing you can do. Now, what do we use this for? Why do we spread into objects? Well, a lot of the time, we'll use it when we're creating copies of an object, which is something you actually do a lot, especially if you're working with libraries and tools like React. That's a whole big topic we're not going to get into at the moment, but there are valid reasons why you copy objects a lot rather than mutating them. Another situation, though, imagine I have some data, let's say it's coming from a form, some data from a user, and I want to take that email blueman@gmail, that password, that username, tfunke, and I want to combine it into a new object with some additional information. Suppose this represents a user registering for my website. This is all a user needs to provide, but I also want to add in an ID, like their unique identifier, and maybe a isAdmin variable set to true or false, or property rather, not a variable. So I could create a copy. I could do copy everything over from data from form. That's the name of this object. And then I'm going to add an ID. Let's say it's set to that right there. isAdmin is going to be false. So these are things not coming from the form, right? This is just coming from me. And then I'm going to save this to a variable, const new user, like that. And we'll take a look at it over here, new user. And there we are. So we took the data from the form, the fake form data, and then I added on my own stuff, ID and isAdmin. So just one situation sort of to illustrate why you might want to know this, why it could be useful in the future. So that wraps up spread. There's a lot to it, but at the end of the day, it has to do with spreading one source of information into some destination, whether that's spreading arrays or iterables into function arguments, or spreading arrays or iterables into actual array literals, or spreading objects into objects. It all has to do with spreading. I guess that goes without saying. All right, next up, we're going to talk about REST. Next up, we have REST, which looks like spread because it also uses 3 dots, but it means something entirely different. So to help explain this, we need to go back and talk about something called the arguments object. Inside of every function we've written so far, we have access to this magical, it's not so magical, but this thing created for us automatically called arguments. And it kind of looks and acts like an array. It's what we call an array-like object. We can use indices to access elements out. In that sense, it works exactly like an array, except we don't have access to array methods like push and pop and reduce and all of that stuff. So what does it contain? What does it do? It automatically will hold all of the arguments passed to our function. So I can just demonstrate this very quickly. Let's just do a function called sum. And we're not going to expect any arguments. I'm just going to say, pass in whatever you want. And I'm going to console.log arguments, this arguments object. And if I refresh my page, remember how we have methods like math.min where I can pass in 1 argument or 2 or 10 or 1,000 arguments, right? There's no way to specify that we want 1, 2, or 1,000 arguments inside of the parameter list. But this arguments object is going to automatically collect all arguments. So if I call sum with nothing, we see that arguments is empty. But if I call it now with a bunch of arguments, about 34, 65, and 77, it contains all of those values in an order. So I can look at the 0th, or the first, or the second, or index of 0, index of 1 and 2 elements from arguments. But I can't actually use array methods. So it looks like an array, it acts kind of like an array, but it's not an array. So if I wanted to make this method sum, where I'm going to sum all elements together, so all arguments together, I want to be able to do sum of 3, 4, 5, or this, where I have a bunch of numbers. To do that, I need to loop over every argument and sum them together, or I could use reduce, a standard array method. So I could do return arguments.reduce, and then for each, then we have our total, and then our element, and we'll return total plus element. So hopefully that's review of reduce. The problem we run into here, this will work, except for the fact that arguments is not an array, and it doesn't have a reduce method. So if I try that, no, arguments.reduce is not a function. So if it were a regular array, it would be, but it's not. So this kind of sucks. Arguments is this thing that's created for us, but for whatever reason, which I've actually never really thought about or tried to look into, but for whatever reason, it's not an array. It acts like one in some ways, but it falls short in a lot of others. So this is where REST comes in. The REST operator, which is 3 dots, goes in our parameter list, and it's going to collect all remaining arguments and put them in an actual array. So let me show you what that looks like. Instead of this, I'm going to comment that out because this doesn't even work. I'm going to create another function called sum. And then I'm going to add a parameter in here. I'll call it nums. And if I just left it as nums, that's only going to be one parameter, right? So if I called sum and I passed in 3, nums would be 3. But if I did 3, 5, nums is still 3. 5 is just ignored. But if I use rest, 1, 2, 3 dots, I'm collecting the rest of the parameters. In this case, all values passed in will be stored inside of nums. So if I console.log nums here, and I call sum now, it is an actual real array. So it could have 1 value in it, or it could have 100 values in it, or more. Lots of 23s. There we go. That's our nums array. It's up to us to come up with that name. But what's great about this is that it's a real array. So I can now do things like, I'll just copy this. Return, but instead of arguments.reduce, I can also just name this something like nums. Arguments, we can't choose that name. It's just always arguments. Nums is just a name of a parameter I can customize at will. All right, so let's see if this works. There we go. I assume that's the correct answer. Let's just do something a little bit easier. 1, 2, and 3, and we do get 6. Okay. Now, it is called rest, so collect the rest of the values, and that does mean that we can have some named parameters that we call out first. For example, if I had a function called medal ceremony, how about race results, and we're expecting a gold medal finisher, a silver, and then just for the sake of brevity, let's just do everyone else and collect them all in their own parameter. So that will be an array, just like it was here with nums. And let's just print out, console.log gold medal goes to, and then here we'll do gold, and then we'll do the same thing here. Silver goes to silver, and then our final one will just be everyone else, and thanks to everyone else. And then we'll just print out everyone else, which will be an array. Okay, so let's try calling that. Race results. We'll say first place gold medal was, Tammy. And then silver was Todd. And then everyone else, really, it's just a list of arguments. So let's do Tina and Trevor and Travis. Lots of T names there. And there we go. Gold medal goes to Tammy. Silver goes to Todd, and thanks to everyone else, Tina, Trevor, Travis. So what we did there was called out the first 2 specifically, and then collected the rest into everyone else. So this is super useful. We can't do that with arguments. Arguments just holds everything in it. So if I tried to replicate this, I would have to call out arguments of 0, arguments of 1 to get the first 2, and then everything else would be arguments of 2 onwards. The last thing to note about arguments is that it just doesn't work inside of arrow functions at all. So that's another reason to use rest parameters. Remember, it's 3 dots. It's different than spread. We're not spreading things out. We're actually doing the opposite. We're collecting things in to a single parameter. So that's rest. Next up, destructuring. So destructuring is another new syntax improvement. It's a nice way of unpacking or extracting or singling out values from arrays or from objects. And we can unpack them, basically put them into distinct variables. So let me show you a few examples. We'll start with arrays. Imagine that I have an array like this one right here. And it has scores that, in this case, they're in order. Let's say these are pinball scores or something. And what I want to do is take that first score and maybe the second score and award them or separate them into separate variables so that we'll have something like const high score equals, and then I could do scores of 0, right? And then I could do const second high score equals scores of 1, right? And that's singling out this value and this value. And that works just fine, but there's actually a much shorter way of doing this. And that shorter syntax looks like this, using destructuring, const, and then array brackets equals scores. And then in those array brackets, I can single out, I want the first value in this array to be called, let's just go with gold and silver. That will be the second value. So let me just show you what gold looks like at this point. There's gold, 929321. Let me remind you, this is scores. So the first element was saved to gold. And then silver is a new variable that was created with that second element. Notice scores is unchanged. So we're not actually extracting something by removing it from this array. We're more just copying it over the value into its own variable. So I could continue with that. I could add bronze in there, and this would be our bronze score. So I'm making 3 variables based upon these 3 values in order. So that order matters. Here's another example. I used marathon runners. I think they're marathon, maybe they're just milers. I don't remember. It's from Wikipedia, but we have Eliud Kipchoge. No, he's definitely a marathoner. Okay. And then I'm going to butcher this name. I'm sorry. Fayisa Lalisa, and then Galen Rupp. And I did the exact same thing. Gold, silver, bronze equals race results. Now we have to have those square brackets there, the array braces, to indicate we are destructuring from an array. So we had a whole bunch more. We had like 7 values here, and I only extracted 3 into standalone variables. That doesn't really cause a problem at all, but let's say I wanted everybody else in a new array called everyone else. I can actually use ... the rest operator we've seen before, and then some variable name I'll make up, like everyone else. And now if we take a look at everyone else, it contains everybody who was not called out, who was not singled out, gold, silver, or bronze. So these 4 elements. So it's all based upon position. This will be the first value in the array. This will be the second, and this will be the third, and this, everyone else, will be everything else in the array that was not singled out. So that's how we can destructure from an array, and that is common, although what is more common is what we'll see in the next video, destructuring from objects. So next up, we'll see how we can use destructuring to extract values not from an array, but from objects. And this, in my experience, is more commonly used. It's more practical than destructuring from an array, because it's not all about order. Often we'll have some object, like here's an example object representing a user, and I need to single out or access a couple of properties frequently. Let's say that I wanted to, get first name and last name out of here. One option is just to do this, const first name equals, and then user dot first name, and then do the same thing for last name, const last name equals user dot last name, right? And that should give me first name and last name, and that's fine. But now imagine I also need to do that for email, and I need to do that for born and died. So const email, I'll stop after email, but if I had 4 or 5 different properties I wanted to single out and do something with, this gets kind of annoying. So we can destructure them using a similar syntax. So we write our let or const, and then curly brackets or curly braces, and then user. And then inside of here, we need to call out individual properties. So the order doesn't matter like it does with an array. We're simply doing it by name. So the name matters. If I want email, I need to do that. There must be a property in here called email. And I'm making a variable called email with that value. So these are equivalent. Make me a variable called email from user.email. Make me a variable called email from user under the email property. So let's verify. Refresh the page, email, and harvey@gmail.com. It works. So I could do email, first name, comma, last name, comma, city, comma, bio. And that's going to make me 1, 2, 3, 4, 5 separate variables. Here's bio. Here's email. Here's first name. Here's last name. What else did I do? City. We pulled them out, although I don't like saying we pulled them out because they're still in there. But we singled them out into their own variables. So we didn't change the original object in any way. But now we have 5 new variables based upon values in that object. So that can be really helpful. Now, sometimes there are values, or there are properties rather, that have a particular name. For example, let's say born and died. And I want to extract them or destructure them, but I also want to rename them because here my variable is going to be called exactly email, or first name or last name or city or bio. But let's say that the property, well, it is called born and died, and I instead want my variables to be called birth year and death year, I guess. Death year sounds a bit grim. I don't know what you would say instead of that, but let's just go with birth year to start. So I could extract it, born equals user, and that gives me the variable called born. But if I want to rename that, I can do this. Add a colon, and then my name, birth year. So this will make me a variable called birth year, not born, but it will be using user.born. So the born property, extract that from user into a variable called birth year. And if I refresh, there is no born variable, and there is a birth year. All right, so I could do the same thing with death. Say death, or what do we say, died. We're going to rename to death year. And there it is, birth year and death year. And the last thing I'll mention is that we can add default values. So let's say that I have another user. Here's my second user, user 2, and she has fewer properties. Her name is Stacy Gonzalez, and she doesn't have things like a died property because let's say she's still alive. And she's not a famous figure, so she doesn't have a bio. And what else? She doesn't have a password. That was just because I was lazy. I wanted to keep this shorter. So if I was to destructure from user 2, and let's say I don't know what that looks like. So I'll go with const, curly braces, equals, and I could pull out, what do we want to use here? Let's go with, I'm going to comment these out just so we don't get conflicts. I'll go with city and state. And then if I wanted to go with died, which does not exist, and I set that equal to user 2, let's see what we get. What does died equal? It's set to undefined. It just is not found in there. It's the same as if I had done this. Const, let's just make something up like silly equals user2.silly. Well, that makes me a variable. It's set to undefined because that's just not a value. It's undefined. No error. But if I want to give a default value, I can do this with an equal sign. So if she hasn't died, what should I put here? Maybe NA. And now that default value will be used. But if I did the same thing for our Harvey Milk example, and I give it a default value, NA, you'll see that that is not used. What do we call it? Death year. 1978 is used because there is a value found for died in that object, and there's not one found in user 2. So we can pull out individual properties, single them out into variables using the same name, or we can assign a new name using colon and then our new variable name, and we can assign a fallback or default value using an equal sign. So that is destructuring from objects. The last use case for destructuring we'll talk about is actually in our function parameter list. So when we're defining a function, we're writing our parameters between those parentheses, we can destructure the values that are being passed in. And this is most frequently used with objects. So here's an example. We'll come back to our movies thing in just a moment, but let's write a simple function. This function is expecting you to pass in some sort of user object. Let's just take our user objects we've been working with. So function, why don't we just go with full name? And it's expecting a user. And then we're going to print out your first name and your last name, or maybe just return first name and last name. So I could do it this way. Return, and then string template literal, right? User.first name. Was it first or first name? Okay, first name, and then a space. User.last name. That will work if I call it full name with user. Whoops. We get Harvey Milk. Okay, but I could use destructuring as we just saw. So I'm going to duplicate that and destructure those two like this. Const first name, comma, last name equals user. And then we can just return first name and last name without having to write user. So not a big improvement, right? This is shorter. But if we had a lot we were doing with first name and last name, then this might be nicer. It still should work, and it does. But if I never plan on using any of the other stuff in user, I don't need, born, died, bio, city, state, email, password. I just want the first name and last name. I can destructure on the way into the function, if that makes sense. I can do this. Function, full name. I'm expecting an object. And from that object, I want to destructure first name and last name. And then I'll just return this exact same line here. So much shorter. I don't have to bother with user at all. I don't need anything else from the object, just first name and last name. So we'll try that. And we get Harvey Milk still. It's working. Okay? So that's just a simple example, but you will see that frequently. You can also give a default value just like you would whenever we're destructuring any old object, like we saw previously, just like this. That's our default last name if we can't find one on our object that's passed in. So this is frequently used as well with array methods. Just as an example, I've got these movies, and let's say that I want to filter the movies based upon score. So just like we did earlier, I'll do something like movies.filter, and then we'll do for each movie. Let's call it movie. I want to return where the movie, movie.score is greater than, how about greater than or equal to 90. I want the higher rated movies. So let's take a look at those movies. We get those three: Amadeus, Parasite, and Alien. But another option is just to destructure score immediately on the way in. So I don't have to do movie.score. I can do this: curly braces score. And that's it. If I'm only using score, that's definitely shorter. Now this is still a one-liner. There are longer functions, and maybe in a longer function, we want title, score, and year. I want to destructure all three. Let's do an example of map. Oh, I guess I should verify and show that this does work. There we go. Same three movies. So let's use map, and I want to map each movie. So movies.map, and then I'll do my movie. And then in here, we'll return, how about some sort of string template literal in here, where we do movie.title is rated, and then movie.score, and then I'll put the year afterwards inside of parentheses, movie.year. So let's see what that looks like. There we go. We get Amadeus 1984 is rated 99. Sharknado 2013 is rated 35. So I could shorten this up by using destructuring, and this is still a pretty short function, but I could destructure those three things on the way in. So I do need parentheses when I'm destructuring in a function call, and then I'll want title, score, and year. And then I can remove movie and just refer to those three: title, year, and score. Verify, still works, and it does. So a little bit of an improvement. We don't have to reference movie all over the place. We don't have to make separate variables. We don't have to extract things ourselves. Instead, it's all done for us on the way in, thanks to these curly braces. All right? So that's destructuring parameters when they're passed into a function. Congrats, everyone. You've made it through most of our plain JavaScript content. I know it's a bit of a slog. Some people really enjoy that stuff. Other people just really want to get to this section because this is where we start to combine everything we've learned so far. HTML and CSS have been waiting in the wings patiently. Now we're going to incorporate JavaScript and start to interact and manipulate HTML elements and apply or remove styles and all that fun stuff. Now, this is also a process, right? It will take a couple of sections to fully understand how everything fits together. So be patient. This first section is chock full of lots of new information, and nothing in here is marked red. Nothing should take you a ton of time, hopefully, to get through. As always, your mileage may vary, and for some people, there will be certain topics in here that are challenging, and for others, it will be a breeze, and you know the drill. People are different. Anyway, intro to the DOM is just sort of understanding what the DOM is, how it works, what the concepts are. We'll call that crucial. A method called getElementById, another one called querySelector. Both of those are going to be marked crucial. Same thing with a property called innerHTML, another called innerText. Manipulating or changing styles with JavaScript, very important as well, or very crucial. Then we'll say manipulating attributes is important, but you don't need to freak out about it. Class list, crucial. Traversing the DOM, we'll say important. And then using JavaScript to create and remove elements, also crucial. So a lot of stuff over here on the left side in our crucial column. So take your time going through this section. Without a doubt, it's one of the densest in the entire course. Make sure you watch all the videos, but also spend some time, of course, with the exercises and just experimenting in your browser and kind of coding along with me. Experiment here. This is fun stuff, at least for me to teach, and for a lot of the students I've worked with, it's always a fun topic. So it's a lot, but hopefully you're looking forward to it. Let's get started, and I guess I need to go away. Bye-bye. Bye. All right, everyone. This is a big moment. I actually learned how to do a drum roll in my slide software just for this moment. It's a bit anticlimactic. There's no cymbal crash or anything at the end. I think I can do confetti too. There we go. So it's a big moment. We are talking about the DOM. So hopefully you're excited. If not, well, that's fine too. But maybe you just don't know what that means and why you should be excited. We've really made it to the promised land here where we're going to learn how to combine JavaScript with HTML and CSS. Instead of just doing JavaScript in isolation in a vacuum like we have been, we now will learn how to interact with HTML and CSS. So the DOM stands for Document Object Model, and that will probably make more sense in a bit. It's just well, I shouldn't say it's just, but at its core, it's a bunch of JavaScript objects that represent the web page. So if we have an H1 on our web page, an HTML element in H1, we will have a JavaScript object that is modeling, it represents that H1. And I can change that JavaScript object, and the page will update to show those changes. So it is our window, it is our access portal into the contents of a web page from JavaScript. So it's how we do things like, well, here's an example. On Google, I'm searching for silky chickens, one of the breeds of chickens that I'm raising. And we have a bunch of HTML and CSS. And then we have something like this accordion here. And there is HTML, whatever this is, a paragraph or a heading, and there's a little button. We can do that without JavaScript. But to make it hide and show, so that when I click, it expands and then collapses or disappears, that requires JavaScript. So we have some aspect of interaction, the actual click, and then we actually have the showing and hiding, the toggling of that content. So that is where we're combining HTML, CSS, and JavaScript. Here's another example, making this slider. Let's go to a slightly more complicated example. Here's a website called Trello. I made a dummy board here of just movies and TV shows. So we know how to do things like in HTML, make a button, make another button, make a text area. We can style it, we can give it rounded corners. But we don't know how to do things like when I click, I misspelled that. Let's edit that actually. Instead of Black Mirror, let's do Black Mirror. Mirror, such a weird word. Mirror, English, crazy language. Anyway, I want to click on that edit button to edit this. So with HTML, just on its own, that's not really possible. There's some JavaScript in here that's going to say when a user clicks, I want you to show this text area. And we'll edit that. I have a bunch of buttons. I can click save. So all of that requires JavaScript. I mean, even just something as simple as fading that background out or making it darker is JavaScript. We could do that with CSS, but we don't have a way of doing it only when you're clicking on here, only when you're editing. But we know how to do those styles, or you may not know exactly, but we could add an overlay or background to the body or something, and then put this in front. But that doesn't really matter. The point is that JavaScript is sort of managing the HTML and CSS. Turn this on, turn that off, show this, hide that, make this larger, make this darker, that sort of thing. So then there's more complicated events and interactions like dragging or just adding a whole new list over here. That all requires JavaScript. So very exciting stuff. The DOM, once again, stands for Document Object Model. And in the next video, we'll dive into that first bit. What is the document? And then we'll go from there. Okay, so the Document Object Model, or DOM for short. As we previously said, it's our window into a web page or the contents of the web page through JavaScript. It's JavaScript's window. And it really consists of a bunch of objects. So the way it works is that when our browser loads a web page, part of that loading process involves taking the incoming HTML and CSS and then creating a whole bunch of JavaScript objects based upon those elements and those styles. So if we have something like this very simple document where we have an H1, a UL, and then two LIs. Each one of those, every single element, including the body, gets its own JavaScript object. And those objects all have certain properties, certain things like the type of elements they represent. Is it an LI? Is it an image? But then some of them have more specialized things like an href attribute or a source for an image or inner text for a heading and an LI. Some things have text inside, some things don't, like images. Anyway, we get these JavaScript objects, which I'm representing on the right with circles. And it's not just these objects that exist on their own. It's actually objects that are connected. There's a relationship, right? This H1 lives inside the body. These LIs live inside the UL lives inside the body. There's a relationship. So that's also captured by these objects and how they're structured. It's something called a tree structure. It's a data structure that we don't really need to get too hung up on at the moment, but it's kind of diagrammed over here. I don't know why I said kind of. I've diagrammed it exactly over here, at least for this simple markup, where there's connections, right? We have a parent and then children, and those children can also be a parent of other elements. Now imagine something a lot more complicated for your typical web page that has maybe thousands of elements, and they're all nested multiple levels deep. So at the top of this tree structure, at the very top is a very special element, or a special object rather, called the document. It's called the document just like we have a special object in JavaScript. If I open up my developer tools, such a nightmare here on Trello, but if I open up the dev tools, right, I can type window. We've talked about that. Window is a special object that's always available in the browser. Well, so is the document. And when I look at it, it doesn't look like a whole lot. It's showing me HTML, but it's not HTML. And this is kind of confusing when you're starting out. This is just what the Chrome DevTools do. When you look at the document, it's showing you the corresponding HTML. But there's a better way. If we want to see the actual document, the object properties in there, I can do this, console.dir. I think it stands for directory, console.dir of this document object. Now, when I open that up, what do we see? Very different. We're not just seeing the HTML, but we're seeing a JavaScript object. And there's lots and lots of properties in here. So we really don't need to care about the majority of these, at least not for now. But here are things like URL. This is the web page I'm currently on. So this is JavaScript in this object telling me that it knows, well, it's not telling me anything, but we can see that it's aware of where we are. This is the URL we're on. We have things like, let's see, a reference to the body. And this body is the actual body of my page. You can see actually when I highlight here, the body is being selected and it's showing up over there. We have things like the domain I'm on, which is just Trello.com, if I'm in full screen or not. Images, how many images are on the page? And it looks like there are 18 different images. And for each one, I think it's really just the avatars of myself and maybe some of the icons or images. But you can see they're showing up. If you look right there, as I highlight, there's my image. But remember, this is a JavaScript object. So this object has things like my alt text for that image. It has things like the image source, which is, where are you? Right there, that's the image source. Looks like it's hosted on S3 on Amazon. There's so much in here, it can get overwhelming very, very quickly. Also, here's the width and height, 25 by 25, it looks like. But as I was saying, it gets overwhelming very quickly, so don't let that happen to you. There's so many properties in here that you will never need to touch or very rarely need to touch. So we'll take a look at another example in just a moment, but to recap, the document is an object, just like everything in the DOM. It's just JavaScript objects, nothing fancy, except what is fancy is that it's created for us automatically by the browser whenever we load a new page, and it's created using the contents. It's based upon the contents of the page. So it's a bunch of objects that represent the content on the page, and then a bunch of other useful methods and properties so that we can do things like listen for clicks and drags, or so that we can change CSS styles or show and hide elements. But it's all a bunch of objects, and the document contains it all. It's like the top level folder for everything. It's the root of the tree in computer science terms. Okay, so I've made a new document here, a pretty simple one compared to Trello at least. I just copied a bunch of markup from Wikipedia for silky chickens. I added in some new images and different sized images. We'll be working with this, so you can download the code. There's a tiny bit of CSS, a bunch of HTML, and then an empty JavaScript file that I'll be playing around in. But if you would like to follow along in the next few videos, I highly recommend that. So I'm giving you this page that we'll be working with. So without doing anything JavaScript-wise, if I just open up my console here and I type the magic words, document, as we've already seen, we just end up with the representation, the HTML sort of inspector. But behind that, that's just the Chrome DevTools showing us that. But behind that, there's the actual object. If we look at the document here, open that, here we go. So we have the URL. This is just a file. It's not hosted anywhere. We have things like this, all. This contains every element on the page. So the HTML, the head, meta, title, link, body, h1, image, paragraph, bold tag, and each one of these is an object. So let's take a look at a simple one like a bold tag. That first bold tag right there, if I expand it, it is itself an object. So remember this diagram back here when we talked about how JavaScript takes in the markup, the HTML elements and their corresponding styles. It spits out these JavaScript objects. And that's exactly what we're looking at here. Each one of these is an object for a single element. And there's a lot of stuff, as we already talked about. Don't get overwhelmed. But we can find some things that might make sense. For example, this is a bold tag, right? And that's what we're looking at here, the object for this bold tag. And it tells us it is a B element or a bold tag. It also tells us that on the inside, it has the inner text of Silky. If I were to look at a different bold tag, let's take a look at this one right there. Whoa, I accidentally clicked. It took me to the Elements tab. And if we look at, where are you? Same thing here. Inner text is Silky. And as a quick demo, I can show you how we could change that actually, just very quickly. So that was document, and then we went into all. So why don't we look at that, document.all. That gives us this massive collection. It looks like an array. So why don't I pick something out of here, document.all, square brackets of 10. What does that give us? Oh, wow. What are the odds? I actually got it right. It gives us Silky. And it looks like it's just text, right? It looks like HTML, but remember, it's an object. So I can do things like this, dot inner text, not text, and then I can change that. How about Slicky? Sure. And what do you know? I changed the HTML that we see on the page without touching HTML. I did it through the DOM. Now this was a demo where I may have overstepped. We may have gone too far because we still haven't really talked about what inner text is, and we have a lot to cover. But I just wanted to demonstrate that this document object is where everything is contained, where it all starts. And within it, I have methods and properties I can change to manipulate the document, to manipulate everything you see and things you don't see behind the scenes, like the style sheets that are connected. You don't see the actual style sheet or the fonts. I guess you do see the fonts, but you don't see, behind the scenes meta tags as an example. Those are all things we can manipulate through the document object. So we've got a lot to cover. This was just an intro to this concept of the document object, which once again just contains a whole bunch of properties and different methods. It contains objects that represent the content of a web page, and then it contains a bunch of other stuff, most of which you probably will never touch. I can't say that enough. There's so much here. It's overwhelming. It doesn't look that bad. Maybe it's a lot, but it's not that bad until you realize that this is one object of a couple hundred. For this page. And if you open up one of them, they each have a whole bunch of properties, and they each have their own massive list of properties and sub-objects. So we're going to go through it step by step. No need to be overwhelmed. Focus on this adorable Silky chicken, or maybe that one, or that one, or that one, and take a deep breath. This is exciting stuff. In the next video, we're going to start by learning about selecting DOM elements. All right, so we talked about how the document object contains a bunch of methods and different properties that actually correspond to other objects who contain a bunch of methods and a bunch of properties, and it's this nasty nested tree. I shouldn't say nasty, but complex nested structure. So in that document object, there are a bunch of methods, some of which are really, really important to understand, and we're going to learn some of them in this video. We're going to start by talking about methods that help us select elements. Now, when I say selecting, I'm talking about using JavaScript to single out maybe one element, or maybe all elements with a certain class, or all elements with of a certain type, just like we do in CSS. We don't just apply every single style to every element. We do things like, make all links blue, or make this one, the first image here, make it larger, and then every other image, make it a thumbnail size, or make the heading a lot larger with a gray background. We don't just make everything have a gray background, right? We selectively apply our CSS. Well, we do the same thing with our JavaScript. We selectively apply, let's say, the drop-down menu functionality. When I click on this button, or this, whatever this is, an anchor tag, a span, it expands a menu. That doesn't happen when I click anywhere else, except for these other menus, which are different. They have different content. But what I'm trying to say is that we select things using JavaScript. So we would say something like, when a user clicks this particular English span, or whatever this is, language selector, it probably has an ID, or when they click this technologies button, show this drop down. When they click again or they click away, hide it. So that involves targeting this element. So that is kind of what selecting is. We have to select elements first. What are we going to be working with? And then we can work with it. We can manipulate. So in this video, I'm going to introduce our first of these selecting methods. The first one we'll see is called getElementById. So getElementById is a method that exists on the document. And when you call it, we pass in a string. And this string needs to correspond to some ID on an element. So if there's an element found with that ID, it will be returned. And if it can't be found, then we get undefined. So let's take a look at our simple example here. I have some markup where I have assigned IDs to my elements. For example, this image up top, this image has an ID of banner. And then I think I also gave the table of contents right here. This has an ID of TOC for table of contents. So if I wanted to select, let's say that image first. To select that image, I'll open up the DevTools just to do it from here for now. We do it from a file typically. Document, dots, and then this method, getElementById. And then if I pass in something where, let's say there is no ID on here of chicken, no element on this page has ID of chicken, we get null. Sorry, I think I said undefined, we get null. Nothing was found in the DOM. But if I use an ID that does exist, like banner, it gives me the image. Now, once again, it looks like it's just giving me HTML, but that is not the case. It's annoying, but if we use that console.dir, we can actually take a closer look. But let's save this to a variable. So I'm going to call this const banner equals document.getElementById of banner. And there we are, we have it here. And if I do a console.dir banner, you can see that it's an object. And it contains all those properties. A lot of them are just completely blank, but there's a lot of stuff in here. But we can see that, let's take a look at some of these properties. It has an ID of banner. Well, we know that. It has things like this source of the image. It's an image I got from unsplash.com. We have the height and width of the element. What else? Different styles, which we're not touching at this point. We can see the tag name. That's very important. It is an image element or an image tag. So there's a lot here, and we just selected that using document.getElementById. So when we select something, what we're doing is we're telling JavaScript, please fetch me the object that represents some element on the page, matching some ID. So we're not saying give me the HTML. I'm instead asking for the DOM object, the actual element object that JavaScript created. If we go back to these slides all the way back here, remember this factory image of HTML and CSS going in and JavaScript objects being generated or constructed that represent those elements? That's what we're getting here. So we're not actually selecting the text, the HTML or the CSS styles. We're selecting the DOM object. So we got an object here that represented that particular image with the ID of banner. Let's do one more example. Let's do document.getElementById of TOC, which is the table of contents. It's just a div. And I'm going to save that to a variable, const TOC, console.dir, just so we can totally see the contents of the object. Open it up, lots of properties. And this time you'll see this object has the ID of TOC. Well, that makes sense. It has a tag name. We find that on here. LMNOPQRST. It has a tag name of div. It has, what else? A width and a height that has been computed, a bunch of empty properties. It has a list of, or a count of how many children it has. So this div has 3 children. Let's verify that. Here's a table of contents. And here's our first child. Here's the second child, that UL. And am I missing one? I think I am. Yes, I am. This input right there. There's our third one. So there's 3 children, and we could actually see all the children if I opened up children. Here's the first one, an input. Here's the second one, a div. The third one's a UL. But we're not going to go into that for now. So that's all there is to selecting by ID. That's one way to do it. This is only to select by ID. It's not going to work if there's a class name that I'm trying to select by, but it just gives me the object representation of that element, which I can then manipulate, which we haven't done yet. So far, we're simply selecting. We're on step 1, right, of this 2-step process. It's at least 2 steps. Select this thing and then manipulate. So we've seen how to select by ID. Next up, we're going to talk about these other 2 ways to select elements by their tag, the type, like image or anchor tag, and then by class name. So that's next. Okay, so the next 2 methods, they're built into the document, just like getElement by ID. The next 2 are grouped together because they have to do with elements. They're not getElement by tag name or element by class name, but it's elements, plural. Hopefully I'm enunciating well enough for that to be clear. And that's because they select more than one thing at a time, right? Give me all of the elements that have this class, or give me all of the elements that are anchor tags or image tags. So let's start with tag name. GetElements by tag name. Here's a documentation on MDN. All we need to do is call getElements by tag name and then pass in a tag name. So we don't pass in paragraph, the element name, like the word paragraph. We pass in P, or we might pass in IMG for images. And this returns to us, if everything goes well, it returns to us something called an HTML collection. So we'll talk about what that is in just a moment. Okay, so let's try something. What can we select here? How about all images? So there are 4 of them here, 1, 2, 3, and then 4. I'm going to clear the console and then document.getElements by tag name, just like that. And then I need to pass in IMG. And sometimes you'll see people do this in all caps. That works. It's not case sensitive, but obviously it does matter that you spell it correctly. So IMG. And that returns to us something called, as I mentioned, an HTML collection. It looks like an array, but it is not an array. So we can use array syntax, like square brackets and indices. Every element has an index. So if I save that to a variable, const all images, we look at all images. I could single out the first one, for example, and it's this banner image. Remember, they're not actually strings of text. They are full-on objects. So let's do it. Console.dir, all images. How about the second image, which is this image here? Open that up. It is indeed an object, and it has things like, a source. There are things like, we don't need to go into it at this point, but this is an object that represents that one image. So this HTML collection is not an array. That means I don't have access to things like, map, for example. If I try and access map, it just doesn't exist. It's as if I was trying to access some other function that doesn't exist. We do have things like a length. We have indices, as we've seen, and we can use for of. So these are iterable collections, but they are not arrays. So I'm just going to copy this line over to our file here, app.js. And then why don't we loop over every single element in all images? And if we go back, each image has a source. And we could view or just console.log each image's source. Nothing crazy, right? We're not changing the sources, but let's just view them first. Okay? So for, and then let image of all images, we'll do a console.log image.source. That's the name of the property. So let's refresh. I don't think I connected my script, did I? Typical. Down at the bottom, yeah, what do you know? I didn't add this script in. All right. Well, by the time you get this, that should be fixed. So app.js. Now we refresh, and here are the 4 image sources I just printed out. So we can iterate over that collection, that's great. Just know it is not an array, and that is something that does confuse people when they try and go and use array methods like map or something. Now, I can also, just as a sneak preview, I can manipulate things. I could change every image's source to be, I don't know, how about, let's take this image right here. Just pick any image source, and I'll do image.source equals that long string. And this will be our first example of really manipulating things. So I'm going to refresh, and now every image on the page looks just like this. It's that same beautiful silky every single image. So we have 4 of them, but if we had 100 images, we would select them all because we used getElements by tag name. All right, so I'm just going to comment that out so that we aren't doing that because I want to have that variation, but that's our first little taste of that. Okay, so we can select other types of elements. I won't go into a lot of detail here. It's the same pattern, right? Document dot get elements, not element by ID, but elements by tag name. We can do things like all paragraphs. There's 2 of them. I can do give me all divs. There's 2 of those. All B tags. There's 3 of them. How about anchor tags? 24 anchor tags. And I guess that's good enough for now. Let's talk a little bit about what this collection returns. So it's an HTML collection, but what's inside of that collection? What's each element? Well, it's a particular thing called an element. An element in JavaScript is that object that we're getting back that has all these properties that represents a single HTML element. So the actual name in JavaScript, the type of those objects is element with capital E. So just to recap here, right, this is an HTML collection and it consists of 1 element here, 2, 3, and a total of 24 elements that we're getting back. Okay, so now let's talk about this second method, get elements by class name. It does exactly what it sounds like. Rather than selecting by ID or by tag name, we're selecting by a class. So I have some class, at least one class I've assigned. Here we go. These images down here, these 3 images have a class of square, because they're all square images. I made them square. They're not actually square, the original image size. So I could select those 3 using document.getElements by class name, and then I pass in the string square. And we get those 3 image elements in this HTML collection, an array-like thingy that is not actually an array, and I can access each one or loop over them and do something. What could we do really quickly in here? I mean, I could change their image sources. Sure, we can do that. So let's come back over here. We'll do const square images equals document.get elements by class name square, and then for let image of square images, let's change that source. Image.source equals, should we use the same source? Sure. So now, if I refresh the page, only those 3 images that have that class have been updated. In the original, I shouldn't say original, the top image does not have that class, so it didn't get selected. It's completely unchanged. Now, both of these methods, if I try and do get elements by class name and nothing is found, we don't get null. We get an empty collection, just like an empty array-like thingy. Same thing with get elements by tag name. Compare that to get element by ID, right? As we saw, that only gives us one thing. There is no collection of elements with an ID because an ID is only supposed to occur once per page. So we get null or we get the element itself. Like if I look for that banner image, we get that entire element, that object. So that's it for now on those 2 new methods, get elements by tag name and get elements by class name. They're similar in that they both return to us an HTML collection, an array-like object. It doesn't have array methods, but it does have indices and a length and that sort of thing. We can iterate over it. Now, next up, I'm actually going to show you a better way of selecting elements, a newer, fancier way called Query Selector. So we just saw 3 specialized selection methods. We can select by ID, by tag name or element type, and by class name. But there's a better way, a newer, more recent addition to the DOM is a method called Query Selector. Now, I don't know why this wouldn't exist from the get-go. I really don't know why. It seems like, if I was designing this, I guess that's kind of a pattern with JavaScript, though. If anybody was designing it from the very beginning, anticipating how it would be used today, things would be different. But that's not really how it's evolved. It's been a slow, incremental thing over the years. So anyway, we are thankful that we have Query Selector, which it's a Swiss Army knife. It's a combo. We can use one method to select by ID or by class name or by element type or by attribute or really any CSS style selector that we want. So this is how it works. Document.querySelector, and then we pass in the same sort of selector we would use in CSS. So if I wanted to select by element name, well, that's pretty easy. Document.querySelector, and then I'll select by paragraph. Now notice, it only gives me one. It's the first matching one, but there's actually more than one here. If I do a get elements by tag name, I look at paragraph. I think there's more than one paragraph. There's 2. That is definitely more than one. So query selector just gives us the first match. So let's try another one. Document.querySelector. I have that ID of banner on this image. I can select it using the CSS syntax. We use that hash symbol, the octothorpe character, #, whatever you want to call it, to select by ID. And there we go. I just found it. Let's try something else. Let's select by class. So how do I select by class in CSS? If I have a class named Square, I need to use the dot. And again, it only shows me the first one, but we'll see in just a moment that there's a way to select all of them that match. Now I can do more complicated things. For example, if I select image, the first matching image is the top one with the ID of banner. But I can chain on other CSS style selectors like nth of type and get the second one, which is image with the class of square. So I can add multiple selectors in here. I can do more complicated things. What would be a good thing to try and select? Let's just do one example here. Let's try an attribute. So if I want to select anchor tags, is this an anchor tag here? Let's see. Sure. Let's do this anchor tag that has the title attribute of Java. So I'm going to try that. So to select by an attribute, document.querySelector, query selector. And then I need to select, I'll just do anchor tag. And then how do we do an attribute? With those square brackets, hopefully you remember this from CSS. And then I can do href. No, we're not doing href, are we? We're doing title equals Java. And it found it. And it has title of Java. So we're not just selecting by anchor tag. We're not selecting by type. Well, we are, but we're also selecting by attribute. So it's type. And it's only the first match, I believe. There's only one of those that matches on this page anyway. But we also have query selector. Drum roll here. Come on. Query selector all. What a beautiful slide. Really doesn't give you any information. Query selector all is the exact same principle, but it returns a collection of matching elements instead of just the first match. So these two, query selector and query selector all, are really what I use all the time. It's pretty rare that we need to use any of these. But these are a good place to start, and you will see them. Definitely things like get element by ID. People still use them. Query selector is supported in all the major browsers these days. We can verify that, though. On MDN, all green. So we're in the clear there. So just to recap, query selector all, document.query selector all is going to match, or it's going to return a collection of all matching. So if I do p tags, for example, it gives me all matching paragraphs. There's two of them. Whereas if I had just done query selector, I get the first match, and it's not in a collection or an array-like object. It's just the element object itself. Remember, it looks like it's actually content or an HTML string, but it's not. It's a JavaScript object created about that or using that HTML string. So I can do query selector all, with images and get a whole bunch of them, 4 of them in this case, and I could work with them. And how about we try something like selecting all anchor tags nested inside of paragraphs. So let's get all anchor tags first so we have a reference point. There's 24 of them. Now, if I select all of the anchor tags inside of paragraphs, remember how to do this with CSS, just P space A, the descendant selector, anchor tags somewhere in a paragraph, and we get 17. Okay, and if I hover over, we can actually see where the first one is, thanks to Chrome, the second one, third one, and so on. So I could select all of these and iterate over them. For example, in my JavaScript file again, let's do const anchors. What should we go with? Links equals document.querySelector all, and then for let link of links, let's do a console.log. What do we want to print for now? Link dot, and we haven't really seen this, but there's an href attribute, so I can print out every anchor tag source, and there we go. They're pretty much all just Wikipedia links to other pages on Wikipedia, which actually won't work locally on the file protocol, but it doesn't really matter. Okay, so I think that's about it for query selector and query selector all. There's a lot that we can do. They're very, very flexible. So I have not shown all of that, but we spent so much time on CSS and selecting with CSS, we can use those selectors here. So as we saw, I use things like nth of type. We can use descendant selectors. We can use the adjacent selector, the plus sign. We can use elements, just the tag name selector like I'm using here. We can use class selectors with the dot, select by ID with the hash symbol. So basically we can replace these methods that we saw here by using query selector or query selector all, depending on whether you want to select the first match or all matches. All right, so we will be using these quite a bit, and that wraps up the couple of videos on selectors. Now that we can select things, we need to do something with them. Yes, it might be fun, maybe in some universe, to loop over a selection and print out hrefs or sources, but in the real world, of course, we're going to want to be able to actually, do more exciting things or more useful things, like showing and hiding elements, or changing their styles, or adding new elements to the page. All of that is coming up. So now we move on to step 2. It's not really a concrete step, but I like to think of it this way. We've talked about selecting, how we find elements, how we select them from the DOM, we get those objects. Now, what do we do with them? That's what I'm calling manipulation. It's not an official term or anything, but you'll hear DOM manipulation or manipulating the DOM frequently used, and it just refers to getting those JavaScript fingers in the middle of HTML and CSS and moving things around or renaming things or updating styles or showing and hiding things, basically using JavaScript to impact the HTML and CSS that a user sees or even stuff they don't see. So there's a lot that we could go into, and it can get a little bit overwhelming. I've said that multiple times here. I mean, we've seen what those objects look like. A single element, the object that we get in JavaScript, has hundreds and maybe more than hundreds, but at least hundreds of different properties that we can set, that we can work with. So we're going to narrow it down to some of the most important, some of the essentials so that you don't go insane. And the main note I want to start out with here is that unlike the basics of JavaScript, where you've got to know how to make a variable or write a conditional or a loop, if you're still weak on some of them, that's okay, but you'll get stronger with them just because you use them so much. So unlike that stuff, where it really just naturally is committed to memory, this DOM stuff, things like remove child or inner text versus text content, those are things that you really don't need to care about too much. You should know how to find them. You should know how to Google it, go to MDN, wherever you prefer, find information and use whatever you find. But you really don't need to panic about memorizing it all or feeling like you have it down. It's just so much. There's a lot to know. This is a very small subset of the possible properties you could worry about. So maybe try and shift your mind here, or your mindset. Instead of trying to master everything like we did with, or hopefully like you did with the intro to JavaScript stuff, now that we've made it to DOM content, focus more on the overall concepts and being able to access information when needed. Okay? So we're going to start with a few related properties: inner text, text content, and inner HTML. So when I select elements, by the way, I'm working in a copy of what I was doing before, the same structure. So when I select some element, like let's say I select the H1. I have so many options of doing it. Let's use query selector H1. There's only one. I want the first one. Okay. So remember, that gives me an object. And if I just actually, let's save it to a variable. Const H1 equals that, and then our console.dir H1. This object has tons of properties, and the ones I'm interested in for now, are inner text, which we can find manually, I guess, if we follow this alphabetical order. Where are you? Inner text, says silky chickens, inner HTML, and another one called text content. So you probably can already tell they all have to do with the stuff inside of an element. So if we have, an H1, the inner text is the content between the opening and closing tag. Or for our paragraph, let's just pick our first paragraph right there, and let's select it with the DOM, or select it using query selector, and let's see what the inner text looks like. So let's start there. So document dot, it is the first paragraph on the page. There are two, but I'll just select that first one. And let's look at inner text. Okay, so it's all of the text that we see as a user showing up between the opening and closing tags for the paragraph. So I can actually both retrieve a value, just like any property on an object, right? I could have any object, just make one up. Let's say it's called person, and I could do person.name and retrieve it, or set it to something. all that this paragraph element is just a JavaScript object, and I can change that inner text value. So I could do document.querySelector paragraph.inner text equals LOL. And there we go. So what did I just do? Well, if we look at the DOM, or we look at the DevTools inspector, I took that paragraph and I removed everything that was inside of it. And I said, actually, the entirety of your inner content, that text, should just be the string LOL. And that's what we see here. So I just used JavaScript to update the inner text of that first paragraph. I'm going to refresh. So we lost a lot of text, but we also lost a lot of elements that were in there. Things like, bold tags and anchor tags. We totally removed all of that. So there's another property similar to inner text, which is called text content. And text content, it seems like it does the exact same thing, actually. So if I just show you that very quickly, let's do query selector of that same paragraph. Here's the inner text, and here is the text content. This is just the first paragraph. So actually, they don't look that similar, but the words look similar, right? The silky, sometimes spelled silky, all the way down to should be handled with care. Should be handled with care. It's the exact same words. What is different is that we have these weird spaces in here, right? So what's going on there? Where's the spacing come from? Well, it's not from this page. You might think it's from the line breaks that we're looking at, but that's not the case. Those line breaks change. Where it's actually coming from is my markup. Take a look at how it's written here. This is just VS Code, how I saved it. It does have auto format. The first line goes from the silky all the way to 4, and then there's a break, and we get this next line and that next line afterwards. And so that's what we're seeing here. That doesn't really matter. It's important to note, I guess, that that's a thing. What matters more is that text content, there's actually a whole little article about this on MDN, differences between inner text and text content. Text content is going to return every element in this element. So every piece of content inside is going to show up here. Now, inner text doesn't actually do that. If something is hidden, like if display is set to none, which I could do just very quickly, let's just take this first bold tag as an example. And if I set display to none just in the DevTools, display none, right, we don't see it here. But it still is in the markup. It's still there. There is a bold tag, so that means that there is a DOM node. There is an element, an object created for this. It's just not actually showing up here. But that's different than deleting it. So if I go back to my console, I'm just going to clear this, and I'm going to look at the text content for that paragraph. It shows the word silky, which was our bold element. It shows it's still here, or it's part of text content. Now, if I do the same thing, but for inner text, it is not there. It is not included in inner text. So text content is just going to give us everything, whereas inner text is actually sensitive to what is showing at the moment and if things are showing up at all. Anyway, both of them I can use to change what we see. Like I could rename this H1, or I could let's take a look at what these are. I don't remember this markup. I could take every li and update its inner text just as a little joke here. I could select all LIs, so document.query selector, or maybe let's do all anchor tags. Let's do that and save that. So const all links, and I should use query selector all to get all of them. So that gives me all anchor tags. I'll loop over that for let, and then link of all links. We're going to take that link dot inner text or text content and change it to be, how about I am a link. Okay, so let's run this. Let's refresh our page. Now every link says I am a link, I am a link. Now they still have their own hrefs. None of them will actually work, right, because they're Wikipedia links, but they go to different URLs. So all we've done is change that inner text. Now if they had stuff inside of them, if they had bold tags inside or something else, we're completely overwriting that. Now here's another thing. What if I wanted to take one of my, let's say I want to take the H1 and I want to add a, let's say an I element, an italicized element, or maybe just an anchor tag or something nested inside. So I could select the H1, document.query selector, H1.inner text, and set that equal to a string where I could do something like Here's just an I, just as an example. Something like that. And close that. It didn't work. What's going on? Well, what happened here is that it's just setting the text. It's not treating it as HTML. Even though it contains what looks like HTML, it's treating it as text because I set inner text. So that brings us to our next property, which is inner HTML. So inner HTML is going to give us the entirety of the markup contained within some element. So sometimes that might just be text. I'm going to refresh the page. If I look at the h1.innerHTML, it's just text. It's no different than if I had done inner text. They both are just text content. It's just a string. But if I do it on this paragraph, so let's take that first paragraph, we just get that text content with inner text. If I do inner HTML, we get all of the tags included as well. We don't retrieve this as much, inner HTML, because when do we really want to see those elements? Generally, where this is more useful is when we're updating the contents and I want to change the inner HTML. So as we saw, if I just tried to change that text on the H1 and make it an italicized element inside or some other element, let's just clear that and recall that line right here. If I did inner text, that's what we got. But if I did inner HTML, it's going to be treated as HTML. The browser knows, or the DOM is going to recognize that I'm setting the inner HTML and it updates accordingly. So we now actually have an italics, an I element located inside of the H1. So inner HTML, it retrieves the full contents, including the tag names of basically everything inside of an element. Between the opening and closing tag, just give me everything in there. Inner text gives us the text inside, so it ignores those tags, and it also is sensitive to what is currently being displayed, or stuff that's being hidden is ignored. And then text content is like inner text, but it does not care about what is being displayed or what's actually showing to the user. So all three we can use to set or to update the content, but inner HTML is really the only one we can use to add elements inside of some other element. And speaking of which, I could, instead of just setting something equal, right, I can just first of all look at what the inner HTML is, but I can also do things like plus equals. And what would I want to put inside there? This makes no sense to have an italics, an I element inside of an H1, but let's add in maybe a sub element for subscript or superscript, SUP. I'm just going to make something up in there, SUP. So notice I'm doing plus equals, and that works. We get our superscript. So instead of just setting it equal, which overwrites whatever is in there, as we saw, if I set the inner HTML of this paragraph, I'm going to eliminate everything and just overwrite it with whatever I include. If I did this, it equals, let's say it equals a bold tag. I'm not getting very creative here, but there we go, a bold tag. I eliminated everything inside. Now, if I had instead set inner text, as we know, we end up with the actual, just the literal text of what I wrote set there. It's not treated as HTML. Those tags are ignored. So that kind of wraps it up. Those three things. We can retrieve the current value just using dots, just like any other object property, or we can update the value using the equals sign, just like any other object property as well. The main difference, of course, is that these are special properties that do things. When I change inner text or inner HTML, what we see here, what's in the DOM, is actually changed. So that is definitely different than just us making our own object out of nowhere. All right, so those are our first three DOM properties. Next up, I'd like to talk about working with attributes. So elements obviously have lots of different attributes involved, some more than others. Things like href on an anchor tag, source on an image, but also things like ID and class are considered attributes. We also have things like on inputs, the type of an input, that's an attribute. So actually, why don't I add a simple input here just as a demo? Where should we do this? Maybe just at the bottom here. Input type equals text. Let's just start with that. Okay, so we'll come back to that. But let's begin by talking about how we access those attributes and how we work with them. So let's take a look at the first image as we've already seen. So document dot, and there's many ways of getting that. I'll just rely on query selector and the fact that it just gives me the first thing. Or we could be more specific and just select by ID. Now we know for sure that's the right one. So there are two attributes I can see that have been set here. I set them myself. The first attribute is ID. and it just so happens there's a property called ID. Now I could change that ID, and I could give it a completely different ID, like, I don't know, how about, whoops, that's my ID. And now look what happened. My styles, I had some styles applied to something with that ID. I gave it a width of 100%, and it's a very large image, so the natural width is far more than 100% of the width of the parent, which is the body. Anyway, by changing that ID, I actually did impact that ID attribute on the image itself. So I changed it in JavaScript with just a property, just like I could change anything on an object, and then the browser updates and we see ID is whoops, and those styles are removed because it no longer meets the ID requirement for that selector. All right, so I could go back and set it back to banner. Oh, no, I'm an idiot. I have to select based off of the ID that it now has, which is the ID of whoops. And there we go. Now it's back to being banner. So that's just one example of an attribute. But if I do the same thing and we look at source, there's another attribute. And we've already seen this. I can change that source to some other image source. If we look at our links, let's just take the first anchor tag, and we look at the href attribute. There we go. There's also a title attribute. This one happens to have a title on it. There's a whole bunch of different attributes that we can access directly. But there's actually another way of accessing attributes, which is through a method, which is called getAttribute. There's also a setAttribute. So I could use getAttribute. Let's just take this link and save it to a variable, const first link. And then I'll look at first link dot href as an example. And then I could also do .getAttribute of href. And this is a method that's going to do the same thing, but there is a difference. And this difference is kind of annoying, and I don't want you to worry about it too much at this point. But when I do getAttribute, what I'm actually doing is getting directly from the HTML itself. I'm looking at, if we can find that anchor tag, here it is. I'm looking at that href attribute and just taking the text in between those quotes. Whereas when I access a property directly on an element, like .href, that is going through JavaScript. It's going to the JavaScript object. It seems confusing. And again, it doesn't really matter a whole lot here, but there is a distinction. And you can see we get a different value. So we get file : / wiki / blah, blah, blah. So the same thing, except here it's been appended or prepended rather with file. And that's because it's coming from JavaScript. You can think of it as like the computed value here. Most of the time, this won't be different, but href is just one example where there is a difference, at least with what I have here. So I can use getAttribute to get other attributes. I could see if there's an ID. There's not an ID. Is there a class on that link? No. There is a title, as we've already talked about, a list of chicken breeds. So we can use getAttribute to get any of those attributes. And I can also use setAttribute. So I could change the title. That's not very exciting. But I could change, how about the href of the first link? And then I need to pass in a second argument. And let's say my second argument is, I don't know, http : www.google.com. Okay, I may have mistyped that, but let's see if I click. Does it take us to Google? Yes, and it looks like my internet is down. Thanks, internet. Or it's going really slow, but you can see that it did work. If we look at that element, it has a new href updated here. Let's get a tiny bit more practice. I added this input at the end. It has an ID, or it has a type of text. So if I select by input, I'll just do document.querySelector. And if I just do that element type, which is input, I actually do have an input on the page already. It's a checkbox. If I go to the HTML, I just copied this from NDN, or from Wikipedia rather. It's a checkbox here for the navigation. It just doesn't show up. Anyway, so that's actually the first matching checkbox. So I could get more specific. Oh, I have a couple of options. I could do this and get all of them and then access the second one, which is kind of janky because there might be other inputs afterwards or that are inserted in between. So this wouldn't really grow with my code, but I could do this: query input, and then specify where type equals text. And we've seen this before. It's just a CSS attribute selector, and that selects it. All right, so I'll save that to a variable, const input. And now I can access a whole bunch of different attributes and work with them, including type. So that's what I want to show here. Type is set to text, but I could set it to be a password input instead, just like this. I don't know why you would do this, change what sort of input you have after the fact using JavaScript, but it does work. I could do even input.type equals color, and now we get a color picker. Ooh. And I could also do input.set attribute type and set that back to text, for example. And there we go, we're back to a text input. So multiple ways of doing the same thing. Now, for the most part, they're the same. There are some differences you may run into, but just for the sake of your sanity and mine, we're not going to spend time going over them. For the most part, you can get away with doing set attribute or accessing things directly using the attribute like type or ID or href or source direct properties on the JavaScript objects versus working with the attributes themselves in the markup. Okay, I'm going to go away. No more attributes. So next up, let's talk about how we can manipulate styles using JavaScript. So how do I select something and then, let's say, make it purple or apply a new class? So there's a couple of options I'll show you. Let's start with our simple h1 element. So I'm just going to select it first. And I think I already did that earlier in a previous video. Okay, so here is our h1 element. It's the object, right? It has a bunch of properties. And one of those properties is called style. If I look at that, h1.style, it's a massive object, and it contains a whole bunch of properties corresponding to all the individual CSS properties. So things like color or font size. The big difference is that they are all camel cased. So something like font size is normally font dash size, right? Font dash size in CSS. You can take a look at it over here. I don't think I'm setting font size anywhere, but things like text decoration, background dash color. Versus in JavaScript, that dash is not valid in an identifier, hyphen or dash or whichever one it is. Instead, everything's camel cased. So if we look for something like color, there won't be a difference. But if we look at font size, here it is, font size camel cased. So that's important to remember. But more importantly, you might have noticed there's nothing really in here. They're all just empty strings. So this is kind of a frustrating thing, a realization that every developer comes to when they're starting out with the DOM. This style object does not contain the current styles, at least not if you define them in a separate style sheet like I did here. Although for this h1, we haven't really styled anything, but let's actually do that. Let's give my h1 a color. How about a color of olive? All right, so I'm going to refresh, and we get that olive. Now, if I look at my h1, I reselect it, and I do h1.style.color. What the heck? It's still empty. So this is the realization I was talking about. This style object does not contain styles from our style sheets. It will contain any inline styles I've assigned, which we've already talked about is not a good idea. But let's say that I thought it was a good idea, and I give my h1 a style color of magenta. I'll refresh. All right, it's magenta. I reselect my h1. I look at h1.style.color, and what do you know? It is set to magenta. So all of these massive, or this massive list in this object, all these different properties, they're going to be empty strings unless I assign them or I set them in line, which we pretty much never do. But we can use this style object to actually change those values, and it will work. So I can do h1, let me clear this, h1.style.color equals, I don't know, green. It's not very exciting, but it does turn green. I can do h1.style. Let's make the font size larger. Font size, right? Remember, not dash. Font size, camel cased. Everything has to be a string. So I have to, whatever I'd write in CSS, things, I don't know, like 20 pixels or 50 EMs, I can't just type that, right? That's not valid JavaScript. I need to do, well, 50 EMs would be huge, or 50 Ms. Let's do 3 Ms maybe. And it did grow. Or I could do h1.style.border equals, how about 2 pixel solid pink. Just like that. And now we have that border. All right. So that's one thing that we can do. We can set all of these style properties through the DOM in exactly the way I'm showing you here, where if I actually go and inspect one of these elements, or just this one we've been working with, you'll see that I'm writing a bunch of inline styles just using JavaScript. So this is generally, it's not preferred, let's put it that way. If you're doing one thing, like you're changing the color of something, or you're doing some one-off property, then it's fine, it's easy, do it through this style property. As we've been doing. But if you have a lot of styles you want to apply through JavaScript, having to do them one at a time, first of all, is really annoying. Second of all, making a bunch of inline style changes is just not ideal. Remember that inline styles are very specific. We want to try and avoid writing styles inline. So there is a better way to make changes, to apply new styles to elements, which is to use a class. We can define a CSS class and then add that class or remove that class from elements. And that's something we'll see in the next video. I want to wrap this video up though, now that we've seen that we can set properties, CSS properties, using some element .style.color. Let's just do one more example first. Let's select every bold tag, or how about every anchor tag, and give them a different color. So const links equals, you know what, actually, I already have all links right here, so why don't we just reuse that. For let link of all links, link.style.color equals, let's go with cyan. That might be a little bit bright. Let's see. Yeah, that's a bit obnoxious. Let's do a hexadecimal color. Let's steal one of the colors. We can use this color picker and just pick a color in VS Code, and I'll just steal that. How about like a darker? Sure, we'll just take that color. So sure, we'll do an RGB, and then I'll just copy that and put it here inside of quotes. Everything just needs to be inside of a string, inside of quotes, in order for it to be valid JavaScript. All right, so let's see if they all turn that color, and they do. It's not all that noticeable against the black or next to the black, but we did get that bluish gray color. All right, so that's just another example. In this case, we're doing it for every link that we selected with query selector all. Make them all that color. We can do one more thing like link.style. How about text decoration? See, I just did it there with the hyphen, even though you're not allowed to do that. Text decoration color. Let's give it a different underline color. Let's go with magenta. Let's see what that looks like. Okay, so there we go. I could even do another property like text decoration. Is it style? And make it, I think it's wavy or wave. I can never remember. Did that work? Oh, there we go. Our lovely wave text decoration. Okay, so that's one thing that we can do, right? I said it's not a great idea, especially if you have more than one property. You have to do a separate line for each one. It's kind of annoying, but it does work. We're doing it all inline, right? Every single one of these elements now, each anchor tag has a bunch of inline styles actually in the element, in its markup. So that's not great. But the other issue we saw is that unless I wrote that style inline in the first place, I can't actually read the styles. I can't tell the font size of this H1, right? If I wanted to make something else the same font size, I don't know how big it is, at least not without looking at my CSS. I don't know. So if I did H1, I need to reselect it here, const H1 equals query selector H1, h1.style.font size. It's just an empty string. So there's another option. There's another way of getting the actual computed styles once everything's been applied. Because you have to remember, it's not as simple as just looking at a style sheet and copying these styles over from JavaScript's perspective. Because we might have multiple style sheets and they might all have conflicting styles, and there's the whole cascade to consider and specificity. So at the end of the day, certain styles might be applied and then overwritten again. So we have to wait until things are loaded and everything has been computed by the browser to figure out actual styles. And I can do that using a special method on the window object, window.getComputedStyle. This is not something you'll really need to do a lot, but I'll just show it to you because I do get questions about it. We pass in the element, so we have to select our element, like the H1. I've already selected it, saved it to a variable, and I can pass it into window.getComputedStyle, and then it gives me this massive object that has the computed styles for that one H1. So it's actually not quite, I think I said it's an object. It technically is an object, but it's something called a CSS style declaration. And there's actually an order to it, right? So I can access the zero with property, animation delay, but mostly what we do is just access the CSS styles off of it. So I can look at color and this is the color that was assigned to that H1, or I can do things like font size. That's what I'm interested in. And it says 32 pixels. Is that correct? I guess so. I would have thought it would be larger than 32 pixels, honestly. Let's see. Let's select it here. And we'll set font size to be 32 pixels. Yeah, I guess it doesn't change. So it is 32 pixels. All right, so I increased it to 62. Let's go back to 32. Back to our console. This is, again, going to contain all of the computer style. So if I wanted to know, I don't know, what else would we want to know? The font, the actual font family, right? What is the font family? Times. So we didn't set that. That's coming from the browser. That's the default. What about, let's do one more example. What's the default margin on the H1? I didn't set that either. Margin left. 0 pixels. How about just margin in general? 21.44 pixels on the top and the bottom, right? So those are all things we can find out using JavaScript. So not that common, but there might be times where you want to know the current font size of something, and then maybe you want to add 10 pixels to it. So we could do that with window.getComputerStyle of our h1.fontSize. Then, of course, it gives you a string. So it's not as simple as just adding a number to that. You've got to actually get the number out of there, whatever it is, 32, let's say. So you could use something like parse int, or you could split it, or select everything but the px. There's different options here. Then once you have it as a number, we can add 10 to it, and then we can turn it back into a string, add px onto it again, and set the font size. It's annoying. There's a lot of steps along the way, but if you do want to get the current styles of any element, you can use window.getComputerStyle and you pass in the element. So this is not a selector like query selector or getElementById. This is the actual element object in the DOM. We pass that in to window.getComputerStyle. So we saw a lot here. I know it's kind of overwhelming. Just try and remember that it's very normal to be overwhelmed, and that I'm showing you a lot very quickly. And it's just not as important for you to cling to every word or to every possible method and every piece of syntax that I show you. Unlike all the early stuff with JavaScript, it's okay if a lot of this just sort of zooms by you, as long as you can go back when you need it and find the information. All right, I'm a broken record, I know, but it's important, and I see a lot of people start to get a little panicked when I get to this sort of content, because the world just opens up and there's so much more that you could take notes on, you could research and study. So let's relax together, take a deep breath, and not panic about all of these properties and methods. All right, so we saw that we can set inline styles using the style property, but it's not a great idea, especially if we have a lot of styles to set at once. And I mentioned that the better option is to create a CSS class and then apply that class. So I've created two very simple CSS classes to play with. I have one called purple and one called border. So two different classes. They could represent anything, this is all trivial, silly stuff at this point. But in the real world, it is pretty common to need to apply a class via JavaScript, especially once we get to things like events. Applying a class when you click on something, making this animate or fade or do something when I click on it. Or, if I'm dragging this image around or clicking the image, giving it a border and something to make it clear that it's selected and I'm working with it. There's so much that, we'll get there. But for now, we're just going to do our silly little classes, purple and border. Okay, so to manipulate classes, first, of course, I need to select something. So why don't I select this, whatever that is. I can't remember if it's an H1, an H2 or an H3. All right, it's an H2. So how would I select that? It's the first H2, so I could do document.querySelector, H2, and it's the first one that comes up, so const H2. All right, I've saved it to a variable so we can use it again. And then to add a class, one option is to use the set attribute. That's a method we've seen already, right? I can set any sort of attribute. Why don't we actually start with get attribute? So let's just look at class. Is there anything there? No, there's not. All right. So why don't we set attribute on class or of class? Set attribute class, and I'm going to set it to be purple. I think that's what I named that class. And did it work? Yes, it did. So that element now has a class. If I select it here, it was already selected. I'm a moron. It has a class of purple. So that's one option. But now let's say I also want to apply this border class. So if I try h2.setAttribute border, it did work, but I lost what I had before. Now class is just border. So you can do things like h2.setAttribute class, and then take the current. So I could do something like this. This is annoying, but let current classes equal h2.getAttribute class, right? And then I could do h2.setAttribute class, and then use maybe a string template literal and combine them. So the way that we have more than one class in CSS is by separating things with a space. So I could do current classes and then a space and then purple. And hopefully that'll do it for us. And it does. We now have both classes. So that's kind of annoying. Because let's just suppose I had 10 classes. That might be overkill. 3 classes that were already on this element. And I didn't want to replace them. I just wanted to add purple. Well, that's kind of annoying to have to just select the current ones and then modify it or add on another one at the end. That seems like a lot of work. And it is. There's actually a better way to work with classes, which is something called the class list. So I'm just going to reselect my H2. I refresh the page just to undo that progress. And if we look at H2, or any element that we select here, there's a particular property called class list. And class list is kind of what it sounds like. It's an object that we can interact with to control the classes on an element and also to retrieve them and to manipulate them. So currently there are no classes on that H2. But if I look at the class list object and I just hit dot here, you'll see that we get some methods. There are methods built into the class list, including things like add. So calling classlist.add, and I'll pass in something like purple, that adds the class of purple to this H2. And we can see it has class of purple. Now, if I want to add a second class, I can just add it again. I don't have to worry about what was there before. Think of it as like pushing onto an array, but it's not an array and we're not actually pushing, but we're calling add. So I could add on another class of border. There we go. Very simple compared to what we just saw with setAttribute. I don't have to worry about what's already in there. I can simply just add a new class. And I can also do the opposite. I can remove. So h2.classlist.remove, let's remove the border. And there we go. The other thing that I can do that's really nice is actually toggle classes. A lot of the time, you may not know if a certain class is activated or not on an element. I mean, you can check. You could look it up. For example, with class list, there's actually a method called contains, which we can use to test. Does this class list contain border? It does not. Does it contain purple? It does. Yes. So that is something you can do. But what's really common, though, is wanting to toggle a class between being on or off, or basically being present and not present. So I can do that with a method called toggle, classlist.toggle. And I'll toggle purple. It already has purple, so it's going to remove it. Now, if I call it again, it adds it on and removes it. So this is really useful, especially if you're making, there's so many things that actually have interfaces where some style is toggled, whether it's a button or a checklist or a to-do list where I click and an item is checked off, or it's grayed out or fades away or something, and then I click again and it comes back. Or this accordion on Google, right? I click and then I click again, we're toggling. That is a toggle there. And one way of implementing this would be to write a class that we could apply and then remove. We can toggle it on or off to open or close this element, right? We could change the height, or we could change the display of the content, show and hide, and that sort of thing. So we could use classlist.toggle. So to summarize this whole video, we saw this class list, which is an easy way to get the current classes on an element, but also to manipulate them, to toggle classes, to remove classes, to add classes. It's just much easier than having to go through something like h2.getAttribute of class. This doesn't have nice methods. It just tells us exactly what the class string currently looks like. So you can do this. It's just more work. Well, here we're just getting the attribute, but adding a class, removing it, it's more work using setAttribute than it is using class list. So I recommend class list. It's a nice little feature to have. And like I said, it is pretty common to manipulate classes. It might seem like it makes more sense, or it's easier to just, change the color and the text decoration and the font size directly. But if you're doing it all at once, right, and that's exactly what we're doing here, it's easiest just to make a class. And then in that CSS class, you can do all of those things you need and then apply or remove that class whenever it makes sense. So we'll see lots of examples of doing this. It's a really common pattern. Right now, I'm just introducing the basics. So yeah, I'll stop talking now. I'll see you in the next one. So next up, we're going to talk about a group of properties I don't really have a name for. They have to do with, I guess, accessing family or relatives, parents, children, siblings from a given element. So we're not talking about methods, but on the right-hand side, things like previous sibling and next sibling, children, parent element. So they're relatively self-explanatory, but I do want to highlight a couple of things. So all of these properties allow us to navigate or traverse or move from one element to some relative, to its parent, or to its parent's parent. So as an example, I'll select maybe the first bold tag. So document.querySelector, first B, I will save that to a variable, first bold. All right, so there it is. It's this right here. And if I wanted to access its parent element, which we know in just the HTML is a paragraph, right? It's this paragraph here. If I needed to move up one level, I can do first bold dot parent element, and then that gives me the paragraph. So from that paragraph, I could do it again, dot parent element, and that gives me the body. I could do it again, and that gives me the root HTML element. So that's parent element. We can traverse upwards. And right now it might seem like that's not useful, but shortly we'll see that we can do things like remove an element or insert a new element. And often we'll have, just as an example, a user might click on something. They might click on a button. And then when they click on that button, what we actually want to do is enact some change on the parent element or on a child element. So that's the next thing we'll see here, is that we can also drill down. Instead of just moving up a level to look at parent elements, we can look at children. Now, every element only has one parent, right? It can't have two direct parents. It could have a grandparent and a great-grandparent, but every element has one direct parent, one thing that contains it. But we can have multiple children. So there's not just a single property that's child element. Instead, there might be 10 children. If we took a look at something like this paragraph, actually, so let's do first bold dot parent element. That gives me the paragraph, this whole thing. I'll save that to a variable. I'll just call it paragraph. If we look at paragraph dot, and the property we'll look at is called, first of all, there's child element count. That tells us how many child elements there are. But if I look at children, it is not an array. It looks like an array. It's one of those HTML collections. It does not have array methods, but it does have indices. It is iterable. Anyway, we can see that there are 2 bold tags, or 2 bold elements, and then 6 anchor tags. So each one of those is a child of a paragraph, and they're in order, the order that they're found in the DOM. So just keep in mind, right, we can have multiple children. It is this list of children. So I can look at the first one like this, and that will give me that bold tag, or that bold element. Of course, it's an object here in the DOM. It's just showing up like this to troll us, but it actually is an object. So I could look at the parents of that, which is kind of redundant, paragraph.firstchild.parent. That takes us right back to the same paragraph. So that's all there is to children. If you wanted to do something for each child of an element, you could iterate over the children list. Now we have a couple of other properties that have to do with siblings. So we have next sibling and previous sibling. And these allow us to navigate from one element to an adjacent sibling. So why don't we start with, what should we do here? Maybe let's take this image. So this is the second image. It's also the first image that has the class of square on it. So I'm going to select that, document.querySelector, dot square, right? That's the name of my class. I need that dot. And I'll save that to a variable, first square. That's a bit large, or a bit long. How about just square image? All right. So from here, of course, I could access the parent. What do you think the parent element is of this image? Well, it's just in the body. There is nothing that's containing it other than that, so we get body. And children, there are no children here, but if we look at children, it's just an empty collection here. It's an empty list. Okay, so now let's talk about those sibling properties. It's a little bit confusing to explain up front. There is a previous sibling and a next sibling. However, if you look at it, there's actually previous element sibling and previous sibling, and the same thing for next sibling and next element sibling. So what's the difference? Well, the methods next sibling and previous sibling, so not element, but just next sibling, previous sibling, they are going to give us the corresponding node. Now, a node is something we haven't really talked about, but a node is different than an element. Essentially, what happens here, if we just look at next sibling, you'll see that it gives us some text. You would think that the next sibling is just the next image, but that's not the case. What happens is that nodes can actually represent text. So we'll have a node, just as an example here, inside of an H1. Here's our element, the H1, and then inside of it, there's a text node corresponding to that text. It's not something we've really spent a lot of time on at all. You don't need to worry about it, except you should know that the browser, at least some browsers, automatically make white space, they make new lines into a text node, and that's exactly what's happening here. If we look at this, well, if I expand it open, you'll see that all that it has inside of it, it's a text node. All that it has inside is a return character. It has nothing. So there's no real value to it except for that return character. It is not an HTML element. It is a DOM node. So next sibling and previous sibling, square image dot previous sibling, not element, no, previous sibling, they're going to give us text nodes because there happens to be return. There's new lines on either side. So that's kind of annoying. Instead, I generally use next element sibling. So let's do next element sibling, and that gives me what you're probably expecting, the next actual element sibling, the next adjacent sibling. So in that case, it's this image here. And if I instead did previous, it's going to give me the paragraph. The next sibling, or the previous sibling rather, comes right before it. So this allows me to navigate from one element to its next sibling or previous sibling, ignoring those weird white space nodes and text nodes, which usually we don't care about. There are times you may want that, but most of the time, if you're just trying to navigate to the next element, use previous element sibling and next element sibling. So that wraps it up here. We talked about children and parent element and then next element sibling and previous element sibling, how we can navigate through the hierarchy, through the tree structure from a given starting point. Next up, we're going to talk about creating new elements with JavaScript and inserting them and deleting things. And then we get to move on to events. All right, so we've seen how to change the text, the inner content of elements. We've seen how to work with attributes and change styles and work with classes and how to traverse from one element to its parent or to its children. The last thing we need to cover in this section is actually creating new elements from scratch. Just creating a new element and appending it to the page or prepending it, removing elements. So that's what we're going to do. Let's start by talking about how we make a new DOM element. So there's a special method called document.createElement. And then we need to pass in the type of element we want to create. So if I wanted to make an image, it's as simple as document.createElement img. So I have to pass in the tag name. Now, of course, this is not going to make me an image that I see on the page. First of all, even if it did, we'd be missing the source. Where does this image, what's it actually display? What's the image source? But second of all, I have to tell it where to go. So that just makes me an empty image. I can save it to a variable, const new image. Here it is, and it is an object. So I'll do my console.dir. Here we go. It has a whole bunch of stuff, just like any image object that we've selected, except it's missing things like the source. So now my job is to go and add an image source in. So I have an image I wanted to use. I'm going to copy this image right here. Okay. And then I'm going to set that as the source. So new image dot source and paste that in. All right. Now I have that image with a source, but it's still not on the page. So I now need to append it to the page. And there's a bunch of ways of doing this. And the first one, there's not really a bunch, there's two we're going to talk about. And the first one is called append child. So I need to select something that I'm going to append my new image to. And I could just do body. So document.body.append child. And then I pass in my new image. That's a variable which contains an element I want to append. So it's going to append this as the last child of the body. Let's scroll down. Whoa, huge, but there it is. So that does work, right? We created a new element. We appended it to the page by appending it to the body. I could change the class, right? I could go and do new image.classlist.add. I think I have a square class, which makes it smaller. There we go. So that works. And that's just our first example of appending something. Let's make an H3 maybe, and we will just append it at the very end still, just to make it simple. So const new H3 equals document.create element. This time I want an H3, and that just makes me an empty H3. It has no text inside. So I could set the inner text. That's one way of doing this. Inner text equals I am new, like that. And then I can append that. We'll just do it to the body. Document.body.append child new H3. And scroll down. There it is. I am new. Now, another thing that we can do when we're actually creating the text content inside of an element, remember we're making our empty element first. It's a shell. And then we have to fill it, whether we're changing the image source or an href attribute on an anchor tag or setting the text on an H3. We just have to go in and modify that element and then append it. Usually we make our changes and then append, just so that, everything's done. It really doesn't matter. It all happens so quickly, but typically that's the flow I go through. So create my new empty element, update it, do whatever changes I need, and then append it somewhere. Now, another option for creating new elements and appending them is to use a method called append. Not append child, which is what we just used, but just plain old append. And the first thing I'll mention about append is that it does not work in Internet Explorer. Unfortunately, it's newer, and it's a little bit more flexible. It allows us to, first of all, insert more than one thing at a time. So I can have 2 different nodes to insert, or 5 different elements I've created. I also could just pass in text, a string. So if I wanted to, how about select, why don't we take this paragraph, our first paragraph, so const p equals document.querySelector p. If I just call append here, and I pass in some text, I am new text, yay, like that. I pass that into append. It just appends that to the end of that paragraph. You can see it right, where are you? I think I'm looking at the wrong one. Yeah, there we go. Let's open it up. There it is. It appends it to the end. So we can't do that, first of all, with append child. It's not going to be happy with me if I just pass in text. It tells me that's not a node. I don't know what that is. That's a string. I can't use that. So that's one thing we can do with append. It's an easy way to add text into something. But the other thing that I can do is append more than one thing. So as I talked about here, I could make 2 different images or 2 different elements. And in this case, I'll just do 2 pieces of text just to prove this, and they'll both be appended to that element, to this paragraph. So when we append, we're appending to the inside of the paragraph. Same thing with append child. It's making something the last child of an element. But we don't always have to append things. We could also prepend. So prepend is also a newer method. Unfortunately, it does not work in IE, but it allows us to insert something as the first child of some element. So I could take the same paragraph, sure. And let's say I want to insert a bold tag at the beginning of that. So I could make my bold tag const new b equals, and then document.create element b. And then on my new b, let's set, why don't we use append if we can do that to append text to it. So let's append some text instead of doing inner text. This is another option. What should we put there? How about just hi? Okay, so now our element looks like this, and we need to append it, but I want it at the beginning of this paragraph, so I'm going to do prepend my new b. And there we go, it's added to the beginning. It's the first child now, instead of the last if I had used append. So it doesn't work in IE, that's the downside, but it can be nice to insert something at the beginning of some element. Now if we want to insert something not as a child, but instead as an adjacent sibling to something, let's say I want to insert something between this H2 and this image. I want a new, or it's an H1. I want an H2 to go between them. So it's not going to be inserted as a child of this or as a descendant of an image, which we can't even really do. I want it to be adjacent. So I could select the body and prepend, but that would put my new element at the beginning of the body. I don't want it there. I want it after this. So that's where this method, insert adjacent element, can come in. It's kind of crazy the way that it works. We have to specify a position. So instead of just insert, before previous element, or I don't know, insert as previous sibling, insert as next sibling, it doesn't work that way. It's just a generic insert adjacent. And then we have to specify if we want the element to be inserted before some element or after some element, or inside some element before its first child or inside some element after its last child. So usually, if we're doing adjacent stuff, we'll do before begin or after end, and then we specify the element. So we'll step through this. If I want to insert something between these two, I could either select this H1 and insert after it ends, or I could select the image and insert before it begins. So I'll make my new H2. H2 equals document.create element H2. And then I'll put some text in there, which we could do inner text. We can do append and just append text. How about silky chickens are adorable chickens? Okay, so there's my H2. And now I want to append it. Let's go with after this H1. So I'm going to select the H1, document.query selector H1, if I can type here. All right, and then we're going to do insert adjacent element, and then we have to specify where, and it's one of these strings, and I want to insert after begin. No, I always mix them up. After end, after the target element itself ends. And here's our target. So after it ends, so after end, and then after that, the actual new element, which is our H2. And I hit enter. There we go. We can verify it's not nested. It is actually inserted as a sibling, the next sibling after our H1. In fact, if we looked at H1.next element sibling, there we go. We get the H2. So I won't go through every possible scenario here, but we have these 4 different values for where we insert something relative to some target. So it's a little bit more complex, but we have a lot of flexibility compared to something like append or append child. Okay? That's pretty much it. There is a method called after, which does not have full browser support at this point. No IE. And what it does is it will insert an element after some other element. So kind of what we just did. I'll just show another demonstration. Let's make an H3. So const H3 equals document.create element H3. H3, let's do inner text this time. Equals, I don't know, I am H3, nothing crazy there. And then I'm going to insert it after, let's do it after the H1. So H1.after, and then we put our H3 right there, and it inserts it after our H1, right? You can see that here, H1, it doesn't make sense to have our H3 before an H2, but I'm going to refresh the page and it will all go away. So there are different options. After is only going to insert after something, right? It doesn't insert before. Now there is a method called before that you can use, but again, they're not fully supported, but they do exist. And then we have our sort of clunkier alternative, which does everything except it's annoying to remember these strings, which is insert adjacent element. And then we have append and prepend, and it's pretty common to use those, but it just depends on the situation. So those are all available for us to use. Now this video is getting a bit long, so in the next video, I'll just split it up. I'm going to talk about removing elements. That will be quick, and then we're done. We're going to move on to events. Okay, so now let's talk about removing elements. There's just 2 methods I'm going to cover, remove and remove child. So the older sort of original OG method is remove child. It has full browser support, including good old Internet Explorer, but it is a little bit more annoying because the way that it works is that we don't actually remove the particular element we have selected. We remove a child from an element. So, if I wanted to remove this image, I can't just select the image and say remove child. Instead, I have to select the parent, which I think is just the body, and then call remove child and pass in the image. So it requires us to call the method on the parent of what we want to remove, hence the name remove child. So if I did want to remove, how about this right here, one of these links? It's an li instead of a ul. So it's not enough just to select the li. I can do that. Const, let's go with first li equals document.query selector. I think it's just the first one on the page. And there it is. Okay. So again, I can't do this first li.remove child. I mean, it is a method that exists, but if I want to remove the li itself, I can't do that. What I have to do is get the parent of the li, which is the ul, and we've seen how to get the parent, right? So I can do this const ul equals first li dot parent element, just like that. And now we have the ul, and now I can do remove child, and then I pass in the child I want to remove, which is the first li, and now it's gone. So it's kind of annoying to do that. You'll see people do it in one go. So if I wanted to remove, let's say, just the first bold tag, I could do this. Document.query selector, b, save that to our variable, and then I'll just clear to make some space. I can do b.parent element dot remove child of b. So if all I want to do is remove an element and I have the element selected, I can do parent element of that element dot remove child and then pass in b, and there it goes. It's gone now. So that's kind of janky. I mean, that's how it's been done for a long time. But more recently, we do have a method called remove. So remove is a method we call on the actual thing we want to remove. We don't have to worry about the parent or the child. It's just remove me. So if I select something and I call remove, I don't need to pass anything in. It will be removed. It does not work in Internet Explorer. Surprise, surprise. Let's remove that image. So const image equals document.query selector image, and now image.remove, and it's gone. So I think that's better than image.parentElement.remove child, even though image is gone now, like that. I mean, that just is annoying. This makes a lot more sense. This is just the more safe way of doing it for all browsers. But for the most part, I just use this unless I really need to be concerned about Internet Explorer support. All right, so you should know the difference, know that they both are there, and that they both remove elements, but in a different way. One is removing based upon a parent and child relationship. The other is just going to remove an element, the actual element you call remove on. Alrighty. Next up, we're going to do a pretty quick demo where we just combine some of what we've seen so far around creating elements and appending them. And again, it's not going to be anything incredibly useful. What we're going to do is make I don't even know what to call this, just a bunch of images containing Pokemon sprites. And there's 100 something here. We're not going to actually create them by hand, right? We're not going to make a bunch of images and add them one at a time in our markup. Our markup is really just going to be like 2 or 3 elements where we then use JavaScript to create a bunch of Pokemon and append them to the page. So the crux of this whole thing is this image URL that I'm using. These are online on GitHub, I believe. Somebody has gone and posted a bunch of sprites for Pokemon, and they all follow this format. If I just paste one in here, at the very end, so they're all sprite / Pokemon / and then a number.png. So if you're not familiar, Pokemon have numbers. If I do something like 3.png, we get the third Pokemon, which is, what is it? Ivysaur? Venusaur, I think it is. Anyway, I type in something like 34.png. There we go. We get a different Pokemon. So we're going to take advantage of that. We are going to use those numbers to make a whole bunch of images, and each image element will have a different source with that number embedded. So it'll be 1.png, 2.png, 3.png, and then we'll append them to the page, and we'll go from there. We'll probably add on, so we'll display the number below. We might style them a bit, but really the point is to create all of these images dynamically using JavaScript. All right, so I'm going to create my new, well, I've already made it, my index.html. I've connected a style sheet, nothing in there. I've connected a script, nothing in here except for the URL. So you could copy this. I mean, you could type this yourself, or you can just download the code, and I'll leave it in a comment up top just so you have it there. So now I need to figure out how I'm going to do this, and really I need to have a place where I'm going to append all of those images. I could do it in the body, but I'm probably going to make a container, some sort of element I can append into. So I'll start with an H1, look at my Pokemon, and then below I'll do a div or maybe a section, and I'm going to give it an ID of container. We don't have to do that, but just to be more specific when I select it. Now in my script, my JS file, I'm going to select that container. So document, I could do get element by ID, but I'm going to do query selector, use the ID symbol, the hash sign for container. And then I need to loop. I mean, I could start by making a single image, const new image equals, and we just saw this, document.create element, and I want an image element. And then I can set the source, and I could start by just setting it to be this, just hard code it. So right there, and then I could append that to the container. Container dot, we can do append child or append our new image, and let's just see if we end up with one sprite showing up. I'm going to refresh, and there it is. So that does work. Now I need to repeat that process, let's say 100 times. I can't remember, I think there's 151 of the original Pokemon, I'm not sure. We'll see how many there actually are, at least on this website. So I need to use a loop, and what I want to do is replace that number with some variable. So it will start at 1, so I can write a loop for, I'm going to do a for loop because I need a number. Let I equal 1. Let's go with I less than 100. Let's do 10, just in case something goes wrong, right? We'll just start small. So I less than 10, I plus plus. Now what I'm going to do is move this logic into this loop. So I'm going to do this for each I might be 1. I'll make a new empty image. And then I'm going to set the source to be dynamic. So instead of having this massive string and putting 1.png, I think what I would prefer to do is actually move this to a variable. So I'm going to cut that up here, go with like base URL and paste that, but I'm going to delete this final part. This is the base. Everything has that in common. And then I can set the image source to be the base URL, and then our I, right, the number, and then .png. And that should do it for me. So I'm going to take this base URL and then add on that number at the end. Let's say it's 6.png or 7.png or 8.png. So I'm using a string template literal, and I'm doing that 10 times in this example, or I guess, 9 times? Let's just see if it works. Hey, there we go. So now let's increase this to, I think it's 1, I can't remember. Oh boy, look at that. So there, I think there's a bit more. I don't know. There's got to be, how many Pokemon? Let me just look it up. All right, yeah, it says 151, and Mew is the last one, and I think that's Mew right there. Alrighty, so that's the basic principle here, using a loop to create a whole bunch of images. Now let's make it a little bit better. Let's add just the number. It's nothing crazy, but let's add the number below each image or next to each image. So I'm now going to be appending more than one thing at a time. And what I'd like to do really is have this markup. So this won't work, but maybe a div for each one, and then we'll have the image in there. And then below we'll have, I don't know, a span with our piece of text. Okay, so we're gonna have a div with a span and an image together. And the number will be below that image. And then we can write some CSS, I guess, if we wanted to style it. So instead of just appending an image, I'm actually going to create a div first. So let's do that here, const, what should we call it, new, let's just call it Pokemon, because it represents the Pokemon, equals document.create element, and then we'll create our element, which will be a div. And then we can come up with, should we call this label maybe, which will be the span. So document.create element, we want a span like that. So label is this piece here. Now we need to add the inner text to that. So we can do label dot inner text equals, and then the I. We can just do that. Well, we could just set it to be the number I, and it should be turned into a string if that's all we want. If I want to put the number sign in front of it, maybe I do. We can do a hash symbol and then I. Okay, so at this point, these are not connected in any way. So I've made my image. Then I'm going to take my Pokemon div, Pokemon, and I'm going to call append child, and I'll append the image, so new image, and then I'll also append that label afterwards. And then here, instead of appending the image to our container, I'm going to append the entire Pokemon div. So it's a lot longer now. We're making a div. We're making a span. We're adding text to that span. We're making an image and changing the source. Then I am taking my div and appending the image, taking that same div, and after that, appending the label, which is a span. And then I take that div and I append that to the container. Let's see if that works for us. Okay, so it is working. Now, it doesn't look great, and I guess I used a div there. If we want to control these, they go back to sharing space. We could change their display property, right? We could come up with a class maybe, or I could just do all, in my CSS, if I just open that up, I could do something like every div, like this, has a display of inline block. That's one option. Okay, so there we go. We're part of the way there. And then maybe I want this text to go underneath in the center of each sprite. Right now they're in a div. If we look at one of those divs, and they're just one after the other. So I could just make the image have a display of block. So for now I'm just doing this in a generalized way. So every image has a display of block, but there might be more images on the page eventually. Okay, so now we have our span, which is underneath the image, right? And then I can call text, or not call, but I can set text align to be center on our div or on the span. And there we go. Now we get our numbers underneath and they're centered. Not beautiful, but it's better than nothing. So instead of just doing this, where I've set everything generically on all divs, all images, I'd rather make a class. In this class, I'll call Pokemon, and then style inside of that Pokemon class, all images have display of block. But now that's, going to throw everything off. I need to make sure that in my app.js, I give that class of Pokemon to the Pokemon div that I create. So I can do that anywhere in here, but just pokemon.classlist.add Pokemon. And now we should be creating a div, and that div has a class of Pokemon. And that's where our styles come from. So no beautiful styles, but I think that's good enough for now. This is not supposed to be a functional, stunning demo, just another demo of doing something slightly more complicated, using a loop to help us create a whole bunch of, oh, you know what? I think this should be less than or equal to 151. Let's see. I think, there we go. That's Mew, right? That's Mewtwo? No, I don't remember. Oh, it's been a long time. Anyway, there's our Pokemon. Hopefully you're still with us. You're still alive after that large section on the DOM and all sorts of properties and different methods. This is part 2 of working with the DOM events. So this is important. I've kind of set it up already in the previous section. I mentioned what events are. Basically, we're going to learn how to run JavaScript code when a user clicks on a particular button, when they hover, when they drag, when they type something, when they submit a form. Very, very important stuff, right? To make interactive applications, we need to be able to react to what a user does. With that said, there are a bunch of different types of events, and they're not all as commonly used as others, so I'm going to go through and rank what really matters. It is important to understand how events work, what they are, the different ways that we work with them and listen to them or listen for them. So add-event-listener is a particular method we'll be using a lot. Crucial, 100%, the biggest thing to take away from this section. Then we have form events, or forms events. That refers to, events when a form is submitted. How do we run code to do something when a user submits something? Definitely crucial. Keyboard events, I'm going to put under important. Not as, at least in this course, we won't be using as many keyboard events. That refers to, doing something special when a user hits one key in particular, like the space bar or the up arrow. Definitely useful. Lots of use cases, like in video games, just a quick example. But form events is what I want you to focus on. Input and change events we'll put under important, not crucial. Event bubbling and event delegation, also important, but you don't have to master it 100% before you can feel like you can move on from the section. As always, everything in here is worth knowing about. It will make you a better, well-rounded developer, and it's here for a reason, but I don't want you to get hung up on things that aren't worth getting hung up on. So event delegation is in red. It can take a bit more time to understand. It will come up later on, but it's not something you really need to panic about. Alrighty, I hope you're doing well. Let's go on with JavaScript and DOM events. Next up, another big topic. Here we go. Our anticlimactic drum roll, our lovely confetti. It's time to talk about DOM events. So events are the key for creating any sort of interactive websites, doing anything in response to what users are doing. So this comes down to responding to or running code when a user does certain things like clicking, dragging, dropping, hovering, scrolling, submitting a form, pressing a key, moving the mouse wheel, double-clicking, copying and pasting on their clipboard, resizing the screen. These are all different things that we can listen for and react to. So we can run JavaScript code when somebody clicks. When you click this button, delete something. Or when you click this button, add a new Pokemon to the page. Or here's a whole bunch of examples. Let's take a look at, here's a simple one. My favorite demo page, Stripe. We get this little pop-up here, the nav bar, where I hover or I mouse over something, and we get these new elements that are appearing. So this is not just CSS. We can add styles when you hover, but I actually took a look here behind the scenes, and I can see the JavaScript code, the events that are being listened for. Anyway, this is an example of reacting to my input. In this case, my input is just moving my mouse and hovering over something. Here's another very different example. This game 2048, I have wasted a lot of my time, not recently, but maybe 5 years ago, playing this game. You use the arrow keys to move around. So I'm hitting the down arrow, the left arrow, the up arrow. So there's stuff happening in response to what I'm doing. But that's not the only sort of event, not just the keyboard events and the specific keys that I'm pressing. We also have things like this click event. I can restart, new game. So there's code that's listening when a user clicks on this one button. So not just anywhere, right? This doesn't do it. It has to be here. When that occurs, start the game over, reset the game board, go back, let's see, does it randomize the position? Yeah. So it comes up with some position where it puts those first two numbers in there, and then it starts the score again. And yeah, so that's another example. In that case, it was arrow or key press events, moving up, down, left, and right. I think, can I also use WASD? Yeah. So I'm using letter keys, WASD, and then left and right, and up and down. Here's another example. Trello. I've shown this dummy board a couple of times. There's a bunch of events that are being listened for here. First of all, clicking. There's a click. That form is showing and hiding when a user clicks. So that's a simple one. When I hit enter in here, though, that also triggers an event. It's adding this new, card is what we would call it, to the stack. Just hitting enter there. I can click that X button to get out of here. Now, of course, I can do things like reorder shows, in this case, TV shows. This is not a real order, by the way. Don't take anything from this in terms of my TV preferences. I'm not saying dark is the best in this list, although dark is really good if you haven't seen it. So that's dragging, right? Just dragging, something happens. And then dropping, something happens where there's an actual reordering. So whenever I drop, it may not seem like there's a big difference, but something is happening behind the scenes to save that order. And now if I refresh, that order is preserved. Of course, I can reorder and drag these around. There's a whole bunch of stuff over here. These are all events, mainly clicking and dragging. And then one more example. This is Unsplash.com. We've used it a couple of times. And on their homepage, they implement infinite scroll, where as I scroll down to the end of the page, new images are loaded. So it's kind of hard to see. Let's see if I can get there fast enough. Can you see that loading icon like right about here as I scroll? New images are being loaded and added to the page. So when we have an infinite scrolling page, it's not that the page itself loads as infinitely long. I mean, none of them I don't think any of them are actually infinite. But let's say there's, 50,000 images that eventually will show up here if I keep scrolling. They're not all there at the beginning. that would cripple our browser and just be, it would be horrible. Most of the time people make it through, I don't know, 3-4 scrolls at most. I'm sure they have data on that, and that's something to track. But anyway, that's not the case. We don't end up with a massive page that loads all at once. Instead, data is loaded in chunks and new images are appended as I scroll. So let's say it's 10 or 50 at a time are fetched and appended to the page. So that's responding to me scrolling. That's a different event. I'm scrolling. So 4, 5, 6, I don't know how many different types of events that we've talked about already. Clicking versus dragging and dropping, scrolling, hovering or mouse overing, keyboard events, right, using the arrow keys. These are all things that we can listen for and react to with our code. And it's really the missing piece to combining everything. We've seen that we can create new elements with JavaScript or change elements or add styles, but it's kind of weird to just do that when your page loads or do it from the console. A lot of the time we want to do that in response to something. When a user clicks, show something that wasn't there before, or delete something. Or when a user scrolls, add a bunch of new images to the bottom of the page. When a user hovers over the menu, create a new element and display it. When a user types the right or left or up or down arrow, figure out which one they hit, and then move all of our divs up or down. Those are all things that we can do. So in the next few videos, we're going to learn how we do that. It's not terribly difficult, but there's a good amount to talk about. So let's get started. Okay, let's talk about events. We're going to start seeing some code in this video. There are 3 main ways. I don't know why I said main ways. There's only 3 ways that I know of that we can use to respond to user events, to user interactions. So let's start with a simple one, just a simple event. How about clicks? That's a good place to start. Let's run some simple code when a user clicks on something. So I'm going to show you 3 ways. And there's really one way that is preferred, but I'm going to show you all 3. So I've got a new file, new index.html, and I can actually start without a JavaScript file. I have one, but it's not even connected. So I'm going to make a button. Let's put a button in here. Let's do an H1, just events, and then a button down below. Click me, just like that. And here it is. And what I'd like to happen is when I click on this button, let's alert or console.log. Let's just do something, right? It doesn't really matter what it is because you can fill in that blank yourself and do whatever you want. The goal is just to run that code when I click. So the first option for doing this is kind of janky. It's more than kind of janky. It's very weird. And I don't recommend that you do this, but it's a good place to start. In my HTML, directly inline on the element, I can add an attribute called onClick. Now you'll also see there are a whole bunch of other ones. As I type on, I'm getting autocomplete from VS Code. On focus, on mouse up, on blur, on double click. But I'm just going to do onClick, just like that. And then inside of quotes, I can write code that I want to run when I click on this one button. So I could do like an alert. And then I do have to pay attention to my quotes, which is obnoxious, right? We're typing JavaScript inside of quotation marks. So I've got to pay attention to that. Alert, you clicked me. Okay. So my HTML is kind of gross looking now. I mean, it's not a lot of code, but still, it's weird to put my JavaScript like that directly in an element. But it does work. So I'm going to refresh, and I'm now going to click, hold our breath, and it works. You clicked me. Okay. So there's obviously a couple of downsides to this. First of all, it's just bizarre to write our JavaScript in HTML. It makes our markup longer and just more annoying to write. Plus, having to work within those quotation marks is actually kind of annoying, right? We have to pay attention, make sure we're using double quotes on the outside and then single quotes on the inside or vice versa. Also, if I want to write, multiple lines like alert, you clicked me, and then afterwards another alert, stop clicking. Got to watch my quotes again. And then I've got to put my semicolon in there. All right, let's see if that works. First one, second one. So if we do want to write multiple lines in there, I have to add those semicolons in. It's just very janky. So that's kind of more like a surface level complaint. But a more legitimate complaint, other than me saying it's annoying, is that if I want to have similar behavior on a second button, right? If I add another button, click me, 2. That behavior doesn't carry over. It's only for this button, which maybe that's what I want. But if I want the same functionality, I have to copy this entire thing and move it over, paste it here, right? And if I want to have 5 buttons that do the same thing, that's a lot of copying and pasting and duplicated code. And then if I want to change the message, so let's say I actually have a whole bunch of these, which is actually really common. Think of a website like Reddit, where I have these upvote buttons, and there's potentially dozens on a page, right? One per post, just making sure I'm signed out. I am, thankfully. And each one does the same thing, right? It does something, or it upvotes a different post, but they all have the same behavior. We could sort of express that in English as, when you click the upvote arrow, find the parent post that we're inside of and upvote that post. Or currently, I'm not even signed in, so they all do the exact same thing. They ask me to sign in or to register. So my point here is that we have a lot of those upvote arrows. They all do the same thing. There might be hundreds on the page at once. And if we use the approach that we just saw, that would not work. We would have to just write a whole bunch of logic, especially because each upvote arrow is really doing more than a single line of code. So long story short, this sucks. I should show you, though, we do have different options, so different events. We have things like on double click, just to show you that. Let's make sure that works. So I'm doing a single click, nothing. Click, I don't know if you can hear that. I'll try and do it very loudly. Here we go, click. Okay, I just abused my laptop. Now we'll do a double click, and it pops up. All right, so we have these different types of events, and we'll go more into those different types. There are quite a few, but I'll show some of the more common ones. So as we saw, this is not a great approach. In the next video, I'll show you a better approach that's still not perfect, but it's something you will see, so I can't ignore it. And then we'll see the final ultimate approach in the next, 2 videos from now, all right? So that is, I don't even know what these are called because nobody really uses them, but inline HTML event handler attributes, maybe? I'm not sure. All right, I'll see you in the next video. All right, so we saw the first option for working with events, which is not great. That's an understatement. Writing our on clicks and whatever the event is inline in our HTML, not ideal. So I'm going to show you the next option, which is done in our JavaScript, where we need to, first of all, I need to have a script that is actually connected here, so I should add that. Script source app.js. We're going to need to have some elements that we then select in our app.js using what we already know how to do, query selector or document.getElementById. by ID. So I'll add another button in here, click me, and I'll say this is second version as the inner text. And maybe I'll give it an ID. Sure. ID of v2. Okay. So we'll select that button over in my JavaScript. So document.querySelector, I'll use the ID v2, save that to a variable, I'll call it btn. Now if I just start with that, nothing's going to happen, right? We selected it, I do have a variable now called btn, and if I look at it with console.dir of button, and scroll down through this massive object, there are a whole bunch of properties here that all start with on, including on click. On double click is in here, on drag end, drag enter, drag leave, drag over, drag start, on drop. All of these right now are set to null, but I can actually change that property. Let's go with on click, keep it simple. So this on click right here, instead of having it be null, I can set it to a function. And that function will be executed whenever this element is clicked. So I can do something very simple like this, btn dot, and then the name of the property is onClick equals, and I could just write a function ahead of time. I can do what you'll see frequently is just inline a function expression, just like this. And then in here I can do whatever I want. So I can console.log, you clicked me, and then what else should we do? Maybe another console.log. I hope it worked. Sure. Okay. So this is now using JavaScript to set this onClick property on the button that we selected first. Let's see if it works. So first of all, if we look at btn.onClick, we should see it's now set to a function. And if I click, hey, it does work. All right. So this is definitely better because we're writing our code in JavaScript instead of writing our JavaScript code in our HTML instead of quotes. Also, this does make it easier to apply something to multiple buttons or to repeat this process. If I wanted every button to do this, I could select 2, 3, 4, 10 buttons and then loop over them and give each one an on click. And that's a lot better than what we saw earlier where, I have to copy and paste the code. And if I want to change what happens when you click on each button, I have to manually change it in 5 or 10 or 20 places. So we have other options too, right? We have on click. I could also say on this button when you, let's do on mouse over. So I'll show you some of these other events here. Let's take a look at, I'm on MDN here, HIJKLM. Okay, let's do mouse enter. So a mouse enter event is when a pointing device, typically our mouse, is initially moved so that its hotspot is within the element at which the event was fired. Basically, right there, well, here's a mouse enter, here's a mouse leave, mouse enter, mouse leave. Okay, so we'll do that. We'll do an on mouse enter like that. And we could write a separate standalone function first, like function, I don't know, scream. And then inside of here, I'll do a console.log, and then another console.log, stop touching me, okay? And then here, button.onMouseEnter is going to be scream. Now, this is something I see a lot of people get confused about. We're not executing scream. I'm never executing that function, myself at least. Same thing with this right here. I'm defining a function. It doesn't even have a name. It just exists for the sole purpose of being called eventually when this button is clicked. But I'm not the one calling this. I'm not the one calling scream. I'm simply passing it to on mouse enter or to on click. I'm setting it. And then when a user clicks, if they do click, or if they mouse over, if they do, then scream will be executed, or this nameless function will be executed. So think of it as, we spend a lot of time talking about higher order functions and how we can pass functions as values and as arguments. We can return functions. We can set them as properties on objects. That's exactly what we're doing here. We're not executing it. We are just setting a property to be a function. So whatever is in here will be executed. Let's try it now. I mouse over. There we go. Stop touching me. And then I click. We get you clicked me. So here we're working with two different events, which is totally fine. Often that we have more than one event, even on a single element. And that's pretty much it for what I want to show you in this video. So we have a whole bunch of these properties, right? It's not just on click. So you can see on the docs and MDN, we've got a whole bunch of on properties, and we can set these. And in fact, I'll just quickly show you with this first one where we did it inline, right? I didn't use any JavaScript. This button has its on click set inline in the HTML. If I take a look at that object, so the corresponding DOM elements, I'll just do a document.querySelector. It's the first button, so I'll select that. Const button 1, and then we'll look at console.dir button 1. You'll see that what actually happens is this on click property is set to a function. And this function does some stuff, right? And it's coming from our HTML. That's actually where it's defined. It has this thing called function location set to index HTML line 12. Well, let's look at that. Line 12, there it is. Index HTML, this is the function. Well, I didn't actually define a function here, right? This is not a function, but it's turned into a function for me and set to the on-click property, just like I did in my JavaScript file for the second button. So this is a different approach, but at the end of the day, this does result in the on-click property also being set on the DOM element, and both of them do work. This is just clunkier than our second version, which is all done using JavaScript. Now, the last thing that I'll mention here while we talk about events like clicks and mouse enters, we've been working with buttons, but we're not limited to doing that. I could add an event to this H1. I could listen for a click on an H1 if I wanted to. It's not that common to do it on an H1, but I can select that. So document.querySelector H1, just take the first one, dot on click equals, and then in here we'll just do something super simple. Alert you clicked me, or you clicked the H1, okay? Just like that. And remember, I do need to wrap it in a function. Even if it's just one line of code, I can't do this. Why does this not work? Well, this code will just execute right away. I'm running a function. That's very different. What I'm supposed to do is set the onClick property to a function itself. The value should be a function. It should reference a function. It should not just execute one right away. So we wrap it in some sort of function. You could also use an arrow function if you prefer. I'll just use that as a quick demo here. There we go. I could even do it on a single line, but that will get a bit long. All right, so this is an H1 now. I didn't bother saving it in a variable, but we're adding or setting that onClick property. And there we go. So I just didn't want you to get the impression that we can only do this. Oh, I moused over. I didn't want you to get the impression we could only do these click events on buttons. We could really assign them to any element, although there are some that make more sense than others. And buttons are pretty much at the top of the list for things that you want to click on, that users will click on. So those are two approaches. Now we still have a third that I promised. I saved the best for last, so that's in the next video. Okay, bye-bye. All right, everybody, on to the main event of this section. We're talking about the best option for working with events. It is a special method called add-event-listener. So I'll go into detail as to why this is better than what we've seen before, but let me just show you how it works. So we need to select an element. This is all done through JavaScript, just like the previous version, right, where we did things through JavaScript, but using properties like onClick or onMouseEnter. Instead of doing that, we're going to select elements and then use a generic method called add-event-listener. It's like the Swiss Army knife of events or event listeners, where we can then pass in any sort of event we want to listen for, a click, a double click, a mouse enter. We just pass in that string, and then the second argument is our callback function, the code that we want to run when that event actually happens, when it occurs. So let's add a new button in here. Let's just duplicate this. I'll call this one V3, and this will say third version. All right, so I'm going to select that in my script. So document.query selector, and then the ID is V3. You can save that to a button, save that to a variable. I'll call this btn3, and then btn3.add event listener. And then what am I listening for? That's the first thing. We'll just do a click, nice and simple. And then the code that I want to run when a click occurs on button 3. So I can use an arrow function or just a regular old-fashioned function expression. And then this is exactly the same principle. Whatever code is in this function will be executed, right? I'm not running this code, but it will be eventually executed if button 3 is clicked. So we'll do a simple alert clicked. Okay, let's verify that it works. So I'll refresh and I click, and there we go. Now I could change the, I could do double click, for example. I think that's how you spell it. I can never remember. Yeah, it's always seemed weird to me. Why do we spell double in a shorter, more abbreviated form, but click is normal? I don't know. It's weird to me. But anyway, that's the name of the event. And if you ever need to find a list of the different events, you can go to MDN and there's this event reference, and there's a whole bunch of different types of events that you can work with. So we have things like, key up and key down, mouse enter, mouse down, double click, click. We really don't need to go into all of them. Also, not all of them work on every element, right? A key press doesn't necessarily work on a button. But anyway, here they are. Let's just do one more. How about a mouse? Let's do a mouse up, just to show you there's these different stages in a click. There's the mouse down and then the mouse up. So I've now said only on mouse up. So I'm going to click. I'll try and do it loudly. Here we go. Okay, my mouse is down. Now when I release, our mouse up event fires and we get clicked. So I'm going to undo that, but just wanted to show you, right? We can change or swap in that event type. It's just that first argument must be the type of the event. The second one is our callback, the function we want to run. And just like we've seen before, this could be a named function that I define on its own, like scream, and I could pass scream in instead of doing an anonymous function, just like that. Now I'll click, and we get, stop touching me, and that's coming from scream. All right, so why is this better? It seems a little bulkier. Some people think, well, I can understand this on click. That seems more self-explanatory. It's cuter. Why do we need to do add event listener click? So there's a couple of reasons. The first one I'll show you here is going to require a quick example. So I'm going to define two functions. One is going to be twist, and the other one will be shout. So twist is just going to console.log twist, and then I'll just duplicate this. We'll have shout, and that will console.log shout. Okay, nice and simple. Now, if I wanted to create a new button, I'll just do it at the very bottom here. And maybe I'll do this. Yeah, I'll just do it like that. Button. And it will say twist and shout as the text. And then I'll give it an ID or something to select it with, just to make it easy. How about twist and shout? That's not very self-explanatory. But sure, twist and shout. All right, TAS. So I'm going to select that over here. Const twist and shout button equals document.query selector, and then our ID TAS. So when we click on this button, I'm going to start with an onClick, that onClick property. I'm going to set it to be shout, right? So if I click on that button, we get shout. All right, so that works. Now, I also want to call twist, which is a separate function. So I want twist and then shout. So I'm going to just duplicate this and do the same thing, but set it to be twist first. All right, and I run this. Well, we're only getting shout. So what's happening here is that we can't have more than one. It's just a property on click, just like any other property. If I have an object and that object has a property called, color, and it starts as purple, pretend that's a valid string, and then I change it to be red, we've lost purple. That's just overwritten. It's the same exact thing here. This is just an object. It has a property on click. I start it out as twist, and then I say, never mind, it's actually shout. So this is a long-winded way of showing you that we can't have two different callback functions for the same event, at least not using this property method or this property approach. If I instead do add event listener, I can do the same thing. Add event listener, click. I don't know why that keeps blocking. Never had that problem. All right, click, and then twist will be the first thing. And then I can duplicate that, and shout will be the second function that we run whenever a click occurs on this button. This allows us to have as many different callbacks as we want. And there we go, we get both of them. So that's one of the big advantages. Now, never mind the fact that I could have just combined these two into a single function, right? If I want both of them to run every single time. But there are situations where you may have more than one click event or more than one callback that you want to run when something is dragged or dropped. And it doesn't make sense to combine them into a single function. So that's just one thing I want to highlight. One of the reasons add event listener is better. Another reason is that with add event listener, if we go back to the docs here, there are actually a whole bunch of other arguments we can pass in, different options. And this options object can contain different options, including things like once, which I really don't use frequently, but I'm just going to show it to you. If we pass in, after the callback, if we pass in an object, and I set once to be true, this is now going to run this callback once, only the first time that this event occurs, and then it actually removes the event listener entirely. So I'm going to click, it runs one time for twist, and then every subsequent time, that event listener is gone, and now we've only got shout. So I could do the same thing for that second one, and now it only runs once, and now nothing happens. Okay, so not that commonly used, but that is just that's sort of proof of the fact that we can pass in these options. There are other options, but they do require a bit more explanation. Things like capture, we're not going to go into that right now. Same thing with use capture. But long story short, there's a lot more flexibility that we have when we use add event listener. There's a reason. We have more control over how the event listeners work and when our callbacks are triggered. Also, there is a companion method, which is called remove event listener, which we can use to easily remove event listeners, which right now is overkill. We don't need to do that. But on complex apps with lots and lots of events going on and lots of event listeners, it can be, things can get bogged down. And you can have performance issues if you're not managing those events or those listeners. So you can remove them if you add them with add event listener. So those are just a couple of reasons to use Add Event Listener. Also, there's just the fact that everybody uses it. So I know that's a horrible defense of it, or horrible reason to give, but it is what you'll see the most. You might see this occasionally, but Add Event Listener is by far the most commonly used, and it's just the option you should go with. So even if you think this is cuter, don't do it. Use Add Event Listener. Pass in whatever type of event you're listening for, and then the callback function. Often it will be an inline function, a function expression, whether it's an arrow function or just a old-fashioned function expression where it's anonymous, it's not predefined, but there's nothing wrong with doing this either, of creating a function first and passing that in. Just remember, we're not executing this, we're not executing that. Two different ways of just defining a function that will be called later by the browser, by JavaScript, if you will, when we click on this button. Okay. All right, so it's time for a little bit of an exercise, a pretty simple project. I don't want to call it a project. We'll call it the random color changeo. So you click this button. I shouldn't have said click me on the H1. It doesn't matter what you have here initially, because as you'll see, it's gonna change immediately when I click this button. We're going to get a random new background color, and the H1 now displays that new color. In this case, I'm using RGB colors because they're the easiest, in my experience, to randomly generate. It's just 3 numbers from 0 to 255. So that's kind of all there is to it. Just like that, every time I click, I get a new color, and I'm showing that color up top. So I'm updating the background color of the body, and I'm updating the text of this heading here. So you don't have to recreate this exactly. You also don't even have to do this as an exercise. I'll show you how I did it. It's nothing crazy. It's just, 10 lines of code or so. Probably the most annoying part is generating the random color, but otherwise it's pretty straightforward. So let's do it. Okay, so I've made a new folder with an index.html and an app.js. And we need to start, obviously, with a button. Click me. And then we'll have our H1 or some sort of heading to display the color, the actual RGB value. Let's have it start with welcome, and then we'll update that. Now we could give each of these an ID, but because this is the extent of the markup, I'll just keep it to H1 and button just to make our selections simpler. But in general, for a larger project, you definitely don't want to select purely by element type. But that's exactly what I'm going to do, just for simplicity's sake. So I need to be able to run code when that button is clicked. So I need to select that button for sure. And we'll just do a document.querySelector button. And then when we click, so I'm going to use Add Event Listener for click as that first argument, and then my callback in here. I always like to start just to make sure things are connected. So I'll do a console.log click, or really anything in there, and make sure that shows up when I click. Okay, so that's a good sign. Now, what we actually want to do is generate a random color, and then set the body to have that random color. So I could simplify that further and just ignore the random color part, and just change the body's color once. So let's pick a color like, olive, great color. And I'm gonna give the body that background color. Now we talked about how generally, we don't want to be modifying styles using the inline properties in the DOM. Usually, if we're doing a lot of styles at once, we create a class in a CSS style sheet and we apply that class. But that doesn't really work if we're randomly creating a color, right? It's just not easy to do it. We could predefine like 10 different color classes, but we can't define random CSS classes. So instead, what I'm going to do is just set the background color property on the body. Now to access the body, I can do this. I can do document.querySelector of body. That's the element. And that does give me the body. But there's a shortcut. I can just access document.body directly. So that's what I'm going to do. Document.body. So when you click, .style, .background. And remember, it's camel case. So that's not it. That is it with capital C. And I'll just start it as olive. Or I'm not starting it as olive. I'm going to change it to olive every time you click. But we'll only see that change happen once. So refresh the page, click. Beautiful olive. Okay, so that's working, right? Now that we've simplified it, let's build it back up and actually generate a random color here. So to generate a random color, we really need 3 random numbers, RGB follows this format. One number from 0 to 255, let's say 200, another one from 0 to 255, and another number separated by commas in between parentheses prefixed by RGB. So we need to generate 3 random numbers from 0 to 255. Well, we know how to do that, hopefully. We can do this. I'm going to call them R, G, and B. So R is a math.floor of math.random, right? And that gives me the decimal from 0 to 1. Unfortunately, I'll multiply it by 255. And then I'm going to do that 3 times. R, G, well, I guess I can do B first, but I want to do G first. I don't know why, just to keep it in a pattern. So R, G, and then B. Then I need to build that up into a new string. So I'm going to use a string template literal. I'm going to write RGB and then parentheses. And then I need to fill in the actual value for R. And then a comma. And then another $ curly braces, the value for B. And actually, I already went out of order. It technically doesn't really matter, does it? Right? It's just 3 random numbers in a row. But if I want to be consistent, I'll put G if I'm saying that represents green. It needs to go second. But again, it doesn't matter really. So RGB. And then parentheses on either side. I'll save that to a variable, const new color. And then I'm going to set the background color to be that new color instead. Not just olive, but new color. And let's see if it works. It appears that it's working. Okay, so now I want to update this H1 to have this new color as its actual text. So I need to select the H1, const H1 equals document.querySelector H1. And then to update the text, the easiest way, I just want to overwrite and erase whatever's currently in there, is just h1.innerText or text content equals that new color. And there we are. Cool. Now what I'd like to do is move this into a separate function. This is long enough where we could easily make a function called random color. So I'm going to do that down here, const random color. We can do an arrow function. It doesn't really matter, but that's nice and short. And then in here, I'm going to repeat this. I'm not going to repeat it, but I'm going to copy this, put it here, and I'm going to return that new string. So now here I can just get random color. So what did I call it? Just random color, maybe make random color or make rand color. Okay. I'm going to execute that and save that to my variable new color. So I've just moved it into a separate function. If I want to reuse it somewhere for something simple like this, it really doesn't matter, but it's just a good practice to get in the habit of. Anytime we have some functionality that could stand alone, like make random color, that's a clear, distinct thing that we're doing. I like to move that into a separate function. So there we go. Make rand color. I'm calling it. I'm saving it to a variable. I'm updating the background color of the body, and I'm changing the inner text of the H1 every time you click on the button. Let's verify. Okay. And then if we wanted to, right, we could style this. You could center everything. You could change the font, make this all larger. That doesn't really matter, but feel free. One fun thing you could do, if I can try and find an example of this, sometimes if the color is very dark, of course none of them are very dark right now. Come on. Come on. Well, I might have to fast forward here. Aha, I found one. Okay, when the color is very dark, we can't read that, right? So one thing you could do is write some code to change the color of the text depending on the color itself, this RGB color. Basically a lower number, right? 3 low numbers like 11, 7, and 17, that's closest to black. Black is 0, 0, 0. So you could figure out some threshold where maybe you could sum them together, and if their 3 values are greater than, I don't know, 50, 100, whatever it is, you could give it a white color. The text could be white, otherwise keep it black. Just a little bonus thing. Alrighty, next up, the return of our arch nemesis / best friend, depending on who you are, the keyword this. So we're going to talk about how the keyword this comes into play when we're working with events. So I have a quick demo here. Right now, there's nothing really to look at. Well, I guess there's things to look at, but they don't do anything. I have, I don't know, 30, 40, 50, I can't estimate, buttons here. And I've made them a bit larger. I just did some inline, or not some inline, but a style tag in my HTML file just to keep it short and simple. So they have some width, some height, and some margin. That doesn't really matter at all. Otherwise, they're all just buttons with the text of click. Now what I want to do is when I click on each button, I want to give that button a random background color. So I'm going to start by just making sure I can click on each one and something happens. So I have this function we wrote earlier a couple videos ago. I'm just going to leave it and ignore it. For now, I'm going to select all buttons. So const buttons equals document.query selector all button. And then I'm going to loop over all those buttons. For let button of buttons. I'm going to do a very simple event handler first. So button.add event listener click. Sorry, I don't know why that thing keeps popping up in the... Usually it goes down instead of to the right, but it's blocking everything. All right. And then our callback, there we go, once again, our function in there. And I'll just start with console.logging clicked. I just like to do that to make sure everything's connected correctly. We should be seeing clicked. Okay, good. So every single button is going to console.log clicked. It's the same exact thing. But now what I want to do is actually change the background color of each button. So I do have this make rand color, so I can use that. And all that I need to do is figure out, well, how do I reference the particular button, the one button that was clicked? Well, right in here, I do have access to button. We're inside the loop. I could use button dot, style, background color. That's what I want to change, equals make rand color. So whichever button you clicked on, let's say it's the second button. So for let button of buttons, we did it the first time, now we're on the second one. Second button.add event listener click. When you click on that, change second button style background color to be a new random color, right? This is a variable. It holds each individual button as we're going through. We're adding a click listener to each one at a time. So that should work for us, and it does. All right, so I'm getting a random color on that, only the button that I'm clicking each time I click on a single button. But what I want to show now is, what if I wanted to move this into a separate function? So maybe I'd want to do that, like if I had a bunch more logic. This is just a single line of code, but also maybe I have some other things that I want to change the change the background color on. What about, I'll just do, what should we do? H1s maybe? It's a bad use of H1s, but let's just make something obvious, and they'll say click me, all right? And I'll make a bunch of those. We don't really need a whole lot, but let's say I have that many H1s. So there they are right there. I want to also be able to click one of those and get a random background color. So obviously I could just do the same thing. We're going to have some duplicated logic. Const H1s equals document dot query selector all. And I just want to emphasize one more time, this is not a good use for H1s. Those should be spans or paragraphs or really anything that is not a heading element. You should only have a single H1 on a page, but we're ignoring that. This is simple. So then I need to loop over each one. For let h1 of h1s, h1.add event listener for a click. Then I can do the same thing and do h1.style, dot background color equals make random color, right? Or rand color. Let's see if that works. Okay, so we're getting the random background color there, and this shouldn't change. It still works on the buttons. Now let's say I decided I also want to change the text color. So that is button.style.color. And I want a random color for the text. It's a bit hard to see, but we're getting like a bluish purple, now a cyan color. So we're changing both the text and the background color. And I want the same thing for my H1. So H1, whichever one you clicked on, .style.color equals make rand color. Okay, so let's just verify that's working too, and it does. So at this point, right, it's still just 2 lines of code, but let's say I've decided this is just too much to duplicate. I'm doing the same thing. The only difference is that I'm doing it to a button versus to some H1, but it shouldn't matter. It just should be some element, and I'm going to make a generic function that will do that. But if I write a function, we'll just call this, colorize. How is this going to work? I'm not going to have access to H1 or to button. This is going to be a generic function. And what I can do instead is use the keyword this. So inside of an event handler callback, so that function there, this function here, the keyword this is going to refer to whatever was clicked on, in this case, that triggered this function being called. Or if we had another event we were listening for, a key down or a drag or something, wherever that event occurred on, the keyword this will refer to that element. Now remember, the keyword this is dependent, or it depends upon the execution context or the invocation context. So that's not a hard rule that the keyword this will always refer to the element. There are ways of changing the keyword this inside of your function. But in general, right, if I just replace the keyword this, or replace h1 with the keyword this, I could even just console.log this, although it's not going to be very illuminating, I don't think. Let's see. Oh, actually, I guess it does stand out compared to the others because it has the background color and the color set. So the value of the keyword this is the exact h1 I'm clicking. So I could replace this with the keyword this. I could replace button with the keyword this, right? And everything should still work just fine, and it does. But now I could move this to a completely new function. Like I have already started here. I called it colorize, and then I can delete all of this here and simply say, I want you to call colorize for me. And same thing here. I want you to call colorize whenever this thing is clicked. So it doesn't matter. I don't need the name button or h1. Those are just variable names I made for my loop anyway. JavaScript doesn't care about that. It doesn't know that it's a button or that it's an h1 based upon this name. That's just us reading it. But because I use the keyword this function will work for both of these as the event callback. Let's just verify. Always good to double check that. So I click, yep, everything still works fine. And down here, still works fine as well. So again, this is a pretty simple example in terms of the 2 lines of code. It's not a huge deal to have it duplicated, and that's not the only reason you should be aware of how the keyword this works with events, but this is just a simple way of illustrating it. The keyword this, when you have it inside of, or you're using it inside of a callback that is invoked by some event handler, it's a fancy way of saying, the function that's called when you click on something, the function that's called when you drag something. This will refer to that something that was acted upon or interacted with, whatever the event was triggered on. Okay? So we'll be using that later on. So next up, we need to talk about 2 topics that are kind of related. The first one is called the event object, and then we'll cover keyboard events. Okay? So let's talk about this event object that I've mentioned. I'm going to start by just adding a single button in here. Click, we'll select it. Document.query selector, not all, just query selector. Button dot add event listener, click. All right, I'll add my callback in here, and I'll alert click when we click that button. So here we go. Okay, nothing crazy. Now there's this thing called the event object that is automatically passed in to our callback here, this function. We're not using it, we're not capturing it, there's no parameter here to capture it, but it's being passed in every single time. So I can capture it, I can put a parameter in here. Often people call it event or E or EVT. I'll go with EVT. And then I'm going to console.log that. Console.log EVT. So this is a thing I didn't make, right? It's an object constructed for me, and it contains information about the object. So here's what it looks like, at least for that click. It's called a mouse event object in this case, and it has things like client X and client Y. So that is relative to the window where I clicked. So think of it as coordinates, 25 and 20. We have things like the event type. We have something called the event target. These are things we'll actually come back to, some of them, over the next few videos. Long story short, though, this is an object that contains information about the event. So if I click on the far right side of that button, we can see client X and Y are 59 and 12 versus on the far left, right, we got 8 and 12 or 8 and 10. So small difference, but there is a difference there. And if we ever needed that, let's say we wanted to, add a nice animation or a highlight or just click and have something appear on the page where you clicked, we could use this event object. Now, the reason I'm showing it to you now is that we often need to rely on the event object when we're working with keyboard events, because frequently we want to know what key was pressed. And that information is included in the keyboard event object. So I'll show you that now. We can listen for keyboard events on the entire window. Like if you're making a game and you wanted something, I'm hitting the arrow keys right now. If you wanted to do something when I hit the arrow keys, or we can listen for keyboard events in a particular input. So we can do that first. Let's add a single input. Type equals text. Over here, I'll select it. I'll save it to a variable this time. Const input equals document dot query selector input. And then input dot add event listener. And there are two different events we can listen for. Well, there's more than that, but two that I'm going to show you. There is a key up and a key down. So let's start with key down. And then our callback. And I'll console.log key down. So this is on the input. When a key down event occurs, print key down. So I'll refresh. I'll open up my console so we can see that. And now if I press a key, so here we go, A. I just pressed A and A again, right? Pressing it a bunch. And that event is firing and we get key down. So it's when I press down. Then we have key up. I'll duplicate this, a separate event. And I'll print out key up. All right, refresh. So I'm going to press down and up. It's a bit hard to convey over video, but I'll try and do it loudly. So down, up, down, up. I'll hold it down, and you'll see that key down continues to fire after a certain delay, and then I get an up when I release. So down, I'm holding it down, and I'm going to release up. There's our key up, okay? It also is firing these events for, I'm hitting the arrow keys right now in that event. We don't actually, or in that input, we don't see anything showing up, right? That's not creating anything in the input here. It is simply navigating, but it does qualify as a key press or a key down / key up. Same thing with shift or tab. Those are all considered, in this case, they're valid events. They are just a key up or key down while I'm in that input. So just to be clear there, the key up and key down events, they don't correspond to typing in this input or to affecting a change in the input. I'm hitting the command key, and that's counting as key up and key down. So there is a different event we'll listen for when we talk about forms and inputs and all of that. But for now, we're just working with key up and key down. Okay, so a lot of the time we want to know what key was pressed. So to do that, we need to use the event object. So I'm just going to focus on key down for now. And I'm going to put that parameter in there. Remember, name it whatever you want, but usually E, event, EVT. It's passed in automatically. I don't make that. I'm never calling this function anyway. It's called for me, and that something, that object is passed through. So I'm going to print out E here. All right, and now I'm going to type just a single one. Let's type Q. All right, now we get this keyboard event object. So different than this mouse event object. They both contain information about the respective event, but they're different events. So what's on this keyboard event? Well, what we care about are two things here. First of all, one called code, one property called code, and another called key. All right, so I'm going to just print those two out. So e.key and e.code. Refresh, and now I'm going to type, let's do A. Okay, so the key is A, lowercase a, but the code is key A. Or let's try another one. Let's hit space. All right. The key is a space. It doesn't look like a space, but there is an actual space there. And then the code is the word space. All right, so this can be a point of confusion. I'm going to type another example. I'm going to hold shift, okay? So the key is shift and the code is shift left. There's a right shift on my keyboard as well, right? I'm going to hit it there. So the key is the same. It's just shift. It's think of it as the end result. And then the code is the actual, the location on my keyboard. It's kind of confusing. You would think key would correspond to the keyboard location, but it's actually code that does. So if you ever get confused like I do, just print them out and take a look in the object. So you can use either. It really depends on what your goal is. So I just did backspace there. Because if we care about the character that was generated, let's say I want to know if, the letter A was typed or the letter C, then we can use key. But if I care about the actual key that was pressed on the keyboard, the location of it, then I can use code. And those can be different, right? A user can change their language settings on the keyboard. So the same exact keyboard I have right now, I'm pressing the letter Q. On an English setting, that's Q, but I could change it to another language, and it might be a completely different character, but the code will always be key Q. So if we care about the position on the keyboard that somebody types something, for example, if you're making a game and you want the arrow keys, or you want WASD, which is used often for navigation, up, down, left, and right, then you would use code. But if we actually want the letter W, A, S, and D for something, or we want actual letters, and we don't care what key was used to generate them, we don't care where on the keyboard, then we could use the key here instead of the code. So it really depends. I'll show one more example here. Often if you're making a game or you want something global, so you want to listen for key down or key up, not in an input, but just anywhere on the page, we can do window.addEventListener. Usually I end up working with key down. Here's our event object, and we'll console.log event.code, because I'm not actually making a game, but say I am. So I'm not in the input, or I can be, but I'm not. I'm going to hit the right arrow, up, left, and down. So I'm looking at the code, which is think of it as the code on my keyboard, the location. And somebody else might be using the same keyboard with a different language setting, and they might be different, but I still want them just to use these keys for navigation. So I'll do up, down, left, and right. And then I can write some code in here to check. Let's say any other code, I don't want to do anything. So any other letter that they press on this keyboard, I'll ignore. So I could use a switch statement, switch, and then key.code, or e.code rather. And then I can have my case, arrow up. Yes, you have to capitalize that correctly. So let's do up first. We'll just console.log up. Let's just see if that part works. So I'm pressing everything, nothing happens. I hit up, and it does work. So then I can do one more example here. Case, arrow down, console.log down. You can see where I'm going with this. So I'm pressing a bunch of keys, nothing happens, but I hit up. Oh, I forgot to break out of there. Okay, I just finished the code here. I just fast forwarded, magic. So we have our breaks in there. We got our switch statement. We could do this with a typical conditional if, this, else if, else if, else if. So I'm just printing up, down, left, or right if you hit one of those arrow keys. Otherwise, I'm printing ignored. So let's try it. I'm going to hit up, right, left, down. So that's working. But I'm going to hit other keys. Space, letters, enter, caps lock, tab, it doesn't matter. They're all ignored except for my arrow keys. So I could use those now to do something. All right, so to recap, the event object is something we have access to in every event handler. It's passed in automatically. We're not calling this function, but when it's called for us, it's passed in. We can add a parameter in there to capture it, name it event or EVT, something that's easy to figure out what it is. And it contains properties, information about the event. This is not the only time we will see it. It's very useful. And it depends on the event that we're working with. If it's a click or a key down or some other event, that determines what information is part of that object, what's included in it. So with keyboard events, with key down and key up, we have the key itself, which is the letter or the character or the thing that was generated, the end result, versus the code, which is the code that corresponds to an actual location on the keyboard, an actual little physical key, which is kind of confusing. It seems like, that would be key. I don't know. The naming's not my favorite. But anyway, those are two things that can be very useful. It depends on what you're trying to do and what you're trying to accomplish, what you want to listen for. Also, we saw that we can listen for those events both on particular inputs as an example, or on the window as a whole if I'm making a game like this horrible game here. All right, bye. So next up, we're going to talk about working with forms. Obviously, a pretty important part of creating web applications. We usually have some forms, and we want to do something when the user submits those forms. Now, just to recap how a form typically works without JavaScript, let's just make a form. We specify an action, which is a URL, a location that the data should be sent. And we haven't really, actually, I shouldn't say we haven't at all seen what we do with the data. We haven't seen anything around creating servers and, receiving that data. So for now, if I put something in here like /dogs, and I'll put two inputs in here. Let's have our first one. And for brevity's sake, I'm going to ignore labels, although you shouldn't do that. I am going to give each one a name. So name will be, let's do username and then a password input after that. Type equals password. And then I give it a name as well. I'll do password. And then finally a button to submit or log in or something, register, whatever we want to say there. I don't know why I'd go to /dogs, but it does. So here we are. Here's my form. I put my information in there. Let's say my username is Colt. My password will be taco popcorn 123. Okay. I click register. Remember, no JavaScript is involved, and it submits my data to /dogs. And that should hopefully be recap at this point. Whatever that action is where our data will be sent. Now, what we're going to do is use JavaScript to stop that and instead do something with the data on the same page. So the default behavior is for that form to submit and for the page to reload and take me somewhere else. I'm going to say stop that. Please don't do that. And give me the username, give me the password, and let's do something here locally. Now, we don't really have, in this video, we're not going to do anything crazy, but I'm just going to show you the steps that we could use to work with forms to make something like that work. So that we could do, commenting. You've probably seen this before where you can comment on a post. You hit submit or add comment. It doesn't change the page you're on. You're not going to refresh the page or go somewhere else. Instead, it just appends a comment to the bottom of the page. So actually, maybe instead of username and password, let's do username, and this will also be a text input. Let's make this a comment. We'll call this comment. So let's add a placeholder. Username. And then maybe actually, I can't decide. Let's call this tweet, all right? And then placeholder here will be tweet. And then here we'll just go with post tweet. All right, okay. So nothing new there. Now what I want to do is when a user submits this form, I want to just run some basic code to start. Like I always do with events, I always want to start with just making sure something is connected and working. And in this case, the event that we need to listen to or listen for is a form submission. So I'm going to select the form. And I only have one form on here, but I may have more than one in the future. So let's give it an ID. We'll call this tweet form maybe. And then select that, const tweet form equals document.query selector, and then ID symbol or hash sign tweet form. All right, and then the event I'm listening for is a submit. So tweet form dot add event listener. When that form is submitted, we have our callback. Maybe we want the event object. We probably won't use it here. And then why don't we just do a nice little console.log, or how about an alert submitted or submit. So let's just verify that it works, right? So I'm going to refresh. I'm going to put something in here and submit the form. It says submit. Okay, cool. But then I end up on this page. So if I wanted to do anything after that, if I wanted to, if I replace this with a console.log, just as a quick example, and do it again, submit, that console.log just disappears. It shows up for a second. You can probably see it really quickly, and then it's gone. Well, why is that happening? Because we are still moving to the next page. There's still a request being made behind the scenes. We're not stopping anything. We're simply saying, oh, by the way, right after you have been submitted, do this. So if I had more logic in here, like if I wanted to take the tweet text and the username and I wanted to append it to the page as an example, I'm kind of out of luck because we're going to be on to the next page. My whatever logic I have, whatever DOM changes I make are kind of all for nothing. So what we need to do is tell JavaScript, tell the browser, please don't do that default behavior of taking me to /dogs or whatever the action is. And you might think we could just get rid of action, but then the action just defaults to the current page we're on, which will refresh the page. So that doesn't work either. So what we want to do is instead, in my JavaScript, in the callback here for my event listener, we have that event object. On that event object, there's a very particular method called prevent default. And this is going to prevent the default behavior that would happen as a result of this event. So when a form is submitted, the default behavior in that case is for a request to be made to the action of the form, for the data to be sent. But now with prevent default, which again is on the event object, so it's not just prevent default in general, it's e or event or evt.prevent default. So try that now. Same thing. And there we go. We submit, or the event was triggered. We prevented default, we console.logged, and we're on the same page and nothing happened. So now what? Well, if I want to use this information from the form, and let's do something very simple. Let's have maybe a UL down below, and H2 just says comments or tweets. All I want to do is append that new content as an LI in this UL. So I'll just add maybe an ID here called tweets. When you submit the form, I want to take the data and add it as a new LI inside of that UL. So we need to figure out how we extract that username and that tweet text here. And to do that, I don't think we've talked about the value attribute on inputs, but I'm going to show that here. So let's say this is my tweet. I hate, I don't know, raw chicken. Okay. And I'm going to select this input just as this demo. So how would I do that? Well, it is the second input of type text. So there's a bunch of ways of doing it. I'm just going to be lazy and do query selector all inputs, and then say, give me the second one. Okay. Now on this particular object, on this element, there is an attribute called value. And value for every input corresponds to whatever is in there. So if I were to change that, by the way, to no, I don't, like that, there we go. I just updated what's in the input. So that attribute value, we could also access through get attribute, as we've seen before, or set attribute. But this is a shorter way of doing it. We have a direct property to access it. So what I want to do, when you submit the form, I want to take the value from this input and from that input, and then make a new LI down below, and I'll refresh the page, on my tweets UL, a new list item that has your username and the tweets, and we'll go from there. All right. So one option is to select those inputs ahead of time, or just directly in here, right? Const, I could do username input equals document dot query selector all. I'm going to change this in a moment, so bear with me, but I could do something like that to get the first username input, and then to get the second input, which is the tweet input, I could use index of 1. And then why don't I start by just printing out their value? So console.log username input dot value, comma tweets input dot value as well. Refresh the page. So my username will just be Colt again. My tweet is LOLOLOL. Post the tweet. There we go. We're successfully getting those values out. So then I could take those values and do something with them, right? And make a new LI and append it. But what I want to show you here is that if we have more than, let's say, 2 or 3 or 4, if we have a lot of pieces of information in our form, it can be kind of annoying to have to select every input individually. So we also have on the form object itself, on every form element, so I'm just going to select, let's go with, I already have tweet form in a variable. If I look at it, console.dir, tweet form, I actually have access to a property which is called elements right here. An element is just a collection of the form elements in there. And what's extra nice, it is an ordered collection, so I could just say, give me elements of 0, elements of 1, but that all depends on the order. So if I swap the order there, all of a sudden elements of 0 might be the tweet instead of the username. But if I give my elements, my actual inputs, a name, as we talked about earlier, way earlier when we learned HTML, that name is actually set up as a property name in elements. So I can ask for the form.elements.tweet or .username or whatever that name is, and I can quickly get to the input itself. So instead of doing this right here where I have to select each one, I can instead do whatever the form is, which I could use tweet form. I could also access just this. I'll do tweet form, I guess. Tweet form.elements, and then if I want username, assuming that's the name, I can save that. So I can print that out, console.log tweetform.elements.username. I'll get rid of what I had before. And we should just make sure we see that username. And, oh, I printed out the entire element, right? We want the value. So I can do the same thing to get the tweet, assuming I have a named input with tweets. So this is just an easier way to go from a form to the elements and their values that are contained inside of that form, rather than having to select the forms from scratch. Okay? So it's just a nice way of accessing the two inputs, or if we have 10 inputs or 20, and we can also iterate over the elements. If you, I got rid of it here, but if we look at it, tweetform.elements, it's this collection where there is an order, and I can iterate, or I can access by name, tweets, and username. Alrighty, so I can get the value from each one of those and do something with them. I'm going to make a new li. So I'll just go nice and simple here. Let's grab those two values. So we don't need to console.log them. Let's do const, what should we do here? Username equals that, and const tweet equals that. And then I'm going to make a, this needs to be .value as well. It looks like I butchered this here. It needs to be .tweet.value. All right, now I'm going to make a new li. So const new tweet equals document.create element. I want an li. And then how do I want to format this? I think what I want is a bold tag with the username. So I'm going to do const, so how about just b tag? That's pretty lame. Might change that. Equals document.create element. I want a bold element, and then I'm going to append to the bold element, append the username. So that's just putting the text inside. And then I'm going to append that to new tweet dot append the b tag. And then finally, I'm also going to append, or I could do inner HTML or inner text rather. I'm going to append a string with a dash like that. So it'll be the username dash and then the tweet text. All right, so hopefully that works. We start off with an empty li. Then we make a bold tag, just like that. And then inside the bold tag, we append the username. Let's say it's Colt. And then we take that bold tag and we append it to our li, right? So then we have our li like this with the bold tag inside. And then after that, we're appending to the li, which is called new tweet, a dash or a hyphen or whatever it is, and then the tweet text. So hopefully that is what we want. We could always just console.log that new tweet to verify. New tweet, just like that. See if we get any errors here. So Colt, here's my tweet text. Oh, did I not prevent? Oh, I waited to prevent default. Should do that first. Try that again. Go back. All right, to post the tweets. Username is not defined. Oh, had a typo here. I had username. Fix that. One more attempt. Here's my tweet. Okay, so this is the markup we made. That should work for us. So now let's append that to our UL. So it has the ID of tweets. So let's just call that container, or const tweets container or something, equals document.query selector, and then our ID tweets. And then finally at the end here, instead of console.logging, we'll do tweets dot append, or tweets container rather, dot append new tweet. Whew, let's see if this works for us. So here's my tweets. Hey, so we should definitely empty out this input. That's an annoying thing if you don't do that. So we can fix that pretty easily. I think honestly what I want to do is move this here, the actual creation of this new tweet, into a separate function. So I'm probably going to do this. Const add tweet will be a function, and maybe we just pass in the username like that and the tweets. Okay, and then we'll take those two and use them to create our new tweet and append it. And then up here, what we need to do is take that username and that tweet and pass it through to add tweet with that username and that tweet. So hopefully things still work. Let's just verify. Okay, so that does work. Now I want to reset that input. So to do that, I can basically just take this and set the value back to an empty string, but this is kind of annoying to have to type that again. So what I'd probably do is username input here, username, or maybe just user, username input's not that long, is it? Equals tweetform.elements.username. And then tweet input equals tweetform.elements.tweet. Like that. And then here I'll pass through the two values. And then down below, username input dot value is reset. And then tweet singular input dot value is also reset. Okay, so all that I did here was select or save the entire input to a variable, and that way I just have a reference to the input itself. So let's verify one more time. Oh, username is not defined. Oh yeah, I messed this up. This is username input dot value and tweet input. Try that again. All right, so now we get our empty input. Colt, here's my tweets, nothing crazy. It's posted. Let's say Samantha tweeted this. Bzzz, that's her tweet. And it shows up, and the inputs are successfully emptied. Whew. So that process here, it took a little while, right? But what we really covered was, first of all, the submit event, which is triggered when a user submits a form, which is not necessarily from clicking a button. There are times in a form where it could be from hitting the enter key, for example, right there. I'm in the last input. If I just hit enter, that submits the form. And by default, the behavior of a form when it's submitted is to take or to make a request, an HTTP request to the action and send the data there. But if we use event.prevent default or prevent default, I'm not sure which way you're supposed to accent that. Anyway, if we use that method on the event object, it will prevent that default behavior. It stops it and it keeps us on the same page. No request is made so that we can do our own stuff. We can extract data and append to the page and manipulate the contents of that form. So that's what we did. When you submit this, I'm sorry for these nonsense tweets and usernames, we stop, we prevent default, we grab the current values in there, we create a new LI, we append that, and then we reset back to empty. So we end up with this form that we are submitting. We actually are submitting. That event does occur. It's just the default behavior does not occur. And then lastly, we also saw that instead of having to select each input manually with regular DOM selectors like query selector or something, we actually have access to all the inputs within a given form inside of that form.elements. So that elements is a collection, and it's an ordered collection, but if we give our inputs a name, which is always a good idea, we can access individual inputs by name, username.tweet, and that's generally a lot better, or it's at least easier to access our data out than having to do something like this. Okay, so that's a lot. That was a long video. I deeply regret making it so long, but we had a lot to cover. Next up, two other events that are form or they're really input related that you may want to use or that you may come across. They are change and input. There's an event called input. So I've got a pretty basic setup here. I've got an H1 and then an input. And suppose that I want to do something every time this input is updated. So I want something to happen live rather than waiting for a submit, as an example. We could use a key press or a key down, so every time you type in here. But remember, that does include things like arrow keys or hitting, the shift key, even if you're not doing anything. That's considered a key down. Also, that excludes other ways of adding to this input or of typing. So yes, there's the physical key down events, but some people may be copying and pasting. Some people may be using a voiceover utility or something where they're not actually typing onto keys. So there are different ways of updating an input, and key down or key up does not include all of them or doesn't encompass them. So there is one event that we'll start with, which is the change event. So I'm going to start by just selecting that input. Const input equals document.query selector. There's only one, so I'm not going to bother with an ID. Input.add event listener. We'll listen for the change event. Function, we'll take that. Console.log, whatever. Okay, so let's see. I'm going to type in this input. I'm going to use arrow keys. I'm going to hit shift. Nothing happens. But if I do change the value in that input, why is nothing happening? This is something I've seen a lot of people get confused about. The change input only fires when you actually blur the input, which basically means leaving it. So I'm going to click away. Now a change has occurred. So if I go back, right, and I blur again, that doesn't count as a change because I didn't change the value. So instead of thinking of it as whenever something happens in that input, whatever you see changes, it's more whenever you leave that input and it is different than it was when you entered the input. So this does not count as a change, just focusing, or even if I type D and leave, that's not a change. But if I type something new that's not there and I leave, that is a change. So that does work, but if you want something to happen every time the value is different inside of this input, not just when you focus and blur, not just when you leave, we have a different input type, or a different event type rather, which is called the input event. And this fires, I'm just going to change this to say input event. This fires whenever what's in the input changes, not on blur, but as soon as I type something, that's an input event. That's an input event. So clicking away and in doesn't matter, but just like before, holding shift or arrow keys or things that don't actually impact the value in here, they don't fire the event. But as soon as I type in there we go. So this can be useful. This is a common one these days because it does, if I have something on my clipboard and I paste that in, that's considered input. Even if I right click, I'm not even using my keyboard and I paste, that triggers the input event. Same thing if I'm using a screen reader or a voiceover utility rather, where I'm doing text or speech to text to type into there. So that's the input event. Why don't we just do something where we update our H1 with whatever you're typing as you type. So const H1 equals document dot query selector H1. And then what we'll start with is, why don't we console.log E every time this input changes. Okay, so it's an input event. What do we have in here? Well, we have this thing called data. Data is not the current value of that input. It's just what you typed, sort of the new part of that piece of text, what's new in there. That's not really what we want. What we want is just the value from the input. So we're just going to take whatever the value is. So I'm going to do input.value. We have input in a variable. And I'm going to save that, or I'm going to update h1.innerText or text content to be whatever that value is. So whenever the value changes inside of our input, the input event, whenever that happens, I'm going to take the value from that input and I'm going to update our H1 to display it. So we should get a live sort of in sync piece of text as I type or delete, hello. So you may have seen things like this, not something like this, so where it's so ugly, but maybe a live preview of your comment or of something as you're typing. Like on the right side, maybe you're typing a blog post and you see a live preview. That can be done using the input event. Anytime that input event fires, we take the value and we update our H1. So simple, hopefully, but important to understand the difference between that and the change event, which only fires when we blur out of the input. And then also key down, which seems similar, except it does not encompass things like copying and pasting, at least not if you're right-clicking and pasting or using a menu. Also, key down and key up, they'll trigger for every key press, even if it's an arrow key, a shift key, something that doesn't actually change the input. All right? Next up, we're going to talk about something called event bubbling. So I'm going to demonstrate something first. I'm in a new file, and you can ignore the code that's in here. I'm commenting it out. I'm going to start by doing some inline event listeners really quickly. So I'll have a button on click. Remember, this is not a good idea, but I'm doing it just to make this short and simple. I'll say button clicked. All right. Make sure I've got my quotes matching up. Let's make sure that works. Okay, I'm an idiot. I didn't put any text in there. There we go. Click. All right. So I click and it says button clicked. Next up, I'm going to wrap that, or I'm going to put that inside of, how about, I don't know, maybe a paragraph. And this should still work, right? I click, I'm still clicking the button. Okay. But then what about if I have some text in here? I am a paragraph, and I add an on click to the paragraph. Well, alerts, paragraph clicked. Alrighty. So let's see what happens now. If I click the paragraph, we get paragraph clicked. But now, the moment of truth, the big question, what happens if I click the button? Button clicked. Okay, it worked. Oh, no, it didn't work, or it kind of worked. What is this? Paragraph clicked. So it's given me both the button clicked and the paragraph clicked. And if I were to add a third level, if I did like a section and then another lovely, on click equals alert section clicked, you can see where we're going with this. You can probably guess. If I click on that button happens to be inside of a section, inside of a paragraph. They all have their own event listeners for a click. I click the button clicked, paragraph clicked, section clicked. And if I were to add an on click to the body or to something else that they're nested inside of, all of them are going to be triggered. So what is that? What's going on? Well, this is something called event bubbling. So an event is going to be triggered first on some element. In this case, we click on the button, and that event is handled, in our case, by this function, this alert. It's really silly. It doesn't do a whole lot, but it alerts. But that's not the end of the story. There might be other events that would be triggered by that click, and in fact, there are. So the event itself will bubble up from this button. Think of bubbles rising up in a fish tank, right? They go from the bottom all the way up to the top or to the higher level, highest level to the surface. So it bubbles from here, it triggers that, but that also happens to be inside of a paragraph. So it triggers this and that code runs. And then again, it triggers this and that code runs on the section. So we get all three alerts in that order. Again, it's called bubbling. So the button is triggered and then the paragraph and then the section. Now, sometimes you want that behavior, maybe not with alerts. You probably never want alerts, but sometimes you want that event to bubble up and have other handlers run depending on where you click. But a lot of the time you don't. I'll show you a very simple example. Here I've got a button. It says change color. It does nothing. When I click on this, I want to change the div that this button is inside of. I want to change that div's color. Okay? So I have make rand color from earlier. I'm going to do a button. I've already selected the button and the div, which I gave an ID of container. So when I click that button.add event listener clock. There we go. Click function. Then I'm going to say container dot style dot, whoa, where'd that come from? Dot background color equals our new random color from make rand color. Okay, nope, that did not work. Did I include the script? Yes. What is it complaining about? Nothing. Oh, I have more than one button. Oh, that's why. I'm doing query selector button, so let's give this an ID. We'll call this change color. So I made it so that when I click this button, eventually we get that new random color. Not what I wanted. So let's reselect that button to use that ID, change color. Okay, so now we get a random color every time I click. All right, simple enough. So now what I want to do, this is super silly, but when you click on the div itself, I want to apply a class called hide to hide the entire div. Basically, if you click here or over here, I want this to just hide. So we can do that. I have this class. I did it in a style element just so I didn't have to have a separate style sheet, even though you should. So we need to just add a click listener, container.add event listener, click, and then my function for my callback. All right. And then in here, I'm going to do container dot, we'll do class list dot add, or we could toggle it, hide. So when you click, it should now hide, and it does. Okay. So the problem that we run into is that if I want to change the color, what happened? Did we change the color and then it hid? Well, the answer is yes. We did change that color very, very quickly. Actually, if you inspect here, we can see that container has a background color. I'll refresh. So it has no background color. Now I click, and it does get a new background color, but it also gets that class of hide. This is event bubbling. We click on that button, and our event handler runs for the button, but then it bubbles up. That event keeps going up because this div has its own click listener. And we did click on that div too. Yes, we clicked on the button, but it's inside of the div, so we clicked on it too. So what we need to do is find a way to stop that. I don't want any more bubbling. Stop going up. After I click this button to change color, just stop. That sounded a bit aggressive, but that's what we want to do. And fortunately, there's an easy way of doing that. On the event object, so I'm going to grab that here, I'll call it E. On the event object, there's a method. Just like we've seen prevent default, there's one called stop propagation. And this will prevent this event from bubbling up any further. So in other words, this is the end of the line right here. So when I click on the button, change color, and then stop, don't move on. And we'll see that it does work. Now I can click on this button to change the color, and we're only having that one button click handler actually execute. If I click here, there we go, it's gone, and I can't get it back, at least with what I have right now. Okay, so that's the idea of event bubbling, right? So we have 3 event listeners here. The first one triggers on the button. Well, that happens to be inside the paragraph, so that one triggers, and that paragraph is inside of a section. So we clicked on 3 things here. They each have their own listener. The order is what matters. The event bubbles up to the top, and we can stop that by using event, or whatever our event object is called, .stop propagation. All right, so we've got one more important topic around events, something called event delegation. It's really a solution to a problem, I guess it's more of a strategy for writing our code and working with events. So I'm going to show you an example of something where it would come in handy. Here's our old, from a couple videos back, tweet form, I guess, where I can type my username, like kit, cat, and then some tweets, like meow, post a tweet, and it shows up here. Okay, nothing crazy. But I'd like to modify it so that I can delete tweets too. Maybe I accidentally type that horrible tweet. I want to exit out, or I want a button or something. Maybe I'll just click on the LI itself to remove it. So to do that, I would just add an event listener to an LI, right? So let's come into my app.js here. Let's select all LIs. Is that how we want to do it? Const LIs, lees equals document.query selector, all for every LI. I'll loop over them for let LI of LIs, not or, but of. I want to delete that LI when clicked. So li.add event listener for a click, and then my callback, and then I'll call li.remove. And let's add a starting LI in here just to verify. I am LI. Okay, we'll add a couple of them. And let's see if it works. So I'll click one. Hey, it does work. It's removing. That's all good. But now, if I add a new tweet, doesn't work. Maybe that was a fluke. Let's try another one. Still doesn't work. So what's going on? Well, these LIs were on the page when the code ran and when we added those event listeners, right? We attached an event listener to each of those 2 LIs that were there when this code ran. But it can't see into the future. It can't say for every LI that may be added in the future, add an event listener. So these LIs, the new ones, the tweets, they don't have any sort of event listener. There's no click listener on them because they were created after the fact. So the solution here is to use something called event delegation, which just means we're going to add our event listener to some element that is apparent. Not apparent, like the word apparently, but a parent of our LIs. We're going to probably attach it to the UL. That UL is there. It's always going to be there, even if it's empty at the beginning. And then we can listen for clicks on the UL, but specifically clicks that are actually on LIs. They just happen to be in that UL. So I'll show you what I mean. I'm going to update this. I'm going to get rid of that code actually and do const UL, or container. We gave it an ID. Okay, tweets. Oh yeah, we already have that tweets container. So we can just do tweets container.add event listener click. And I'm going to use the event object here. I'm going to start by console.logging click on UL, and we should see that that's considered a click on the UL. Right? And this is also considered a click on the UL. It doesn't matter that this is new. I'm still just clicking on the UL. All of this is considered the UL. So now I'm going to print out E, console.log E, because this is really the crux of making this work, is being able to tell which LI was clicked on inside of that UL. So here's my tweet. Let's say I tweet LOL I guess I tweet that a lot. I'm going to click on that. So we get our click on UL. Here's our mouse event object. And inside of this, there's a particular property that we care about called target. And here it is. Target is set to the LI that was clicked on. So even though the element that I actually attach the event listener to is the UL, the target is the LI here. No, here we are. And that's important because I want to basically write some code that is going to look at that target, check if it's an LI. It's possible there's stuff in here. Like I could click on the UL. Maybe if I had, I don't know, padding on here, or if I had some other content that wasn't LIs. You're supposed to only have LIs really inside of a UL, but maybe there's something I added in there. I could check to make sure that the element that I clicked on, which is the target, I want to make sure that it is of type LI, and then I want to remove that LI. So event.target is what I want. Okay, so that's important. Event.target is the thing that was actually clicked. Even if my event listener is on the UL, I clicked on the LI, or this LI. So now I'm just going to call event.target.remove. That's the simplest way to do it, not remove event listener, just remove. So that should still work for these new ones, or sorry, for the old ones that are there at the beginning, but it should also work for the new ones. And it does. Now, I mentioned sometimes you want to verify what you're clicking on, what the target is, because we might have other stuff going on inside. For example, maybe each LI also has a button, and in that button you can delete. And then if you click on the LI, something else happens. It changes color. You can click and drag. I don't know. There's different things we can do where basically we can check to see what exactly you clicked. So not just always remove event.target, but we could verify is event.target. So I can do this event.target dot. We can do node. Let's see. I can't even remember. I'll have to console.log. I think it's node type. Console.log e.target. Console.dir. Try that again. Okay. So to verify that it is an LI, local name, node name, that's what I meant to use. So we can do this, e.target.node name equals LI. And then I can just do and event.target.remove. That's just a short way of saying if it is LI, so if node name is LI, then do this. Because remember, in a Boolean and, if the left side is false, then this just never runs. However, I don't even think there's a situation where there's something else I could click on in there. I'm trying to think if I can put something, I could put something invalid in here, like a paragraph. You're not supposed to do that. But if I click on that, nothing happens. I click on the LI, they are removed. Whereas before, if I did not add this in, we're just always removing event.target. If I click the paragraph, it's removed. So just a little bit more discretion there where I'm checking, is this actually an LI I clicked on? Okay, then remove it. So that's event delegation. It's useful in situations like this, where we have elements that may not be on the page at the time our event listeners are added. So we can add event listeners to some parent elements. I mean, technically you could add one click listener to your body of the entire app, the body element, and then just check event.target for everything instead of individual listeners. Generally, I wouldn't do that, but you could. And that's kind of it for event delegation. So next up, we're going to get a bit of practice using the DOM manipulation content we've learned, the events and working with events, plus HTML, some basic CSS. We're going to wrap it all together and make this pretty simple ping pong scorekeeping widget. So it doesn't have to be for ping pong, but that's the way I decided to theme it. It's very straightforward. 2-player games. Each player has a button, player 1, player 2. And then you can select what you want to play up to. And we can expand on these options, but let's play to 5. So I can add a point, and you'll see that my score changes up here. 1, now it's 2, and then this button updates player 2. So let's say player 2 wins, and you can see what happens. Now 2 to 5 shows up. 5 is in green because player 2 won, and this number, the first number, is in red because player 1 lost. The buttons are disabled, but I do have a reset button, and I can start over. And that's honestly kind of it. So very simple. we do have some styling in here. And I'm actually using a different CSS framework, not Bootstrap, but another similar tool called Bulma, B-U-L-M-A. And I'll address it in the next video if you want to get a bit of practice using it or exploring different CSS frameworks, but it's kind of irrelevant to the DOM content. It's very much irrelevant to what I want you to focus on here, which is events and buttons and listeners, plus this thing here. This is a select, right? So that's not a click event that we're listening for, it's a different event. So I recommend you give this a shot on your own, ignoring the styling. Just try to, add 2 buttons or 3 buttons, I guess, some sort of H1 or some display place, and then a select, and just add the right logic in there, make the right variables, select things, listen for events, and see how it goes. But if you want to follow along, no shame in that either. I just recommend you try it first. So if you do want to follow along, I'm going to get started in like 3, 2, 1 right now. Okay, so I'm going to make a new file to start. I'll call it index.html, nothing extravagant, and then, app.js. And I'm in a folder right now, I'm calling it Scorekeeper. In my index, we'll do our basic Emmet exclamation point tab, and then let's just begin with an H1, and it's gonna say 0 to 0. And there it is. I'll zoom in a decent amount so we can see it. All right. And before we go any further, we actually need to discuss how this is going to work, where we are updating just one number out of this H1, and then we're applying a class to make something green just to one number and not the other. If we just have markup like this, where we have an H1 and no other elements, that's going to be very difficult. We need a way to single out this and this, the 2 zeros, and then select them and change them using JavaScript. And I'm going to use a span for that. It's a perfect use for a span because that's kind of what a span is supposed to do, a piece of inline content that we can single out. So we'll wrap them in a span, and then we should give them each an ID. So I'm thinking this will be for player 1. So the ID will be something like, how about player 1 or P1 display or P1 score maybe? And then we'll do the same thing for this span, but it will be player 2 score. Great, we shouldn't see anything different if I refresh. We just have those underlying spans I can select. Then let's add in 2 buttons to start. Button, and this will be +1 player 1, and then duplicate that, +1 player 2. And then I'm going to give them each an ID. We'll call this P1 button, and then this will be P2 button. All right, and then we can add a reset button. We'll just have the text of reset and an ID of reset as well. So again, very ugly, but we have the bare minimum of what we need. We can start without the select. Just get the logic to work for our buttons. We'll assume we're playing to 5, just hard code that to begin with. All right, so now I need to make a script. I'll also add a title, Scorekeeper. And then I have my app.js. I will link that here down at the bottom with a script tag, source equals app.js. And then I always like to just do a simple alert something to make sure it's working. And it is. We are successfully connected. Okay, so now what I want to do is begin by selecting the buttons and then doing something when we click on the buttons. So let's just select both of them up top. Const player 1 button equals documents, and then we can do query selector or get element by ID. I'll do query selector just to be consistent because I'm going to use query selector for pretty much everything here. So query selector, #, and then our ID was player 1 button. And then do the same thing for player 2 button. And then let's do something when we click on player 1 button. So .add event listener click, and then our callback function. And let's do just another alert clicked, and just make sure we see something. All right, I'm going to click, and we do. So that's good news. Now let's actually talk about the logic of what we want to do. When we click on player 1, we want to take whatever the current score is for player 1 and add 1 to it, and then update this span to have that new score. So we need to keep track of whatever the current score is for player 1, and I'll just have a variable do that. Let P1 score, and let's just have that start at 0, right? And then when you click, we will add 1 to P1 score. So that will be P1 score plus equals 1. We increment it by 1. And then we want to update what we see in this span. And the span has P1 score as its ID, which I think is actually kind of confusing if we're going to name this variable P1 score. So I think I'll name this display, P1 and P2 display. All right, so now I'm going to select those. So const P1 display. Well, I did P2, that's fine. We'll just copy and repeat this for P1. It's going to be the same idea, P2 display. That's what we're selecting upon, or based upon that ID. And then I'll duplicate this and do the same thing for player 1 display. So that gives us the span, hopefully. And then all I need to do is change that span's text. So P1 display dot, and then to change that text, I'll just do text content equals whatever the new score is, P1 score. So it starts at 0. If you click, we add 1 to it, and then we update that display. Does it work? Yep, it looks like it's working. Cool. So that's the first bit, and obviously we want to repeat that for player 2. But now we also need to pay attention to what we're playing to. And we're going to start by just playing to 5. So let's make a variable. We'll call it winning score. And I'm going to use let, not const, because at the end of this, if we finish it up, I want to be able to select a different winning score. So that variable value will change. I don't want to hard code it with const. So let winning score equal 5. Cool. Then inside of here, I could just do something like, if player 1 score is equal to winning score. So if player 1, or P1 score rather, is equal to winning score, if that's the case, what do we want to do? Well, not this. This is not the logic we want. This is saying if you have the winning score, we're still going to add 1 and change your text content. So I could rewrite this as if you do not have the winning score, we will update you and display your new score. Otherwise, nothing happens. So let's see. 1, 2, 3, 4, 5, and now I can't go any further. Okay, so that's a start. We are preventing us from continuing to click and add to the score. So what we could do next is basically duplicate this logic, but for player 2, right? So player 2 button, add event listener, click. If player 2 score is not equal to the winning score, player 2 score plus equals 1, player 2 display.text content, the only thing we need to do is make another variable to keep track of player 2's score. Oh, and I need to make sure I update this. Use the content, or fill the content with whatever player 2 score is, not player 1. Okay, so right now I can get to 5 here and I can't click anymore, but I can still add points to player 2. So that's not what we want either. We need to make sure that if anybody gets to 5 in our case, we are done. That's the end. So how do we make that work? Well, basically, we just need to keep track of that winning score like we are, and then we need to keep track of whether anybody has gotten to that winning score. Or another way of thinking of it is we need to keep track of whether we're still playing the game or not. And that's just a yes or a no, a Boolean. So let's make a Boolean called game over or is game over. So let's do, is game over. And we'll start it at false. At the beginning, game over is definitely false. You're still playing, it just started. Then if anybody hits the winning score, if anybody hits 5 in our case, we're going to set game over to true. And then inside of each of these callbacks, I'm going to rewrite my code a tiny bit. I'm going to say if not game over. So if we're still playing a game, and then I'm going to wrap all of my code inside of that. So if we're still playing the game, we'll add 1 to player 1's score. And then we'll update the score display. But I'm also going to check in this conditional if your new score that we just added 1 to. So just focus on this, this callback here. Ignore this one for now. Let's say you're at 4 points. And I click, we get to 5, right? We add 1, you're now at 5. Well, now I want to disable the buttons and add the green class. So right here we go to 4, I click, now we're at 5. Oh, well, I'm playing to 8. Let's redo that. Let's go to 5. We're right there. And right in that callback, we're going to add that class here, add this other class to make this red, disable the buttons. So once we increment, we don't want to wait until you click again. and you go to 6 or 7, we want to do it right when you click or right after you click. Add 1, your score is now 5. Then we're going to check. If your score is the winning score, we're going to set game over, or is game over, to be true, because now it is a game over. You are done. And we'll also update player1 display.text content. Now the reason that we set is game over to true is so that if you click again, this is now false and none of this code runs. So you can't increment any further. And if I update this code for player 2, I'm just going to delete what I had and paste this, and just update player 2 score, player 2 score, same thing here. It's identical except for doing it for player 2. But they're joined by this, right? If not, game over. So if either one of these gets to game over first, if they achieve the winning score, is game over becomes true, then they both don't do anything. If I click, nothing happens. So let's check it out, hopefully. Oh, looks like game over is game over. How did I not catch that? Sorry about that. Is game over. Try again. Okay, so we'll add some to both, then we'll get to 5 over here, and nothing happens when I click anymore. Same thing on player 2. Both of them just don't run. Well, the function runs, but no code really runs except for this line. It's evaluated and it comes back false because game over, or is game over, is true. Okay, so if I change what that winning score is, let's say it's 3 now, and I click here, I go to 3, that's it, game over is true, and we're done. Okay, so I'm going to stop here. In the next video, we will finish up our logic. We will make the reset button work. We'll add in our select, the drop down, so that you can select where you're going to play up to. And we'll also work on adding the green and red text if you win or lose. Alrighty. So we've got our basic logic, at least for the first game, up to 3 in this case. That's working. Now let's quickly make our reset button reset the game. So that's pretty simple. Have we selected it? No. So let's do const reset button equals document dot query, not command, query selector, and then reset, I think is what we named it. Just double check. Yes. Okay. The next thing that we need to do is just run some code when you click. So that's just reset button dot add event listener, once again for a click. When you do click on that reset button, in order to actually reset the game, there's a couple of things we need to do. First of all, we'll set is game over back to false. And we'll also set player 1 score to 0, player 2 score to 0, just like that. And then we should also update the display, because what will happen otherwise, once I hit 3 and I click reset, we don't update the display, and so we end up with, scores behind the scenes 0 to 0, because we did update that, but they're not reflected until I click. And so now it's janky, and we go back to 1 to 1, and we just skip 0 to 0. So we need to update the display as well when we reset, and that's not super difficult. Just player 1 score, display, is that what we called it? Dot text content equals 0. Player 2 display dot text content. Let's see. We'll go up to 3, reset. Looks good. Reset. So that's working. Next up, let's add in the select so that we can play to a different range or a different end score, a winning score, like 10, right? I can go all the way to 10, but no further, instead of just hard coding in 3. So we'll just begin by adding in a select, and we'll give it the ID of, play 2. And then in here, we'll come up with a couple of options. And if you remember how selects work, we need to specify a value. So I'm just going to do like 3 and then 3. That's all we'll display. So this is what we will get via JavaScript, and this is what we display to the user. So if you prefer that way or something else, you can totally do that. And then we'll just duplicate this, and I'll keep it short for now. Let's see. Do we want to do just consecutive numbers or just common numbers like 3, 5? I'll just do consecutive numbers. Feel free to do whatever you'd like here. Okay, so I did 3 up to 11. Let's see what we end up with. There it is. Cool. So now all we really want to do is when you make a change over here, we want to make sure that our new winning score is whatever the value is. So winning score should now be 11 instead of 3. But also we're going to reset the game because I don't want you to play to 3 and then somebody says, actually, we're going to 5 and the game doesn't reset. Like, that just seems janky to me. It should start over. You can't change halfway through. At least that's how I would implement it. So basically, we need to select the select right here. I gave it the ID of play to. Let's call it, play to select equals, and then actually, how about winning score select? Equals document dot query selector, and then the ID was play to. Okay, so what's the event we want to listen for? Well, we talked about this with different form inputs. For a select, the easiest option is to use the change event when that value changes. So instead of doing like a click or something, because a user might just end up not doing anything, they might just stay on that same value, 5 or 3. Nothing should happen here in terms of my code and my score changing. But if I go from 3 to 4, I do want to trigger some code and I want that to run. So here, let's do our winning score select dot add event listener. When there's a change, let's do a function in here and let's just start easy. Let's do an alert change and just see when it runs. Looks like I screwed something up here. There we are. Okay. So is there a change? Yep. Cool. But if I stay on 6, nope, nothing happens. I go to 9, yes. So the next thing we need to figure out is how to get the value out. Is just to reference this, right? This refers to the specific object that we are listening for an event on. So this, and then I have access to the value. I'll just alert this dot value to start. That's how we get the value out of an input. And we get 7 and 11. Okay, so that gives us the number. And unfortunately, it's not quite as easy as just updating the winning score right here, which is 3. It's not as easy as just updating that to be whatever we get from the select, 7 or 10, because it's going to be a string. And we want it to be a number. So I'm going to turn it into a number first using parse int. So I'll do something like winning score equals parse int, which is how we take a string and get a number out of it, this dot value. So that should update whatever the winning score variable is. And we could just start with that and just make sure it does work. So winning score at the moment is 3. Change this to 11. What's winning score? It's 11, and that is a number. It's not, 11 in quotes. Okay? So now I also want to reset the display, and I want to reset player 1 and player 2 scores. I could just copy this, but what I'm going to do instead is actually move this into its own function, so I can call it in here. So I'll define a function called reset. Function reset, and it just does this logic we already had. Now, when you click on the reset button, we call reset. Notice I'm not actually executing it. That's very different, right? I'm passing a reference. It will execute reset when the time has come, but then I want to actually execute it in here because this is the callback. Versus here, I'm passing it as the callback. Here, I'm passing this anonymous function as a callback, and then I execute reset inside. So let's see. Let's go 3-0. Let's make sure our reset button still works. Yep, still works. Okay, but now if I go to 6, let's say, it looks like it worked. And yeah, looks good. So now I get up to 6, and we can't play anymore. Have to click reset. Great, that's the basic logic of the score selector. All that we really have left is adding in the color to whoever wins and then also whoever loses. So as I mentioned, I'm going to be using a CSS framework called Bulma, and it comes with classes to make things red and green. But for now, I'll just come up with a class in the index.html. I'll end up removing it, but I'm not going to make a separate style sheet just to keep this short. So I'm going to just add a style element inline. I'll end up deleting this, but I'm going to add two classes. Win, or winner, color will be green, and loser, color will be red. All right, so nothing changes because nothing has, or we don't have anything with the class of winner or loser currently in the DOM. But what I want to do is when you win, meaning when P1 score is winning score or when P2 score is winning score, I want to add that class, the winner score, to P1 in this case. So let's do that. P1 display.classList.add winner. So if P1 score is exactly equal to the winning score, and that happens first, because if it happened to P2, then game over would be false and this whole thing is, or game over would be true rather, and this code wouldn't run. But if we make it here, we set game over to true, and we give you P1 display the class of winner. Does it work? We're going to 3 by default. There we are. Okay. Now, we do need to get rid of that when we reset, so we'll fix that in just a moment. But let's also do a P2 display.classList.add, what did I call it, loser? Yeah. And then duplicate this down here, but switch the numbers. P2 winner, P1 loser. So let's make P2 win. There we go. But reset is not working for those classes. So then down here, when we call reset, or in the definition of reset, we're going to call ClassList.remove. And I can actually have it remove winner and loser, whichever one it finds on P1 display, and then the same thing for P2 display. So hopefully we don't end up with both of them on anything at the same time, but if they both were there, this will remove both of them. All right, let's go to 3, you win. Go to 3, P2 wins. Let's go to 6. 1, 2, 1, 2, 3, 4, 5, 6. Cool, red, green, reset, that looks good. What about if I go reset this way? Still looks good. All right, so that's the basic logic. That's pretty much all that there is to do. In the next video, I'll introduce this framework Bulma, which is totally optional. You know, it's kind of out of the blue, but I ended up using it and I kind of like it. So if you want to check it out with me, we will update our code so it looks a bit nicer. Okay, so in this video, I'll be introducing Bulma very quickly. I'm talking like 10-15 minutes of Bulma. It's essentially a full-blown CSS framework that you could use to replace something like Bootstrap. It's very simple to pick up. The language, the terminology is a bit simpler in my opinion than Bootstrap. The styles are definitely different, although not that different. It's just a different approach. So it's nice, it's customizable, and the big thing that people like compared to JavaScript or compared to Bootstrap is that it doesn't impose it doesn't force you to use something like jQuery, which Bootstrap has for a very long time, or Popper.js, another dependency of Bootstrap. Although with Bootstrap v5, that goes out the window, but that was one of the main driving forces behind Bulma. Anyway, if you take a look at the documentation, it's broken down into helpers, and then form sections, elements, and then components. Components include things like cards, very similar to Bootstrap. We're going to use a card to make something like this. You know, I'm not thrilled with this layout, but this will work to start. And before we go any further, we need to actually install it or include it in our app. So if you go to Overview, Start, they give you the CDN links that you can use. You can also download it. They also give you just a starter template. We really just need that min CSS file. So we'll just copy that link, and we're going to put that up top in our index.html. I'll keep this for now, but I am going to get rid of that and replace it with some Bulma classes. I'm going to refresh, and we see some changes. Okay. The next thing I'm going to do is go to the docs again, go over to, let's do a card. So components, card. And we could start by just copying a card, like this one here. This is what I do all the time. Copy a card or something and just paste it into your document. Let's just do it at the top. And it is super wide. So now we need to figure out how to control that. And there's a grid system. it's very different than how Bootstraps works. I mean, it's the same concept, dividing up space, but the class names are very different. So if we go to, I think they call it columns, go to basics, it says in order for this to work, you need a columns container and then a column element. Okay, so that's easy enough. But then in addition, we can change the sizes of columns using the following classes. And take a look at these names. Is half, is 1/3, is 1/4. Very different. We don't use things like, column 6 or column medium 5. So some people prefer this approach. If I want something to just be halfway across the screen, I can use is half. So I need to start by setting up my columns. So I'll just cut this card back out. I'm going to make a columns div. I'm also going to put everything in a container, actually, which is very similar to Bootstrap. It just adds a bit of spacing. So columns, and then we add a column inside, and then put our card in the column. Okay, so that's our container there. But now if I only want it to go halfway across, I can use column is half. And now it's only half. And then to center it, I have these offset classes, which you can see further down somewhere. Offset is offset 1/4, is offset 1/5. Kind of long, but simple. So if this is 50%, it's half, and I want it to be centered, I need to put 1/4 on the left, 1/4 on the right. So is offset 1/4. Refresh, and there we are. We are now centered in the middle of the screen in our container using the Bulma grid system, the columns system. Next, let's add our content in here. So what should we start with? Let's go with the card header, just this little thing up here. Keep it very simple. Let's just replace that with ping pong scorekeeper, like that. I'm also going to get rid of this anchor tag. We don't need that. There we are. And then I have this card content, div classes content, and in here, I'm going to put an H1. So I'm just going to get rid of all this stuff and just replace it with what we already have, actually, this H1 right there. Put it right there. So this is our score display. What is going to change, though, is the H1 itself. It's going to have a new class, a typography class from Bulma. So if you go to, where is it, helpers, typography, there are these 7 sizes, and I'm going to do is size 1, just makes it larger, 3 rems font size. We also have a component called title, which just makes larger text. So that's what I want. Title is 1. I'm going to do that. So H1 class equals title is -1. Okay, so now we have 0 to 0. My buttons are still over here, but that's working. Cool. And then down below, I'm just going to put some text in this card content div after the H1. I'm going to do a paragraph with the class of subtitle. And it's just going to say, use the buttons below to keep score. I think that's what I said on this example. Yeah. Refresh. Okay, so there's that. Nothing crazy. Now let's get our buttons down here where we have these 3 links. I'm going to replace them with buttons. Each one of them has a class of card footer item, so we'll keep that, but they're anchor tags. To make an actual button in Bulma, very, very easy. Go to the docs on button. We have class of button, the actual word button. So that's the difference, right? Bootstrap is all about BTN, BTN large. This is very straightforward, button. And then different colors, is white, is black, is primary, success, info, warning, danger. Sounds familiar, right? So I'm going to use those. And I'm also going to use them alongside something we haven't seen, which is large. We can define sizes, or we can add classes for sizing, normal, medium, and large. So back in my code, I'm going to add a button in, and our first button is just going to be is primary. It also needs the class of button. And I'm going to do card footer item, which is just this class we have here. And then I'm going to take this ID of P1 button and put it on that button. So this will be our player 1 button, and then the text inside will say +1 player 1. Let's see what that gives us. Okay, and then I'm just going to duplicate that a couple of times. So that's our player 1 button. Now I want a player 2 button, so P2 button, and the color will be is info maybe. Okay, and then a reset button as well. So get rid of that, duplicate this, ID is reset, class is danger, and then the text is reset. Let's see what we're looking at. There we are, our 3 buttons. And do they still work? Yes, they do. Reset, looks good. All right, so after that, we do need to add this in, our select, and that's another Bulma piece. If you go to forms, input, actually we want select. To make a regular select, it looks like this, div class select and then select inside. Or for our rounded one, select is rounded. So that's what I'm going to do. I'm going to take my current select, cut it, put it in a div. I'm going to go right after the subtitle in the content, and then put a div with our select rounded, like that, and paste our select inside. And then refresh. I screwed that up, didn't I? Is rounded. There we are. Is dash rounded. And there it is. Okay. And then if I want to add some text, a bit of a label that says playing to something, I won't go through the docs to show you this, but it's on there. We can add in a div to group all of this together. So I'm going to make a label first. And my label will just say, or we'll have a class of label, is large, and I'm also going to make it is inline. More Bulma classes. You'll see a lot of them start with is. And then I can connect them, so for play to, like that. And then the text will say playing to, and then 3, playing to 4, playing to 5. Let's make sure it works. Can I get to 5? Yes. Playing to 8. And there we are. Cool. So I'll also add that image up top that I showed you. I have it here if you just want to copy it from my code. It doesn't look great, honestly, but it's simple enough. So above our card content and above the card header, but inside the card, I can add a card image. And then the way we do this is, according to Bulma, is using a figure. The class is image. And then I can constrain it with a ratio like 2:1. And then we put the image inside with a source. And there it is. Okay, not too bad. I'm also going to wrap everything in a section elements with the class of section, which is what Bulma shows us to do. So section with the class of section, it just adds some spacing. So that will go around everything. And there we are, a bit of spacing up top. Okay, the last thing we can do, if you want to use the Bulma colors in classes instead of these win or winner and loser, I can delete those and then use the color classes from Bulma, which you can find under helpers, color. We've got has text success and has text danger. So let's do that. Instead of winner, select all of that, has text success. I screwed that one up here. I meant to select this too. And then instead of loser, has text danger. Refresh. Let's see, does it work? Yep. So now we just get the Bulma colors that match a bit better, but it doesn't really matter. Okay. One more thing that we can change. We can disable the buttons so that, when you do score and you win, you can't continue to click. I mean, right now we can still click, but nothing happens, but we should always indicate that the button is disabled. And there's an attribute called disabled we can set. Bulma has built-in styles for disabled buttons. So when do I disable them? Well, whenever there's a game over. So P1 button dot disabled is true, and P2 button dot disabled is true as well. And then we just duplicate that for the other callback. So disable both of them. Great, when somebody wins. Reset, we then need to undisable. So set them both to false. Great, same thing here. Now we go to 3, can't click, reset. Let's go to 4, can't click, reset. And that's pretty much it. Let's just compare. Is there anything different? Oh, I didn't add the isLarge class to the buttons if I want to make those larger. So I will just create a couple cursors by holding Option, isLarge. There we are, a bit bigger. And that's it. So our ping pong scorekeeper, some Bulma styles here. I like Bulma. Totally up to you if you want to keep using it for other projects. There are many other options out there. Of course, there's also Bootstrap. Both of them do pretty much the exact same thing. So we're done building our little scorekeeper, but I know some of you will be interested in some refactoring. If there is some potential to clean up our code, to reduce some duplication, let's go ahead and fix things up. Let's try and refactor. So I can identify, and you probably can as well, one very key area of logic that is almost duplicated. It's not exactly the same, but I already called this out, I think, previously. This chunk of code here and this chunk of code here. What happens when you click button 1 or P1 button versus P2 button? It's the exact same flow, except one of them is happening for P1, the other one's P2. So how could we rewrite this? Well, the way it's structured right now, these are variables, right? P1 score, P1 display, P1 button. So unfortunately, it's not as simple as just, writing a function like, we could do something like function update scores as an example. And what would we pass in here? Whoops, not like that. There we are. If I wanted to call update scores when you click on P1 button, what would we pass in to update scores so that we could update P1 score? I can't pass in, I guess I could do this. I could do, score and then button and display. And then I would call it like this. I would call update scores, and then I would pass in P1 score, P1 button, and P1 display. But the obnoxious thing is that even that wouldn't be enough because, look, we're also updating player 2, P2 display, P2 button. Like, we need access to all that stuff inside of our event handler callback. So what I'm going to do is a bit of a radical change to how we're structuring our code. I'm going to group together everything that has to do with P1 into an object, and everything that has to do with P2 into its own object as well. So I'm just going to call them P1 and P2. I'll do them up top for now. Const P1, just an object literal, where I'm going to have score start as 0. I'm going to have just a property called button, and it's going to be equal to this right here. Document.querySelector P1 button, just a reference to the same thing. And then I'm going to have a display equal to that. So I'm still selecting the same things, I'm just storing them now as properties in an object. And then I'll do the same thing for P2. So P2 will have a score, starts at 0. And then it has a button, which is querySelector P2 button, display is P2 display. So now I'm going to get rid of that here. I'm going to get rid of P1 display, P2 display. I'm going to get rid of P1 and P2 score. Now my code is completely broken, but what I'm going to do now is write a pretty simple function that's going to duplicate this code or replicate this code, except it's going to be a generic function that can do it for either direction. So I'm going to call it, update score, just like I had before, and it's going to accept, how about player and opponent. And then in here, I'm not going to, do P1 score plus or equals 1. I'm now going to say whatever that player is, dot score. So it could be P1, it could be P2. Player dot score plus equals 1. Player dot score here is game over. And then this will be player dot display. and then this will be opponent.display. So it can go either direction depending on what those values are, which one is player, which one is opponent. It's just changing the perspective. So then player.button, so hang on, player.button.disabled, opponent.button.disabled. So player's an object, opponent's an object, and then here player.display.text content equals, and then I don't want this to be P1 score. I need this to be player.score. Okay, so there should be no references to 1 or 2 in here anymore. Well, aside from that actual number 1, there should be no P1, P2, player 1, player 2. So now I have this generic function called update scores. And if everything went well, I should be able to do this. When you click on P1 button, update scores, P1, P2. So player 1 is going to be player, player 2 is opponent. And then I'll just do the same thing, except switch them. When you click on player 2 button, we're going to call update scores where player 2 is player and player 1 is opponent. Okay, now we will have to change some of this down here for resetting. Oh, and we're going to have a major problem where none of this code runs because P1 button and P2 button just don't exist anymore. Right? We put those selectors in the corresponding buttons that are selected in an object. We have a reference to them as P1 button, P1 dot button rather, not as a standalone variable. So P1 dot button, P2 dot button dot add event listener. All right. So now, does this still work? What's the problem here? Cannot read property add event listener of null. Let's see. P1 dot button. My markup, what the? Somehow this got changed to P4 button when I wasn't paying attention. Okay, well that would hopefully explain the problem. Okay, so that appears to be working. What happens when I click reset? It looks like it worked, but it didn't. As you can see, it's now up at 5, 0 to 6. Not quite accurate. So let's update our reset logic. It's just all referencing variables that don't exist anymore. So this needs to be P1 dot score. So let's just update that. Whoops, P1 dot score, P2 dot score, P1 dot display, P2 dot display, P1 dot display, P2 dot display, and then P1 dot button, P2 dot button. Now we definitely could use a loop or something to make this shorter if you wanted to. With 2, it's not that big of a deal, but if we were to, add in like a 3 or 4 player mode, this would be really obnoxious to do P3.score, P4.score. So we could loop over them and just do something like for let P of, let's just do an array we make right here, P1, P2. We'll just do P.score equals 0, P.display text content equals 0. Whoops, I misspelled that right there. So P dot display dot classlist dot remove, and then P dot button dot disabled equals false. So all that logic there is now just happening for every button. For every player. There's just 2 players at the moment. All right, let's see if that still works for us. So let's game over, reset, and it looks like it's working. Okay, let's go up to 9, sure. All right, reset, does it still work? And yeah, it looks good. So a bit of a refactor. This just sets us up better if we were to have multiple players. Now we would need to refactor this. Update scores is expecting player and opponent. What I would do is refactor it to player and opponents, and you would pass in an array of opponents because if we had 4 players and 4 playing objects, or P1, P2, P3, and P4, which I'm not crazy about the name P1 and P2. Maybe player 1 and player 2 would have been better, more clear. We're not saving that many characters. It's not worth it, honestly. But it's done at this point. Anyway, what I was going to say is if we have a bunch of them, it would be better to set up this function so it accepts an array instead of like opponent 1, comma, opponent 2, comma, opponent 3. We don't want to hard code that in. So just player and then everyone else. And then we could iterate over everyone else and, disable them all and add the loser class list to everyone else if this one player wins. But this is good enough. It's still an improvement over what we had before. There are still ways of improving this for sure. Feel free, well, of course you should feel free, but please make any changes and suggestions you have, post them, talk about them, discuss. Also, features that could be added, a very relatively simple one that makes sense for ping pong is a win by 2 feature. So if you're playing to 9, for example, I don't know if I've ever played to 9. If you play to 11, you're not supposed to be able to, have a score like 10, 11. Let me just get there. So if I right now click player 2, I will win the game. But in real ping pong, at least when I've played, you have to win by 2. So there's an edge case there where the score keeps going up past 11 potentially. So you could code that in. There are many other features you could do. As I said, multiple players. What else? You can get creative here. Fireworks when somebody wins. The ability to, do a best of 3 or best of 5, something like that, where you have multiple games and you keep track of them, have a tally or like a overall score, allow players to enter their names. So many other features. I recommend you try and tackle at least one of them and share your results. So that's it. Goodbye. Bye-bye. Welcome back, everyone. Next up, we've got a bit of a doozy of a section, asynchronous JavaScript. There's some pretty important stuff in this section, but there's also a lot of red here. So I definitely want you to know going into this section that for the average student, this is going to be a lot, and there are things that just aren't as important to understand. Okay, here we go. The first thing I talk about in this section is the call stack, and I'm going to put that under important but not crucial to be a master of, at least not at this point when we're just starting out, right? We're not experts at this point with JavaScript. That's something, if you were to be interviewed for a role somewhere, I would definitely say you need to understand everything and, well, pretty much everything in this course, but especially the stuff in this section. But it is another one of those topics that could definitely be a roadblock for some students, so it's important, not critical. Understanding web APIs. I'm going to put that in nice to have. Absolutely not something you need to master. It's sort of a look behind the scenes of how certain things work in JavaScript. Callbacks and callback hell. I'll put that in important. Working with promises. Crucial. Now, there's a distinction here between working with promises and creating our own promises. This will make sense once we talk about promises. Being able to create your own promises in your code and return them yourself, nice to have, not essential at this point. Being able to work with promises coming from a library or from another function, this will all make sense when we get there, I promise. That is critical. And then async functions, crucial as well. So a pretty good spread here. Lots of red, but lots of things that are nice to have and important. Just a couple of very crucial things to take away. So focus on understanding how to work with promises and how to write and work with async functions. Async await. That's all coming up. It awaits you in this section. Let's go. I promise you'll love it. It won't be callback hell. Bye. So the first thing we'll take a look at is something called the call stack. It's a feature, or it's a mechanism, I guess, that JavaScript uses behind the scenes. And we're going to step through it. It will help us understand a bit about how JavaScript manages function calls. And it's also something that we'll refer back to as we learn more about asynchronous JavaScript. Alrighty? So here we go. The call stack is the mechanism that the JavaScript interpreter uses to keep track of its place in a script that calls multiple functions. It's how JavaScript knows where it is. Sort of like, a finger in a book. If you're flipping back between different pages in a really long book, you're trying to reference like the glossary or what do you call it at the end? Is that the appendix? There we go. You're trying to reference page numbers and flip back and forth. You usually put a hand or a bookmark or something to keep track of where you were. It's kind of what the call stack is. So the term stack, before we actually see the call stack in action and talk about how it works, but if we think of the term stack, this is actually something I mentioned early on when we talked about arrays and push and pop and shift and unshift. A stack is a basic data structure in computer science. It is known as a last in, first out, LIFO, L-I-F-O data structure, where if you think of a stack of pancakes, a stack of books, with an apple on top in this case, the apple was the last thing added to that stack, right? We don't add to the bottom or the middle, we add to the top. And then when we remove something from a stack, we remove from the top. So stack of bills, stack of whatever, books, fruit, doesn't matter, pancakes. You remove the thing that was most recently added first. Alrighty? So that's important. Okay, so the call stack, again, is the mechanism that JavaScript uses to keep track of where it is in a bunch of function calls. So I'm going to read you something here. It's going to sound a bit wonky. When a script calls a function, the interpreter adds it to the call stack, and then it starts actually carrying out or doing that function. Any other functions that are then called by that first function are also added to the call stack further up, and they are run when their calls are reached. And when the current function is finished, then the interpreter takes it off the call stack and it continues where it left off in the last code listing. So I'm going to show you what that looks like. Often we have functions that call other functions. So here I'll just show you this very quickly in my editor. I have a function called isRightTriangle. Very simple. Hopefully, well, you may not remember how right triangles work, but it doesn't really matter. Hypotenuses and a squared plus b squared equals c squared, that whole thing. This is a function that tells us if the three sides, the three lengths you pass in, represent a valid right triangle. So I'll just show it to you here. A right triangle, a common one, is a 3, 4, 5. So 3 times 3 is 9, 4 times 4, 16, 5 times 5 is 25. So 9 plus 16 is 25. A squared plus b squared equals c squared. So we get true. If this was slightly different, we get false. It's not a right triangle. Anyway, that honestly doesn't really matter the math at all. What I want to focus on is the fact that isRightTriangle actually calls square. It calls square 3 times. So square is right here. It's a simple function, but it happens to call multiply, which is a simple function that returns two numbers multiplied, x times y. So square is really just multiplying one number times itself, x times x. All right, so isRightTriangle is going to call square, square calls multiply, and then it calls square again, and it calls square again, and then finally we have those values and we can compare them. So in order for this to work, JavaScript needs to be able to keep track of its place, because isRightTriangle doesn't give us a value right away, right? It doesn't just return 7 or it doesn't return 2 times 2 or something. It returns the result of whatever we get back from square of A plus square of B, and if that equals square of C. So at the very beginning, our call stack looks like this. isRightTriangle. I'm representing function calls on the call stack with books. isRightTriangle 3, 4, 5. That's what I called it with. A is 3, B is 4, C is 5. So we don't get an answer right away. So the first thing that has to be evaluated is square of A. So square of 3. And that's added onto the call stack. So square of 3 returns multiply 3, 3. Well, that's not an answer yet either. We have to then call multiply. So that's added to the call stack. In other words, isRightTriangle is waiting on the value from square of 3. But that is waiting on the value of multiply 3, 3. That gives us 9. And at that point, a number is returned. There's no new function calls in multiply. So it's removed from the call stack. And now square has a value. Multiply 3, 3 is 9. So it can return 9. And now isRightTriangle has a value for this first little chunk. Square of A has evaluated to 9. And now it moves on. Here's a new function call, square of 4. All right, same process. What does that return? We don't know yet. Multiply 4, 4. What does that return? 16, so that's removed. Now our square of 4 returns 16. Now we have 9 plus 16 triple equals square of C, or square of 5. We don't have a value yet, so we call square of 5. Multiply 5, 5. That means we have to wait for multiply to finish. We're not really waiting, but it is added to the call stack. It's evaluated. It returns 25, so it's removed. Then square of 5 returns 25, and it's removed. And now we have all of our numbers here, no new function calls, and the math can actually happen. 9 plus 16 equals 25. That is true, and we're done. So that's what happens behind the scenes. JavaScript adds those function calls to the call stack, and then it removes them whenever a value is returned. So the whole answer here, the whole value we get back, is true. So we can actually see this in action. I'll show you a couple of different places. First of all, there's this little tool called Loupe, L-O-U-P-E, that it's pretty nice. It helps visualize the call stack. It does not like arrow functions or let and const. It does not like any of that, so I had to rewrite our functions a bit. But here we are, same exact code, or same idea. I'm calling isRightTriangle 3, 4, and 5. I'm going to hit save and run. I'm just going to pause then. our call stack is being visualized here for us. It has is right triangle 3, 4, 5. Well, that can't give us any answer until it has square of A and square of B and square of C. And as we know, each of those has to get an answer, if you will, from multiply. All right, so I'm going to resume. Okay, so square of A, square of B equals square of C. So it's going to call square of A first, which is going to call multiply. And then that gives us an answer. So it's popped off the stack. And now it's going to call square of B. And that gives us an answer. And then we'll call square of C, which needs to call multiply. That gives us an answer, pop, pop. And then we have all the numbers. And finally, it evaluates to true. It doesn't actually show us the value. I didn't print anything else. But that's one way of seeing it. Another, much more common tool to use is actually built into Chrome, the debugger. So I have written this code in a JavaScript file. I've connected that to an index HTML, right? I'm going to open it up in the sources tab this time, not the console, but sources. And if you don't see anything here, you can expand this. Under page, I'm going to click on app.js. That is my script. And then what I'm going to do is first, I'm going to make sure I call is right triangle at some point. We'll do 3, 4, 5 again. And then if I put a breakpoint, which I can do by clicking right there, you see I get that red dot. Also over here it says breakpoints, line 9. What this will do is when I refresh the page, it's going to stop my code's execution and allow me to, it's sort of like Matrix time or something. It just stops. I guess Matrix time doesn't stop, does it? I haven't seen that movie in a long time. It just pauses it. If you've ever seen that movie Click, it's more like that. Adam Sandler movie from years ago. Not the best film. It did make me cry though when I was a kid. Anyway, it's going to pause execution and allow me to inspect variables and values and move through time one function at a time. Okay, so I'm going to refresh the page. And this is what I get. All right, paused on breakpoint. So if I had code after this, which I could just add in here really quickly, at the very end, console.log done. And before that, console.log, I guess I should do before and after, but whatever. If I look in my console, I will see before. So we got to this line, all of this ran, and then we paused. So this did not finish or didn't even start. This did not run. So we pause here. Now, I'm going to step through. I'm just going to use these buttons here because the shortcuts are kind of annoying for me I have to tell you exactly what I'm typing, but you can see the shortcut if you hover. So I'm going to click, and if you watch here, call stack, this is going to represent our call stack, and is right triangle is added. Okay? And the value for A is 3, B is 4, C is 5. But there's no value yet, no return value, because we don't know what square of A is. So that's the first thing that needs to happen, and now square is added to the call stack. You can see if I look at square, it says X is set to 3, but that doesn't give us a value. It calls multiply. So now we have multiply on the call stack. And then that's going to give us 3, 3, right? X is 3, Y is 3. So then hopefully it can return a value, which it does. It shows us here the return value is 9. So now it's going to be removed from the call stack. There it goes. And now square is able to return 9 as well. That's what it was waiting on. So it will be removed from the call stack. So now square of A has been evaluated. We know that it's 9. So now we need to do square of B. So I'll go faster here. We end up with square and then multiply returns, square returns. Now we get to square of C. Okay, keep going, multiply, that returns a value, so square can return a value. Now we have all 3 values that have been returned from square A, B, and C. And then I step through one more time, and we finished is right triangle. I didn't print it out, so we can't actually see that we get true, but it's done. And then we console.log done at the end. If we go to the console here, we can see done is now printing out, or it has printed out. So that is a basic intro to the debugger, a very basic intro. This is useful in a lot of situations when things are going wrong. If you're not sure what in the world is going wrong, or where something went wrong, or why, what you can do is put a breakpoint in. So I'm going to actually get rid of this breakpoint and refresh the page so we go back to normal. But if I was ever confused about something at some point in my code, I can put a breakpoint, I can pause, and then I can actually play around with values in the console. But for now, I really want to just use this as a demo for the call stack. Debugging is a separate topic. Alrighty, so the call stack is not a physical thing we look at. I mean, it's underlying all of our code. It's a structure, a tool that helps JavaScript keep its place in our code, in our function calls. But this is just a representation. It's just a tool for us to view it, just like this is here, or just like my lovely slides are. All right, so that's the concept of the call stack. Next up, we'll continue talking about how JavaScript works behind the scenes, under the surface, under the hood. That's what I was looking for. I don't know why I said under the surface. Under the hood. Okay, so this is all information that's going to help us understand why. It's going to motivate why we're learning things like promises and async functions and why this all matters in JavaScript. And in other languages, it may not be an issue. In some others it is. Anyway, this sentence in front of us, JavaScript, is single-threaded. What does that mean? This is a vast simplification, but basically it means that there's this one thing in JavaScript that can be working on a process at any given point. Think of it as having a one-track mind. It cannot be multitasking in the sense that it's actually doing two things simultaneously. So another way of putting it is that JavaScript is running at most one line of code at a time. Now, it can switch back and forth between different lines of code. They all happen very, very quickly for the most part, so we don't really think about it. We don't think that only one thing is happening at one time, but the reality is that JavaScript itself, at any given point in time, is running at most one line of code. Now, that seems like it could be very problematic. For example, shortly we're going to get into Ajax and making requests, loading information using JavaScript. So we'll write code on the front end that says things like, hello, movie API, please send me all the movies that match BAT. They have BAT in a title or in their title. Well, that's going to take time. That could take a split second, half a second, or if our internet connection's poor, if the server is down, if we have no internet, that could take a couple of seconds or more to time out. Or if we're trying to load something large, like a really large image or a huge set of data, I mean, that sometimes can take quite a while. So what happens in between that time when I request it, I write the code to ask for something, and then the time where I actually get a response? Well, if JavaScript can only do one thing at a time, and this takes time, let's just say it takes 5 seconds. Does that mean nothing happens in my code for 5 seconds? Is everything just going to grind to a halt? What if I had something like this? This is, not fully implemented code, but this is a common thing we might do. New to do equals some value from an input, and then I'm calling some function, it doesn't actually exist right here, called save to database. And that can take time as well. My database is somewhere else. It's on a server somewhere. I've got to send a request, and I need to hear back from the database or from the server that says, okay, that worked, or no, that didn't work. So that might take, let's say, another 5 seconds. So is there 5 seconds in between this line running and this line where we extract the value, and then a user waits for 5 seconds or 10 seconds or longer, and then we set the input to have an empty string or just reset it to be empty? That is not a good experience for a user. Unfortunately, that's not what happens. Even though JavaScript can only do one thing at a time, it can only focus, it can run one line, at most one line at a time, there are ways around this. For example, we've seen this before, set timeout. Set timeout is a way of running some code after a delay. Okay, so imagine that I have a nice little console.log, right? And I have, hello, everyone. And then I have my set timeout, which just as a recap, it receives or it expects a function as an argument. So I'll just do an arrow function. And in here, let's pretend, actually, instead of hello, everyone, let's go with sending request to server. I'm just going to fake it. And then in here, after the second argument is a number of milliseconds, so in this case 3000, aka 3 seconds. After 3 seconds, I'm going to print out, here is your data from the server. And we'll just pretend we actually got something back. All right, and then down here, hopefully this is all recap, but I'll console.log, I am at the end of the file. All right, so what order do we expect to see things printed out in when I actually run this? This hopefully is obvious. This happens first. Then this code runs. And we just talked about how only one thing at a time can happen, right? So are we just waiting for 3000 milliseconds? Is JavaScript just counting, 1000, 1001, 1002, 1003? No, It does not just sit there hogging everything and stopping this code from running. And instead, this runs kind of. We'll talk about what that means. And then life moves on and it just runs this line. And then after 3 seconds, this prints out. So we can see that here, right? Sending request to server. I'm at the end of the file. 3 seconds later, here's your data from the server. So how does that work? Why didn't things just get held up? Why do I see this line printed out? If we just said JavaScript single threaded, shouldn't this just stop everything? It's just waiting for 3 seconds. Fortunately, the answer is no. How does it work? Well, the browser is actually doing the work. It's not JavaScript. And this is this is the part that's really under the hood, that it's not a huge deal if you understand this, but it's good to know. What happens is that the browser itself, your browser, whether it's Chrome or Firefox or Safari or something else, that browser is not written in JavaScript. That browser is written typically in a language like C++, and it can do things JavaScript can't do. So what happens is that JavaScript actually is going to hand off certain tasks to the browser to take care of. Browsers come with something called web APIs, and these web APIs are generally methods, things that we can call from JavaScript that basically are handed off to the browser. It's JavaScript saying, I can't really do this. Can you take care of this for me, browser? And these things happen in the background. JavaScript doesn't really have to care about it because they've been handed off to the browser. So this includes things like set timeout, but also things like making requests, which we'll see soon. It's the same idea. They take time. They could take 5 seconds. They might take a split second. It might take 10 seconds, hopefully not. But JavaScript isn't the one doing it. JavaScript isn't in charge of that. Instead, it's handed off to the browser. So how it works in practice is that the call stack in JavaScript is able to recognize these special web API functions, and it can pass them off to the browser. So it says, here you go, please remind me in 3 seconds to take care of this. And then once the browser finishes those tasks, let's say 3 seconds later, then they're added back to the call stack. Then JavaScript takes over again and executes the appropriate code. So here's an example of what we just did, slightly different text that were printed out, or that we are printing out. Console.log I print first. All right, so JavaScript can do that, right? It prints out I print first, that's what we see. Then we encounter set timeout. Now that is one of the web API functions. So it's passed off to the browser, which I'm indicating, or I'm representing as this down here. Hello, browser, can you please set a timer for 3 seconds? That's basically what's happening. And then after those 3 seconds are up, remind me to run this function. Okay, so then JavaScript just goes about its life. It does the next thing. Console.log I print second. And the browser this whole time is sitting there tapping its fingers, waiting and counting. Has it been 3 seconds? Has it been 3 seconds? And then after it has been 3 seconds, it says, time's up. I'm the browser. Hello, JavaScript. Make sure you run that callback now. And then JavaScript runs that callback, and we get I print after 3 seconds. All right? So the whole mechanism by which this works is, well, there's really two things. One is the fact that browsers come with these functions, these things that browsers can do for us, for JavaScript. And the second is this concept of the callback, of passing a function in that is not executed right away, but is instead executed later. If we had just written this code as a console.log or something, it would be immediately executed. But because it's wrapped in a function, it's not executed. It's wrapped up in a function until it's time for it to run. So this is a bit, we're kind of in the weeds here, but it's important to understand, or it's at least, I find that it's helpful, just because when I say things like JavaScript can only do one thing at a time, that seems entirely at odds with what we're seeing here, that this code is able to run before this finishes. How is it keeping track of that time and printing this out? But remember, it's not. The browser is keeping track of the time. JavaScript just does one thing. And we can actually see this over here. I'm just going to copy my code. That tool I showed you in the last video called loop. I have to replace this with an arrow function. Forget about that. It does not like arrow functions. Okay. Let's see what happens now. So I'm going to pause. And it runs our first console.log, sending request to server. Okay. Then, I think actually I can open my console and we can see that. There it is, sending request to server. And then it gets to this next part, the set timeout. And it's going to pass that off to the web APIs, which is what we see over here. There it is. And then this is visualizing the timer. So I don't actually know if this will take 3 full seconds, but that's the principle. Console.log, I'm at the end of the file. So JavaScript moves on. Its call stack does not contain this function at this point in time. But Then those 3 seconds are up. The web APIs finish up, put it in the callback queue, and then JavaScript takes over again, and it runs that callback, and we finally end up with all 3 console.logs. So you don't need to be an expert in this. You don't even really need to know this, but I've found that it's helpful for what we're going to learn next. Next up, a little bit of a demo involving callbacks. So I have a new almost empty HTML page, just my H1 that says hello. And what I'd like to do is write some JavaScript that will change the background color. Let's just go through the rainbow from red or to red, then to orange, then to yellow. But I want it to be spaced out. So I can't do it all at once. Obviously, if I did everything at once, document.body.background color or style.background color. I'll set it to red. If I did that, that will work, hopefully. But then if I do orange immediately after, it's just going to be orange. There's a split second where it is red, but we don't pick it up. So what I'd like to do is delay it so that we get, maybe 1 second of red, then 1 second of orange, and then 1 second of yellow. And we know that in order to do that, in order to wait, we need to use set timeout, or at least we need to do something to delay it. So I'm going to do just that. I'm going to set a timeout, set timeout, and then we pass in a callback function, and then a delay. I like to do that first. So what I say, 2 seconds, 3 seconds? I can't remember. 1 second, something like that. And then I'll put my code in there that I want to do. So in this case, I'm just going to turn it red after 2 seconds. Let's do 1 just to keep it easier and shorter. So white and then red. Okay, so that works well enough. And now if I want to make it orange 1 second later, I have a couple of options. I mean, I could duplicate this. And then, now if I run it right now, it's not going to work. Well, it's going to be red, but if I change it to orange here, we're doing the exact same interval or same delay of 1 second. So it just ends up turning orange after a second. But I could double this and say, wait 2 seconds. So this is going to be 1 second, and then this will be a second after that one. It's kind of janky to do this though, because I'm depending upon the timing of the first one, right? I have to sum that in. I have to add that. So if I wanted to do yellow, and I want that to be a second later, I'm going to do 3,000 milliseconds. And all of a sudden I'm doing some math. So it'd be nice if I could just say, I want this to be 1 second, and then 1 second later do this, 1 second later do this. Now, the way that I can do that involves nesting. So I could nest this in here. So set timeout, after 1 second, run this function. And then after we change it to red, set another timeout for 1 second. After 1 second, run this function. So this function only runs after the first one runs, which is 1 second, and then the second one is another second later. So 2 seconds, all right? And then I can do the same thing. I could just put this in here, and I end up nesting. So this will be a full second later. Let's verify that it works. We should have red, then a second, and then another second. Cool. Also, just to get fancy, I'll add a little transition. Style, I'm just going to do it here in my HTML. I'll do it on the body, transition, background, dash color. I don't know. Let's just do 1 second, linear. There we go. Nice little transition there. Okay. So if I wanted to keep going, right, we know what I could do. I could just keep nesting this further. So we'll do red, orange, yellow, green, and then blue. And there's our beautiful rainbow. Okay. So this is fine, right? This works. I mean, we're getting quite nested. Now we could also extract this into a function. So if I wanted to do this a lot, not just, change it to red, orange, yellow, green, blue, but maybe I wanted to be able to reuse this and maybe have different delays. I could write a function, maybe something like, what should we call it? I guess I'll use an arrow function just to be consistent. Const, how about delayed color change? It's kind of long, but that's fine. And then in order for this to work, we'll need to pass in a couple of things. We need to pass in the color we want to change to. So new color. We need to pass in the delay. And we need to pass in what you're supposed to do next. So I could just do this once, like this. Delayed color change. Instead of here, we'll call set timeout. So I'm just duplicating what I've done, but I'm trying to make it more generic so that I could reuse it. So set timeout, and here I'll have my callback. And then I'm going to have some number of seconds, which you pass in, which will be delay. And then in here, we'll do our document.body.style.background color equals whatever that new color is that was passed in. So to use this, I would call delayed color change. And then after that, I'd pass in, or not after that, but in there, I'd pass in my new color. And then the number of seconds or milliseconds, let's do 3 seconds. Change to olive. Let's see if it works. Moment of truth. Come on. There we go. So it does work. But now if I want to have a second one, right, I could do this where I could have a different color afterwards. How about, is there a dark olive? I swear there's a dark olive. I don't want to risk it though. I might be wrong. So how about magenta? That's going to be a horror. How about teal? And I want that to be 3 seconds later. Well, this isn't going to work. We'll just end up with it being teal after 3 seconds. It's the same thing that we did earlier where I said it wouldn't work. We'd have to either add on and do 6 seconds here if we wanted 3 seconds later, or I need to nest them. And to nest them, I can totally do that, but I need to work with callbacks. I need to pass in a callback here. I'm going to call it do next. And whatever do next is, it will be a function. I'm going to execute it after we change the color. So I'm just replicating what we had here. All this nesting, it's going to look like this. Delayed color change. Let's go with the rainbow just because it's easy. Let's do red after 1 second. And then the third argument is a function. So I'm going to call or pass in a function. And in this function, I can do whatever I want. I could just do console.log inside callback. And we should see that after 1 second, we get inside callback. So it doesn't run immediately, right? Because it's it's inside of a set timeout callback. It runs after this delay, which was 1 second. So now I could add another delayed color change. And this time I can do orange. And after 1 second, I should also probably check. I'm going to do if there is a do next. So do next, and just in case you don't pass it in, it will be undefined. Anyway, 1000, and we'll do another one here. I'm just going to duplicate this whole thing and keep nesting this. So in here, we'll go to yellow, and then to green, and then to blue, red, orange, yellow, green, blue. All right, we'll stop there. Okay, so these are all after 1 second. Let's see if it works. Red, orange, yellow, green, blue. Just beautiful. All right, so we just replicated what we had before, right? But now we have a generic function where I can pass in a number of seconds. I can pass in a callback afterwards. This pattern is super common. It seems weird, but anytime we have dependent actions where one thing needs to happen and then only after the first thing is finished can the second thing happen, well, that's where we frequently use callbacks. Here, we could do the math, and I could say, this thing needs to happen, 5 seconds later? 1, 2, 3, 4, 5, right? I could just say 5,000 milliseconds, but there are times where we don't know. For example, this is all fake code, or not real functions that don't exist at the moment. Let's say that I'm working with some data from a movies database, and I'm going to search movies. I'm going to call it Movies API for Amadeus, probably my favorite movie ever. That could take a lot of time. It might be very quick, but it might be a couple of seconds. I don't know. So this function, which again does not exist, it doesn't work, but we'll see how to do this later, pretty shortly actually. It will accept a callback, and it will execute this callback whenever it finishes searching for movies. So let's say it finishes. Then what I want to do is I actually want to send the movies that I searched for, and I want to save them to my database. So I could have another function save to my DB. And whatever those movies are that came back from searching, but that might take time as well. And it might work, and it might not work. And this is where it gets crazy, because often what you'll see is actually a pattern where we have 2 callbacks that we pass into a function, a success and a failure. So if things go well, this could be our first callback. And then if they don't go well, we can have a second callback. Now, things might be getting crazy in here, and you might be a little bit confused, but this is a really common pattern. So if it works, run this. If it doesn't work, run this. This is incredibly common because we just don't know. This might work, saving to the database, but maybe the internet's down, maybe the database doesn't exist, we don't have permission, it's full, I don't know. So it might not work. So we need to anticipate two possible outcomes, and we won't know until it happens multiple seconds later. Same thing with this, actually. Searching for an API, it might work, we might get data back, but there could be a whole second callback here if API is down or request failed, right? So we could do something else in here. So what I'm trying to show you is that yes, nesting like this is bad, but frequently what we'll actually have is more than one callback we pass in to each function for these asynchronous operations like this fake searching for movies or saving to database. They could work, they could not work. And the result of this is something that a lot of programmers, JavaScript developers refer to as callback hell, where we end up passing a whole bunch of callbacks. Our code gets very nested, very deep, and just crazy and ugly and confusing. So this is a problem in JavaScript. The whole idea of having to use callbacks is something we can't really get around, or at least having to provide a mechanism for running code later at some undetermined point in time, whether it's a second or 10 seconds from now or 0.2 seconds. It doesn't matter because JavaScript just moves on, right? We've talked about that. It just does one thing at a time. It keeps going. It hands things off to the browser and says, all right, let me know when that finishes up. So we have to use callbacks or something to delay code execution. And because of that, they get messy, especially when we're using callbacks. Fortunately, there are some newer additions to the language that make things a little bit easier, namely promises and async functions, which is where we're working towards. I just needed to explain this concept of why callbacks can be so frustrating to work with. If you're doing a single set timeout, it's not bad, but if we have 5 or 6 dependent actions, all of a sudden our code's very nested. And then if each one of these actually could have multiple callbacks, like I showed here, where something might work, but also might not work, that nesting grows even crazier, and we really end up in callback hell. So this is where promises come in, and it's what we're going to start in the next video. If you're feeling a bit confused, hang in there. All right, so now we get to promises, kind of. This is going to be a multi-step introduction. Let's begin with the overarching idea. Promises are objects that represent the eventual completion, or let's say eventual success or failure of some operation, some async operation. So the most common example, and the one that we'll be working with a lot, is making a request, getting data from some other location, getting data from a movie's like IMDb API or from Netflix's API, or getting information from, what else is there? Amazon's API, Goodreads API, the weather API, whatever it is. We haven't actually seen how we do that, but we've talked about how it takes time, and sometimes it works, and sometimes it won't. Maybe you don't have the right credentials, or the URL is incorrect. Maybe the API is down, or your internet's down. There's a whole bunch of things that could go wrong. So what I'm going to do, if you download the code, there's a folder called Promises Intro, and there are 2 functions in here I've already written, and we're not going to touch them at all. I'm just going to show you how they work, or rather how we work with them. So I mentioned in the previous video that a really common pattern for things like making requests, at least in the past, would be something like this. Make request, and then we would pass in 2 callbacks. The success callback, so we could have our first callback, and then a second callback, only one of which is going to run, which often we would call our failure or fail callback. So make request would be some function implemented that basically checks, all right, did this request work? Then call this function. If it didn't work, call this function. So we end up with 2 callbacks per request. And then if I want to do something after in the success, I end up nesting again and again, right? I get this very nasty looking thing. And that's actually what I've written here. I've written a function called fake request callback. So it's not making a real request. We're not loading real data. But what it wants you to do is pass in a URL. So I'm just going to try it here. Fake request callback. I'm going to pass in a fake URL or a real one. It doesn't matter, but let's just say books.com. Okay? And then I have to pass in 2 callbacks, success and failure. And only one of these is going to run, and it's all based upon a random number. So I'm picking a delay from 500 milliseconds to 5,000 or to 5 seconds. And if that delay is greater than 4 seconds, I'm going to call the failure callback. So it's all based upon the order, right? Success is the first callback, failure is the second. So if it takes more than 4 seconds, we'll get a connection timeout. Otherwise, we'll call success, which is just the name for the first callback. So we can pass in 2 callbacks. Again, here's the first one. This would be our success. Let's do console.log. It worked. And then our second callback, a second argument here, another function, console.log, error. All right. So let's just see what happens. I'll run it. We wait. And we get it worked. Let's try it again. It worked. And eventually, nope, still it worked. Eventually we'll get the error. Come on. There it is. It only took me like 10 more tries. Okay, so we see error. All right, so imagine this is real. This is not random number based. It's an actual real request we're making. And that will help us understand why we would do this. It's a little trivial when we, completely manufacture this random number thing. But if I introduce real requests right now, there's just a lot to talk about. The nature of requests and get versus post and status codes and the response body. There's just a lot of additional baggage that we have to cover. So we're starting with our fake requests. Anyway, if you notice, these callbacks are called, I execute them, but I'm also passing information in. So this is a really common pattern as well. And we've seen it before. If we do something like, imagine there's an array called array or ARR. When we map over it, we pass in a function, right? And this function has a parameter we define, like we'll call it element. And element is filled. It's actually passed, right? Map is automatically going to pass a value to this callback. Same idea here. My callbacks, if I look at how this function works, or if I didn't write this function, if I looked at the documentation, I would see that there's going to be a failure message passed to the failure callback, and then there's a success message passed to the success callback. In this case, they're just strings. But if I wanted to work with them, also, you'll see people do this as well, where you indent. So this is success, the first one. We'll call this data or response. Console.log it worked, and then we'll console.log the response. And then here, we can call this error, and we'll just console.log the error here, all right? So nothing really different except now, all right, we see it worked, and here is your fake data from books.com. That is what was passed to this callback right there. Here's your fake data. Okay, so now let's say I want to make another request only if books.com works. Let's say I'm doing books.com/page1. So if we got page 1, I also want to make a request to page 2. So I need to do another fake request, and then books.com/page2. And then I have to have my 2 callbacks. I have my success callback. Here's our response. Let's just do that right there. It worked again. And we'll print the response. Otherwise, we have our second callback where we have an error because this second one could go wrong. The first one might have worked, but the second one could go wrong. So we'll print error here. We'll do error second request just so we can tell what's what. Okay, and already this is pretty nested and obnoxious, but let's take a look. Does the first one work? Okay, so our first request came back, and then our second request came back. So in order for us to wait, to only make that second request after the first one finished and was successful, we have to nest it inside of this success callback, right? It's like a branching path. Success, fail. But then inside of success, I can make another one, and we have success and fail. And I'll make one more, which is, it's definitely a thing in the real world where we might have 3 requests. I want to make one after another, but in a chain, a sort of a series, only if each one worked. So if one of them at any point fails, I want to stop, which is what we're doing here. So inside of here, one more fake request, and then I'll put my books.com/page3. And then my first callback, right? And this one, we'll do the same thing. I'll just console.log it worked. Again, let's do third request. And then our error callback. And this whole thing just gets hideous. And this is exactly what people are referring to when they say callback hell. It's just a nightmare to try and figure out, all right, if I need to change the second request fail callback, it's not that hard to figure it out, but it's just not immediately obvious. And then keeping things indented properly and, associating, all right, these two are connected, success, fail, it just gets overwhelming. But let's update this. So this would be an error for the third request. Now we'll make our first one. If it works, we make the second one. If that one works, we make the third. If at any point it does not work, all right, good so far. And, timed out, and now we're done. We didn't make that next request because we didn't run that success callback. But one of these times we'll get all three. Just sitting here waiting. Oh, first one failed. So again, this is mimicking something in the real world, right? This function I wrote is completely fake and silly, but this is something that is real, where a request may not work. Hopefully it has a much better success rate than ours right here. Okay, 2 for 2. Hey, there we go. We get all three. Okay, so this is the callback approach, and this is how we would do things for a very long time. When making requests, we would have our success and our fail callback. And then if we needed a nested request, it was the same thing. 2 callbacks per request over and over and over. And it wasn't limited to just making requests, but that's a really common use. And again, we haven't seen real requests, so this is all silly and fake for the moment. Anyway, then along came promises. People got very frustrated with this experience, as you can probably imagine. It's just annoying. Look at this code. It's scary. It's ugly. So promises came along, and they promised a future where we could have asynchronous code where we didn't need to have all of these nested crazy callbacks, but we could still have the exact same logic or the same flow where, we only make this second request if the first one works. We only make the third one if the second one works. And then at any point, if there's an error, we'll print out the error or we'll do something. We handle the error. So promises still allow us to have that branching path. Do this and then do this and then do that. But it looks a lot nicer. It's a lot easier to understand. There's just a bit of syntax we have to cover. So in the next video, we'll see how we work with promises. Okay, I kind of cheated you in the last video. I said we were going to talk about promises, but I still kind of just set up the idea of promises. But now we're actually going to see the syntax. So we saw this horrible callback hell situation where we have a success and a failure callback. Everything's nested. It's hideous. And I said promises make it better, or they can. Remember, promises have not been around since the dawn of JavaScript. If we just go to MDN and we take a look at the promise page, you'll see that there's not support in Internet Explorer. But these days, IE support is not necessarily mandatory, depending on what you're working on. Anyway, promises are new. That's the first thing I want you to understand. Second, there's a bit of syntax involved in promises, and we're going to go through it step by step. And you might feel lost or you might feel confused at some point. If this is all new to you, this has been a whirlwind of asynchronous JavaScript, and we're going quickly. I recognize that. And this is even in person when I'm teaching this, and we have multiple TAs and exercises and office hours and students study together. It's still one of those topics that just some people have a rough time with. So don't feel bad about that if you do. I'll point out the stuff that's really essential, and then the stuff that's good to know, but not mandatory in any way. Okay, so a promise is just an object. It's a promise of an eventual value that may or may not work out. I like to use the explanation or the analogy of a promise in the real world. When I was a kid, let's say I really wanted to get candy. My parents would never let me have candy, and now I have a massive sweet tooth. It's horrible. I wish I was allowed to have more. Maybe I could have some self-control as an adult, but I don't. So as a kid, I would beg to go to the candy store anytime we were near the candy store in the food court where I lived, or not where I lived, near where I lived. And I would ask and say, can I please have candy? And I would be promised, if you are a good boy and you eat all of your dinner and you eat all your vegetables, then you can have candy. Now, that is not the same as me having candy right then, right? It's not the same as just handing me candy when I wanted it. It's a promise for the eventual hopefully resolution of me getting candy, but also I might not eat my vegetables. Most of the time, I had a pretty rough time with that. I might fake eating the vegetables, put them in a napkin under the table, wait until we go by a trash can, throw it away. Sometimes that worked. Long story short, a promise is the eventual guarantee of either a value or an error. It's the eventual resolution of something good or bad, but it's not the same as having that value. So if I've written a function in here called fake request promise, it does the exact same thing as this callback version, except it does not involve callbacks. We're not going to talk about the syntax here just yet. We're just going to use this. We'll be on the other side of calling this function. We're not going to write it. But if you notice something, it only expects you to pass in a URL. It does not expect a success and a failure callback. It doesn't expect callbacks at all to be passed in. So if we just call it, I'm just going to comment out our callback hell. If I call it over here, fake request promise, what you'll see, I can pass in any URL here, it doesn't matter. What we get back, the return value, is this thing called a promise. Now, if I save that to a variable, I don't know if you could see that, but at the very beginning it says pending. And then it's not going to update here, but if I open it up, it actually says resolved. So I'm going to save that to a variable, fake request. Let me just hit the up arrow. Fake request promise. Let's say I'm going to, I don't know, hikingtrails.com/API/ near me. Okay, I'm going to save that to a variable. I'm just going to call it res. If we look at res, it says pending. And I look at res again, now it says resolved. So it's this object that just represents at the beginning the eventual value. It doesn't have anything. It just says that there's going to be something here. And then in this case, it was resolved. But I could make another one if I just redo this. Oh, I shouldn't have used const. Let's do response, and I'll use let. All right, so if we look at response here, is it still pending? Yeah. Oh, there we go. Now it says connection timeout. If we look at our promise, which we got back, rejected. So those terms, resolved and rejected, represent basically success and failure. It's just the terms that are used, resolved and rejected. So this promise can have three states. It can be pending, like it is at the beginning while we're waiting for something, right? Promises represent this asynchronous value that eventually will be resolved or rejected. But at the beginning, that might be almost instantaneous, but it could be an hour that it's just pending. I don't think I've ever done anything like that, but it could be. So it's pending and then eventually resolved or rejected. Now what I can do, and the whole point of promises, is that I can run code when that promise is rejected or when it's resolved. And the way that we do this is by attaching callbacks to the object, to the promise itself. Rather than passing callbacks into a function, we wait for the function to return a promise object like it has here, right? Every time I call this, I get this object, which is a promise, if I can spell it correctly. And I can attach methods, or I can attach callbacks to it that will run depending on whether the promise was rejected or resolved. So here's how it works. I've got this fake request promise. It's the same thing we just called in the console. I need to pass in my URL. Let's do, what else? yelp.com/API/coffee. All right, let's pretend that gives us some real results. It doesn't. I save that to a variable if I want, const, and I could call this, I'll just call it promise or request, sure. So this gives me an object. And then if I want to run code, if this is resolved, if the promise is resolved, I do this, request dot, and then this is the important part, dot then. And I pass a callback in here. So I'll just do an arrow function, and I'll console.log. It worked. Okay, so let's just see if we get that. Hey, we did. So that tells us the promise was resolved. If I look at, or no, what did I call it? Request. If I look at that, it says resolved in here. Okay, now eventually, and I could do this again. No, that one worked too. But eventually we'll see that we'll get one that was not resolved. Here we go. We got a connection timeout. Again, fake, but that's how I've written this function to return a promise that sometimes is rejected. And if we look at it, request, it says rejected. So I can also run code when the promise is rejected or if it's rejected. And to do that, there is a method called .catch, and I can pass a callback into that. And I can console.log, oh no, error. Okay? And often what you'll see is people space these out, or they put them on the next line like this, so it's just a little bit flatter looking. Okay, there we go. So this is an object. There's a method on it, .then. There's another one, .catch. We pass a callback into both of them. Only one will run. If the promise is resolved, this function runs. If it's rejected, this function runs. So I'll even make that clearer. Console.log promise resolved. And then here, promise rejected. All right. So we wait. Hey, it worked. That was a quick one. Promise resolved. It worked. Next up. I'm trying to get a rejection. Come on. Nope. Nope. Oh. Yes, there we go. Promise rejected. Oh no, error. So I could make a second request, right? If I mimic what we did before, let's do coffee/page1, and then I'll do the same thing for page 2. First, I'll show you though that you really don't need to save this to a variable. What a lot of people do is just chain it like this. Just like that. Fake request promise. This returns an object, a promise object. Then we chain our .then and our .catch. Then in the .then, in this callback, that means it worked. I can make another one, right? Page 2. And then I need to add my own .then. So we'll just do 2 levels to start. Okay, so in my .then, what do I want to do? I'm going to do a promise resolved. It worked, but I'm going to say 2 just so we can see there's a difference. Alrighty, so this may not seem a lot better than what we've seen so far, but I promise it will be cleaned up, right? This is still nested. We're nesting more here. We have our .then. Let's just see what happens though. So the first one worked, and then the second one worked. Good news, right? So we made one and then the other. But what if this second one doesn't work? Well, I can have a .catch here as well, and I'll just copy this. Why don't I just duplicate that? Okay, so we have our .catch for this second request, this fake request, and let's see what we get now. It worked. Oh, and it didn't work that second time. So our .catch, this callback, ran. So I'm going to clean things up just a tiny bit. We won't say promise resolved every time now. Let's just say it worked. And then I'll put request, or how about page 1 here? And then I'll duplicate this and say page 2 here. What did I do there? Just so we can tell where things are going wrong. And then I'll do error on page 2. So we know versus error on page 1, and then I'll make a third request. So the same exact thing after and only if the second request works, which means the first one also worked. So fake request promise. I should just copy that URL, fake URL, page 3, and then I chain on my .then with my callback, and we'll do it worked for page 3. Oof. This seems like it's not really an improvement at all. Trust me, it will be. But I just want to show the very basics, how we can recreate what we already had. Okay, so lots of nesting. How is that any better? But let's just see that it works. So we make our first request. That returns a promise. If it's resolved, this callback runs. If it's not, we stop. It's a dead end. We get an error. So then if it is resolved, we make our second request. First, we print this out. It worked, page 1. Then we make our second fake request, and the same thing repeats. If it's resolved, this runs. Otherwise, this runs. So here we are. I refresh the page. First one. Oh, we errored out on the very first one. Let's try it again. Come on. It worked. Now, next page. It worked. And it worked. All right, so we made it. We got all 3 pages of data, which really is nothing. We didn't get any data. However, this really doesn't seem like an improvement at all, and it's not. We just moved the nesting from inside our function call right here. We're passing callbacks into fake request callback. This is all nested between the opening and closing parenthesis. Here, we're not nesting it that way, right? We're not passing it into fake request promise. Instead, we're calling a .then and .catch method on the returned promise object, but that still requires us to nest stuff. Well, in the next video, we'll see the magic of promises that allows us to actually significantly shorten this and flatten it a lot. So that's coming up next. At this point, it seems like promises are kind of maybe a waste of time, but they're not. Now, on to the cool part, the magical part of promises. Magical might be a bit strong. actually cool might be a bit strong too, but the nicer part about promises, the part where they get better than callbacks, because at the moment, this really doesn't look any different. We still have that same level of nesting. So here's a secret. With promises, instead of .then, I can actually return a promise myself. So this is a promise here, or it gives me a promise. If I return that from within .then, I can chain other .thens on without having to nest them. So I'll rewrite this. I'll keep this. I'm going to make the first bit here. So here's our first request. Just comment this out. And then we're going to have a .then. We know that. So let's just start there. And inside of this .then, what do I want to do? I'll just console.log that same thing again. And then I'll make my next request like this for page 2. This is no different than what we did before, but what we did before was that we wrote our .then right here and we chained it on. Well, that's not valid syntax. There we go. Inside of there, we chained it on to this promise, the object that's returned from this method or from that function. But I can instead return this promise. And what that allows me to do is just write my .then here. I don't need to nest it. I'm returning a promise here and I'm calling .then on that returned promise. So in here, I can do the same thing. I'll print out page 2, or it worked for page 2, and then I'll return another promise to do page 3. And then I can do another, I'm just going to copy the whole thing, .then, page 3, and I won't make another request. We'll just finish there. So we still don't have .catches in the picture, but the extra nice part is that I can use a single .catch for all of these. So in here, my callback, console.log, oh no, a request failed. So if at any point one of these promises is rejected, it falls through and it hits this .catch. So this is the same idea as what we had up here. The one big difference is that I'm actually printing something different in each .catch. I'm saying error for page 3, error for page 2, error for page 1. Here, we'll always get that same message. Oh no, a request failed. It doesn't matter really in this example, but that's something to be aware of. I can put my own .then and .catches and I can nest things, but this is far nicer. It's flat. It's completely flat. Well, almost completely. We do have some indentation. But I could make 10 subsequent or sequential requests. First this one, and only if that works, then the second one. Only if the second one works, then the third one, and so on. And I wouldn't have to go nested 10 levels deep like I would with callbacks or with what we saw in the previous video. But let me shut up and just prove that this works. So I refresh. Okay, first one worked. Second one worked. Third one worked. All right, let's see one where we get a rejected promise. First one worked. Second one worked. Come on. Ugh. We need one of these to be rejected so I can prove that the catch works. Okay, well, there's our first .catch. That was the very first request failed. First one works. Second one. Oh, there we go. It failed. So we didn't have a separate .catch for that second request. It just fell through to this right here. So again, the trick to all of this is that we return a promise from within our callback, from within the .then callback, and that allows us to chain things on. So run this. If the first promise is resolved, return a new promise. So then run this if it's resolved. And if it is, return this new promise. Here's our .then for that new promise. But if at any point that promise is not resolved, aka it's rejected, our .catch will run. Okay? Now, the next thing to know about promises is that they are resolved and rejected with values. So right now, our callbacks here, they don't have any parameters. But actually, a promise can be rejected and resolved with a value passed to it, and that's important. If I was actually making a real request, we would want the data. And the way I wrote fake request promise is that it actually does pass in some data. It's not real data, it just passes in a string. So let's use that. Let's print out the data. Just like that. And then I'll just duplicate that for each one of these. And you'll see that we do get data passed through. All right, so let's try it now. And we should see, here's your fake data from this page. Here's your fake data from that page. So this is coming from the function. I didn't write that here, but imagine that this is real data, right? That's what we're waiting on. We care if a request worked or didn't work, but a lot of the time what we want is the information, the actual data from that request. Anyway, this whole thing is taking us into the weeds quite a bit, but this principle of the .thens being chained, as long as you return a promise from within each .then callback, that is crucial to working with promises. That's really the thing that makes it all work, that makes our code so much cleaner. I mean, compare this, so much easier to just logically read. Do this, and then do this, and then do this, and then do this, compared to this here. Oof, or especially this right here. I mean, this is a nightmare. All of these functions and nestedness and callbacks. I mean, I'm not saying that this is a joy to read, but it's substantially better. All right. So also, when a promise is rejected, we can pass a value through when it's rejected. So in here, I believe I passed something through when I wrote this function. Let's print out that error. Let's see if we get a rejected promise. Resolved. Come on. Okay. Connection timeout. That was what it was rejected with. That was the error. Okay, so hopefully you can see how this is nice. We still haven't written promises ourselves, right? We're working with them. You probably have taken a peek at this if you're following along in the file. Here is the function. It returns a new promise object. We'll learn more about how this works, but really what's crucial is that you understand .then and .catch in this thing called promise chaining, where I can have dependent asynchronous actions, where this only happens if this happened and if this happened, or if they all worked. And if at any point something went wrong, this callback runs. So this is really, really important to understand. We'll get more practice with it, and soon we'll be making real requests where you'll see the utility of this. If you're feeling lost or shaky or confused or afraid, totally normal. I promise. This is a big step. We will actually see another iteration of improvement upon this syntax when we talk about async functions. So try and get familiar with this. Don't stress too much. We'll get more practice. And this is one of those things that you'll use a lot, and eventually it will start to make sense. So don't feel like you need to rewatch the last couple videos a million times. I know they're hard to watch. They're long. They're a bit dull. I know. I recorded them, okay? I know. So don't panic. Okay, so previously we talked about how to work with promises that have been returned from functions, how we can pass a callback into .then or to .catch, but I wrote the function for us. We didn't really go through the actual writing of the promise or the creation of that promise. In this video, I want to talk about it. This is not as important as working with promises when they are returned. In the next section after this, we're going to be making requests and talk about AJAX, and we won't be creating those promises ourselves. We'll instead be just calling .then and .catch and that sort of thing on promises that have been made for us, just like what we've been doing. But it's good to know how to make promises, and it's a more advanced topic, and it's something you can use going forward to improve your code, but it's not as important as what we've already talked about. With that said, here's how we make a new promise. Just on its own, you can do this. New promise, capital P promise, like that, and then it expects us to pass in a function. And this function is going to have two parameters. This is always how it works. Two parameters. The first one we usually call resolve, and the second one we call reject. Now these are just parameters, so you can name them whatever you want, but they represent the resolution of this promise and the rejection of this promise. They are actually functions we can execute at any point inside of this promise. So for example, if I call resolve immediately, and if I just paste this over here, you'll see we get a promise that has been resolved. It has a status of resolved. If I instead called reject, or whatever I name this second parameter, and paste it in over here, we get a rejected promise. And then if I do nothing, and I just make a new promise, there's my promise object, and it's still pending. It will continue to be pending until at some point, hopefully, resolve or reject is called inside of this function. So here's how we would use them. Let's make our fake request function. So I'm going to call it fake request or something like that, equals a function. I guess we could pass in a URL. Okay. And then inside of here, we're going to start, let's just take 1 second or 2 seconds and resolve our promise. So we're going to make a new promise, just what I showed you. And then we have our callback, or this function inside, resolve and reject. And then we're going to return this promise. And then after a second, this promise will resolve. So set timeout. And then we have our callback in there, our delay of 1 second. And after a second, we will call resolve. So if I execute that function fake request and I save it to a variable, I'll call it request, rec. And we can see it's now been resolved. Now, I didn't go fast enough to show you that it was pending originally, but it has been resolved. So now I can I can add on my .catch and .then to the fake request, so the promise that gets returned. We can pass in a URL even though we're not using it, but let's do dog/1 .then. And then when that finishes, we'll console.log done with request, just like that. So hopefully we should see that after a second. There we go. All right. So what I did in the original video was I generated a larger delay instead of just 1 second, and then I randomly rejected or resolved. So why don't we just generate a random number? Const, we'll do rand equals, and then math.random, and we'll just see if rand is less than 5 maybe. So if rand, or less than 0.5 rather. Actually, 50-50 chance seems a bit high. How about if it's below 0.7, we will resolve. Otherwise, we will reject. And we can always pass a value through. So we'll resolve with some information here. Your fake data here. And then we'll reject with an error like, I don't know, request error. Okay? So now I can add on my .catch as well. And in here, let's console.log whatever that error is. Oh no, and then error. Up here, done with request, and I'll console.log data is. And then we'll print out whatever our promise was resolved with, which in our case is just your fake data here. So let's see. Oh no, request error, okay. Oh no. Oh no again. There we go. Done with request. Data is your fake data here. So that's the basic idea. To make a new promise, we just pass in this function, or a function, where there are 2 parameters. The first one is a function that will resolve the promise. The second one will reject it. Name them whatever you want, but the only thing I've ever seen is resolve and reject. And if at any point you call resolve, that promise object will be resolved. And if at any point you call reject, the promise object will be rejected. All right, so let's see another example. If you remember early on in this section, I talked about callback hell, and we made this delayed color change function, which changes the background color of the body after some set delay that you can pass in. And then we structured it so that you could pass a callback in that will be executed after this set timeout finishes, or after it executes its callback. So this happens, and then this happens, and then this happens, and so on. And this was before we learned about promises. And just to recap what it looks like, there we go. We go from red to orange to yellow, green, blue, indigo, violet, and then we finish. Okay, so you could continue with this, but this is 7 levels, right? And it's quite nested. So I could rewrite this to use promises instead. My delayed color change function could return a promise. Instead of us passing a callback in, do next, right? This is the next thing for that first delayed color change. This entire thing. It's just crazy. It's very nested. Instead of that, I'll rewrite this function, const delayed color change equals, you'll pass in a color and a delay, but not a callback. And then we'll return a promise in here, return new promise. And this promise, standard promise we just talked about, we have the resolve and reject parameters. Although we're not really going to reject this promise ever. There's no reason to. All that we want to do is resolve it after we've changed the color, after this delay has finished. So we're going to do a set timeout. Here's the function we'll run after whatever this delay is. So in this case, I was doing 1 second, but we could make it 5 seconds or 3 or 2, or it doesn't matter. So in here, I'm going to change the body color. So what is it? Document.body.style.background color equals whatever color you passed in. And then we resolve. And that's it. So it's a little bulkier than what we had if I compare. but it's not a huge difference. Yeah, we have to work with this promise that we're returning. That's kind of annoying, but it's worth it because what we're able to do now is avoid having to nest and pass a bunch of stuff in. I can just call delayed color change, pass in a color like red, and a delay, and we'll just start there, right? This is going to run, but we don't have anything happening after it. Okay, it does work. Now, if I want something to happen after it, I can't just do this, as we know. I can't change that. Those will happen at the same time. So we only see orange. But I did return a promise. And we can see that here. That returns a promise, and eventually that promise will be resolved. As you can see there, it starts as pending, now it's resolved. So I can use my .then. .then, and then we'll go to orange. Now, if I return a promise, remember, from within my .then callback, I can chain promises. But let's just see that this works. Red and then orange, and it does. So I could return it like this, or I could actually do it on a single line and just use an implicit return, like that, and just keep chaining these. Orange, yellow, green, blue. Sorry, almost there. Roy G. Biv, indigo. There we go. Violet. All right. So let's verify that it works. Get all the way to violet. Keep going. Looking good, looking good. And there we go. That's violet. Take a look at how easy this code is to read. Right? Do this, and then this, and then this, and then this. It's flat, or it's pretty much flat, right? We have a little bit of nesting, just one level deep. But otherwise, it's incredibly easy to read and look at compared to this. The exact same outcome. After 1 second, do this. After a second, do this. Change it to red, orange, yellow, and so on. Exactly the same. But because we're working with promises, we can really clean the code up and just make it easier to read. And we're not even bothering with rejecting this promise. We don't have a branching path where we could have a success and a fail. Everything is just success. We're resolving this promise. But if we did have a success and a fail, then the nesting gets even crazier, like we talked about early on in callback hell. And promises really don't get much crazier at all. We just add on a single .catch and we can catch them all, like it's Pokemon. Alrighty. So that's how you create promises. Again, it's something we'll be doing a ton right now. We're really more concerned about working with them when they've been returned to us. In the next section after this, we'll be doing this sort of thing a lot, where we're calling .then and passing in callbacks, or we're calling .catch and passing in callbacks and chaining them together. But the promises we'll be working with will be coming from some library or from some function we didn't write ourselves. But we can, right? We know how to write this at this point. It's just not as important. So I'm not saying you shouldn't care at all, but just make sure you care more about this in the short term over actually writing promises. Okay, bye. Okay, so hopefully you're feeling okay with promises. Notice I said okay, I didn't say great or comfortable or thrilled. I am going to throw a little bit of a wrench in here, a good wrench. We're going to talk about async functions, which are another syntax improvement, a newer feature in JavaScript, so not supported in Internet Explorer, unfortunately, but really, really useful. Async functions help us write really, really clean asynchronous code. So nothing new that we couldn't do before. They don't give us some new superpowers. They just make our code a lot cleaner. And it's all built on top of promises. So I call it, people say syntactical or syntax sugar or syntax makeup. I've never heard somebody say makeup, but I like to use that term, I guess, where you're just trying to pretty something up. It's still the same thing behind the scenes. It's still promises, but we're just prettying it up. We're putting a new coat of paint on it. So there are two keywords here, async and await, and they work together, and we'll spend some time with each one. So we're going to begin with the async keyword. And before we go too much further, I just want to lay out sort of the game plan here. Async and await, those two keywords are what we'll be using from here on out. We have to understand how promises work, which is why we talked about promises. But as you'll see, async and await make things a lot cleaner. So we'll be using that, for example, in the next section when we talk about making requests and AJAX. So this is really the thing that matters the most in terms of syntax, but understanding promises in the past few videos is also crucial. Okay, so the async keyword itself is a keyword we use to declare a function as an async function. It stands for asynchronous. And the first thing you should know is that if we declare a function as async, which we do by just putting the async keyword in front of the function, that function automatically returns a promise. Even though I never said return a promise, explicitly at least, it returns a promise. So I can show you that here. I've got a new JavaScript file, open it up in my browser. I'm going to make a function. We'll just call it hello to start. Okay, that returns nothing, or it returns undefined at this point. Hopefully that goes without saying. But if I declare it as an async function, just like that, I refresh my page and I call hello, I get a promise automatically for me. I didn't have to do any of this, return new promise, none of that stuff. Simply declaring it as async returns a promise automatically. Now we can also do async arrow functions. So that's a function declaration. I can do things like this, const sing equals, and then here's my function that's non-async, but I can declare it async just like that. And if I call sing, we also get a promise. Okay, so here's how these promises work. If our function returns a value, then the promise will be resolved with that value. So if I have a return value in sing about la, 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 like that, it's going to return a promise just like it did before, but it was undefined. It was resolved with the value of undefined. Now it's resolved with whatever value I returned, which is la, 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 la. It still may not seem all that useful at this point, but trust me, once you see the await keyword, it gets even better. But I can do things like sing, right? I can call that and then chain on my .then because it returns a promise. There's nothing fancy about that promise. It's just made for me in a slightly mysterious way behind the scenes. I don't actually write new promise. So I can have my .then, and then in here, why don't we just take that resolved value? We'll just call that data, and we can console.log promise resolved with, and then we'll print out data. Okay, so let's see what we get. There we go. Promise resolved with la, 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 la. Now, there's nothing asynchronous really happening here at all. I'm just returning a string. There's no reason to use an async function, but we'll see some examples where it does make sense shortly. But first, let's talk about that promise that is automatically made for us. If we return a value, that promise is resolved, as we've seen. But what about promises that might be rejected? How do we reject a promise, which happens frequently as well? The way that we reject a promise is by throwing an error inside of an asynchronous function or an async function. So that could be anything ranging from something like this right here, just a syntax error. That's not going to make JavaScript happy. I'm just going to comment this out. If I try executing sing right now, I still get a promise, but this promise has been rejected, as you can see, and the value says reference error, blah, 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 blah. So usually that's not what we do. Usually we can throw our own error. So I can literally throw an error like this, just to show you here. Throw new error. And there we go. Uncaught error. So I can do that from within here. Throw new error. And you'll see that if I execute sing, we get our promise. It's been rejected, and the promise value is error at sing. I also can just throw a string like, oh no, problem. Wow, that comma makes a big difference. Oh, no problem versus oh no, problem. Okay, so what I'm trying to show you here before we go into the details is just that if we throw an error, or there is an error inside of an async function, that magical promise that's created is going to be rejected. So if I return a value, the promise is resolved. There we go, resolved promise. And if I throw an error, or if something goes wrong along the way, whoops, I didn't save, then that promise is rejected. There we go. And it's rejected with whatever that error value is. So I can do things now like, I could chain on my .catch, of course. Should do that. If there's an error, just be consistent here with our parens. If there's an error, we'll console.log, oh no, promise rejected. And then we could console.log the error itself, like that. And we get, oh no, promise rejected. Oh, geez. Oh no, problem. It's not the best error. But you can see that it is actually hitting this .catch callback, right? Because it is a promise generated for us. And in this case, this code will never run. We're just throwing immediately. It's a rejected promise. So of course, something like sing makes no sense here, but we'll do something slightly more complicated, but still trivial. But in the next video, when we add in the await keyword, it will all come together, hopefully. Let's make a function here, an async function called, what should we call it? Let's call it login, and it's going to expect a password, maybe a username too. And this is usually in the real world, if we're actually logging somebody in. I don't know what sort of syntax I just typed here. That is not a valid function declaration. Const login equals, and we'll do an async arrow function. There we go. Oh, the perils of talking and typing at the same time. Anyway, what I was going to say is that logging somebody in is usually an operation that it does take time because usually we have to contact a server somewhere else, check credentials against a database, and that can take a little bit of time. It's definitely not instantaneous. So we might actually use an async function for that, almost certainly, but we're not going to actually implement the backend logic at this point. We're just going to fake it. So we're expecting a username and password, and if neither of those have been passed in, why don't we just throw an error right away? So we could do something like if, username, let's just say not username or not password. If either one of those is missing, we can throw whatever we want here, missing credentials. Alrighty, and then otherwise, why don't we check, let's just say that the password just has to be some magical password we have in mind. This is still very silly and trivial. Let's say the password has to be if password equals, what should it be here? How about corgi feet are cute? Okay, if that's what the password is, we will return maybe true, or how about just welcome. Otherwise, at the very end, we will throw invalid password or something. This is so silly, but we have 3 different outcomes. And imagine this is real and it's happening somewhere else on a server. It takes time. I can now call login, and I'll just pass a username in just to start, just like that. And then I'll add my .then. Alrighty, here is our, let's just call it message. Console.log logged in, and we'll print the message. And then we can have our .catch, and if there's an error, we can print the error. Console.log error, and then we'll print the error itself. So at this point, we know we're just passing 1 argument in. We're expecting 2. We should get missing credentials, let's see, and we do. Now, if I pass something else in, an invalid password, that's what we get. And if I have the valid password, corgi feet are cute, they really are, we get logged in, welcome. All right, so still silly. It seems like a waste of time, nothing asynchronous, but I promise in the next video this will all make sense. So far, all we've seen is the async keyword we use to declare a function as an async function, which means that it magically behind the scenes returns a promise for us. That promise is either resolved or rejected, depending on what's going on inside of it. If we return a value, the promise will be resolved with that value. If we throw an error, the promise will be rejected with that value, or with the error value. Alrighty, so next up, the await keyword, the missing piece. All right, so we talked about the first of the 2 pieces here, the async keyword we use to declare a function as an async function, which means that it magically returns a promise for us. It's not really magic, but it returns a promise even though we don't write the promise ourselves. Now, the really cool part is the await keyword. The await keyword is what allows us to write asynchronous code that it looks like is synchronous. So what it does is it will await. Whenever we use the await keyword, it will pause the execution of our async function and wait for a promise to be resolved before continuing on. Now, this only works in an async function. That's why they're a pair together. Last I checked at least, I don't think you can just type await something. Oh, I guess you can. So maybe I'm wrong that it has to be in an async function. Oh, and I guess we have async loops, something we're not getting into now. So scratch what I said about it only working in async functions, but that is by far the most common place to use it. So here's what it will do. I've got a function here from a couple videos ago, delayed color change. If you remember this, it returns a promise. We talked about how we make promises, and we have a bunch of .thens we're chaining, right? So we go from red to orange all the way to violet, and it looks like this. If I refresh, red, orange. Oh, I forgot to add my little transition to my CSS, so it's quite harsh, but there we go. One thing, and then the next, and then the next, and then the next. And this is still nice compared to what we had with callbacks. But what I can actually do instead is write an async function. So I'm just going to call it, I'll do a function declaration this time, async function. Let's call it rainbow, just like that. And I'm going to call delayed color change red. We'll just recreate this. Now this returns a promise, right? So let's just verify that that does work. There's nothing crazy going on just yet, but we should see if I call rainbow, it does turn red. Okay. Now if I wanted it to turn orange afterwards, well, I can't do this because, as we already know, they're not going to wait for each other. It just happens at the same time. But if I use the await keyword, it's going to wait for a promise to be resolved. This returns a promise. This returns a promise. So essentially things will just pause until this promise is resolved after a second. Oh, and was waiting there. I never called it. And there we go. So if I wanted to keep going, I can just keep awaiting things. So if I had a console.log in here, console.log hi, that's only going to run after that first promise is resolved and we get a value back. Oh, I did the same thing again. I forgot to execute it. Okay, let's try that again. Watch here. We don't see hi, and then it shows up after a second. So now I can rewrite this. Roy G. Biv, so red, orange, yellow, green, blue. And look at how flat and easy this is to read. I'm just saying wait this, or await this, and then this, and then this. I don't even have to bother with the .thens. It's all, hopefully, a lot cleaner. Red, orange, yellow, green, blue, indigo, almost there. I don't know why I care about doing this full rainbow, but we're doing it. Violet. I'll call rainbow. And there we are. I've written this function, which is asynchronous, right? Each one of these promises is going to take a full second to resolve. And I just await each one. So this is really nice, not having to worry about .thens and passing in these callbacks and returning promises and chaining things. I can just say wait this, and then this, and then this. So this line will only run after this is finished, after this promise is resolved. So I only await promises or functions that return a promise, right? Like this here, delayed color change, that returns a promise. I can also, of course, await other async functions. So I could do something like this, return all done. This is going to return a promise, rainbow. When it finishes, it will be a resolved promise because I return a value. So then I can await it down here. I'll execute it, rainbow, and then I could do a .then if I wanted to, and print something afterwards, like, I don't know, what should I do here? End of rainbow, just like that. And we should see after 7-ish seconds, keep going. Okay, that async function finishes, we return a value, and I'm a moron. I didn't console.log, I just typed a string. Try that one more time. Ooh, that was a bad one. All right, red, orange, yellow, come on. Almost there. And there we go, end of rainbow. All right, so the await keyword is awesome. It really allows our code to be a lot cleaner. Promises were already an improvement, but this is super easy to read in my opinion. And I could even rewrite something like this. If I wanted to wait until rainbow was finished, I could do something like async function print rainbow. And in here, I can await rainbow. And then afterwards, just console.log end of rainbow. I don't need to bother with .thens either. It's an async function. So this await here is going to wait for this promise to be resolved. Rainbow returns a promise, but that promise is not resolved until all the way down here, and it's awaiting all this other stuff. So this takes 7 seconds, then the promise is resolved. So this will take 7 seconds until it's resolved. Then we can move on to print end of rainbow. So I can mix and match them, right? I can use promises explicitly, if you will, and chain on the .then and all of that. Or I can just write another async function and call print rainbow, and we should get the exact same outcome. End of rainbow. So that is the await keyword. It works inside of async functions, and it will wait, it will pause execution until a promise is resolved. Now, so far, these promises are being resolved without any values. The way that this promise is resolved, we're not passing anything in. It's simply a mechanism for delaying code execution for asynchronous code. But a lot of the time, we do have promises that are resolved with information, like this fake request function from a while back, where it returns a promise. That promise is resolved with some fake data. Not really, it's resolved with a string that says, here's your fake data from some URL, or it's rejected with a connection timeout. Now, we haven't talked about how we handle rejection yet. It's very hard to handle rejection. But what happens if our promise is rejected in an async function? That will be in the next video. But I'll just show you here that if I have an async function, we'll call this async make two requests. And I'm just going to await fake request the first time. And we'll pass in some value like page 1. What I can do is actually await the value and save it in a variable. So I could do let data1 equals await fake request of page 1. And then I could console.log data1, just like that. So if I try this now and I call make two requests, there's a chance our promise is rejected. It's pending. And then we get, here's your fake data from page 1. And that shows us that this information that the promise was resolved with was awaited and then stored or captured in a variable. So this is a pattern we'll do all the time in the next section when we're working with real requests. We'll await some request, and then whatever comes back, if it's resolved, we'll store in a variable. So in the next video, we'll talk about what happens if a promise is rejected, because so far, all of our promises have been resolved, but we need to be able to handle errors and handle rejection. So that's coming up next. Okay, so the last thing we need to talk about with our async functions and the await keyword is what happens when a promise is rejected that we are awaiting. So we saw that if we await a promise and that promise is resolved, then whatever that value it's resolved with will be stored in a variable if we are using it. We could also just await something and ignore that value, but we can store it, save it in a variable, but that's only if the promise is resolved. If it's rejected, which in this case, our fake request function, it returns a promise that is randomly rejected, just to jog your memory. It's just a random number that determines how long the delay is and if it's rejected or not. And eventually, let's see, it's pending here. Okay, so that worked. We can try it again. Eventually, we'll see one that is rejected. There we go. And what happens? Well, an error is thrown. And that isn't a real error. It's problematic. If I had code afterwards, console.log data, or even just console.log hello, and I'm just going to shift the number here to make it so that it's almost guaranteed to be a rejected promise. You can see that we get that error showing up, and this line did not run. So it stops the execution of this function. It's an error. So what we can do is use good old-fashioned try and catch. So it's been a while, but try, catch, just in case you need a reminder. If I try something in here, like this will definitely give us an error, right? That does not exist. If I try running that, we get an error. However, if I try it and then I catch any errors, I can console.log or just do nothing in here. It's okay. We caught it. And so we see it's okay. So if this code results in an error being thrown, we're going to catch it, and then we can handle it in here. And E, by the way, refers to the error itself. So you can see here, E is a reference error. That's the error we got from this. So if I put a try catch in here, try catch, E or error, that can be anything you want, but I just like to use E. This is what we want to try doing. Make our first fake request, and then actually, why don't we do a second one afterwards? Data2 equals await fake request for page 2, and maybe one of these will be rejected, just depending on that random number. And if it is, if either of them are, we catch it, and then in here we can do something like, what should we do? Console.log caught an error, and then we can console.log the error itself. Error is, and then E. So whatever value that this promise is rejected with, which in our case is connection timeout. It's just always that. But often in the real world, if we're making a request, there are different things that could go wrong. So a promise will be rejected with a reason, with some information, and we can then access that if we have a parameter for our catch. So in our case, it's E. So I'm going to print out data 1 and then data 2 if we make it that far. Let's see what happens when I call make two requests. So the first one, okay, first one worked, second one worked. Let's try again. First one, and second one. Come on. Don't make me cheat and change the, I'll change the values if this one doesn't work. Okay, I'm going to cheat. And still. Come on. Okay, this feels good. There we go. Caught an error. And then you can see the error was connection timeout. That's the value that our promise was rejected with. So that's how we can work or handle errors, how we can handle rejected promises in an async function. We need to use try and catch. But overall, very simple syntax, right? A wait inside of async, one thing and then the next thing and then the next thing. It's very clean, easy to follow. We don't have to worry about a bunch of .thens and callbacks. So that's it for async functions. In the next section, we'll be using them quite a bit, when we can at least. And we're going to move on to making requests, real requests, not fake requests. Hello, everyone. Welcome back. Surprise, surprise. Another section. This is actually a topic that I've found over the years students gravitate towards. It's somewhat exciting. The topic is AJAX. So we'll go into what that is, what it means, why you should care in the next video. I'm not here in this video to actually teach anything. All I want to do, as always, is give you the lay of the land and explain what really matters here. So in this section, we've got a healthy mix of green, yellow, and red. There are three things up top that are really quick, just sort of conceptual things I'm going to introduce in this section that are absolutely crucial. The idea of APIs, reading API docs, what is an API, and along with that, what is JSON? Those are things that will haunt us. I shouldn't say haunt. They will recur throughout the course from here on out, and including when we get to Node. Just important topics. Then we get to Postman, which is just a tool. It's like a 5-minute thing to install. I mean, a 5-second thing to install, 5 minutes to use. It's not really, I wouldn't say crucial. It's important. I guess it's crucial for this course, but as a developer in general, there are similar tools. It's kind of like Chrome versus Firefox. There are other versions of the same tool, the same concept. Anyway, then we have these three remaining items. Which all have to do with different ways of making an HTTP request via JavaScript. And I'm going to show you the old way, the clunky, hideous, just awful way, just so you understand where we came from, understand our JavaScript roots. XHRs, which stand for XML HTTP request, they suck and they're old, but they're good to know about. So I'm going to put in nice to have, but 1,000 million bajillion % does not matter. You could skip that video and you'd lose some context, but you're not going to be missing out on any code that you need to know. The fetch API is important. This is a newer way of making requests, but what we're going to be favoring is something called Axios. It's really commonly used. People favor it for a reason. That's all I'll say about it for now. Again, I'm not trying to teach the topics at this point, but here you have it, the lay of the land. Most important takeaways from this section are: what are APIs? How do you read API docs? What are endpoints? What is JSON? How do we work with JSON? Why is JSON a thing? And then how do we make requests using Axios? All right, so here we go, AJAX. All right, so in this section, we're going to learn how we can make requests using JavaScript. So we make requests all the time, as we've talked about very early on in the course as humans, by clicking a link. We're making an HTTP request. By typing something into my URL bar and hitting enter, I'm making a request. What else? By hitting the refresh button, that's a new request. So those are really the main ways we do it. But that's not the only way to make a request. We can make requests from code. And this is something we actually do a lot when we're writing modern web applications, or it's something that we can do. In fact, it has its own term, its own name, AJAX. AJAX technically stands for asynchronous JavaScript and XML. We'll learn more about the and XML parts in just a few videos, but really what this refers to is a concept of making requests to load information or to send information to save something, basically behind the scenes on a given website or on a given application, seamlessly behind the scenes, interacting with a server somewhere. So that could be things like, on Reddit, as I scroll, right, I get new posts. Eventually, I hit the bottom, new posts load. And I'll hit the bottom again, hopefully nothing horribly inappropriate. New posts are loading. So I'm not clicking a link like a couple of years ago on Reddit, I would click next or previous to go to a new page. Instead, we get this infinite scroll. And if I open up my DevTools, we have not talked about this network tab. It's somewhere we will spend some more time on. But what I'm going to do is just clear this. What this shows us are any requests that have been made on this page, any new information that's been loaded. There's a lot, as you can see here. A lot of these are images and these videos, but there's actually requests that are being made to Reddit servers to load new posts. Anyway, that's one example. Here's another example of what we call AJAX. Remember, it just refers to making requests on the page while it's already been loaded or after it's been loaded, making requests behind the scenes. And that enables us to do things where basically in the past a user would have to click around and go to a new page. For example, I can do live search. So this is pitchfork.com, a music blog. I can search for things like Phoebe Bridgers, an artist that I like. I get this autocomplete, or it's not autocomplete, but I get suggestions here. And what's happening is that as I'm typing, requests are being made to a server somewhere, one of Pitchfork servers, to see what matches and to get results and suggestions and that sort of thing. And again, if I open up the DevTools here, ignore the craziness in the console. If I go to network, not performance, network, and then I clear everything out of there, well, there's nothing really in here, and I start typing, I'll try that again, Phoebe, you can see that we get new requests. This is showing me requests that have been made. There's quite a few. And if we open one up, you'll see that it doesn't really look like what we normally get back from a request. Normally, what we've seen so far at least, is that we make a request by clicking a link or submitting a form, hitting enter, whatever it is in the nav bar. We make a request as a human. It goes to a server somewhere, it asks, or we're asking for information, we're asking for a particular resource, and then the server sends back HTML, CSS, and JavaScript to make me this nice, web page that I see. For example, this web page right here, of course, as we know, we can view page source, and there's a lot of stuff here. HTML, CSS, and JavaScript. We don't have to have all three, but for every modern application, every nice website is going to have all three today. And this is really for humans to read. Well, it's for your browser to display and render, but the results is for us to read. If we were to boil this page down just to the information, the text, the actual data, or the content that we read, there's not that much here. We could squish it down compared to all of this stuff that's required to display it, to change the colors and the fonts and the layout, and to resize things and move them around, and to make things responsive. And all of that stuff is important, obviously, for humans. But when we're dealing with AJAX, when we're making requests behind the scenes, like what Pitchfork is doing here, as I type, they're taking my input and they're searching on their own server. Does this match anything? Does this match anything? They're making requests using JavaScript. So I'm not, clicking a link or hitting refresh or something like that, but I don't know why I'm saying they, but the JavaScript code is making requests using what I'm typing here, and it gets information back, but it's not getting a web page back. It's not getting craziness like this, HTML, CSS, and JavaScript, which is made for humans, again, made for browsers to render for humans. Instead, it gets bare bones information. Same thing with Reddit here, but I meant to go to Pitchfork. It's getting just a list of, different matches and different titles, and there's still a lot of stuff here, but basically it's just getting the essentials, the data. So instead of HTML, CSS, and JavaScript, which is what we do to make a web page, instead, a lot of the time when we're working with JavaScript and making requests, what we want is just data. So if I wanted to make an app that would show you the current Bitcoin price every 2 minutes or every 30 seconds or whatever with JavaScript, so I don't want you to have to refresh the page. I could use a set timeout. I could make a request, which we haven't seen how to do yet, but I could make a request every 2 minutes to this API, which is a term we'll define in just a moment. api.cryptonator.com/blah, blah, 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 blah. This is an endpoint that I can request. And what it responds back with is not HTML. It's not CSS. It's not JavaScript. It's just plain old information in a format called JSON, which is a topic we'll go into more depth on shortly. But that's all I need. I just want the price. Let's say that's all I cared about. So this is English. It doesn't quite respond with this, but it's kind of the same idea. Instead of a whole web page that might be hundreds or thousands of lines, just give me the pure data. So in the next video, we'll talk more about APIs and what that term means, and we'll see some examples. But the idea here of AJAX, even though we're not talking about XML, the whole concept is creating applications where using JavaScript, we can load data, or we can fetch information, or we can send data somewhere, to save your progress, save something to a database, do all sorts of things behind the scenes where in the past you would have had to refresh a page to send a new request. We can do it with JavaScript while you're on the same page, right? I can get new Reddit posts as I scroll. I don't have to do anything except scroll, and I'll clear this, but pretty quickly you'll see a whole bunch of new requests popping up. Those are all requests that Reddit is making, the JavaScript is making. It's loading a whole bunch of information and then doing something with it, showing it on the page, making new elements, making new HTML elements, manipulating the DOM. All that stuff we know how to do. Same thing here. As I type, requests are made behind the scenes to try and find matches. There's a server. Pitchfork has a server. Requests are being sent. Can you send me any matches here? Is there anything that matches here? Data is sent back. Not a full web page, just tiny pieces of information that are then used and displayed here to make new links, it looks like, or new buttons, or whatever these are that I can click on. So going forward in this section, we need to talk more about what that format is that data is sent back in. We need to talk about APIs, and then we need to see how we actually make these requests using JavaScript. That's really the bulk of this section. So that's all coming up. So we talked about this cycle, the request response cycle, quite a bit, and how for a typical web page, we're loading HTML, CSS, and JavaScript. But when we make requests using JavaScript, AJAX requests, we are looking for just bare bones information. We don't want the HTML or the CSS or the JavaScript. We don't need that extra stuff that's made for humans. I just want the data. So this is where APIs come in. The term API stands for Application Programming Interface. And technically, API is just a very broad term that refers to really any interface for one computer to interact or communicate with another piece of software. So it's actually more about one piece of software to another piece of software. It doesn't have to be separate computers. Anyway, it does not have to do with the web in general. But most of the time, when you hear web developers and you just hear the term API, most people are referring to web APIs. Now, web APIs are interfaces that are web-based, HTTP-based. So basically, some company, whether it's, let's say, Twitter or Facebook, or just some weather or Bitcoin API, I'll show you some examples, they expose certain endpoints. And these endpoints that are exposed are going to respond with information for code to consume or for other pieces of software to consume. So these web APIs are like a portal into a different application or a database somewhere or a data set or just some startup's information. There's all these different tons and tons of different APIs out there. I'll show you a few examples. But again, when we say web API, we're referring to this interface that occurs over HTTP. I make requests to particular URLs, which we usually call endpoints. So I'll show you an example. In the slides, I talked about this Bitcoin app. If I wanted to, have every 2 minutes get the new price of Bitcoin and then display it using JavaScript, update the DOM, select an element and change the inner text or something with the current price, I need to make a request every 2 minutes somewhere. Now, we haven't talked about how to make requests, but let's just say I know how to do that. Well, there is a Bitcoin API that I could request. I just want the price. And there's tons of these APIs actually, but one free one is called Cryptonator. And on the website for Cryptonator, this is not the API itself. This is the documentation for it. This is for human eyes to read. It is a web page, HTML, CSS, and JavaScript. But there is this endpoint here, an example that I can just send a request to. So if I just send this request as is, just open a new window here, this is what I get back. So it's not a web page. It's something called JSON, which we'll be talking about in the next video. It's a format, a data format made for code or other computers to consume. It's not made for humans to look at. That's not to say it's, impossible to understand, but there's no styles. It's just pure content. And you can see in here we've got, target is US dollars, price is 11,280 point something dollars. So once we learn how to make requests from JavaScript, this would be a very easy endpoint to request this API. Just ask for the current price, take that or extract it from the response, and then display it on the page every 2 minutes. Much, much easier than trying to request a full web page that has HTML and CSS and JavaScript. Just as an example or a counterpoint, this is a web page that displays the price of Bitcoin in a nice human readable format. It looks good. I could request this instead using JavaScript, but this is what we would get back. Lots and lots of HTML, CSS, and JavaScript. And buried in here is the piece of information I care about. I don't care about the code to make that chart. I don't care about the colors, the styles, the sizes. I just want that price. So that's where we turn to things like this API. It just gives us the information we need. It's an interface, not for humans, but for my application. Okay? So there are lots of APIs. Tons of them out there. Pretty much anything you can think of. I'm sure there are things you can think of that there aren't APIs for. But generally, the restriction that you'll run into is actually around pricing. A lot of the more useful ones are not always free, or they have price tiers because it costs money for servers to respond to your requests. And, these are companies a lot of the time that are there to make money. So just to give you a couple of examples, we have simple things like this cryptocurrency exchange rate API. There are slightly more complicated APIs that, will do things like give us weather. So this is an API that will give us weather data. I believe it does forecasts. Go to the API documentation. It will give us current weather data for over 200,000 cities. It can give us forecasts ahead of time, 16-day forecasts, climate forecast for 30 days. I think there's other things it can do, but this is slightly more complicated because we need to specify, where we want this information for, what zip code or what city or, however it works. You got to read the documentations, and they show you some examples. So it looks like you do pass in a city name in the URL. So as an example here, this is latitude and longitude that you can use, and then you get a response back with weather information. Okay, so that's slightly more complicated. And then we have the bigger companies, things like Twitter. Twitter has an API, and this API does a lot. It does things like, I don't really use Twitter, so I might mess up the terminology, but it allows you to search and get results for tweets. So if you're trying to find tweets or display tweets on your website, it also allows you to write code that will post a tweet for you. You have to be logged in and authenticated. You've got to sign up for an account and hook up a credit card. And, it requires a lot of work, but you could write some bot to post tweets automatically for you every time it senses somebody mention your name. Companies can use the API to set up direct message responses, so automatic direct messages. Just as an example, we can send a request to this URL. Now, you have to be signed in. You have to have your special account, basically a password that's included, that's unique to you. But if you put all of that in here and you make the right request, you can send a direct message without ever opening Twitter yourself, without ever going on the website, just by having your code do it. So there's a whole bunch of other things. There's APIs to look at trends on Twitter, I guess by location. Yeah, you can get information about a place. Same thing for websites or apps like Facebook. Facebook has lots of different APIs where you can set up automatic messenger responses, Instagram APIs. Let's see, what do they allow you to do? Yeah, so you can write code to share to stories or to share a new photo to your feed. You can write code that will basically send a request to make a new Instagram post. Again, you do have to be logged in, you have to have an account, you've got to usually pay for these. Here are other examples, insights and mentions APIs. So if you're a business with a whole bunch of mentions, let's say like thousands of people commenting and mentioning your account name, it looks like this API allows you to reply back automatically. So you could probably set up some code that, will come up with a couple random responses and pick one and post it for you automatically. So it's not always about fetching or loading data, although that's a really common thing that we do with APIs. A lot of the time an API just exposes information like Bitcoin prices, or there's a Reddit API, which allows us to do things like, get the latest posts or find a user's posts from the last day. But it also lets us create Reddit bots, automatically post using code without having to open Reddit ourselves. So those are a couple of examples. And then one that's very different but really useful is Twilio. So Twilio is definitely something you have to pay for. I think there's a free tier, maybe. I'm not sure if you have to include a credit card these days. It's changed over the years. But Twilio allows you to basically send HTTP requests to Twilio, one of their API endpoints, and it will do things like send text messages for you or make phone calls, programmable voice calls, like automated calls, also email API, so they can send emails, they can make WhatsApp messages and respond to them, programmable chat, lots of stuff, but text messages or SMS messages is kind of fun and actually very useful. A lot of the time, you'll have an app and you want to, let's say I'm making a reminder app or a doctor's office app, and I want, to automatically send out reminder texts to anybody who has an appointment tomorrow. So I could write code to do that using Twilio. Just loop over all of the appointments and then send a request to the correct Twilio endpoint, which we could find on their documentation. You'll soon see it's all about reading the docs. But on here, if we'll find somewhere, here's the Twilio SMS API. We have to figure out who we're sending this to, what the message is going to be, and then we send the request. And they should get a text message. And you can even set it up so people can respond and you'll get, updates. And long story short, APIs do a whole bunch. And we're referring to web APIs primarily, which are programming interfaces for our applications, and they work via HTTP. So we send a request to an API, we get a response. I send data to an API, sometimes like this Twilio API, I'm sending information about who I want to send a text to. Other times, I'm just requesting, give me the latest Bitcoin price. Again, there are tons of APIs out there. I encourage you to explore some of them. We'll see some in the next few videos, but that's kind of it for an intro to APIs. Next up, we need to talk about what these APIs respond with. What is this? Something called JSON. And then we need to talk about how we actually make those requests. Really, the whole point of this section is making requests using JavaScript. So that's all to come. So next up, let's talk more about this format, this mysterious format that APIs will frequently use to send data back. Rather than HTML, CSS, and JavaScript, there are other formats out there that are much more compact, and they basically exist just to give us information, just pure data, none of that style stuff, no, JavaScript events, no markup, just data. So there are really two common formats, and it's changed over the years. Originally, the most popular one was XML. It stands for Extensible Markup Language. And these days, you probably won't see many APIs, if any, that will respond with XML or that require you to use XML. But while we're talking about it, this is what it looks like. It looks like HTML basically, except the elements, the actual tags are custom and they can be really anything. So in this case, we've got a list of products, and then inside, here's a product, opening and closing. Each product has a code, a stock quantity, a barcode. So that's XML, right? We can have a whole bunch of different tags. It's totally up to us. Here we've got quiz, Q&A, question, answer. But again, XML is just nowhere near as common as it used to be. Even though we still say AJAX, what most people use these days is a completely different format called JSON. So AJAX does not have the same lovely ring to it. Most people say AJAX, but it's almost guaranteed that they're referring to using JSON, not XML. So JSON stands for JavaScript Object Notation. Yes, it has JavaScript in the title, or in the name, and it has to do with JavaScript, but it is not the same thing at all. JSON is just a format for sending data, for serializing or for sending information from me to you or from an API to my browser or whatever it is. It's a way of formatting data that is consistent and predictable. and it's very similar to JavaScript. It's based upon JavaScript objects and the syntax, right, where we have key value pairs and curly braces, but there are important differences. First of all, you'll see we have our key value pairs, but every key has to be a double quoted string. So unlike in JavaScript where we can just write them without quotes at all, or we could use single quotes, that's invalid in JSON. We can use strings as the values, numbers, other objects and arrays. We can use booleans and null. If we actually go to the homepage for JSON, there's a website, json.org. This gives us the actual sort of standard of how it works. There's these crazy looking charts. But if you look on the right-hand side, you can see under value, these are the possible values in JSON. So an object, an array, a string, a number, true, false, and null. That's not the same as JavaScript. There's things like undefined in JavaScript. That is not considered valid JSON. If I actually just typed undefined, there's a JSON validator here. I'll just show you very quickly. I can do things like, price is 12.34. This is not valid JSON, but if I click process, it will turn it into valid JSON, puts quotes, double quotes specifically, around my key name. But this is valid. That's a number. We don't need quotes around that. But now, I'm just going to fix that. If I try and do something like, age, and I'm going to set it to undefined, like I might have in JavaScript, it's going to put quotes around undefined. It assumes it's a string. So what I'm trying to say is that there are distinctions here. It's not a one-to-one relationship where, JSON and JavaScript are identical. Now, a lot of people get confused or they assume that JSON is only for use with JavaScript, but that's not the case. When I teach Python or Ruby or really any other language, we still work with APIs that are JSON APIs. So they all have their own way of parsing JSON and turning it into actual Python code, or in our case, JavaScript. It's pretty easy to turn JSON into JavaScript. We actually have a method built into JavaScript to do just that, which I'm going to show you right now. This is something we need to do a lot because when we request information from an API, what we get back is basically a giant string. So if you remember this Bitcoin API here, this is the endpoint. If I request it, this is what we get back. So I just copied this and I put it in a file instead of quotes to mimic what we would get back from actually making a request, which we have not done yet, but we're getting there. If I wanted to access the price out of here, this is a string, right? So I can't just, if I open up my console, I can't just do data.price or, what is it? It's inside of ticker. Well, I can't do any of that because it's a string, right? I could use this, which would be horrible, use character indices, but that's not really what I want. So what I need to do is ask JavaScript to turn this into a valid JavaScript object instead of just a string of JSON. Fortunately, we have a method for that called JSON, in all caps, .parse. And then we pass in some string, and it will be parsed into a JavaScript object. So I'll just do it over here to start. JSON.parse, pass in my data, and it turned it into an object. So I could save that to a variable, right? Const parsed data, dot, and then I can look at, ticker, and then .price. And that's how we could extract the Bitcoin price out of there. Alrighty, so this is something we'll definitely come back to. I just want to show you now in this JSON video. We also can go the other way. If we have information that is a JavaScript object, and I want to turn it into JSON, I can call a method called json.stringify. And this is useful if we need to send information to an API, and that API wants us to send data as JSON. We can't just send a JavaScript object. We need to make sure it's valid JSON. So it tells us, for example, all instances of undefined are replaced with null. Other unsupported types are censored. It includes quotes when needed. So let's do another example of that. I'm just going to make an object here. I'll just use this dog object from my history here, and we'll say it has no owner. So owner is undefined at this point. All right. Now if I call json.stringify of dog, you can see it adds quotes around all of the properties to make sure everything is double quoted. It doesn't do that for Booleans because that's a valid value in JSON. So other languages can then receive this, if you will. It could be Python or Ruby or Java. and they can parse it into their own native language. So it's just a format for sharing information. So JSON.parse we will use pretty frequently. JSON.stringify, not as much, but it's good to know they're both there. This one takes a string of JSON, turns it into JavaScript, and then stringify goes the other direction. All right, so these APIs that we'll be working with, all of them are going to support JSON. Some of them may also work with XML. I won't say it's a relic, but it's far less common these days, even though, yes, we have Ajax. That name is referring to XML. It's almost always JSON. So these APIs respond with JSON. We then can parse that JSON and use it as a JavaScript object. So now all we need to figure out is how we make the requests. That's the big missing piece. That's coming up. Next up, we'll make a bunch of requests to different APIs and learn more about how HTTP requests are structured, different status codes we could get back, what headers are in a request, what the query string is. So basically the anatomy of an HTTP request and a response. And we'll be learning all of that at the same time that we're making requests and playing around with some maybe interesting APIs. If not, they're at least a diverse group of APIs. And to do this, we're going to be using a tool called Postman. So to explain why, I can just show you, we've already seen we can make API requests just like any other request. It's just an HTTP request, whether I'm requesting a web page or an API endpoint. I type a URL in, I hit enter, I can get the response. But what I don't see here, well, there's a couple things that are not great. First of all, the way it's formatted is really annoying to work through. But also what I don't see are the different pieces of the response. There's something called the headers. There's the status code. And I can view them if I open up the DevTools and I go to network. And then if I refresh the page, whoops, here it is. And we can see the response, but this is still not great. And it doesn't allow me to save requests and easily modify and redo requests. So we're going to use this tool called Postman to help us. I just want to be very clear. It doesn't do anything that we couldn't already do. It's just a great way of making requests. It's incredibly commonly used by developers for testing APIs that they've created, and also, like what we're going to do, playing and testing APIs that we did not create, trying to understand how they work. So much of what you do when you're working with an API is reading the docs and then testing it out and verifying that things work the way you expect, and then writing code to make those requests. So there's a free app. Just click download. I already have it downloaded. So download it for your particular platform, whether you're on Windows or Mac or Linux, and then open it up. And here it is for me. You may see a message asking you if you want to log in. You do not need an account. At the bottom, you can click something that says basically ignore, I don't want to sign in, or something like that. I don't have an account signed in here, so you do not have to create, at least as of recording, you don't have to create an account. So here's how this works. We type in a URL, right? Any URL here that I could request, and then click send. That's the very, very basic, the most basic thing we can do is just request a URL. So I could request the Postman homepage if I wanted to. Just remember what I get back here is HTML, CSS, and JavaScript, so it's going to be massive, but I can send a request. I'm going to hit send. And instead of being a browser that renders the content for me, it just shows me the response. So HTML, CSS, and JavaScript, this is not an API, but we are making a request. It's just another tool to use to make a request instead of the browser itself. But where this becomes a lot more useful is when we start working with APIs and looking at the data and tweaking the requests that we're sending and inspecting the responses. So let's go to this very simple Bitcoin API that I showed you, and you can find all of these links included with this video. So if I copy this URL that they give us, I'm just going to paste that in here. And notice this tab here, this menu, Get. We will talk more about these different HTTP verbs as we make some more progress in the course. There are different types of requests that we can send, and they are completely different. So I'm just going to send a GET request to start. That's everything we're going to be doing in this video, and for the next few videos are GET requests. Think of it as retrieving or getting information. We're asking to get something. Versus post requests, which we use if we are sending data that we intend to somehow impact the server side, whether we're saving something to a database or updating something, or there's a lot of different nuance for what we can do with posts. And then there's all these other verbs, put, patch, delete. We're not going to worry about that for now. We're focusing on get requests. We have enough other stuff to worry about. Okay, so when I hit send, we get that get request, or I send a get request. Here's our response that we get back. And hopefully you can see this. I can zoom in a bit. Notice this is the raw response. This is what I saw in my browser, right? If I just went to that URL versus here, if I go to Pretty, we get this nice interactive JSON viewer where I can condense things. So I can close that down and toggle it open and closed. So already this is nice. It's an easy way to see what's going on and what we get back. But what I want to focus on are the core pieces of an HTTP response. So notice here it says body. This is the data. This is the body of the response. Think of it as the content. So if we requested if I go back, I can see the history over here, by the way. If I click on one of these, I click send. This is an HTTP or an HTML response, right? It's included in the body. So the body, whether it's JSON or XML or HTML or something else, is the content, sort of like the payload of your response that we got back. And then we have status code, which you can see right here. Now, an HTTP status code is just, you've probably seen some of these before, certainly 404. Well, I shouldn't say certainly, but likely you've come across a 404 status code in the browser. These status codes are just numeric codes that are standardized for the most part. And they are a quick way of indicating from the server, so in this case, the Cryptonator API server, to us on the client, it's an indication that things are okay, right? We've got a good response. But there are plenty of other status codes that mean other things. So if I try requesting, something that it doesn't recognize, like /API/LOL, LOL, something like that, and click send, what do we get back? This time we get a 404 status code, which is, it means not found. It's very common to see when we're requesting something that the server cannot find. It doesn't know what we're talking about. There are lots of different status codes. Here's another example. If I go back to the regular, or the correct valid endpoint, I'm sending a GET request. But if I try and send a POST request, which again is a totally different type of request, they're distinct, entirely distinct. What ends up happening is that I get a 405 status code, which means not allowed. And this tells me that, it's a request method that's not supported by this resource. So the server is going to recognize this URL, that endpoint, but not as a POST request, only as a GET request, and it tells me that. All right? So there are lots of status codes, and you definitely do not need to know all of them. I don't know most of them, but there are some things that you should know. Anything that starts with a 2, like 200, or 202 or 201, those are all good status codes. They basically mean success, things are okay. That doesn't mean they're all the exact same thing. They do have different meanings, but if it starts with a 2, it's good overall. If it starts with a 3, they have to do with redirects and redirection. This is something we'll learn more about when we get to server-side and Node, and we actually redirect people, which for now we're not working with. But if it starts with a 3, it's not necessarily good or bad. Now, if I go down further, the 400s, anything with a 4 at the beginning, they are not great. These are client error status codes. So this means basically we did something wrong. If we get a 400 from a server somewhere, it generally means what we're asking for is the problem. Versus if we get a status code that starts with a 5, these are server error responses. It basically means something went wrong on the server's side. So the server, it could crash, or something goes wrong on that server side. Something's unavailable. These are generally rarer. Usually the problems are on our end when we're asking for something that the server doesn't recognize, or it doesn't have, or we don't have permission to view. Then we'll get a 400 something status code. So different status codes, that's part of the response that we get back. And here it's displayed for us in Postman, just right there. But if I, were to send a request and got a 404 here, well, I can just show you the 200 first of all. If I open up Network tab again, refresh the page, we can see in Chrome status 200. If I request something that does not exist, we're going to get status 400. Now there's a bunch of other stuff loading here because they respond with a 404 page, an HTML page. And so there's images and icons and fonts, and it looks like all that stuff was loading. But the core status code that we got first was a 404 rather. Okay, so that's status code. Now let's talk about headers. So headers are a bunch of key value pairs. They're kind of like the metadata for the response and also for the request. There are headers on both sides. And in this case, when I ask for the current Bitcoin price in US dollars as a GET request, we get these different headers, including things like the date, the time something was last modified. And then we have this one, which is an easy one for us to look at. Content type, application/JSON. See if I can make that larger. I'm sorry. Is that better? Maybe. So this is telling us we're getting JSON back. Now we already can see that, but if I were to request something, for example, the home page, or actually if I just get the 404, that's an easy one. Let's just make up a URL. We get a 404 status code. Let's look at the headers. Now we get content type text/HTML. That's just how we say HTML. It's not HTML, it's text/HTML. And JSON is not just JSON, it's application/JSON. All right, so there's a bunch of stuff that we get back, and most of the time we don't need to care about these headers, but those are the core pieces. We've got the body, which is the content itself. It might be JSON, might be XML, might be HTML, could be something else, could be plain text. And then we have the headers, and those headers include a whole bunch of information. A lot of it we don't care about most of the time. And then we have a status code. And that status code is just a quick indicator of what happened. Was this a good request? Is there a problem on the server side, on the client side? Were you redirected? That sort of thing. All right. So in the next video, we will play around with making more requests to different APIs. It's still just this Bitcoin API, but we'll see that they don't all work the exact same way. And we need to talk about something called a query string. So we have a bit more to talk about with how requests work, and we're going to take a look at a couple different APIs to help illustrate this. So we'll still be using Postman. That will be a pretty constant presence for what, maybe not constant, but intermittently we'll be referring back to Postman pretty much from now until the end of the course. So the cryptocurrency or the Bitcoin exchange rate API is pretty straightforward. Reading the documentation, there's really not a lot that we can, is there much that we can do? It looks like there's two endpoints. We can get the simple ticker, which gives us less information, or we can get a full, what do they call it? The complete ticker, which has rate change and prices and volumes across all connected exchanges. So there's two different endpoints. They are just different URLs. This one is API/full. This is API/ticker. So we could, let's see, I think we've been doing full, just like that. And our response we get back looks like this, where we have the different marketplaces. You really don't need to know anything about Bitcoin. Just wanted to show you that there's a difference versus a different URL. If I can spell it correctly, we get a lot less information. It's simpler. Okay, so two different endpoints. But now let's take a look at a completely different API. Here's one for TV shows. It's called TV Maze. And it actually, I think they do a lot of stuff around TV schedules, different people and shows. So there's a lot of endpoints. As always, look for the documentation. So a lot of websites and applications will have an API, but it's not immediately present, or immediately obvious, rather. This is like the consumer-facing part of the website. Usually you either go to the bottom or to one of the like developer or menu or somewhere you can find API. Here it is for this website, and then read the docs. So take a look at some of their endpoints. Here's an example one. This is to search across TV shows, and notice what we see here. Q equals, and then colon query. So anytime you see colon or a colon in a URL on API documentation, it's a way of saying that this is a variable. This is something you provide. Now, what this is here, this Q equals something, that's called the query string. And you've definitely, well, we've talked about it briefly, but you've probably seen this before. Just as a quick example, if I go to MDN and I search for something on here like JavaScript and I hit enter, if you look at this URL, I don't think I can zoom in on that, but I can paste it somewhere. Let's see, I'll just paste it here. Can you see this question mark? I don't even know if that's larger. Question mark Q equals JavaScript. This is called the query string, and it's a way of providing additional information to a request. So this is always the base URL. We're searching. So Mozilla.org English US/search. But then we need to specify what we're searching for. And the way that this particular endpoint is set up is that it's expecting a parameter called Q. So if I change that name to be anything else, A, it doesn't know what I'm searching for. It's looking for a Q to be provided. And usually you're not going to type that up here. Usually this comes from the form, right? So if I look for something like React, Q equals React. That's where it sends me. This is the request. But I can do this myself, just like I'm doing here. So question mark, that indicates the start of the query string. Q equals, and then let's look for color. Send. And this is not an API, so we're getting a full web page, right? It says search results found for color. Okay? Now, the reason I bring this all up is that a lot of APIs require us to use query strings. So here's an example. To search for a TV show on this web, or using this API, TV Maze API, the endpoint is /search/shows, which is relative to their base URL, api.tvmaze.com, and then query string, Q equals whatever show we're searching for, whatever the term is. And Q is often used in searches for query, right? That's what we're querying for. So why don't we copy this URL, copy link address, we can paste it in here, and sure, we can search for the show Girls, and this is what we get back. We get a whole bunch of information because we're doing a search, so it doesn't give us, just one result. It's going to give us matches that have girls, I think, is in the title. So there's the show Girls, if you've never seen that on HBO. And then I can close this one if I want to. Then we've got this one here, Good Girls, never seen that. Shining Girls, never seen that. Chicken Girls, Powerpuff Girls, I have seen that. Anyway, we get a bunch of information about each show. And then we can do other searches. For example, we can look up a show if we know a show's, let's say, their IMDb ID. So do we see any IDs here? Let's see. Yes. Okay. So this is for Powerpuff Girls, I believe. I'm just going to copy this URL or this ID and just save it. And then if we make a request now to /lookup/shows and then a query string IMDb equals some ID. So /lookup, a different endpoint. We had /search. Now we're doing lookup/shows, query string IMDb equals, and then that is the ID I just copied. We should get a whole bunch of information just about the Powerpuff Girls. And there we go. We get other stuff like an image that we can use. We get a summary. So that's another endpoint, and it is expecting us to provide an IMDb ID, or it looks like other IDs, TV Rage, whatever that is, TV database, so different IDs. So I just want to be very clear here. Query strings are just information that we can provide to any URL or as part of a URL that usually is going to impact what we get back. Now we could put whatever we want in the query string, and if I want more than one parameter, by the way, more than one piece, I use the ampersand, and then I can put something else in here like color equals purple. It's just going to be ignored. I assume they don't expect a color, but if they did, color would be purple, IMDb would be this ID here. So there's a lot of endpoints on this API. We're not going to spend a whole bunch of time on this, but as you can see, here's an example. There's an endpoint called episode by number. So shows / and then some show ID. So we can get an ID for a show / episode by number, query string, season equals 1, number equals 1. All right. So in this case, they're doing show /1, which is a show called Under the Dome, it looks like. So I'll just show that here. Paste that in here and send. Here we go. If I do show /2, so this is not the query string here. It only starts right there. And there's actually another way of structuring this when we're using Postman. If we don't want to have to send or type the query string ourselves, I can click on params and type these key value pairs, like season will be about 1 just to be safe, and then episode, how about 3? And then you can see it's building the query string for me. So I don't have to type the ampersand or the question mark. It does it for me. It's just an easier way. But at the end of the day, we're just impacting or we're changing that URL. And, we're missing number. So I don't think it wanted episode. I think it wanted number. Whoops. And there we go. Whatever this show is. Person of interest. Okay. So that's just a quick taste of this TV show API. There's a whole lot more that you can do. Let's take a look at one more. This is an example for a weather API. Now, this does actually require you to have an ID, an app ID that you need to sign up for. So I'm not going to actually request it here just for time's sake. But I just wanted to show you that they want you to pass in an ID for a city, or you pass in a latitude and longitude. Those are part of the query string. So again, query string, it's just key value pair information we can pass into any URL. We have seen this before when we created a form way back when, very early on, we made an HTML form. We saw that when we have a GET request submitted by a form, it just creates a query string and it redirects us to a URL. Anyway, there's a lot of stuff that we could go into around query strings, and we will see many more examples. But in Postman, the main takeaway here is that you can add or change those query string parameters, those pieces of information, key value pairs, by setting them in this params section, or by editing it manually, whichever you prefer. And then from the API side of things, certain endpoints are expecting certain pieces of information to be present in the query string, but you can pass in as much as you want. It will just be ignored. So it's different than the URL itself, right? If I just change this URL, that's entirely different, and that's a completely different resource that I'm asking for, versus if I just change the query string and add some nonsense thing onto the end, it's ignored. So it's additional information. And then let's take a look at one more joke here. One more API. This is a different one. It's called Icon Has Dad Joke. It's just dad jokes. And the reason I want to show this to you now is actually not for the query string, but for the fact that it requires us to set a header. So every API is different. And this API is able to respond with HTML, JSON, or plain text. Now, if we read how it works, it actually requires us to pass in or to include a header on the request. And this header is called accept. So we haven't seen adding headers in. We've seen how we get headers back from a response, or part of the response we get headers. But we can actually set our own headers on the request. And in this case, the API is expecting us to do that. So if I just request the basic endpoint right here, iconhasdadjoke.com, if I just do it in the browser, we get HTML for a random joke. This is HTML here. What do you call a pig that knows karate? A pork chop. Oh, great dad joke. So if I request that using Postman and just hit send, the default that it's going to respond with is HTML. But I can send my own header. And to do that, in Postman at least, I can go to headers and then set a header here. And if we look at what they're expecting on the docs, it's the accept header, and they want application/JSON if we want JSON. So accept, and it gives us some autocomplete because this is a very common header. And then application/JSON. So I got HTML by default. If we look at the response headers, you can actually see content type is text/HTML. But now, if I send a new request with my new header included to the same exact URL, we get JSON. We can see it here. Oh, what a lovely joke. I invented a new word, plagiarism. Very funny, dad jokes. And if we look at headers, we get content type now as JSON. So an important header here, and I just wanted to show it to you so that you can see how to set headers using Postman. We'll learn how we can set headers and query string and all of that when we're making requests, and that's actually all coming up because in the next video, we'll be making our first request from JavaScript, not from Postman, although Postman is incredibly useful to have as a nice debugging tool. So we've got some good news. It's time to make our first request via JavaScript. I also have a little bit of bad news just for this video, which is that the first option I'm going to show you is something called an XML HTTP request. It's horrible. It's the old way of sending requests. I just want you to see it so that you have an appreciation for the newer options. So again, this is the original way of doing it. There are newer options, including fetch, which is what we'll see in the next video. So it does not support promises. XML HTTP request is all based on callbacks. There is some weird syntax. I can never, ever remember it. I mean, I never use this anymore because we have newer options. But here is an example of how it works. We make an object, a new XML HTTP request. That gives us a new request object. Then we have to attach an onload callback and an onerror callback. And then we have to open the request and then send the request. So I'm going to show you how this works. We'll do it with this simple Bitcoin price API. I'm in a new file. I'm going to make a request, const rec equals new XML HTTP request. Weird capitalization, right? XML, that's an abbreviation. It's all caps. HTTP, also an abbreviation. Why is that not capitalized? I don't know. Then we add our onload callback. And I'll just print something to start. All done with request. And then in here, what I can do, well, I'll just start with this so you can see, and then request dots on, is it error, I believe? I can't even remember. And here we'll do a console.log error. And then let's also just console.log this. In both cases, you'll see what this refers to. It is the object for the request itself. So request, REQ, the XML HTTP request. So I've attached these. Then I need to open the request. And the first thing I need to pass in is the method, which is going to be a get request. Then the second argument is going to be the URL. So I'm going to do get, and then I think I have the URL. No, I don't. I thought I had it on my clipboard. Here it is. Let's copy that. Paste that in. And what are you complaining about? Okay, here we go. I then need to send the request, request.send, and let's see what happens. Refresh the page. Okay, our onload callback ran. We got all done with request, and then here's what we end up with. The request object, this XML HTTP request object, now has this response property that includes the text, or the JSON that we got back, rather. It also has response text. And it has some other stuff in here, like the status code is 200. So if I were to request something that, let's say, did not exist, I assume that doesn't exist. What do we get? Error. So my error callback ran. But I'm not going to do that. I'm going to go back to what we had. And then I'm going to take this .response text, which is the text, right, that we got back, the body of that response. Just like in Postman, when I send this request, same URL, get request, this is what we get back. It is just raw, it's text. So we need to parse it, as we've seen before. What I want to do is just print out the current price. So I need to parse it. JSON.parse, this .response text. Let's save that to, what should we call that? Just data. And I could print out the data, but what I really want is the data price. But price, this is a nested object, right? This is where Postman becomes nice. I can see, okay, it's actually instead of ticker, and then I want price. Okay, so I'm going to do that. Data.ticker.price, and we'll just console.log that. And let's see if it works. Hey, there's the current Bitcoin price. Cool. So that is working. And that's all I'm going to show you for XML HTTP requests. Hopefully you can see how this is annoying, especially if we have subsequent requests I want to make. First this, and then I want to make another request afterwards. Well, I'm going to nest, and horrible, ugly callbacks, and things just get out of control. So next up, I'm going to show you the newer option, something called the Fetch API that is a lot better. Still not perfect, but it's a definite improvement upon or over these XML HTTP request objects. Next up, we have the Fetch API. So this is a newer way of making HTTP requests using JavaScript. It was written or implemented in response to the fact that XML HTTP requests kind of suck. Long story short, originally in the early days of web browsers and of JavaScript, AJAX was not really a thing. But then it slowly caught on, and this concept of making requests asynchronously while the page was still, or with the page never refreshing, let's put it that way, that was novel, and it caught on. And after a while, it became clear that XML, or let's just say XHRs, that's what most people say, XML HTTP requests, XHRs were not ideal. So the Fetch API was proposed, and it's a newer way of doing the exact same thing, making requests via JavaScript. But it's promise-based, so we don't have to worry about callbacks. We can, use .then and .catch, or we can use async await. It is newer, so it's not supported in IE, as you can see here. But these days, usually, it depends where you work, but often that's not a problem. So here is how it works. I'm going to request the exact same endpoint, and the syntax is to simply call fetch. Now, this is going to return a promise to me. If I just run this in the console, we get a promise. And in this case, it's resolved. So it's resolved with this response object, and this response object has a whole bunch of stuff in it, including the status code. It has the headers, and these headers, well, it's going to be annoying to show you, but there's different headers in there. Now, if I tried instead to request some endpoint that does not exist, our promise is going to be rejected, right? And our value here is an error. It's rejected with an error. So we can chain on our .then with our, we'll call it response or just res. And then in here, we can console.log response and then the res, right? And then we can also add in a .catch if there's an error. Console.log, oh no, error, and then print the error E, okay? So let's try that. Refresh the page, and we're in the clear, everything worked. Here's our response object. Now, on this object, this is one thing that's kind of annoying about fetch. We don't actually have the data just yet, or we don't have it easily accessible. What happens is that fetch is actually going to resolve the promise, triggering our .then, as soon as it receives the headers coming back from this API. So it doesn't wait to resolve when all of the data is back, the body is back, everything is done. Information is sent in these streams. It takes time. It doesn't all arrive at once. And so as soon as it gets the first bit of the headers, fetch is going to resolve the promise. So at this point in my code, I'm not guaranteed to have the body, the content that I want. So that is where we use a second method called .json. It's not the same as parse JSON. It's kind of confusing, or JSON.parse, I mean. But inside of here, I've got this response.json method. And the thing is, this returns a promise. So I can chain it. So at this point, I have a response object, but it does not have the data on it that I want, or that I care about. So what I'm going to do is just return that. Well, I guess I can print this out first. We'll say response waiting to parse. And then we will parse it here, which we can return so that we can chain on our .then. Or, as we know, I could just do res.json .then right here, but I'm not going to do that. I'm going to keep it flatter. So return this res.json. It actually returns a promise itself. When it finishes, basically that's saying when all of the data is back and it's been parsed as JSON. That's why this returns a promise, because it is asynchronous. It's still waiting potentially for the body to arrive. It's kind of confusing, like I said. But in here, if we have a second .then, this is where we'll have our data. And we'll console.log data parsed and show the data. Okay, let's see if it works. There we go. Here's our first .then, and then the second one, here's the data. It's already been parsed as JSON for us, and inside of here we've got things like ticker. So why don't we do data parsed, and then console.log data.ticker.price. And we arrive at the exact same end result. We get the Bitcoin price. It's a little bit of work, right, to have multiple promises we're working with, so fetch is not ideal. It's not the perfect solution, which is why libraries like Axios exist. And Axios is what we're about to see in the next video. I just always feel bad about showing people the library without showing the native version, which is what fetch is. So Axios is built on top of fetch and it improves upon it so that we don't have to do these multiple steps. But fetch is still an improvement over XHRs, okay? Trust me, it's a lot better than what we saw here. Because if I wanted to make another request after this first one, I don't have to nest things. I don't have to, nest those hideous callbacks to success and fail. I can use the same .catch. So from in here, I could just return the exact same thing. That's a promise. I don't know why I would request the same endpoint twice, but I could. And actually, let's just take a moment to clean this up a bit. Here's our promisey version. Now let's do the same thing with an async function. So I'm going to write a function. We'll call this get, or maybe fetch Bitcoin price, async, no real arguments or no parameters rather, and we're going to call fetch, and we're going to await it. That returns a promise, so we'll await it. Let's just do const res equals await that fetch, okay? And then in here, and we can just do a console.log res just to see that it's working. fetch Bitcoin price. And there we are. Okay, so that is working. But now we need to await res.json, just like we did here. I don't have to use .then, but we are awaiting a promise being resolved. So we'll call this data. And then we can console.log data.ticker.price, I think is what we want. And there we are. So that is working. And this is super nice and clean, nice and short and cute thanks to async and await, but it's all built on top of promises. This is not something we could do using XHRs, what we saw in the previous video. Also, we're not handling errors. Remember, we have this .catch here. If something did go wrong, we would be catching it. I'll just show that here. If we request, a URL that doesn't exist, here we are. We caught that error and we did something with it. We printed it out. We're not really doing much, but we did something. But with my async function, if I request something that doesn't exist, I assume that doesn't exist. I'm not catching it. Remember what we need to do to handle errors in here. If any of these promises are rejected, we wrap them in a try and a catch. So we're going to try all of this stuff. And then just to keep things simple, I'm just going to print out, if something went wrong. Console.log, something went wrong, just like that. And we could also print the error if we wanted to. So now if I try it, we're at least catching it. And there we go. Something went wrong. Type error failed to fetch. So hopefully you can see how this is a significant improvement. I mean, both of these, the syntax for promises is kind of annoying. But again, if we wanted to make multiple nested requests, well, I shouldn't say nested, multiple requests in a series, it's super easy. We don't have to worry about these ugly nested callbacks like we did with XHRs. Where I would be nesting, I'd make a new object for each one and then attach an onload and an on error. And I would do that in here and then nest further and further. Oh, what a disaster. Not a fan. So thankfully fetch exists, but in the next video, we'll see that there's an improvement upon fetch, a library that's extremely popular that just solves some of the annoying parts of fetch and just makes it easier overall. So it's built on top of fetch. It's called Axios. That's coming up next. So now we move on to our third and final option I'm going to show you for making requests via JavaScript. It's a library called Axios. So it's code that some other people have written that has been turned into a library we can include, and it gives us a bunch, well, there's not even a bunch, it gives us a handful of useful methods to make requests. And it's built on top of fetch, and there are a couple of reasons to use it, but the main one that we care about is just that it's easier. So I didn't show you how we use fetch to do things like send a post request or to include query string information or to change headers in the request. It's not that much work, but Axios makes it easier. But one thing we did see is that without Axios, just with fetch, we have to worry about this first promise that's returned, or that's resolved rather, when the very beginning of a response is received. And then we call res.json, which itself returns a promise when everything is done, when the whole body has been parsed. It's two separate steps. Axios turns that into a single step. It makes it a lot easier and just shorter. So it's a library, which means we need to include it in our code. We can just go to Axios' homepage. I think they actually have a web page, but this is just the GitHub repository. There are multiple ways of including Axios. The easiest one for now is to just copy one of these links. So this is just take this one. I'm going to copy it here. Then in our HTML file, somewhere before our script where we want to use Axios, somewhere before it. So it could be right here. Also, people will put them up in the head because these are just external scripts. They don't depend on the DOM being loaded. Either one is fine. We just need it before our app.js. So I'm just going to paste that in there. And now I have access to Axios stuff. So if we look at how Axios works, there's quite a bit. But the thing we'll start with, the most important method for now, is called axios.get. Now, a quick note, on the docs, you will see things like this, require Axios. This is actually not something we need to do. Axios is a library that works both with client-side JavaScript, like we're using it, and also Node.js on the server side, where you can install libraries and require them or import them manually. So if you do see that, this will make sense in a couple of sections from now, but it's not something we need to worry about right now. but the methods are the same. And that's actually one of the reasons people like Axios. You can use it both in Node.js and on the client side with the exact same syntax. So Axios comes with a method called get, and we're going to call that. We're going to pass a URL in. Just copy the same Bitcoin URL. So axios.get, paste that in. And I'm just going to copy it or cut it and paste it in here so you can see what we get back. It's a promise, and it's resolved, thankfully. And the value already has data in it that's been parsed. If you can see that there, we don't have to deal with any, JSON parsing, or we didn't have to, chain multiple thens together like we did with fetch. The promise itself comes back, and it's only resolved once everything is finished, unlike fetch. So it includes all of the information we could want here. It's a simpler object to look at. So we could use it just like this. Axios, I'll just paste that, .get, and then our .then, and then inside of the .then, we already have our response object fully parsed. Whoopsies. There we go. And on that response, we could console.log response. And then if you look at what it looks like, it's response.data and then ticker and whatever we want. So data.ticker.price. Okay, so let's take a look. And there we are, the current Bitcoin price. Probably a poor choice to include this. It's going to change radically, I'm sure, by the time you're watching this, even if it's tomorrow. And then I could also add on my .catch, of course. If there's an error, console.log, I'll do an error like that, and then print the error itself. So we shouldn't get an error there, but let's say, I request something that doesn't exist again. There we go. We caught it. Nice and simple. We'll go back to normal and make it work. Okay, so this is still promise-based. It's built on top of fetch, like I mentioned. It's just a little bit shorter. So if I were to rewrite my function, my async function, to get the current Bitcoin price, const fetch Bitcoin price equals an async function. It's going to be nice and short if I use Axios. I'll just do a try and then copy this axios.get. I will await that. Const response equals await axios.get, and then I'll just print this out. res.data.ticker.price, and then I can catch it here. Catch error, and then whatever I need to do, same thing. So it may not seem like a huge improvement, but there is a difference, right? We saw that with fetch, we do have to first make our fetch call that returns a promise, but that promise is resolved with what's basically an incomplete response object. Data is still coming in, it's not been parsed. So then we have to call res.json, which returns another promise. We have to wait for that to finish. So it's just an extra step. Axios does it all for us at once. We just await one thing, or we have one .then, and we get this nice, response that has everything in it. It's got the data already. It's been parsed. It's got the headers already available for us. And this is just a simple example. In the next few videos, we'll see that Axios gives us nice, easy ways of making different types of requests, including query string parameters, including or changing headers on the request. So those are things we'll explore in the next couple of videos. Remember, it doesn't do anything we couldn't do beforehand. It's just there to help make things easier. It's an external library. We have to include the script. If I don't have that, I'm not going to have a good time and we'll run into errors. So you can see there. So we need to have that defined. And then, of course, I should just verify that my function works. So we'll call it fetch Bitcoin prices, fetch Bitcoin price. And there we are. Current price. Okay, so that's a quick intro to Axios in the get method. Next up, we're going to get a bit more practice with Axios, and we're going to focus on configuring headers, request headers when we send a request, just like we did over here in Postman. If we go back, if we use this dad jokes API, if you recall, we had to specify this accept header in order to get JSON back. Otherwise, we get HTML, which is the default. And if I'm trying to build an app with my JavaScript, let's say you click a button and we get a new dad joke. Every time I want to just get the JSON, I don't want all of this stuff, right? All this HTML. It's very difficult to figure out where the joke is in here. I know it's somewhere in here. Nope, that's a footer. Where are you? Here we are. Why are mummies scared of vacation? They're afraid to unwind. Okay, well. So what we need to do is specify that header, just as a recap, except, and then we want application/JSON. So this is in Postman. There we go. Whiteboards are remarkable. Very funny. So now we need to figure out how we do this with Axios. And all we need to do, if we're making a GET request, we'll use axios.get. So axios.get. And actually, I'll make a function in here. Let's call this one const get dad joke. And let's make it an async function so we don't have to deal with .then and everything. Axios.get, and then this URL. And then let's take a look at the response. Let's call this res equals await axios.get. And then let's just console.log res. And over here, if I call get dad joke, you can see we're getting HTML. That's not what I want. Also, we do have this headers property that I can look at, and we'll see content type is HTML. This is constructed for me by Axios based on the response that it got back, the actual information that came back, which is just text. Axios is going to parse that information and turn it into an object that we can work with. Anyway, we want to specify that we only want application/JSON when we're making our request. It's just the way this API is configured. It's not something you would just know. Okay, I want to be very clear. You have to read the docs and figure it out, and it will change from API to API. Some will have you specify an endpoint that has /JSON in it, like this. Others might have you add the query string in that has type equals JSON. But the way that this API in particular is set up, it wants a header, except set to application/JSON if we want JSON. So what we do with axios.get, there's actually a second argument we can pass in with configuration information. And one of those things we can configure is the headers, which itself is an object. And what I like to do is just make this independently or make it separately, because it can be a little lengthy to do it at once. So I'm going to do this, const headers or config equals an object that has headers inside of it. And then the header we want is except, and then application/JSON. Just verify it's matching, application/JSON, except. That is just the only header we really need to pass in, but we could have other headers if we wanted to. I can add as many as I want, but remember, it's just like the query string. Only certain things actually mean something to the server we're requesting. So this is something that the API is looking for. It's going to look, is there a header that specifies the type? In our case, now there is. So I just need to pass that in as the second argument here, my config object, and then I can await that like I am, and then console.log res this time. So we'll try it again, get dad joke, and what do we have here? It looks like JSON instead of our data. There we are, it's been parsed. Here's our joke. What did the left eye say to the right eye? Between us, something smells. Wow. And then in headers, we can see we got JSON back. So it tells us this is JSON, and we can see it. It definitely is JSON that's been parsed into a JavaScript object. All right, so now I could extract the joke out of there, which is res.data.joke. And now every time I call this function, we just print out the joke. Sore throats are a pain in the neck. A weasel walks into a bar. The bartender says, "Wow, I've never served a weasel before. What can I get you?" Pop goes the weasel. Okay. So now that we've made a request, multiple requests, let's do some DOM manipulation as well. Nothing crazy, but why don't we add maybe just a button in here? So let's add like a H1, click to get new jokes. And then we'll have a button here, click me. All right, and then let's have a place where we can append new jokes to. Maybe just a UL. We're not going to bother styling. We'll give it an ID of jokes. And then every time we get a new joke, we'll append a new joke to that UL. All right, so over here, instead of, I could start by just putting it all in line. So I could select that div, or that UL rather, jokes equals, and then document.querySelector with the ID symbol of jokes. And then here I could make a new li, const new li or something like that, equals document.createElement li. And then new li.innerText, or we'll just do append res.data.joke. So we're appending the text from this API call. And then we can append this new li to jokes. Jokes.append, and then new li. And let's see if that works for us. I'm not going to console.log the joke anymore. Let's call the function. And there we go. My dog has no nose. How does he smell? Awful. Why do ducks make great detectives? They always quack the case. All right, so we're doing very simple DOM manipulation, but this process is really, really common, making a request and then doing something to update what the user sees or change their experience where the page never actually refreshed. We never navigated anywhere else. This is all happening behind the scenes, although, yes, I am having to type a method or a function call and execute it myself. So let's add a click listener, and then I might either rewrite this function or split it into two. So we could fetch the joke and then, add the joke to the page. So that's probably what I'll do. I'll add a click listener on that button. So I need to select it. Const button equals document.query selector. We'll just assume it's the only button, which is not always the best idea, but for something small, it's fine. Button.addEventListener for a click. I'm sorry, that keeps blocking the screen here. Oh, come on. And then I think I'm going to write a function in here called add new joke. And what it's going to do is request a new joke. So I'm going to extract some of this. I'm going to call get dad joke and save that to a variable, const joke text or something. And so from here, I'm going to return res.data.joke. So get dad joke now just exists to return the joke text. But remember, it's an async function. So it automatically returns a promise. But that's fine. I can await that, or I could chain on the .then callback. But I'm just going to make this an async function here. All right, so add new joke equals async. And then in here, I can await get dad joke. So that will give us the new text. So I could start by just console.logging that. Console.log joke text. And let's see if I click. Oh, I didn't add the click listener, did I? Let's try that. Add new joke. When you click on that button, we're calling add new joke. And I have an order issue. I need to make sure that I add the event listener after I have defined that function. So now we try it again. I'll click, and there we go. So a duck walks into a pharmacy and says, "Give me some chapstick and put it on my bill." What cheese can never be yours? Nacho cheese. Oh, that's an old one. Okay, so now I've extracted that functionality into its own function. It just gives us the joke text. And then here in add new joke, I can await that. So we've got two async functions instead of just combining it into one. So I await the text, then I can make my new li, create element, append joke text, like that, and then append that to the jokes list. So nothing new, I've just split it up. So we have add new joke, get dad joke. Add new joke calls get dad joke, and it waits for it to be resolved, hopefully. Now, I do not have any error handling in here. There are many things that could go wrong where, the API could be down, our internet could be down. There's other things as well, but I'm talking about in terms of Axios. So we probably should address that. Why don't we do this here? We'll try all of this like that. And if there's any error, we'll catch it. And why don't we just return no jokes available or something? Sorry. And we'll append that as our joke text. So let's try and cause an error. Let's just see that it still works. Okay. Now let's change this to some URL I don't think will work. No jokes are available. Sorry. Okay. Good enough. All right. There's a lot more that we could do, but that's just a simple demo. Okay. So in this video, we saw really two things that I crammed together. One is that we can specify headers when we make a request. We pass in an object. I like to do it in a separate variable. You don't have to. It's kind of a long line. And in our case, the header was accept. We wanted application/JSON so that the API, just this one API, it's the way it's set up, will respond with JSON. Remember, that's not standard for every single API that it requires that. And then we talked a bit about this process of, once we have this data, manipulating the DOM. So nothing crazy, pretty simple. And in the next video, we'll get more practice doing something similar, we'll be using the TV show API, and I think we'll make a simple search and talk about changing query string parameters when we make a request. One thing I should mention about these APIs, they do often have rate limits, so don't spam this, don't make your API calls in a loop, don't try and make 1,000 calls in a second or automate it. They'll usually ban your IP address or at least give you a little bit of a cooldown for a bit. And if they don't, a lot of these smaller APIs, it's just a taxing thing to do to them, and it's not very nice. So try and be respectful. If you accidentally make a huge amount of requests, like in an infinite loop, don't do it again. Don't aim for that, all right? Don't be a troll. Okay, so next up, more practice with Axios. Next up, even more practice with Axios. I'd like to use this movies API, or rather TV show API called TV Maze. There's a lot we can do, but I think we're going to make just a little search where you can search for a TV show, and then we'll get some images back, hopefully, and show you images and maybe titles or something for movies. I keep saying movies, TV shows, okay? And we'll talk about how we can update or change query strings as we are sending requests with Axios. So let's work with the search endpoint. So I'm on the documentation, tvmaze.com/API. I'm just going to copy this, and let's use Postman, always a good place to start. And it's a GET request. Remember, we can just type the query string ourselves in the URL if we're using Postman. It wants a Q. If we're doing a search, it wants Q equals and then some query. So let's say I want to search for TV shows that have, I don't know, dark in the title. And there we go. We get dark. Excellent show. And if we just look at what we get back, we've got things like, obviously, the name, genres in there, status, if it's ended or still going, rating, look at that, such a high rating, and then image. And under image, we have things like, well, original and medium. So I think we'll use medium just because they're probably smaller, and we'll display that. We could start by just displaying the first result and finding its image and displaying that. Depending on how many we get, we could loop over them and display all of their images. We'll play around with it, but I want a user to be able to search. So really the process will be to have a form, so that's not too bad. A form or just a basic input. So let's do, TV show search. And then in here, we can do a form. As we talked about with events, we can use a submit event on a form, or we can just do a click event on a button. It's really, we have a lot of options, but I guess I'll do a form. And then in there, our action really doesn't matter. It can just be jank and not have an action in there. And then inside of here, we'll have our input type equals text. Placeholder will be, TV show, or how about just search? And then a button. Whoops. We'll also say search or something. So I don't know. What should our placeholder be? Movie, TV show title. Sure. Okay, so here we are. When I click, it's very quick, but you can see that the page refreshes. We talked about why that happens. It's the default behavior of a form when it's submitted. So in my script, I'm going to select that form. Const form equals document dot query selector. Let's get in a better habit here. Let's give it an ID. So we'll call it search form. Give it the ID of search form. And I think I deleted a bracket accidentally. Hate when I do that. And let's also give our input a name. Name equals, we'll just call it query, or even just Q. I'll do query though, just to make it less confusing, because Q is the name of the query string we're passing, or the parameter. Anyway, over here, search form, that matches, and then form.addEventListener will listen for a submit event. Then we have our function, and we want that event object because I'm going to call prevent default. And then in here, let's console.log submitted. So let's see if the page refreshes. Oh, cannot read property add event listener if null. Oh, I didn't use the ID symbol. There we go. Try that again. Okay, so now it's preventing default. Next, what we want to do is extract whatever the user has in here, whatever they typed in. So there's multiple ways of doing this. If you recall, if I just console.log form, or this would work as well. Let's type something in here like chicken. Console.dir. Try that one more time. if we look at that form, so I could select the input separately, or I also have this elements property we talked about a while back, and I can look up, the name of my input. I gave it the name of query. So that's what I'm going to do. I'm going to do a console.log form.elements.query.value, and that should give me the form itself, or rather the input value. So I'll type something in there. There we go. So I want that in a variable. I want to extract that. So I'll save that to a variable. And actually what I think I'll do, because I'm going to reset the inputs, I'm probably going to take form.elements.query. So I'm going to save that to a variable. We'll call this const user, I don't know, how about search term or something? Just like that. And now we need to make our API call. So I do have Axios included. I just copied what I had in the previous couple videos. I've got that script. It's just coming from this website, or the CDN. We talked about that with Bootstrap. Content Delivery Network, I think, or Distribution Network. I can never remember. Anyway, it's hosted online. We don't have to download it beforehand. Now what I'm going to do is call axios.get, and then the URL that I want to get is, if we go back to the docs, this URL right here, right, /shows, and then I want the query string, and I want Q to be whatever that user types in here, chicken, for example. So I don't just want to get this URL. I want to maybe just use a string template literal and replace this with whatever the user types. So search term. And this is one option for this, just like that. And then I'll want to await this, but I'm not in an async function, so we can make this an async function. We'll do const response equals await axios.get. When you put the search term in there, technically right now we have no validation. You could just have an empty search field and hit search. That's fine for now. And then we'll do a console.log res.data, and let's see what we get back. Okay, so I'm going to search for chicken. Fingers crossed. Oh, there we go. We get our array. In this case, it's been parsed from JSON, and we have 10 different shows. So for each one, it looks like we've got show is a property, and then .image is what I want, and then .medium. All right, so let's do just, how about the first one? Res.data of 0, .show, .image, .medium. Hopefully that just gives us the URL of an image. Perfect. Now I want to display that image. Okay, so we could do this all in line just to start. So we can make, or in the same function rather, we can make a new image, const img equals document dot create element, image element, and then image dot source equals this lovely thing there. And then let's just append it to the body, document dot body dot append image. Let's see what happens here. Okay, so I'm going to search for chicken. Hey, there we go. We got robot chicken. I should probably clear that input as well. What else should we try? Dog. Lucky dog. Okay, so that is working. Now there are definitely some things I would change. First of all, I think we want to do this for every result we get back. So we could just repeat this process for every single element, or every single result rather. I think 10 is what we got for chicken. We may not always get 10. I think that's probably the upper limit. That's pretty common to just give you 10 at a time, but there might be 2 or 3. So I'm not going to hard code that. We'll loop over res.data, which is an array. And then for each one, we'll make an image and append it. So I'm going to make a separate function, I think, to do this. And I'll call this function, how about, I don't know, make images or display, create images. I don't know. How about, sure, make images. It's not a great name. And it's going to expect an array of images. It's not images. It's just going to expect an array of shows. Alrighty. So just like that. And then we'll loop over that for let show of shows. And this is really just sort of a rough way of doing this. There are probably better ways we could structure it. But for each show, we're going to make a new image. And then we're going to set that source. Instead of doing res.data, it's now just going to be show. That's kind of confusing. Show.show. Show is referring to each element in the array. So maybe we'll call this result. And then this dot show is just coming from the API itself. So if I were just to console.log result, just to be very clear here, and then I'll call this, right? I'm going to call make images with res.data. Let's see what we get. So we won't see anything, but chicken, there we go. Each object in that array has a show property, and we want image medium. Okay, so instead of doing that, we're going to make our image. We're going to do result.show.image.medium, append that to the body. We should probably make a container, but for now we'll just append to the body, and there we go. Oh, interesting. So not every single thing has an image. So we need to add some logic in there. We're getting a message saying cannot read property medium of null. So that means there's no medium on image. Image is null. So we could do something like this, just kind of janky, but if result.show.image, if there is that, we're going to do all of this. So we'll make a new image. We'll set the source on that image to be result.show.image.medium and then append it. Otherwise, we ignore it. So hopefully that gets us out of that problem. Let's make sure. Yep, no errors now, even though some shows, we got, 9 results out of 10, or we got 9 images out of 10 definite results, so one of them did not have an image. Okay, now, what I want to show you next, this is still not, perfect code in the way it's structured. We could probably move this out into its own function, but this is fine enough. We definitely should empty the input though. So form.elements.query.value equals an empty string. Now what I'll show you is that we don't have to add the query string in manually like this. This isn't too bad, but sometimes when we're making API calls, we might actually have often multiple pieces that we're adding to the query string. So here's an example: queue and embed, or TV DB people. Now that's not a query string. Here we go. Country is US, date is 2014. So these are different things that we can add, and we might have 2 or 3 or 4 at once depending on the API. So Axios gives us another way of doing this where I can just request this URL and then add in my config object where I can set something called params, and we can do this as a separate object too if we want. Const config equals this object with params, and I'm going to set it to its own object, and every pair that I make in here, key value pair, will be added to the query string. So I want to set q to be search term. Okay, and then I can pass that in right here. And this might seem like more work than it's worth, but remember, if we have 3 or 4 different things that we need to add to the query string, it's annoying to have to add them all into the URL itself. This allows us to add them in programmatically using this object, and sometimes that's easier. Sometimes you might even have an object already that has your values just made for you from some other, let's say a form or some other place in your JavaScript code, and you can just add that in here. Params is what we're looking for. So we could also, as we saw previously, add headers in here. So this config object, you don't have to call it config, it's just a variable name. It has multiple purposes. We can add these params in, we can add headers in, but we care about params. So it still needs to match, right? Q is going to be added here. We'll see the exact same thing, hopefully. Make sure I pass that in. Let's see what happens. Chicken, search. Okay. Now if I actually look on the network tab, we spent a little bit of time here. I'm going to try this one more time. Let's look at puppy. You'll see that we did make a request, and I'm just going to expand this a bit. It shows API blah 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 /search /shows q equals puppy. So if I had anything else in there, I can add my own stuff if I wanted to, like is funny, and set that to cold. Now if I do that again, search, there you go. We can see that our request did include that query string, or that parameter as part of the query string. Interesting. I just typed gibberish and we still got results. Wow. I was expecting to have to handle some errors or something. Interesting. All right. Well, it seems to be working just fine. It's just giving us empty results, which is great. We should, do a whole try and catch, but just for simplicity's sake, I'm going to stop here. So in this video, we got more practice making requests. This time we're working with a form. We prevent default. That's nothing new. we extract a search term from the form, and then we made our query string object, which uses the name of, or the property of params. And we can pass in this config object, and whatever we have under params, those key value pairs will be added to the query string. So I'm going to get rid of that one. And then we just await it. And then we called make images, a function we made that just creates a bunch of images and appends them to the page. I guess, it might be good to, I'll do cow. It might be good to delete images every time you search. So instead of just appending them, now we just get a whole bunch of images added on top. We could do that, definitely, right? We could write a function to clear all of the images. I'll leave that up to you, but that's probably something you want to do. And the other thing I should mention is the reason that I went with a form that has to be submitted, rather than doing like an input event or a change event or a key down. It's tempting to do a live search like that, and you definitely can. But when you're using someone else's API like I am and I'm teaching, I'm very hesitant to do any API call or HTTP request heavy code, because you may end up making a mistake in requesting them. Every time you type, you might, if you're typing quickly, that might be 20 requests. And if you're not careful, you need to pay attention to make sure you're slowing things down and not requesting on every character. And you just don't want to overload their API. So you definitely can do something like that, where instead of waiting for somebody to search, you could just send requests as I'm typing. But typically, if you've seen that before, people are either requesting their own API that they've configured, or they have some delay or some functionality in there to make sure that they're not overloading an API. And I think that's good enough for now. Okay. Welcome back, everyone. Next up, we're going to talk about a part of JavaScript that is not always the most beginner-friendly. Something called prototypes. We're going to dive deeper into how objects work. How do all of these arrays and strings that we make have access to like dozens of different methods every single time we make a new array? How do we replicate that functionality ourselves? How do we add a bunch of methods and properties into some repeatable, reusable recipe? That is what this section focuses on. So object-oriented programming is a term you may have come across before. Classes, prototypes, those are all things we're going to talk about in this section. Now, you may have noticed there's a lot of yellow and red over here. This is a dense section. It's definitely not the easiest thing to pick up in this course. And I'll tell you right now, you do not need to watch this right now. I put it here kind of to group it with the rest of the JavaScript content, but it's at the very end. And you need to know this throughout the rest of the course, but you don't need it right now. So if you would prefer to move on and go to the back-end stuff, take a break from JavaScript, you'll still be using JavaScript, but taking a break from learning new syntax, really the first time you'll need to understand classes and super and extends is when we get to handling errors in Express. So you'll then probably want to come back and check this out. Or you could just go through it now. It's not horribly painful, or you're hopefully not going to pull your hair out, but it's also not the lightest, fluffiest, simplest topic in the course. Okay, so there's a couple of concepts. Really, the first concept that is important to understand is the concept of object prototypes and what it is and how that works in JavaScript and what prototypes are. Then we're going to talk about something called the new keyword and the 4 things that it does in JavaScript. And that kind of goes along with constructor functions. I'm going to say understanding the new keyword is important, and then defining constructor functions the old way, which I put in quotes, basically not using classes. Classes and the class syntax is newer in JavaScript. That's completely nice to have. It's good to understand how it works and why classes are nice. The way I'm kind of structuring this is that I'm going to show you how we achieved one version of JavaScript object-oriented programming pre-classes. Then, with classes and the newer syntax, how much nicer things are now. It will help you understand what actually happens when you make a class and you use these keywords. So it's nice to understand how that works, but it's not critical. What is critical in this section is defining classes and working with the keywords extends and super. When you get to the last couple of videos in this section, that will make sense. So just keep that in mind. This stuff really matters. Everything else, I mean, you don't need to go back and panic and freak out about it. If you're interviewing for a job and you really want to know JavaScript well and prove that you know it well, it's good to be able to do this stuff and explain exactly what the new keyword does in a constructor function. But really, for now, it should not hold you up from moving on, which is why I kind of feel bad about putting it here in the course. I have to put it somewhere. I considered just burying it in the Node section and just having a little break from Node, but then I thought some people might want to just go through JavaScript all in one chunk. So here it is at the very end of JavaScript. Lastly, in this section, I do talk about, or I use colors as an example. We build a class that helps us represent colors and convert them from RGB to hex and to HSL colors. And how do we find the opposite of a certain color on the color wheel? There's a whole bunch of functionality there, but the actual math, the logic does not matter one bit. I'll put it in nice to have, but really it should be in a whole other category called don't even bother. I'm very transparent about it. There's, the math to convert from RGB colors to hex. I just stole from Stack Overflow. I didn't steal it, but, copied it. But that's what it's there for. So I don't even bother explaining how it works. I just want to be upfront about that. It does not matter. What is important is understanding classes, super extends, all that. I happen to use color as one way or one example, but again, the logic does not matter whatsoever. All right, so this has been a long intro and you've been staring at this hideous Trello board for a long time. Let's go ahead and get started. Just come back to this video mentally as you're making your way through the first couple of videos in this section. Just focus on this stuff. If you have questions, concerns, if you feel frustrated with some of this stuff, don't panic too much. Ask the questions, but don't let it hold you up. Okay, here we go. Welcome back. In this section, we're focusing on object-oriented programming, or at least JavaScript's flavor of OOP, object-oriented programming. So we'll cover things like constructor functions and classes, super keyword, inheritance. But we're going to start with a quick video on a quirky but important aspect of JavaScript, object prototypes. So you may have come across this at some point. We've briefly touched on it throughout the course a couple times. We're now going to take a deeper dive into what the heck a prototype is. What does it mean? What is this thing when I look at an array? What is this proto __ proto property? So that's what we're going to talk about first, and then we'll go more into creating constructor functions and classes and all of that stuff. All right, so according to MDN, prototypes are the mechanism by which JavaScript objects inherit features from one another. Objects can have a prototype object, which acts as a template object. So what this means is that certain objects, like we'll take an array as an example, an array has a whole bunch of different methods. If we look at something like array on MDN, on the left side, we've seen this a couple times, methods, under methods, there are so many methods that start with array.prototype.concat. Entries, every, fill, keys, push, reduce, all these methods that we use all the time, like 123.push 4. That push method is not defined as a method on this array right here. If I save it to a variable, const r equals 123. If we look at that array, I don't see any methods right here. I mean, I could define my own method, array.sing equals a function, and we can console.log, how about la. Okay, so there is a function, or a method, technically, that I added to the array itself. The individual array, it has a method called sing. Remember, arrays are objects in JavaScript. So when we added that method to array, we see it show up here. But when I call array.push, push 5, I don't see that method listed here. I don't see any of the methods we used. They're all inside of this property called __ proto __ or just proto. Some people also call this dunder, dunder. I just say proto. It's a property that references the array prototype. So a prototype is the template object for, in this case, arrays. It contains a bunch of methods typically. So all of these methods that every array will have access to. But rather than defining them individually in every single array, a separate copy, right? I could make another array here, const array2 equals 456. We look at array2, it doesn't have its own copy of push and pop. All that it has just as the original array that we created, they both share a property called proto, which is a reference to this blueprint object, the prototype. This prototype contains all of the methods. And through the magic of JavaScript, I can simply access array dot, and then what's another one we haven't used yet? How about includes? Does that array include 2? We get true. This includes method is not defined on every single array that we make. It is defined on this prototype object. Now, the reason I'm bringing this up is that it matters. It's something we will cover and come back to as we talk about defining classes and constructor functions. So rather than having a separate method on every single array called push, there is one prototype, and each array has a reference to that prototype with this special property _proto. And we actually can see this in other types of objects in JavaScript. What if I take a look at the document.body and I save that to a variable, const, we'll just call this body. If we look at body, I'm going to have to console.dir body. We'll open it up. It has certain properties that are specific to this body. Things like the base URI, the background, but then it also has a proto down at the bottom. Its prototype is an HTML body element, and there are different methods and properties that correspond to that prototype template, this HTML body template. So that's the basic idea of a prototype or prototypes in JavaScript. We have this one object that is the prototype for other types of objects. So there is an array prototype. If I look at array.prototype, capital A array, so not an individual instance of an array, but capital A array, here is everything on that array prototype. And I could actually define my own type of an object, my own brand new object, and set its prototype to the array prototype, and I would have access to those array methods in my whatever object, my version of the array. But we're not there yet. All we need to know at this point is that prototypes are like a template object. That's actually what they are. They are objects. They contain typically a bunch of methods, and then we can create multiple objects that share the same prototype, so that they all have access to the same methods without having to have their own copy. Now, as a fun little demo here, we can actually mess with or add our own properties and methods to the array prototype or object prototype or whatever prototypes we want. There is a string.prototype as well. Strings are kind of confusing because we've talked about how strings and numbers and booleans are technically primitive types. However, in JavaScript, they all get these intermediate object wrappers. And that's where all those string methods come from, the string prototype. So I could actually add on something to the string prototype. Right now, if I just take a look, we see a bunch of string methods like concat and a property like length. What else do we have? Substring, starts with, search, replace. I could add my own method called grumpus. Go back to good old grumpus, set it to an arrow function, and we'll just console.log. Or how about we alert? Go away. Just like that. Okay. So it doesn't seem like much happened. We look at string.prototype. This prototype object, this template for other strings, now has a property called grumpus. So why don't I make a new string? I'll call this const cat equals blue, I guess. One of my cats. Now, what if I try and call cat.grumpus? Hey, this page says go away. So now every time I make a string, at least until I refresh my page, I now have access to a new string method called grumpus. I could also add on a property. I could do string.prototype. How about we do yell? And we'll do something slightly more complicated. I think I'm going to move over to my code here. Let's access string.prototype, which remember is the prototype object for every string. It is the place where string methods are stored. I can now add on something. Let's go with yell, which will be a function. And let's just console.log this inside of here for a moment. So we're getting ahead of ourselves, but I want to just show something kind of fun. If I run my code, I make some string like hello, and I call .yell. This referred to the string hello. So what I could do is console.log this dot to uppercase. So this refers to whatever string we're calling the method on, which is actually something we've seen before, where we had an object and we would refer to this.x inside of that object. This will refer to whatever is on the left-hand side of that dot, at least in this case. So let's try hello.yell again. All right, we've just called an existing method .to uppercase, which is already there. So why don't we return a template literal string where we have this .to uppercase plus a bunch of exclamation points, and then how about some other stuff like OMG, more exclamation points. That's screaming apparently. Okay, refresh my page. I make some string like I love you dot yell. And this is what we get. We've made our own method that we can use on every single string. It's important to realize that this is not really a good idea. This is not a pattern that I would recommend you follow all the time. It's just a demonstration of how prototypes work. So we can add something to the array prototype, array.prototype, which is a specific object, a template that stores methods and properties for every single array. And we can override something like .pop. And we'll make that a function, but it will just always return, sorry, I want that element. I will never pop it off. Okay? So we are now replacing the existing pop that every array looks up to on its array prototype. So if I make an array like 3, 4, 5 and I call pop, it doesn't work. We get our version. So kind of fun stuff, not highly recommended, but it is going to be informative. It will be helpful to understand prototypes. It's actually a relatively simple idea. It's very intimidating, I think, when you're starting out. But the idea boils down to having a single object that contains common properties and methods that other copies, other objects of arrays or other strings look up to find their common properties. It's a place to store things. It's a template, a blueprint. There's so many ways of putting it, but the term in JavaScript is prototype. The one confusing thing that I would like to address is if I make an array here, const, I don't know, nums again, I know it's so boring, nums 789. If I look at nums, what is this underscore proto versus prototype? So they both are very similar, and they both sound like prototype or proto. This here, array.prototype, is the actual object where we add the methods to or the properties. This is the template object, the prototype. This is a reference. So underscore proto is a property name on this array or on this string. I could look, or I don't have a string there, but I could make a string const dog equals Timothy. And if I look at dog dot underscore proto, it's a reference to the string prototype, to this object. So it's a reference versus this here is the actual prototype object that I can add on to. But inside individual strings or arrays or other objects, the property name that is used to reference that actual template, the prototype object, is _proto. It's pretty rare that you would ever need to touch this yourself or do anything with _proto. If anything, you will be accessing the actual prototype itself and manipulating it. So that is a brief primer on prototypes. Next, we're going to talk about some basics of constructor functions in JavaScript. All right, so now that we've seen a bit about prototypes, we are ready to move on to talking about basic object-oriented concepts in JavaScript. So we have a lot to talk about. Things like factory functions, constructor functions, the new class keywords, constructors in a class, the new keyword, there's super, inheritance, there's a lot of stuff, but it all has to do with this one central idea, which is organizing our code, designing and structuring our applications by breaking things up into distinct patterns of objects. When I say patterns of objects, you can also think of recipes for objects. So I have an example here. This is a class that we'll be creating later on. It's a little bit long. It models a color. Now that seems kind of stupid, but with colors, we have so many different systems. We have RGB colors, where you can have a color like, I don't know, this right here. We also have hexadecimal colors. I don't know what the hexadecimal version of this color is. I could just make something up. FF31. That is clearly not it. VS Code is giving me a preview, but that is another format for colors. We also have HSL colors, and HSL is always tricky. We have a number from 0 to 360 and then a percentage and another percentage. And this gives me another format for colors. Not to mention, we also have RGBA, where we have an alpha channel for opacity, for how transparent a color is, from 0 to 1. Now, a lot of the times when we're making colors or working with colors in the DOM, we frequently may not need to translate between two. Sometimes we need to, but there are times where it would be easier if we had a color as HSL, for example. If I want to find the opposite color of this color right here, it's pretty easy because of this hue channel. So I don't want to go into too much detail, but we can take this hue and all you need to do is add 180 to it to figure out the opposite. This is the saturation and the lightness, but all of the hue data is here versus RGB colors and hex colors. It's spread out across all of those different values, so it's much, much more complicated to calculate an opposite color. So I've made a class, essentially a recipe for colors. You pass in a name like caret or emerald, and then RGB values. And we can easily translate between different colors. So I have a color called nav color. Nav color has a couple different properties, and it has some different methods. If we look at these methods, things like opposite, RGB, RGBA. So I could call nav color dot RGBA, or let's do RGB, and I get the RGB representation, but I could instead change that to hex, and I now have a hex color. But what's more fun is that I can use it to find the opposite color. I've added an opposite method. So if I select that first H1, I'm selecting all of them. I'm going to do it sort of in a hacky way. Take the 0 with one dot style dot background color, and I set it equal to nav color dot, and I'll just do an RGB color. All right, so it gives me this orange color. If I wanted to make this one the same color but slightly lighter, I could easily do it first by selecting the correct H1 and then calling the RGBA method and passing in maybe 0.8 for the opacity. Now I have a slightly lighter version. Or I could keep going lighter. I could do 0.5. Or I could go with the opposite color, opposite, which is another method I added, which gives me an opposite hue across the color wheel, so orange to blue. And it's all calculated using these color values. I also could go full saturation, which is another method I added. I can't remember. Okay, it's called full saturation, which will take the root orange color, called caret, I think, and make it as saturated as possible, as you can see there. So there's many things we could do. Point is that this color object for this caret orange color has different values that it's storing, different numbers, and it has different methods, and they are grouped together in a repeatable, reusable object. I made a second color here using the exact same pattern. So this color, which I'm calling emerald, has the same methods, but we get different results. If I use that color, the variable name is logo color. I'll clear this, rerun this code, but I instead use logo color, the name of that variable. I now have that green, and I could do the second H1 in a slightly lighter version, 0.7, and it's lighter. I could also do the opposite, as we saw, and we get this purplish, magenta-ish color, the opposite on the color wheel. So the same pattern, the same recipe for a color, the same methods, the same properties, but they have different values. We get different results frequently. And we've seen this before in a bunch of different contexts. When we learned how to make XHRs, which are XML HTTP requests, we ran this code, new XML HTTP request, save that to a variable like rec request. that made us an object with a bunch of different properties and methods already baked in. This line of code right here. We haven't talked about this new keyword, but we'll get there. But the key takeaway here is that we end up with this pattern. Every time I make a new request, I end up with an object. It may eventually have different values instead of just null everywhere, but it's the same pattern. They're cut from the same cookie cutter. Same thing with DOM stuff. When we select an H1, document.querySelector, just the first H1. That H1, if I do a console.dir, I forgot about that. Let's take a look at that line there. It's an object, and it has the same properties we've come to expect. And that's because it is cut from the same cookie cutter that all other heading elements are. It's called the HTML heading element. It is a recipe to make an object like this. So I think I'm going on and on about this. If you're already familiar with OOP, this idea of creating these classes or these object templates that contain a definition of the properties and the methods for a given instance of that recipe or class, this will all seem very basic and repetitive. But if you're new to this, it can be a little bit tricky to wrap your head around up front. So we're going to take it slow. I'm going to start with one approach called a factory function, and I'll explain how it works and what is not so great about it. So that's coming up next. Okay, so I've got a function here called hex. I did not write this. I adapted it from a Stack Overflow post. Don't worry about line 2 at all. Don't worry about how the function works. I took it from Stack Overflow. I don't know how to explain it anyway, but it converts RGB colors to hexadecimal colors. It simply takes some RGB value, so 3 arguments we pass in. Let's go with 255, 125. That will spit back to us a hexadecimal color. That looks like that. So if I put this in my VS Code, you can see the color there. It's an orangey color. And if I wrote the correct RGB string, just so we can double check, it needs to be RGB and then 255, 125. It's the same color, at least according to VS Code. So we have this function. I could also write another function to take 3 numbers like we have here, RG and B, and actually return a valid RGB string for use in CSS. I could just call that function RGB. It accepts RG and B, and then it returns a template literal where we have RGB and then $R, comma, $B, comma, $C. And that should be it. Let's make sure that works. If I use the same values, but I call RGB instead, that's the name of our function, which the VS Code extension is actually already giving me a preview of. Oh, this should be G. Not sure where C came from. If I try running this, all right, we get our string. Okay, so we have 2 different functions. They are perfectly fine on their own as is. But if I wanted to make a nice little object where I can convert back and forth from RGB to hex without having to pass in numbers each time, kind of what I showed you in the last video, I could use a factory function which would make me an object that automatically had a hex method and an RGB method, and it stored the RG and B values as values or properties on the object. So we could just make a function and give it a name like color make or make color, and we would pass in R, G, and B. And then in here, I could make a new object, const color equals an empty object. I'm going to add some stuff into that, but at the end, I'll return color. So I could say color.r equals R, color.g equals G, color.b equals B. Those are the values that were passed in. So I would use this, if I run the code, by calling make color, pass in some numbers like 35, 255, 255, and then I get back this object, R35, G255, B255. Now I could add in a method on this object, color dot, let's go with RGB, equals a function. So I'm building up an object, hence the term factory. We pass in some values, and this factory makes us an object and returns it at the end so that I can use it. Okay, so color.rgb equals, and then I'll basically copy this, but instead of RGB R, B, and G, I just realized they're in the wrong order, RGB. But instead of doing this and hard coding it, I'm going to use the keyword this, which we also saw back in that secret life of objects section. The keyword this, in this context, if I were to call, first color, const first color equals, and then make color, I pass in some numbers, 35, 255, and 150. If I call first color.rgb, in this method RGB right here, the value of this will refer to this object to the left of the dot. So if I use this, I can access this dot R, this dot G. And if I just console.log this, just to give you a refresher, because that section was a while ago, I'll comment that line out. We're simply printing this inside of this method. So if I call make color, some numbers, 35, 150, 140, save that to a variable, I'll call it C, and I call c.rgb. You can see that this is set to the same color object, to C. So it has access to R, G, and B via this. So what I would do is probably extract or destructure from this R, G, and B. Instead of having to create my string and access this.r, this.g, and this.b, it gets kind of annoying. So instead, we can leave this as is, and now destructure from this. Let's see if it works. I have this first color. I'll access first color.rgb, and I have an RGB string. I could also add in a hex function, like we saw earlier. So I'll just paste it in, and then I'll adapt it. I'm going to write color.hex equals a function, no arguments necessary. Unlike here where I have to pass them in each time to the function, by storing these methods on an object, I'm calling it color here, but I'm returning it at the end, the name doesn't matter. But because I store the methods on the object, and that object also contains the R, G, and B properties, I can access them, just like I did here. So I'm just going to repeat this line, to extract or destructure R, G, and B from this. Just like in this function here, this referred to this color object, this entire object we've been adding on to, as long as I'm calling it like first color dot RGB or dot hex, just like we would call some array dot push, right? The dot is very important here. We're not calling push and passing in the array. We're not calling hex and passing in some numbers. We're calling some color dot hex. We don't provide arguments. It looks on this object. So I could have another color. I could have purple.rgb, purple.hex. All right, so this should work. Let's make sure. The math doesn't matter whatsoever. It's not the point. I don't even want to take time to explain it, honestly, because I haven't even looked at how it works. I know that it's going to convert to base 16 at some point. I think, it's doing that right here, but really it does not matter to this video. All right, so it returns that. Let's make sure it works. I call first color.hex. There we go. First color.rgb. And I could also change the R value or the G value at any point. I could say .r is now going to be 255, full R, full red. And now if I look at first color.rgb, object on Earth. But it can be nice because if you do have these color values, working with them, converting them can suck. And later on, we'll add some more useful methods like a lighten method or a darken or a saturation, all those different things, opposite color. Anyway, the focus here is on this function. This function makes us an object. It starts empty, but then we add some properties based off of arguments that we were provided. Then we add some methods, and then we return that object. This is called a fact, and then we return that object. This is called a factory function. And it does work. This is one way of making objects based off of a pattern or a recipe. We've defined a recipe for a color. We call make color, we pass in 3 numbers, and we get back an object, and that object contains a whole bunch of things. Well, a whole bunch is an exaggeration. It contains 3 properties that are numbers and then 2 methods. And I could make another color, right? Make color where, let's say it's 0, 0, 0. Same pattern, different values. I get different outcomes from the methods, but the same pattern in general. But this is actually not the main way most people create objects based off of a pattern. This is not how people like to do it. And to understand why, we're going to have to talk about our friend Prototype in the next video, and we'll see a better approach. So there's nothing wrong with this. It's just not as ideal as it could be. So we'll see another option. Just hang in there. So that's coming up. Next up, we're going to talk about why this pattern, a factory function, is not commonly used, and why instead we use something called the constructor pattern or constructor function. So let's start with what you probably have seen at this point. We've seen this new keyword occasionally, like new XML HTTP request. I hate typing this, but we run this if we need to make an XML HTTP request. We're not using fetch, we're not using Axios. Check out the requests section if you're not sure what the heck I'm talking about. This makes us a new object following a pattern. Also, we can make an array with this syntax, new array. It's definitely lengthier. It's not commonly used at all. You could do new string. Notice I'm using capital letters. What is that new keyword? It's actually an operator, and we'll get to it. And we'll talk about why it's preferable to this approach. But let's start with understanding the shortcoming here. It's not a huge one, but it's important to understand. Every time I make a new color object, we start with an empty object. We have 3 unique properties, right? They're added directly to the object. That makes sense. But then these functions, they're recreated, and a unique copy is added to each color object. So each color object has its own RGB function. Yeah, the values are going to always be different, assuming that the colors are different. We have different R, G, and Bs. We can end up with a different result, but there's no reason to have a unique copy of the function itself. Just like if we were to write a regular function called RGB out here, function RGB, we could reuse that with any inputs. We don't need to have function RGB2 and RGB3 and RGB4 anytime we want to pass in different values. We just make one function. That is not what's happening here, and I can show you that. I have 2 colors I've created using make color. I have first color and I have black. They have different values that I passed in, so we get different objects, right? We have black where R, G, and B are 0, 0, 0, and we have first color, not a very original name, 35, 255, 150. Notice they have their own copy. Well, it looks like they have their own copy of hex and RGB, and we could verify that in a bunch of different ways. The simplest would be if we compare black dot, let's take hex, and compare it to first color dot hex. They are not equal. Triple equals for a reference type is going to check, and functions are reference types as a reminder. It will check to see if they are referring to the same function in this case, and they are not. But if we compare that to something like a string, any string, hi dot, what's a good method to use? How about we use dot slice? I'm not going to call it, just hi dot slice, triple equals by dot slice. 2 different strings. Notice that we get true. What's happening here is that the slice method is not defined on every single string. Or if I had worked with an array, if we look at some array, 1, 2, 3, 4, the methods are not defined in this individual object. Arrays are objects. A weird part of JavaScript, they are considered objects. Instead, they are defined on the prototype. Remember, we started this section off with prototypes. Every array gets its built-in array methods from one prototype array object. This contains all of the methods and functionality that we're used to using. Array.pop, array.concat. Same thing with strings. The string prototype contains the methods. So instead of having their own copy, this array does not have its own copy of pop. This string does not have its own copy of slice. They're referencing one function, and it's located on the prototype. With what we've set up here, we don't have an easy way of making that work. So this is where the constructor function enters. A constructor function is kind of a weird part of JavaScript, honestly. It's pretty different than most other programming languages I've worked with, but don't let that scare you. It's not too bad. If we go to MDN, there's a nice little explanation of this new operator, which we will use. But first, take a look at this code right here. We have a function. It's starting with a capital letter, which is just a style choice. But inside the function, there's never a return value. And we're referencing this directly in the function. We're not in an object like we had here, right? We created an object color and we referenced this inside that object on a method. Here it's just a function, this.make equals something, this.model. What is going on? Well, let's try it out. So on the docs, we had a function and it had a capital letter, which is really just a way of indicating that this isn't a regular function. It is a function that helps you create objects. It's a constructor function. Function color, we pass in R, G, and B. And then what they did on MDN was this.R equals R, this.G equals G, and this.B equals B. Okay, well, let's see what happens when I call color. I'm going to come over here, refresh my page. I'm going to execute color and pass in, I'll just do 255, 0, and 0. I didn't get anything back. It doesn't appear to be working. If I save that to a variable, I would just see undefined. What if we print out this, console.log this, and let's print it out at the end, after we've added those properties, R, G, and B. What do you think this is going to refer to? Ooh, it refers to the window. Why is that? Well, if you remember back in the Secret Life of Objects section, we talked about the keyword this and how it behaves. In the scope of this function, it's not inside of any other object. This is going to refer to the global scope, the nearest object, which is the window object. So then why on earth would the docs talk about making a function like this and referring to this in your function, not returning anything? Well, the secret is this new operator. When we call this function, but we call it with new before the function call, it behaves differently. These are the steps. I guess I'll just copy these over and show them to you here. When we call this color function with new color, and then we pass in values, 255, 40, and 100, just like that, it's going to create a blank plain JavaScript object, okay? It sets the constructor of this object to another object, we'll come back to that, passes the newly created object from step 1 as the this in this context. So it's going to make us a new object, and it will set this to that new object. So we'll be adding R, G, and B to that new object. Then it returns this at the end. So it's kind of doing what we saw earlier. Const, let's just call it O equals an object, and then this would be referring to this object, and then it adds these properties to that object. And then at the end, it would return O, but it's doing it all implicitly behind the scenes for us. This behaves differently here than it normally does, as we saw. If we don't use a new keyword, this refers to the window object. But when we use new, it's just how JavaScript works. It's the magic of this operator. It will be used to create a new object for you based off of this pattern. So why don't we try it now? I'm going to copy this over, go back to my code, refresh. If we just call color like that, not good. If we call it with new, all right, take a look at this. We get an object, and this object has properties on it that we assigned using this. I never told it to make an object explicitly. I never said return an object. It did that, and it did something else. If we look under proto here, it has a constructor property set to color. That was the second thing. Links, or it sets the constructor of the object to another object using whatever we named this function. So it sets the constructor to this color function. What this allows us to do is now we can add methods not to the individual objects, not to the instances, but to the prototype. So if I copied what we did earlier, like this RGB method, and I put it in here, I'll have to uncomment some of this and fix it up. we would have something like this.rgb equals that function. And we can access this. It should work fine. This is not new. This is kind of what we saw earlier. Let's see what happens when I call new color again. Inside of color, it still has RGB defined on the individual object. It's not defined on the prototype. But we have a workaround. Rather than doing this, we would define that method on the prototype outside of this constructor function. It's kind of odd, but that's how it works. We call color.prototype.rgb equals this function. So it's a little clunkier, but we saw this syntax already. We saw how we could change array.prototype.pop and overwrite it to be some other function that did nothing. Same idea. So we have now made this constructor function for color. Anytime we call it with the new keyword, it makes us a new object. It sets the constructor to color of that object. And then it sets the value of this to that new empty object. We can add properties to it. It returns that object. So if I call, new color 40, 50, 60, I save that to a variable, const color1. I now have an object here that has RG and B. But not only that, if we take a look at color1, it does not have that method RGB defined on itself, on the actual object. It's defined on the prototype. So I can still call color1.rgb, which is the very important part. If we couldn't, then it wouldn't be worth doing. But I don't have a unique copy of it here. I can still access it from the prototype object, just like with an array or a string. So this is now better or more efficient than our factory approach, where we returned a new object every time it was called, and on that object we added in individual methods that were unique each time. Now I could have two colors, color 1 and color 2. They could be totally different. This one could be 0, 0, 0, 0. And why don't I add in a second method? We'll do color.prototype.hex equals function. And I'll just copy the code from right here. Have to tweak it a bit. Don't need that. Don't need that. Uncomment you. Save. And everything else should work. We still have access to this inside of these functions. This will be set to whatever is on the left side of that dot. So color1.hex. Color1 will be the value of this. If I do color2 will be the value of this, even though the function is defined as a method on the prototype. So let's verify that color1.hex is the same as color2.hex because they are on the shared prototype object rather than uniquely defined on each instance. So we've defined a recipe for a color. We've said every color will have this one prototype that has RGB and hex, and we need one copy and one copy only of those methods. Let's test it out. So we have color1. I can still call .hex. Color2.hex. I get different results because the value of this is different inside those methods. But then if I call color1.hex triple equals color2.hex, hallelujah, it's true. They're pointing to the same thing. And we can verify that also. You just open up this object here in the DevTools. We don't see hex and RGB defined here. They're defined on the prototype. So a key distinction from what we saw earlier. All right, so why don't we end by adding one more method in. This method will be RGBA, which I could call by color1.rgba, and I can pass in a number from 0 to 1, like 0.5. And this should give me an RGB color, or an RGBA color, which follows the same pattern here, but it has a fourth channel, A, alpha, which is in charge of opacity. So I would define color.prototype.rgba equals function. And while I'm doing this, an important thing to note, you don't want to use arrow functions for this. Remember that they behave differently with the keyword this, so you can run into trouble. So use traditional standard function expressions like I'm doing here. So we could duplicate this line to get RG and B. We also want the parameter for the alpha channel. And why don't we give it a default of 1? If it's not passed in, we'll just do a full regular color. It won't have any translucence. Alpha will be 1.0. Then we have to return our string template literal, and it should be RGBA. And then we interpolate R, we interpolate G, we interpolate B, forgot the $sign, and then finally we interpolate A. And we also need the closing paren. So let's test it out here. We've got color 1. Let's see what color 1 looks like. I don't even know. Color1.rgb gives us this color. Is it at all interesting? I'm just going to paste it in here. Yeah, it's pretty ugly. Why don't we change that to be much, how about much greener? We'll try again. Color1.rgb gives us this. Let's take a look. Okay, very bright green. Now, if I want to use that somewhere, let's just do document.body.style.background color equals, and I'll use color1.rgb. There we go, pretty green. Now let's try our RGBA method. It has a default parameter, so it should be the exact same color. But now if I pass in a number like 0.8, oh, it's getting more translucent. Go down to 0.4, 0.2, 0.1. There we go. So we've made this one method defined on the color prototype, and it works across any instances of color. Anytime we ran new color, that's the main takeaway here. The new keyword does these mysterious operations. It's very confusing when you're starting out, because if you look at this function on its own, it seems like it shouldn't really do anything. It doesn't ever make an object. It doesn't ever return anything. But you put that new keyword in front when you execute the function, and it changes how it behaves entirely. And then we saw that we can add methods to the color prototype so that they are only defined one time, rather than on each individual color like we had up here. So as you can see, the syntax is kind of annoying, and it leads to these long files where things aren't really grouped together, right? We have our color definition here, but then all of the methods are defined separately. This is why the class keyword in the new class syntax was introduced, which is what we'll see right after this. Another way of achieving the exact same outcome, but a prettier syntax. All right, so next up, we're going to see an even better way of replicating the exact same functionality, creating a template for a color, in our case, where we have different properties like R, G, and B that are numbers in this case, and then we also add methods that are on the color prototype. So there's only one copy of them across all instances of that color. And this better option is the new class syntax. So it is just syntactic sugar for exactly what we've been doing. Syntactic sugar, remember, is just like a cleaner, cuter way of writing something that behind the scenes is going to turn into what we already have here. So you still have to understand prototypes and the keyword this, but I'm going to show you how we could rewrite this as a single class. And the main benefit, in my opinion, is that we don't have to add methods to the prototype manually like we have here. We don't have to break up the constructor function and then separately add methods. I hate doing that because you end up with this nice little compact function that explains the properties of your object, and then you realize, oh wait, no, there's all these other properties. They're on the prototype, so they're defined separately and individually like this. It just is kind of clunky. So let's see the alternative. I'll comment this out, and you'll have to hang in there with a bit of this syntax up front. So we have a keyword called class, and then I can give my class a name. And typically we use an uppercase letter to indicate that it is a class or a constructor function. It is a pattern for some sort of object. Just like we have XML HTTP request where the X is uppercased. Normally in JavaScript for a function name, document.querySelector, we don't capitalize the Q, but we do when we are creating classes or constructor functions. So this gives us a class. Next, probably the most confusing part for beginners, we always add in a constructor. Now a constructor is a function that will execute immediately whenever a new color is created. So it's kind of like this constructor function here. So we would add in 3 arguments, And if I called this console.log R, G, and B, and maybe also console.log inside constructor, like that. If I create a new color, we have to use the same syntax we've already seen, new color, save it to a variable, const, what should we call it? C1, very boring. Pass in some numbers, 2, 5, 5, 6, 7, 8, 9. Okay? And if I try running this in my browser, refresh, you can see my inside constructor console.log ran immediately, and I have R, G, and B printed out. So those arguments are passed through. So I never said run the constructor. I never called .constructor or anything like that. It automatically runs as long as it's named constructor. So that is a must-have whenever you define a class. You have to have the class keyword. You need to have the constructor, which will run immediately whenever we instantiate a new instance of color or whatever the class is. XML HTTP request or the dog class or the alert class or button class. You have to call it with new, and you need to have a constructor there. So usually in the constructor, we're going to access this. This.a or this.r equals r, this.b equals b, and this.g equals g. So these are going to be added as properties on this color object that we get returned. Just like we had this here in our constructor function. Same idea. This will automatically refer to a new object. So when we call new color, it still follows those same steps, even though it's in a class. It's going to make a new empty object, and it sets the value of this to that object. So this.r will be whatever is passed in as r. This.b will be whatever is passed into b, and this.g, the order doesn't matter, but it's driving me crazy to have b before g, so I would probably change that up, but it won't change anything. Let's also add in a name for the color. We can do that last, maybe. This.name equals, and then this could be a name to describe the color. So this.name equals whatever name was passed in. And you can change these. They don't have to match, right? We could have name and name it as color name instead. But this is the property we are adding to the object. And typically we use the exact same name. Very common to see that. Okay, so as far as a name for this color, what even is this color? Let's just take a look. Using VS Code here, let's just put RGB in front of that. Okay, it's a reddish color. We'll call that tomato. So we'll pass that in, tomato as a string. Like that. Okay, so let's look at this C1. When I run the code, C1 is an object. It has a B, a G, a name, and an R. They were all set in this constructor. So I never made an empty object myself, just like I never did it here. The new keyword takes care of that. All I did was say, on this new object that will be created for me, even though I am not ever seeing it, and it magically is stored in the value of this, add an R property, set it to this argument, or this parameter R. Same for G, B, and name. All right, now let's look at the proto for this color. This object, you can see the constructor is set to color. All right, so we didn't do that either, but by using new, it all takes care of it. Now what about methods? This is the real advantage in my opinion. We don't have to do color.prototype.whatever like we did up here. We could do something trivial like, how about greets? I don't know why a color would have greets. The easiest way to do this is with this adorable syntax that we can use inside of classes. We can actually use this inside of objects in general. We talked about it in our objects, what do we call it? Secret Life of Objects section. It's a new shorthand syntax for defining a method. In here I can just return hello from a color. And actually, why don't we include the color name? From, I'll need to make this a template literal, backticks, this dot name. And then we'll add an exclamation point at the end. So this is now a method on every color, but not on the instances. This is the nice part. It's just like we had done this here, color.prototype.greet equals some function. But we don't have to type prototype. We don't have to type color. We just put it inside this class. So we can group everything together, which makes things much easier. So let's try it. We have this color 1. Let's open it up. It does not have greet showing here. Instead, greet is on the prototype. There's only one copy of greet. c1.greet. Let's execute it. Hello from tomato. Let's make a different color. New color. Let's do 255, 255, 255. And I think that's white. Save that to a variable, const white, sure. And call white.greet. Hello from white. All right. So let's actually add in some methods that we would want, like an RGB method. We can copy the logic from what we did earlier. We'll just return this string, but we need to make sure we get R, G, and B. And we have access to those just like we did here by using the keyword this. So this, anytime we're inside of a class, this refers to the instance of the class, the individual color object. So not the prototype or anything, not the function, not the window, unless you're not using the new keyword, that is. But if you use the new keyword, this will refer to the individual object. And then whenever we have an object, a color, like white.greet, white is a color object. When we greet, the keyword this was used instead of greet. I got rid of it, but we had this.name. This referred to the individual object, the instance. So we can destructure. We could do this.r, this.g, this.b, or just destructure r, g, and b from this. Now, if I call it, we have c1. c1.rgb gives me this nice RGB string. Take a look, and we get that reddish tomatoey color. Let's add another method in. Let's go with this hex method. So I'm just going to copy the logic and add hex. And that relies on R, G, and B, which we already have on the object. So I'm going to destructure again. Let's try that one out. c1.hex. And did we have another color? White. I think I defined that and refreshed the page. So let's define another color over here. Let's call this one red. And then another one, which will be white. And just have 255, 255, 255. Now, I need to save that to a different variable, white. Okay. So if we check here, white.hex, we get FFFFFFF, that's accurate. I do know that one hex color. And then if we do red.hex, we get a different outcome. And if we compare them, red.hex, not execute them, but compare the references, triple equals white.hex, they are the same function because they're on the prototype. They are not in the individual instance, they're over here. And let's add in our RGBA as well. Let's see, this was RGBA. We'll copy this logic, but I think I'm going to refactor this. If we look at RGBA, it accepts a parameter called alpha. We set it to be 1.0 as a default value. It returns something very similar to RGB. This right here is the same thing. We just have A added after the fact in RGBA, and we have RGBA at the start and RGB at the start of RGB. So we could make a separate function, maybe call it inner RGB, like that. And all that I'll do there, nice and easy, is return this part of the string. So I'm just going to copy the whole thing over. You'll see what I'm going for. I'm just going to return this string, no parens, just a comma separated list. So it would look like 255, 255, 255. So if I called this from within another method, I could easily do RGB and put parens around that. Or I could add in another number and do RGBA around that. So I just made a method that is going to help me out. It's called inner RGB. And now we get the opportunity to talk about how we would call one of these methods from within another instance method, another method on this class. To do that, we just reference this, same thing. So we could call this dot inner RGB. That should give us a string that will go on the inside of our RGB right here. And I need to escape that with my $, curly braces. Let's make sure that works for RGB. Refresh the page, white.rgb. That looks good. We can verify if we paste that down here, it is white, at least according to VS Code. Now we can rewrite RGBA to do the same thing. So I can get rid of that and replace it with this dot inner RGB and execute it. It is a function. And then we add RGBA open paren and then closing paren at the end, as well as comma the alpha value. So very similar, because we're using the same function on the inside, it just gives us a good opportunity to call a function from within, or a method to be more accurate, from within another method on the class. So does white.rgba work? It's going to be quite boring. Not as exciting as, let's do red.rgba. There we go. And if we try 0.4, we get a more transparent color. We could do the same thing, document.body.style.background color equals red.rgba. This is the full strength of that red color, and this is half strength. This is a tenth of the strength. Cool. So we've added a couple methods, and we've covered most of the basics of classes so far. You define a class with the class keyword. You usually capitalize that name. You should always capitalize it, although you don't have to, you should. And then inside of those curly braces, the first thing we need to add is a constructor. This function will run automatically whenever you instantiate a new instance of the class, so we don't call it manually. Inside of that constructor and inside of the entire class, if we're in a method, like I have here, constructor, or down here, the keyword this will refer to the individual object. So this.r, this.g, this.b, I'm assigning properties to each color. Not to the prototype, but to the color. Then these methods I've added, they are added to the prototype automatically. So I don't have to do any of this color.prototype.blah blah blah. I can keep everything together inside this class. I don't have to have the separate constructor function, then later add my methods. I can put it all in one happy family and define my class, define my pattern for every color. Every color has an R, G, and B and a name, and every color has these 4 methods, but they're located on the prototype. They look up to that one prototype template object. Okay, so we're going to continue to add on to our class in the next video. Next up, we'll continue to add on to our color class so we can get more practice adding methods. So I have a very long, complicated function I found online. I did not write this. This function converts a RGB color into a HSL color. HSL is a very interesting color system. It stands for hue, saturation, and lightness. And it looks like this, HSL. And then we have a hue at the beginning from 0 to 360, like a degree around the color wheel. So let's do 130. Then we have saturation, which is a percentage. Let's go with 50%. And then we have lightness, which is also a percentage from 0 to 100, 80%. So that is the resulting color, apparently. If I change lightness to be 100%, it's extremely light. If I go to 20%, it's a darker green. Let's go to 40. If I change saturation to 100%, it's very saturated. If I go down to 10%, it is not at all saturated. Let's go around 80. And then hue is interesting because I can completely change the value of that color, the hue of the color, by just affecting one value. So I can do, 0 will give me red, apparently. If I do 80, 90, 100, 200, 300, I'm making my way around the wheel all the way to 360 where I'm back to red. So I can change the color very easily. I could make a more saturated color by impacting the second value, the saturation. I could make a different value entirely. I could go from red to the polar opposite by adding 180. So if 30 is the hue, I add 180. What is 180 plus 30? 210, which gives me this blue. And I can easily lighten something. Well, 100% it will be white, but I could do 90% to get a very light blue, or I could darken it to a very dark blue. So let's make a function. I already have the logic, but let's use it to create HSL values, and let's actually store HS and L on our class instances, because we could reuse them for different functions. If I want to make a lighten function or a darker or a full saturation or something like that, I want to use those HS and L values. All right, so here's the function. It's called calc HSL. It expects 3 arguments, and at the end, we have 3 variables. They're not being returned, but we could return H, S, and L as an array maybe. We could make a string. This has nothing to do with a class at the moment. I'm going to move this into my class. I'll put it down at the bottom because it's so long and ugly. And I don't want to pass in RG and B. I have access to them on this. So my constructor runs, right? RG and B are set based off of whatever I passed in. If I ever call calc HSL, RG and B will be on this. Then what I'm going to do is actually assign HS and L to the object, to the instance. I'll do this.h equals h. H is calculated up here. S is calculated in the same function. Again, the logic does not matter. I have not even glanced at it. I just took it from a website. Where did I find this? I think on Stack Overflow. But it does work. Who knows how elegant it is, but it works. So now HS and L exist on the individual instances as long as I call calc HSL. So let's try it. Why don't we go with a white one, because white is probably easiest for us to tell if it's working. So I'm going to refresh this and call white.calc HSL. And if I just look at white to begin with, it only has 4 properties, RGB and name. If I call white.calc HSL, assignment to constant, my bad. I think I can't use const here because the way the function is written, it is updating, as you can see here, divide equals / equals. So I'll use let. And now we should be good to go. All right, so we don't return anything, but if we look at white, it now has H, S, and L. And lightness is set to 100, which makes sense. As we experimented with a couple minutes ago, lightness of 100 gives us white. So now let's make a function called HSL that will actually display the HSL correct format string. And to start, before I get there, I'm going to show you that we can call a function from within the constructor. We can call one of these methods like this.calc HSL. We'll just call it immediately. After we assign RGB and name, we'll call that function automatically. Whenever you make a new color, we'll calculate the HSL based off of the RGB that was passed in that we then added to the object. This is called, it looks up RG and B from the instance of the actual class, the instance that was just created, and then it adds on, it tags its own new properties onto that instance. So let's make our function called just HSL, and it will extract the structure HS and L from this. And then we can return our template literal, which is going to be HSL. We need parentheses. Then we have the hue, which is not a percentage. It goes from 0 to 360. Then we have saturation, which is a percentage. So we need to add the percent. Then we have lightness, which is also a percentage. Let's see if that works. Refresh over here. We have our color white. It was created and now it automatically has H, S, and L properties. And I should be able to call white.hsl and get a string. Let's verify on a different color. We have red. Let's verify that it works. Document.body.style.background color again equals red.hsl. And it works. Okay. So now we could have a little bit of fun and define some other methods, like one that I'll show you we'll call opposite, which will take H and generate an opposite color. Remember, it's a color wheel from 0 to 360. So I'll just add a method called opposite, and we can start by just duplicating this. We're going to want to use H, but we're also going to want it to make a new H, new hue, equals. And what we'll do is add 180. So if we had, 60 before, we add 180. If we had 0 before, we add 180. It's 180 degrees, the other side directly across that circle, the color wheel. But if we're above 180, then if we add another 180, like if we're at 200 and you add 180, we're suddenly at 380. So what we can then do is modulo by 360, which will take us back to 20. If you're lost on the logic, don't worry too much. It's not that important, but we can do h plus 180 modulo 360 to keep us on that 360-degree wheel. If we go too far, we just start back at 0. All right? So then here, we would put new hue instead of the existing hue, H. Let's try it out. So I'm going to refresh. I'll run the same code, red.hsl. Did I lose the line? Here we go. To update the body. Now let's do red.opposite, which gives us that color. They are opposite on the color wheel, at least as far as the hue. The saturation and lightness are still the same. Let's do one last one. Let's make one called full saturation. And it's just going to have the existing hue, the existing lightness, but set saturation to 100. Full saturation, or fully saturated. All we need are H and L. We don't care about saturation because we're always going to return saturation set to 100%. Let's see if that one works. So we'll set the background color to red.hsl, and then we'll update it to fully saturated. And was it already at 100? Well, that's disappointing. It was already 100 saturation. Let's try another example. Here's a different color. I'm giving it a name, which I have been leaving off for the record, which is actually not the best idea. So I should either add a default name, which I can do, just like any other default parameter, or I should just pass in a name, like I did here. Even though we're not using it anywhere, it's just good to have on there. We don't want to have just undefineds all over the place. So let's save that to a variable, const orange, and then we'll do the same thing where we change the background color, but we'll change it to orange dot HSL or RGB. It doesn't matter. We should get the same thing. Okay, it's not 100. Now let's do full saturated or fully saturated. I don't know if you could see that, but it did change. If you go back to RGB or hex or any of these other ones, it's slightly duller. Now fully saturated. And how about opposite? So it'll be our last one. Hey, nice, beautiful blue. Okay, so this is our color class. A lot of the logic to calculate the HSL, to convert from RGB to hex, really doesn't matter. Don't focus on that. Focus on the interplay of the keyword this, the idea of the constructor, adding in values to this, to the individual instance as properties, calling methods on this, which allows us to access other methods in the same class, and then using the new keyword to instantiate new colors. All right, we've made it. We have one last important topic around classes in JavaScript. It is the keyword extend, along with a keyword called super. They both have to do with subclassing, essentially inheritance. This is a way of sharing functionality between classes. So typically I would want to show something more realistic, kind of what we did here. This is nothing crazy, but I mean, I've used plenty of libraries that are color libraries. They exist just to do this. Some of them are more fully featured, but this is not totally unrealistic. It's not the typical intro to classes idea of dog and cat or bank account or deck of cards. It's something slightly better. But for this video on inheritance and extends and subclassing and super, I'm going to dial it down. We're going to go back to the basics, the most cliche possible classes. Let's define a class called cat. I know. And we'll pass in a name and an age. How about that? All right, and then we'll set this.name to be name, and then this.age to be age. So the reason I'm going simple is so we can focus on the concepts and not get too bogged down in the actual logic of things. The logic here will be incredibly simple. So a cat class, and we'll have a simple method called eat. And in here, we will return the string. Let's do this.name is eating. Okay? So I can make a new class or a new cat, save it to a variable, const Monty equals new cat Monty, who is technically dead, but I'll say 9. Let's look at Monty. It has name of Monty, age of 9, and I call Monty.eat. Monty is eating. All right, so now let's say I have another class. This class is called dog. Dog is very similar. Surprise, surprise. It's almost like I planned it that way. Oh, that was stupid. I don't know why I said that. I'm sorry. So a dog also has a name and an age. We set this.name to be name, this.age to be age. It also has an eat method. Let's just copy that over. Okay, let's make a dog. So I'll call new dog. I'll pass in Wyatt, const Wyatt equals new dog and an age. He's also dead. Yikes. We look at Wyatt. It's an object, has a name and an age, and it has a eat method. They're basically the same thing, just different names. But we could go ahead and add some method to cat that doesn't exist on dog, like meow. And then it could just return meow. And we could do the same thing for dog. We could have a method called bark, which returns woof. Okay, so now they're slightly different, but there is a lot of duplicated functionality. So one of the options we have in JavaScript is to move this duplicated code from here and from cat and from dog into a separate standalone class that both of these classes could extend. So you can think of it as kind of like a parent-child relationship. We could have a parent class. I'd call it probably animal or pet. Let's do pet. Class pet. And let's just copy this entire thing here like that and remove all of that from cat, all of that from dog. So right now, I'm not going to be able to make a new cat. I won't be able to make a new dog. I can make a new pet. But if I try and rerun this code and make a new dog, let's look at what Wyatt is. An empty object. There's no constructor. No constructor on dog and no constructor on cat. So here is how we can tell cat and dog to include the functionality of pet, to extend pet. It's as simple as saying class cat extends pet. I'll do the same thing for dog. Class dog extends pet. So now does it work? Well, let's see what happens when I make a new cat or a new dog. All right, I just made a new dog. Look at that. Age and name were already filled out. But I don't have a constructor in dog. It doesn't matter. Because I extended from pet, it's going to use that constructor if it doesn't find one on my dog or on this dog class, which it didn't. So it looked to the constructor from pet. So we end up with age and name, and take a look, we also have bark. Bark, which was defined on dog. And even more exciting, we have access to eat, which is not defined on dog at all. So we don't see it here, right? We don't see eat there. I don't see eat here. But if I look at this proto here and proto again, there we go. So we have dog. This is a functionality from dog, which is just bark. Then we have the functionality from pet, which is eat. So I can call Wyatt.eat, even though I never defined eat on the dog class. We are extending the functionality from pet, both on cat and dog. So I could do it again with a cat. Let's just make that Monty. Where are you? Here we go. We have Monty.eat, not defined on cat. Monty.meow is defined on cat. That's the basics. A couple of other things that are important to note. If I had another method on, let's say on dog, also called eat, and this one returned, I need to use a string template literal, something else like this.name scarfs his food, like that. And now I make a dog. If we call Wyatt.eat, which version of eat does it call? It calls the dog version. So if it doesn't find eat on dog, on the dog prototype, it will look up on the pet prototype where it does find it. And if it didn't find it there, it would look on the object prototype. If it didn't find it there, it's going to be unhappy, and it will let you know. So I'll leave that there so you can see how it works. The other important keyword here that we haven't talked about yet is called super. So sometimes you want to rely on the exact same constructor from your super class, from pet in this case. Cat extends pet. We don't have a constructor. But if I wanted to have some additional information for cat, like, I don't know, what else could we pass in? Let's say you pass in a name, an age, and we want to pass in, how about lives left, which will default to 9. Very good. It's a cat. 9 lives. Okay. In here, I could manually set this.name equals name, this.age equals age, but I'm already doing that here. So really all I want to do is set this.lives left equals lives left. And if I don't want to duplicate that, I can use the super keyword. Super is going to reference the class that we are extending from. So if I call super inside of here, and I pass in name and age, it's going to call this constructor. So we can see this in action. Let's console.log in cat constructor, and then duplicate this up here in pet constructor. And let's see what happens. We'll make a new cat. I'll pass in a number of lives. Actually, I won't. It will default to 9. Take a look in cat constructor, in pet constructor. If we look at Monty, Monty has a name, Monty, an age 9, and lives left was set to 9. So we reused the functionality from this constructor, but we added on our own for cat. So very important, super is going to be a reference to the super class. It can be confusing, definitely trips people up, but it's a reference to what we're extending from, which is pet. So we could do it, we could use it instead of dog, but just to save you time and not bore you to death, we'll keep it simple here. So this is a common pattern. You have some base class, you have other classes that extend from it, and in this case of dog, we didn't add any new properties in. It's the exact same constructor as pet, and that's fine. It will call that constructor automatically if we don't define our own. But in the case of cat, which is common when we're building more realistic things, we have other data, just a simple lives left, which we want to add on to this. So we call super, we can take advantage of this constructor and then add on lives left as well. And that's the basics of inheritance. I mean, you can continue to go multiple levels. We could have pet extend from animal. We could have animal extend from living thing. There's so many different things we could do. And you'll see this with things like HTML element in the DOM. That extends from like 5 or 6 different classes. But remember, when you extend something and when you define a class, it's all just setting up these constructor functions and calling it with new and adding methods to the prototype. So this is all just nice syntactic sugar. Okay. Hey, what's going on, everyone? Well, I guess you can't really respond. Well, you could. I can't hear you. But I hope you are doing great because this is a pivotal moment. We are not talking about JavaScript in this section. That doesn't mean we're done with JavaScript, not by any stretch, but we are moving away from it for a moment because this section marks our first section on back-end content. We are now going to transition to talk about, or to begin to talk about Node and Express and databases, authentication, all these topics that take place server side. So we've got a lot of conceptual content to talk about, an overview of how everything fits together. Basically, this is a big shift. That's all I'll say. But we're not leaving everything behind, right? Just like we didn't ignore HTML and CSS forever. We learned HTML, CSS, we put it away for a bit, went to JavaScript, and then brought them back together, happy as can be, one big family. Pretty similar idea here. We're going to talk about terminal in this video. No JavaScript, no HTML, no CSS. We need to get set up with the terminal. We need to understand why, what's the point. We need to talk about common frustrations, and then important terminal commands, Unix shell commands. So yeah, I'm not going to go into detail about any of that right now because that's the whole point of this section. But I do just want to start by saying this is a relatively easy section in terms of the amount of content. I'm going to show you a couple of commands, and they're pretty straightforward. What's hard are really two things. One is installation, and that's going to be very important. installing the tools, getting a terminal up and running, depending on the platform you're on, can be a bit of a headache. But that's why, we're here. We have teaching assistants. We have videos and tutorials to try and explain installation. And as a last-ditch effort, if things go totally south, there are online resources, online terminals that you can use that don't require you to install anything. So that's probably the only big issue in this section. The second thing, though, that is worth considering is remembering all the commands. So this whole chunk of commands here, ls, pwd, cd, make dir, touch, rm, rmdir, we don't know anything about them at this point, but they are different commands, and it can be overwhelming trying to recall them all or stuff them all in your brain. It is important to remember them, but it's not important to just sit there and memorize. Make a cheat sheet if you want. I've seen students write them on a post-it note, put it on their laptop or on their monitor as a reminder, but don't panic about the actual command. So I'm going to say it's important, but you'll learn them in time. Now, the actual commands themselves are crucial. ls, pwd, cd, these are all things, commands that you can execute in a Unix shell. You'll understand what they do and why we use them. All I'll say for now is that they're all important to understand. You don't need to, be an expert in using them. You don't need to be able to type whatever it is, 10,000 words per minute in your terminal. You just need to be able to understand the point of each command. And then lastly, relative versus absolute paths, just a conceptual topic, also crucial. So this is a very different section from pretty much anything we've done so far. And if you find it not to your liking, don't fret. This is really the only section we have on pure terminal stuff. We're not going to really write any code here. It's just about using a tool on your computer. But then we will use these terminal commands from here on out. When we're creating node apps and starting up a server and interacting with the database, we need to understand all of this. And I'm going to make a better case for why you should care in the next couple videos. So I'm going to shut up, go away, have a great time. I'll see you on the other side. So this section marks the first of many upcoming sections that is focused primarily on back-end development. We spent a lot of time on HTML, CSS, and JavaScript, and they're not going anywhere. But we are now going to focus on creating servers and connecting to databases and really completing this picture. Remember, if you do recall, from the very beginning of this course, I talked about how we send a request somewhere. Let's say I search for silky chickens. Once again, never shut up about chickens. On Google, I'm searching for that. That fires off a request from my browser to Google's servers. And then Google's server builds me a response. It sends it back in the format of HTML, CSS, and JavaScript that my browser can then display. But remember, it's more complicated than simply having a response ready to go to send back to me. Think of how many things you could search for on Google and how many different results there are. There's so much work that goes into building that web page. So far, all the web pages we've made, all the HTML, CSS, and JavaScript, they are static websites, meaning they're always the same when you open it up. It's the same file, the same contents, the same scripts. Yes, you might get some randomness in there. You might get some, API data, but for the most part, they're exactly the same. We double click on them, you open it in the browser, and you see what you see. But now we're going to focus on creating dynamic pages that are actually web pages made by code. So just like with Google, if you search for something like silky chickens or what to do when a rooster won't stop mounting one chicken and she's traumatized, if you search for things like that, Google server is going to then figure out what results there are. It will rank the results. It will build the web page, send back the HTML, CSS, and JavaScript. Then your browser displays that. So we're going to be focusing on the right side of this equation for a solid chunk of time. A lot of the remaining course is focused on working with Node and databases and building a server. By the end, we'll be making full-blown applications that are completely dynamic. Every page in this app that we build is constructed when it's requested. So right now I'm looking at search results I'm looking for a particular campground in Stinson Beach, just a little beach town in the Bay Area. But if I go back, I can also look at all campgrounds. It's the same page, the same sort of format. It's just different data that's in here. It's dynamic. Similarly, if we take a look at one of those campgrounds, also you can see we've got fancy JavaScript and a whole bunch of stuff going on. But if I take a look at one of these campgrounds, go back to that same one, And you can see that this campground, I'm looking at it in detail now, was created by me, by somebody with the name of Colt Steele. It has a rating of 4 stars. Or here's another very simple example. Currently, I'm not logged in, so I see log in and register. But if I now try and log in, I have a very fake account, Colt and Colt. If I log in, what do I see? Just log out. I don't see those other 2 buttons. Anyway, some very, very simple examples here just to illustrate kind of what I'm referring to. We're going to learn how to build dynamic responses. We will learn how to build this part of the equation, a server that is able to take some incoming request, figure out what someone's asking for, and then build a web page and respond back. So that is a pretty big task, and it involves a lot of different tools and technologies. So not to scare you in any way, we've just got to start small. And before we can even start building servers, we've got to talk about the terminal. So that's what we're doing in this section. All right, so before we can get to topics like Express and Node and databases, we do have to talk about using the terminal and terminal commands. Now, there are reasons for this, right? I'm not just introducing this kind of archaic, frustrating topic for no reason. I have to cover it in order for us to cover those other more exciting topics. And I'll go into those reasons in just a bit in this video. So when I say terminal, we'll also talk about terminology in this video, but when I say terminal, I'm referring to some text-based prompt where I can interact with my machine through text. It doesn't have to be black and white like this. We can change those colors, but the point is that it's a text interface. You've probably seen them before if you've watched any developer tutorials, or if you have ever seen a hacking scene depicted in a movie or a TV show. There's always just some crazy hacker typing a bunch of text in a terminal. So we do have to cover this, as I've mentioned. And before we get started, I just want to give you a bit of a pep talk about it. When I teach it in person, I see a lot of students who get frustrated with it because it will be slower for you at first. We are going to see how to do things that you already can do, right? I can make a folder. I'll do it right now in VS Code. I will make a new folder. So I'll make this folder. I'm going to call it, I'll put it in terminal demo, and I'm going to call it, what should I call it here? I don't know. How about project 1? Okay. And then I'm going to make 3 files. So Command N, I'm going to save this file, app.js in project 1. I'm going to do it again, app.css. And one more time, I'm going to save that as index.html. All right, so we know how to do that, right? This is something we've probably done a bunch of times in the course already, making files of different types, putting them in a new folder. That's common stuff, right? Not even just as developers, but that's something we do all the time, whether it's Word documents or spreadsheets or photos or something else. We make and save files a lot. I just use the graphical user interface with my mouse and buttons and, stuff to look at that I can interact with that isn't just text. But I can do the exact same thing over here in just a couple of lines, and it can be quick. So there's our project 1 folder. You'll learn all of these commands in the next few videos, but I can do things like make a new directory, and then inside of this directory, in a single line, I can make multiple files at once. So app.css, app.js, index.html, all of them are right there. I just made 3 files in, I don't know, a third of the time, a quarter of the time, maybe less, that it took me to make those same files over here. So I do see students get frustrated, though, because it takes time to remember these commands. It is one of the few things where you really do need to memorize the basics, and you'll just get practice. You'll figure it out over time, but it's going to be slower at the beginning, and you're going to have to force yourself to stick with it. Otherwise, it's just a painful experience, and you're not going to, you won't enjoy it, but you're also not going to get anything out of it. So please keep that in mind. It takes practice and time, unlike a lot of the other stuff we've seen where I've said, it's totally fine to just, look it up whenever you need it. If you have to look up how to make a file or make a folder or delete something every time you do it, it's going to slow you down a lot. So practice, and it'll get better. All right, so that's a bit of a pep talk about terminal. In the next video, I guess, I'll go into why we need to know this. Okay, so now let's talk about why you should care about this and why we need to know how to use the terminal. There are some important reasons. The least important that I'll start with is speed. So developers use the terminal, a lot of them, for a very long time, and they get very comfortable and very fast with it. And honestly, it is faster if you know what you're doing and you have enough practice and you remember the right commands typing something with a single line, you can accomplish, 5 or 6 different commands at once. Things that you would do normally with your mouse and clicking and dragging and who knows what else, you can do with just typing. So if you're quick enough, that can be very, very fast, and you can just become more efficient. Now, that's not going to be the case at the beginning, as I mentioned in the last video. It does take time and practice, so that is really not the primary reason. Honestly, if that was the only reason, I don't know if I would cover it in an intro to web development course. It's kind of a roadblock. Nobody likes learning this, or very few people do, and I've seen it turn away a lot of students, which I hate. But there are really important reasons, including this one here, what I'm calling access. So the terminal provides it's like an all-access pass to your computer, and it's different settings and different pieces of software and parts of the operating system that we can do a whole bunch of stuff with that normally is completely off limits. Now that can be a good thing, and also can be a bit of a scary thing if you just go copying and pasting commands that you find online. You could erase a lot of stuff you don't want to erase, or you could set some, you change some setting that you definitely don't want to change. So I don't recommend just going and copying and pasting a bunch of long commands that you find somewhere. But the point is that we do have this ability where we can affect things. We can make serious changes. We can change permissions. Like I said, we can modify settings that are normally off limits. We can view hidden files, things that just won't even show up to your average user if they're navigating using a graphical user interface or a GUI. So if you're using Finder on a Mac, or the File Explorer, whatever it's called on a Windows machine, where you just, you see the files and folders, you click, you double click, all of that stuff, you won't see hidden files by default. And there's a bunch of other examples. Now this matters for us because there are certain things we want to be able to do, like start up a server, stop processes. We need to be able to create hidden files and modify them and put certain settings in them. So these are all things that we need to be able to do to develop, to be a web developer. So it's important that we use the terminal for that because we don't really have a choice. And then the third reason is that a lot of the technologies, the tools we'll be using, things like Node and Express, once we get to databases, those are all based around the command line or the terminal. We'll talk about that terminology too in just a second. So we need to be able to open up a terminal, navigate. We need to be able to start a server. We need to be able to run Node. We need to be able to connect to a database and inspect things. That is all done through our terminal. So that's really the main reason. If you want to use Node to run a file, you need to know how to do that on the command line. There's not really another option. So those are the three main reasons. The command line or the terminal gives us potentially greater speed. It definitely gives us access and more power, and we have to use it because a lot of the tools we're going to use require the use of the terminal. Okay, so hopefully that explains why we're doing this. Now I just want to get some terminology out of the way. You'll hear things, and I've already mixed up some of these as I was talking. Terminal versus command line, console, I haven't said shell yet, or bash. These all are kind of around the same idea, but they're not the exact same thing. So I do want to clarify just quickly. The term terminal originally was a physical object, an actual terminal that was made to interact with a computer back when computers were a lot larger. And I mean, I don't know if this is when they took up rooms or not. I'm not super well versed on the history, but a terminal used to be a physical object, but we would interact with the keyboard and all of that. But these days it refers to software terminals. So the one I'm using on a Mac, it just comes built in on the Mac. It's called Terminal. It's free. You can install other terminals. There's one a lot of people like that I use sometimes, which is iTerm. Again, a different Mac application. There are different terminals. They're just virtual or software terminals for Windows and for other platforms or operating systems. So that application is what we would call a terminal. Then there's the shell or shells. And these are the programs or the software that run on the terminal. So originally, when a terminal was a piece of hardware, it was something you actually plugged into a computer. There's a more clear distinction where there's hardware, that's a terminal, and then the shell was software. It was a program running on that terminal machine. These days, it's a little harder to explain. So if we have an analogy like this, the terminal would be the actual ATM that you're looking at on the left, and then the shell would be the software running on the ATM to make it work, right? So there could be different, on one ATM, one actual machine, maybe one bank has its own software, its own shell for, Bank of America versus Bank of, Estonia. They're going to have different software on there. That's kind of a thin, bad analogy, but that's the general idea. So when I have this terminal, this is my application, it's called terminal, it actually has different shells that it can run. And I have to actually modify my slide here because it says Bash, one of the most popular shells, is the default on all Macs. That's actually not the case with the brand new, I don't know how new it is, I guess. For me, it's new. Catalina, I think, is the new update for the Mac operating system. So there are different shells out there. The most popular are called Bash and Z Shell. And the good news is all of the commands I'm going to show you are perfectly acceptable in either. And in fact, if I open up a terminal window here, which again, we're going to go into installation, we're going to talk about commands and all of that. But if I open one up top, you'll see that it says ZSH for me. That means I'm using Z Shell. That's the name of this shell. And I'll just show something very quickly. Here's a command. It's called pwd. It works in Z Shell. But if I want to switch, if I do want to use Bash, which is a completely different shell, I can type Bash, and it tells me right here my prompt has changes. Wow. My prompt has changed, and I can still use that same command, which again, we're going to learn. So I just want you to understand that yes, they are different shells. There are different reasons to use one versus the other. Z Shell is a newer shell. It has some new features that Bash does not have. Bash has been around for a very, very long time. But for whatever reason, Bash has been the standard on Macs, and it's been sort of the standard, I guess, everywhere until recently, where now the default shell is ZSH or Z Shell. Anyway, it really doesn't matter for our purposes. We're not going to spend hours and hours talking about the differences and different features. We're really just trying to get the bare bones that we need so that we can move on to things like Node. All right, so in the next video, I'll talk about installation, what you need to do. If you're on a Mac, you really don't need to do anything. If you're on a Windows machine, you have a little bit of work. So check out the next video, and then we'll meet up and talk about commands. So to recap, the terminology just at the end here, terminal is this piece of software, the actual application, and then I can swap different shells, which the two most popular are Bash and Z Shell. I can swap them within this one terminal app. And they do a lot of the same stuff. They overlap. If you think of a Venn diagram, there's a lot in that middle intersection area, but they do have some distinct features that we're really not going to go into. Okay, so yeah, I'll see you in the next video. Bye. Okay, so we're going to start by learning our first essential commands. And the first thing you have to understand is that what I'm looking at right here, it's just a new terminal window. I can actually close this one. I'll make a brand new one. Just make it a bit larger here so you can see it better. What you're looking at right now, it obviously is from my machine, so I see my username here. But you'll see something probably similar, maybe a different prompt, obviously different text, but it might not even be this format. You might not see exactly the same, % and the tilde, depending on what platform you're on. But you'll see something here. And in this window right now, I am in a current directory. I'm in a folder, just like I would be in a folder if I opened up a new Finder window on a Mac, where I can then navigate and click, and go into the, my code folder, which is all the code from this course so far. So I am in a current location in my terminal, and it just so happens that every time I make a new window, the location that I end up in by default is something called the home directory. Now, the home directory is just my user account directory. So my user on this machine is Colt Steele. I might have a different account. I might have 5 accounts on this machine. And they each will have their own home directory. So my home directory actually looks like this. It's where on a Mac at least, where applications and downloads and movies and, I made some folders here. And I can see the same stuff over here if I use our first command, which is called ls. ls stands for list. And anytime I type it in my terminal, it's going to list the current contents of the directory that I'm in at the moment. So I'm going to do it, ls, and I'm going to hit enter. And I see applications, pets, pictures, public, music, all that stuff that I saw over here. One thing that's mildly confusing, maybe more than mildly, is that on a Mac, our desktop folder is not actually appearing here, but the desktop is part of this home directory. As you can see right here, wait, where is it? There we go, desktop. Same thing with documents. I don't see documents over here. For whatever reason, the operating system just hides it from me. I think it's because they want you to use this sidebar, and because of iCloud, your documents and desktop are, synced with the cloud. I don't understand why, but anyway, our home directory, whatever your username is and whatever you have in there, it's the default location that your terminal will open in. So just one more time, I'll open a new one. I'm going to type ls. I see the same contents. So you may see different stuff in there. It depends on how you've, used your machine and what you've put in there over the years. But that is your home directory. And there's actually a shortcut way of referring to it. That's what this little tilde is here. Anytime that you type tilde, it's going to reference your home directory. It's a shortcut way of referencing it. So sometimes we might be nested in a whole bunch of directories, 5 or 6 levels down. And if I want to go home, we don't know how to go anywhere yet, but we can use that tilde character, okay? So ls right now doesn't seem that useful because we can't actually do anything as in terms of moving or changing where we are, but I can list the contents of this home directory. I also can use our next command, which is pwd, also not that exciting. It stands for print working directory, and it's just a quick way of orienting yourself. It's like a compass. It will tell you where you currently are. So if I type pwd, there we are, it tells me that I'm in my Colt Steel directory. That is my home directory for this one user. So again, there could be different users on this machine, but I'm logged in as Colt Steel on this Mac, and this is my home directory. So, in the past, I've had different machines where I have like a personal account, and then I usually call it like recording account or something, or teaching account. They each have their own home directory located inside of this users folder. We don't really have to care too much about users, but just know that there is stuff above us, above the home directory, but everything we're going to care about and all the folders and files we'll make will be somewhere in this home directory. Okay, so those are the first 2 commands we've learned. We're stuck in the same spot. We're not able to move. If I wanted to, navigate into one of these directories or navigate up into the users directory, I still don't know how to do that. That's coming up in the next video. But as we've seen, when you open up a new window, it defaults to your home directory. You can get there using Finder or whatever your file viewer is with a GUI, a graphical user interface. Basically, what I see here right now with my eyes, I don't have to do anything to get it to display. I can see the contents. Over here, I do have to type ls in order to see those contents. List, and then if I want to know where I am specifically, pwd. And that's the full path to where I currently am. And again, I haven't changed that. It's just the default for this machine. That's my home directory. All right, next up, we'll learn how to navigate. Okay, so we've talked about ls and pwd, which basically give us information about where we currently are, but we're stuck in that one spot, the default folder, which is the home directory. So next, we need to talk about how we change directories. How do we move forwards, or I guess forwards is the wrong terminology, but how do we move into a folder or back out of a folder? Basically what I would do here, if I wanted to look at my code directory, I would double click. And then if I want to look at the intermediate HTML code, I double click again. And then to go back, I can click the back button, right? So how do I do that with the terminal where I'm moving around, I'm navigating? Well, there's a command called change directory, cd. So cd is versatile. We use it to move forward and backwards. All that you need to do is type cd and then some directory that we want to change directories into. So for example, here I'm in my home directory. If I type ls, I can see, all right, here's my code directory. I'm going to change directories into code. Also, we do have autocomplete, so I could just type capital C-O or C tab, hit enter. Now you'll see that my prompt does change. It says that I'm in code instead of just that tilde. Remember, the tilde is a short way of saying you're in the home directory. So if you see that, it means home, but now I'm not in home anymore. I'm in the code directory. And if I do pwd, we see that the full path is /users/coldsteel/code. So if I type ls, now I see a bunch of folders that are in here, and I could cd into one of those. I'll do the same thing over here just so we're sort of keeping in sync. Right now, this is what I'm looking at. And here, I'm actually going to clear the console. I can type clear, that's one option. Or, I'm just going to dirty it up, I can type Command K on a Mac. I believe it's Control K on a PC, I'm not positive. Anyway, over here, right, I'm looking at my code directory. Here I'm looking at code. If I type ls, let's say I'll change directories into, how about CSS intro. cd04 CSS intro. Now I'm in my CSS intro directory. I'll do the same thing over here. Double click. Here are the contents. App CSS, index HTML, and then another folder. App CSS, index HTML, and then a folder, text properties. So let's cd into text properties as well. And now I've hit a dead end, right? If I go into here, there's nothing else that I can change directories into. I need to go back if I want to, I guess. I don't have to go back, but if I want to see something else, or I want to move into a different directory, with what we know so far, I'm stuck. But if I run cd followed by 2 dots or 2 periods, that's how I back up one directory. It's the equivalent of the back button here. You click it once, you go back once. Click it twice, you go back 2 levels. So we're navigating the hierarchy in reverse. So right now, if I look at pwd, this is my full path to where I am right now. CSS intro / text properties. Now if I do cd ... now I'm back in just CSS intro. I'm not in text properties anymore. If I type ls, I can see the contents. I am one folder back. I'm in this folder. So I'm going to do it one more time. I'm going to clear and then type cd space ... Now I'm back in my code directory, and one more time, I'm back in the home directory. So that's how we move forwards and backwards. cd into something. I'll cd into my pets directory. I take a look around with ls. I'll cd into chickens. ls again. Okay, let's say I want to, make a new file here. I don't know how to do that yet, or delete a file. We haven't talked about that either, but I do whatever I need to do in here. Maybe I'm starting up a server, and then if I want to go back, cd ... and I can get back home. Now there are other ways that we can use cd where I don't have to go back one step at a time. That's something we'll cover in the next video, but for now, cd, we use it to change directories. cd followed by a folder name takes us into that folder. We change into that directory. cd followed by ... is going to back up one level. So next up, we get to talk about the distinction between absolute paths and relative paths. I know it sounds gripping, and it is not at all, but it's important. So when I say path, we're talking about a path to a particular file or resource. So things like, when I type pwd, I see a path to my current working directory, my current location, /users/coltsteel. So if I want to cd into the, let's do the pets directory one more time, I can just say cd pets. I can't run this from every single directory. This only works if pets is in the current directory. So as an example, if I back out one level, I'm no longer in my coltsteel directory. I don't have pets in here, so if I try and cd pets, it doesn't work. So that is relative to where I am currently, and the correct path to get to pets from where I am right now would be coltsteel/pets. And I can do that. And now I'm inside of pets. So this is relative still to that directory I was inside of, which was /users. So now I'm back inside of this pets directory. And if I want to cd into coltsteel, right, I can cd ... as we've already seen. Or if I really want to, I could do this, cd/users/coltsteel. And this is an example of an absolute path. This is something I can do from any folder on my machine. It doesn't matter where I am. It's not relative to my current location. I'm saying go all the way to /users/coltsteel, and it takes me to my home directory. So this slash here, it's important. It actually means something. It's called our root directory. And I can cd to /. And I'm now in my root directory. If I type pwd, my working directory, the path is /. And if I type ls, we see a bunch of stuff in here, a lot of system stuff that we usually don't touch, but we also have some other stuff, library, users. That's where we work inside of for the most part. So this is our root directory. Everything that we care about and everything that we want to work with is somewhere nested inside of this / directory. So I can quickly get here by typing cd / from anywhere. I also can quickly get to my home directory by doing cd tilde. And that takes me to users / cold steel. All right. So again, the distinction between a relative and an absolute path is an absolute path is going to start with / from your root directory. It's like the complete directions to get to this one location, and I could run it from anywhere. So just as one more example, if I go into my code directory and I nest in further, let's go into, I don't know, HTML forms and tables. Okay, so I'm going to clear this. This is where I am currently. If I want to get to the pets directory, I cannot do pets, right? But I could do cd / users / cold steel / pets. And that takes me right there. If I wanted to get back to where I was, I could type this cd / users cold steel code blah 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 blah, and now right I'm back here at that exact location. This is an absolute path. No matter where I am, I can get to this location using this path, which is quite long. Or I can do something relative to where I am right now. So if I want to get to the pets directory, technically I just need to back out to get into cold steel and then / pets. So I could do this, cd, back out, and then I can actually back out again. So back out one level, that takes me to code, back out 2 levels into cold steel / pets. And that works as well. So that is a relative path. It's only going to work relative to where I am currently. So this is not going to work from any directory on my machine. I can't just get to pets using this. This is saying specifically go out or go up one level, go up another level, go down into pets. This, or this example here, works anywhere because it starts at the top level of my machine, the root directory. So any path that begins with a / is absolute. Okay, so don't get too bogged down in all of this, but just remember / is a shortcut. It signifies our root directory. And tilde is another one of those shortcuts. It signifies the home directory, which is usually where we work from here downwards, somewhere nested inside of our home directory. You can, do stuff up top if you want. Keep backing out into your home or into your root directory, but usually we don't touch this all that much, and we work inside of that home directory or documents, or I've made a code directory. It's up to you how you want to structure things. But those are 2 important directory names, home and roots, and then we talked about absolute versus relative paths. So at this point, we can navigate, we can move around, and it might be slow. It's almost certainly slow. Try and use autocomplete, right, so that you can tab and hopefully quickly move around eventually, but just keep practicing. But still, we're only navigating and viewing files. Next up, we'll talk about how we can make files, how we can make folders, how we can remove things. All of that is coming up. All right, so next up, let's talk about how we make new folders, new directories from the command line. The command we need is mkdir. It's short for make directory. And we just need to provide the name of a directory or directories that we want to create. And they'll be made for us as new empty folders. So why don't I do this in, just make it somewhere we can see it, in my pets folder. I'm going to make a new folder in here. So I need to navigate there, cd to pets, and mkdir. I'll make this a bit larger. What folder should I make? Okay, how about goats? If I type ls, that made me a folder called goats. Over here we can see it, it's totally empty. I could cd into goats, cd goats, and make more than one folder. I could do make directory and then some folder and then another make directory, or I can actually just separate different folder names with a space and it will make them all at once. So what kind of subdirectories would I want in goats? How about I make a dwarf goats directory and then standard goats. Okay, so that makes me 2 directories at once. You can see them both there. And that's kind of all there is to make directory. If I look at goats, we have 2 empty directories. Now, if I try and make a directory that already exists, like where I am right now, make directory dwarf goats, it's going to tell me that already exists. You can't do that. So that's kind of it. mkdir and then the name of one directory we want to create, or more than one. As many as you want, you can make them in one go. So that can be very quick if you have a lot of folders you want to make in the same location. Now I can use this, with a different path. So I could do something like make directory ... and then how about frogs? My sister had a frog as a kid, and this is going to make a frogs directory, not in my current location, but one folder up. So now if I look, no frogs. But here, we do have frogs. So I just wanted to show that you can make directories in different locations. I could even do something like this. I'll clear this. Make directory frogs / tree frogs. And then I could also make another directory in here in the pets folder called, how about rodents? Well, I guess are hamsters rodents? Okay, what's another? How about sugar gliders? My friend had one of those as a kid. All right, so this is going to make me a tree frogs folder within the frogs folder that already exists, and a sugar gliders folder in this folder, which is pets. So 2 different paths, 2 new folders. One is in here, as we can see, sugar gliders. The other was added into frogs. Okay, and that's all there is for make directory. Next up, we're going to talk about a command called man, which doesn't really do anything to impact our file system. It doesn't make a file or folder. It doesn't change directories or anything like that. It's really just there to give us information. It's like a help command. MAN, it's short for manual. And then after that, we type the name of some command like ls. So this is not going to run ls. It's going to run man, which changes what I see. It's going to give me information about ls. Here's what it does. Well, what it's called, ls, list directory contents. Here's a description. It displays the name of every file and folder and blah, blah, blah. And if we don't provide any folder to look inside of, it looks inside of the current directory. We've already seen how that works. Now, the reason I'm showing this to you now is because I'm actually trying to introduce another concept at the same time, something called flags. So if you see this list down here, all these dash things like -1, -A, -B, -D, these are all different flags that we can pass in to ls. They're kind of like, almost like arguments in a function. Kind of, it's not exactly the same. There are options that we can enable or sort of different parameters for how we want ls to work. For example, we can sort things in reverse order with -R. We can sort files by size with -S. We can display more information about each file if we use -L. Can I find that one? Here we are. List in long format. So this will show us more information. There's a lot of them. I don't know the majority of these, but they exist, and we can read about them by using man, which is how we got here. Now, to get out of here, you'll see that just typing characters, like I'm hitting enter right now and the down arrow, it's just taking me further down in this description, in this man page, but I'm not getting out of here. I can type Q and it will go away entirely. It's like we just visited a different world. Everything is gone that I was just looking at, right? It's not here in my history. So type Q to get out of there. Now let's actually try some of these flags. So we saw ls on its own, as we know, lists files. I don't really have much to look at there. So why don't I go into my code directory. This is where I'm just keeping all of the code for this course. And let's look at, I don't know, how about, async.js. And then let's look at promises. Okay, so we have a couple of files there. Not a lot, just 2 files. And if I type ls, we see both of them. I'm just going to clear this. But if I type ls and then a flag like -L, which is long, they don't always stand for something, but in this case, I believe L is for long format, we see a lot more information. We don't really have time to go into what all this is, but we have, what is this, creation time? Or it might be, I think it's actually last updated time. We have the file name. We have the owner, the creator. I don't remember what this stands for, or what this one is. Then we have permissions around reading and writing. And Honestly, the point of this is not to show you -L because you need to use it. I'm showing it to you just as an example of flags. We will see some other commands where we need flags, or we may want to include flags when we get to deleting files and folders. But for now, I'll show you one more. I'm going to go into my root directory. If I can type that, actually, we'll do cd/. That takes me to the root. And I mentioned this very early on. On our machine, there are files that are hidden files. We can't see them over in Finder, for example, but that doesn't mean they're not there. They all start with a period, and I can actually see them if I use ls-a, which I actually don't know what the A is for. I always just assumed all, but I don't think that's what it is. If you want to learn more, of course, we can do man ls. We look at A, and it says list all entries. Okay. And lowercase a, include directory entries whose names begin with a dot, so hidden files. Okay, so you'll see that we get a whole bunch of new files here that we didn't see earlier because they start with a dot. So here's regular ls, here's ls-a. And then I can combine multiple flags like ls-l and a at the same time. If you remember, a gives me I don't know why I said if you remember, that's what I just showed you. A gives me hidden files. L gives me more information. ls-la does both at the same time. More information, so we get this long format, and we see the hidden files included. So again, it's not that important that you remember the exact flags. I just want you to know that flags are a thing. Other commands have flags as well, like make directory. I don't really know any of them off the top of my head, but we can do man make dir. Learn more about it. We have different modes, so not very many, but verbose. So this is going to list them as directories are created. We could try that. Let's see what happens there. Let's go to the home directory, maybe into pets, and then let's try making some directories with -v. So make directory -v. What are different pets we could have? Cows, horses, and rats. Okay, so that's verbose mode. It shows us create a directory cows, create a directory horses. I don't know why you would really want that. Maybe there's a reason, but normally make directory does not do that. It doesn't show us what it's creating. So make directory, mice, it just makes it for me silently. It doesn't tell me like it did here. So that -v flag, just another example. All right, so the takeaway here is that flags are a thing. They are different characters you can pass in that alter the behavior. They modify the behavior of the command. We use a dash in front of them. We can combine multiple flags. You only need one dash, right? So we saw ls-la. And then there was man pages, which is manual. We can learn more about particular commands, man, and then a command name. Okay? So next up, we're going to learn something called touch. Next up, let's talk about how we can create files from the command line. So unfortunately, the command we use has a bit of an odd name that doesn't sound like it makes a file. It's called touch, Touch, and it does make files for us. So touch and then a space and then a file name with an extension like txt or pdf or png will make a file with that name and extension for us. So we use this all the time. I'm in a folder, in this case, dogs. If I wanted to make a new, I don't know, a HTML file. Sure. My friends have a dog named Bubs, so I could do touch bubs.html. That's going to make me a new file. If I type ls, there it is, bubs.html. It's completely empty. If I hopped over here into Finder, I can see it. There it is. So I could open it in VS Code and work on it. I can make multiple files at once. So, I could do something like new project. I'll make a new project folder. I'll cd into it. And then in here, I can do a touch index.html, app.css, app.js, and then anything else I need. And it makes all three for me in one go. So that's great. Nice and easy. And that's kind of all that there is that you need to know about touch. You run it with the name of a file or multiple files separated by spaces. Include the extension. So don't just do app or index. You need to be very clear about what type of file you're making. And it will make them for you with that name and extension, and they'll be completely empty. So you can even use this to make an empty image if you wanted to. It's very weird to do that, but you could make an image file like a JPEG or a PNG. But usually we'll be making JavaScript files, HTML, SQL files, CSS, that sort of thing. Now let's talk about why it's called touch. Why on earth is it touch? Well, let's use our handy dandy man pages. And this is my favorite part of any terminal course. Let's run man touch, the most inappropriate sounding command out there. Also sounds like some sort of album title.
The new album, Man Touch.
So here we are. We're looking at the man pages for touch, and it doesn't really mention making files, does it? It says change file access and modification times. So touch actually has a different, I guess, primary purpose, although most people who use it do use it to make files. The official primary goal is to change the modification and access times of files. And then as a secondary thing, it says if any file does not exist, it's created with default permissions. So that's what we've been doing so far. We have been calling touch with files that don't exist, so it's making them for us. But if I call touch on a file or with a file name that actually already is there, it touches it. And what that means is it's going to change the access time, the modification times of the file. So this is not really something that we need to do often at all, but I always get this question, why is it called touch? So remember this, ls-a, or let's do L from the previous video. We can see the modification time. I actually can't remember if this is access or modification. It's one of them. I made all three at the same time, these three files. So let's focus on app.css, 1526, all right? Now, if I touch that file, it's not gonna make a new app.css. It doesn't erase what was there. It simply updates that time. It touches it, a little gentle caress, a little boop. And now if I run ls-l, it has a different access time or modification time, 1529. So that is, I guess, where the name of for touch comes from. It's a way of touching your file to simply update when it was last modified. But if you call touch and you pass in some file name that does not yet exist, it will make it for you. And that's how we almost always use it. So that's how we make files from the command line. And keep an eye out for my new fragrance. It will be in stores soon. It's called Man Touch by Cold Steel. Man Touch. So at this point, we've covered a whole bunch of commands. Well, not a whole bunch, a handful, where we can view files with ls, files and directories. We can see our current directory using pwd. I can change directories with cd, and I can create folders with makedir, and I can create files with touch. Now we're going to talk about undoing that. How do we delete files and delete folders? So there is a command called rm for remove that we can use to remove a file or multiple files. You definitely want to be careful with this because if you do rm a file, it does not go to your trash can or whatever, recycling bin or whatever it is on your operating system. There's no temporary like sort of holding pen where you then go and delete. It's just gone. So if you remember when I said that the terminal gives you greater access, and also you need to be more responsible when using that access and using that power. So if I want to remove something, let's see, I'll go into this new project directory, and I'll remove app.css, rm app.css, and it's gone, like completely gone. If there's stuff in it, if there's 1,000 lines of code, it's gone. So that's important to keep in mind if you are using rm. I can remove multiple files at once, like rm app.js space index.html. Both are gone, and I have an empty directory called new project. So I'll clear this. And now let's talk about removing folders. So I do have a folder here called new project. And if I try an rm new project, it gives me sort of an error. It says new project is a directory. rm is trying to, or it assumes you're deleting files. So there is a command called rmdir to remove a directory. And I can call that on new project, and that will work. But rmdir only works on empty folders. So the folder I'm in right now, dogs, if I cd back one level and I try rmdir on dogs, it will tell me directory is not empty. So this is where flags come in. And this is really why I introduced flags, because the rm command accepts flags, just like most commands. And the two that we're going to use are R and F. So rm-rf. This will enable us to delete a directory, even if it has stuff in it. And even if it has further directories and nested directories on and on and on, we can delete it all at once. So R here stands for recursive, and F stands for force. Recursive in this context means it's going to remove everything in nested folders and continue in more nested folders if necessary, and it will just keep removing, not just one level deep. And then force is going to tell it to just remove everything without stopping to ask us if we want to remove it. So we can actually do man rm rather for remove. Here's F, attempt to remove the files without prompting for confirmation. Okay, so that's the F. Otherwise, we have to potentially prompt for every single, or we have to confirm every single deletion. And then R is here, attempt to remove the file hierarchy rooted in each file argument. And it looks like lowercase r and uppercase r are equivalent here. I always just use lowercase. Okay, so I tried to remove the dogs directory, which I can't do with rmdir. But if I do rm-rf, and remember, if I leave that off, it won't work because rm is not going to work on directories, regular rm. But if I do -rf, dogs, goodbye dogs, it's gone. That's it. It's not in my garbage can or recycling bin. It's just totally gone. So you definitely want to be careful with that one, but it's good to know about. And at this point, we've really covered all of the basics that you need to know. Again, it will take time and practice to get fast using the terminal, and you'll see why we need this in the next couple of sections. If we're going to use Node, for example, we need to be able to navigate to a file and run it using the Node command from my terminal. So I need to be able to cd into the right directory. I need to run Node on a file. So I can't do that from my file picker from Finder on a Mac. So in this video, we saw rm, which removes a file or multiple files, totally gone, permanently gone, unless you have them backed up or you're using something like Git. And then we have rmdir, which removes empty directories only. And then rm-rf, which stands for recursive force, 2 flags that we use to remove directories and whatever they contain. Alrighty, so that's about it for the commands that we need to know. There are many, many more commands that we're not going to go into, in depth at least, but over the next few units or sections or whatever we're calling them, I'll throw in new commands as needed. There may be times where it'll be useful to learn a new command, but these are the bread and butter commands. I do have a YouTube video if you want to learn more about some of the other commands I do think are important. We could have a whole course on commands, Unix commands. There's probably 20 very useful ones. They're just not as commonly used as the core 5 or 7 or whatever I showed you in this section. So don't feel like you are, supposed to be a master of the terminal. That's not at all the case. I've only given you a tiny little preview of what you can do, but this is an important start. So we'll get some more practice, and this is something we'll continue to use from pretty much here on out. Yep, you guessed it. It's me again. I'm still here. I still got a bit of a pulse left. We are now talking about Node in this section, our first section of many, where we will be working with Node.js, which, as you'll soon see if you're not familiar at this point, is basically the JavaScript we know and love, minus a lot of the stuff that we know and love, plus some other things that we don't know that we might love. That's a horrible explanation. It's just JavaScript that will run outside of the browser, and that means we miss some of the browser-specific stuff, like events and working with, the DOM. But we also get some additional features in the language that we don't have in the browser. Anyway, I'm doing too much explaining for this intro video just to set your expectations. So, what do we have in this section? Well, it's really just about orienting you with Node in general. Not even with an eye towards web development, just overview of Node. So the most important thing to start with is going to be installation. It's not horrible. It's actually pretty easy. You can just download a file and installer and double click it, and it's kind of done for you. So it's not too bad, but obviously important. And like anything, if you do have trouble installing, make sure that you reach out for help from a TA, or just use one of the online Node environments that don't require you to install anything. Alrighty, other crucial things, the Node REPL. It's kind of like the JavaScript console in our browser, but for Node. Running Node files, very important. Being able to run code in a JavaScript file using Node. Okay, then we get to process, which I'll say is important, but not crucial for this section. Process is basically a special thing that exists in Node. It's a special object that you have available to you in every Node file. Kind of, you can think of it as like, how we have document or how we have window available in every JavaScript file in the browser. Again, I shouldn't do much explaining here. I'm going to say it's important, not crucial, at least not for now. It will come up later. argv, not that important. I'm going to put that in nice to have. And the file system module, the last video in this section, demonstrates that using Node, we can create files, save files, update files, delete files, write to files using JavaScript. Which has nothing to do with web dev and is just a demonstration that you can do things with Node that we can't do in the browser. So I'm going to say nice to have. If I had a fourth category, I'd put it there. Don't let it stress you out. Don't let it trip you up in any way. Watch it, please. It's, I think, worth your time, but it's not worth your time if you're going to be panicking and trying to study after the fact to make sure you can recreate that code. So it's there, but not at all crucial. These are the crucial things. Okay, let's go. Hey everyone, big moment here. This is actually deserving of a drum roll. Okay, just wait for it to finish. Come on, and there we go. Node.js. It's time to talk about Node. It's been a long time coming. This is the official introduction to Node in this video. So we're going to spend some time just setting the stage, talking about what Node is, what it isn't, why we're learning it, and then we'll actually learn some stuff. So here we go, Node.js, a topic that a lot of students look forward to or have some misconceptions about. It's not scary. It's really just JavaScript, as you'll see. Trying out some new slides here. Not sure if I like those animations. So let's begin with the obvious question. What exactly is Node? Well, technically, it's a JavaScript runtime. Now, if we go back to some early part of this course when we introduced the idea of JavaScript and how there is not really one official, JavaScript that we download. We don't install JavaScript, and that actually there's a specification, this ECMAScript specification, that browsers then go implement. So it's the job of a browser to follow the rules and implement the language. So for a long time, that was the only place we would run JavaScript and write and execute it would be in a browser, whether it's Firefox or Chrome or Safari or Internet Explorer. Hopefully not, but maybe. They're all browsers. That's where we were running our code. So that was great for web applications, right, and doing browsery stuff. But there's so much more that we could do with other languages like Python or Ruby, where we could write, create web servers. We can interact with file systems. We can make command line tools. You can make video games. These are things that we couldn't really do with JavaScript until the advent of Node.js. So Node is an implementation of JavaScript that runs outside of the browser. So we can run JavaScript code without ever opening a browser, without even having a browser on our machine. Now, that doesn't mean that we can do exactly the same stuff, right? If we don't have a browser, we're not going to be able to manipulate the DOM or deal with, user inputs and events and all of that. But aside from those differences, and we'll go into them, it's just JavaScript that runs outside of the browser. So we can use the same syntax that you already know to write code that runs on the server side. And there are a lot of applications for this. So there's a lot of reasons to do this. So just a bit of history here. I actually always assumed that Node was the first implementation of JavaScript that ran outside of the browser. That's not the case. Apparently 13 years before the introduction of Node, there was something called Netscape's Livewire Pro Web, and this was a server-side implementation of JavaScript. I just had never heard of it. So in 2009, this guy Ryan Dahl created Node.js. And it really took off a couple of years later. I'd say 2011 or 12 is where it really started to get a lot of attention. And these days it's incredibly popular. Here are a couple of charts just from Google Images. You can see around 2011 or so is when Node, it's this purple line, really started to go crazy. But it had been out since 2009. Here's a couple other examples. This one's from 2017. You can see the growth of Node being very steady. It's the red line here, as other languages and tools have come and gone. Here's another example. This is showing something slightly different. This is the number of modules. These are sort of like add-ons, packages, tools people have developed. And you can see that Node, which is the red line here, is growing very, very quickly. And not only is it growing quickly and faster than the others, it also just has far more packages available. So that means there's a very strong community around Node as well. And then here's just another sort of data point, or a couple of data points from the Stack Overflow Developer Survey from last year, 2019. We can see that most popular technologies has JavaScript up top. Probably no surprise there. And Node is considered JavaScript, right? It's the exact same language for writing JavaScript, but this is kind of misleading because it doesn't actually tell us, how much Node is used versus just client-side JavaScript in the browser, which is pretty ubiquitous. But further down, if we look at things like other frameworks, libraries, and tools, whatever that is, Node is right up top. 50% of respondents saying Node.js is the most commonly used. Anyway, it's popular, it's continuing to grow in popularity, and it is the same JavaScript syntax that you know and maybe love, or you may not love it, but you still know it at this point in the course, assuming you didn't just skip to this section. So we could have used other languages. We could have used Python. We could have used Ruby. What's great about Node, other than the fact that it's just very popular and has a great community, is that you don't have to learn a whole separate language. Not that that's a bad thing, and in fact, I encourage you to learn other languages, but for our sake, in having a smooth experience of just learning as much as possible about web development, it's just easiest for us to focus on a language that we already know. And it's a great benefit and a great bonus that it's already very, very popular and trendy, and everybody wants to know it, and there's lots of jobs. So there's a whole bunch of reasons to learn Node and the different tools that are associated with Node that we'll be focusing on. So hopefully you're excited about it. This is kind of a whole new world of development for us. There's a lot that we just haven't been able to do with client-side JavaScript in the browser that we now are going to be able to do. So in the next video, I'm going to quickly talk about what people actually use Node for. And then we'll install it and get set up, and we'll start using it. Okay, so we've established that Node is just JavaScript that runs outside of the browser. We just run it on our machine, and because it's not in the browser, we can do a lot of other stuff that we normally couldn't do. So in this video, I want to talk about what some of those uses are. So the predominant one that we care about is this first bullet point, creating web servers and writing server-side logic for a full-stack application. So right now, without Node, we can write code in the browser that can request a server, right? We can request an API with Ajax and get some information back and do something in the browser. But what if I wanted to make my own API? What if I wanted to work with a database and connect that database to my web server and, build a full application? Right now, with just what we know, JavaScript in the browser, we can't do any of that. So that's one of the most popular use cases for Node. There's a framework, a tool that's very popular called Express. We'll be learning this. Just to give you an idea, though, Node is used by Netflix. I don't know exactly where they use it these days, but there's a lot of articles about the topic. Uber uses it as well, among other technologies. And here's an interesting one. NASA uses Node to help keep astronauts safe on spacewalks. So apparently there was an issue on this spacewalk in 2013. Water was leaking into this astronaut's helmets, and that's a big problem when you're in a spacesuit and you can't just wipe your eyes and all that. Ooh, wow, had trouble breathing. Anyway, so what happened after all of that is that NASA decided to build a more reliable, centralized source of their data about these EVAs and their spacesuits. I think EVA is extravehicular activity. So they built this one database using Node, set up this one microservice that contains all the information from 3 separate legacy sources into a single service. Anyway, kind of an interesting case study there. So that's probably the most common use case for Node. But it's also used to make command line tools. We'll be seeing at least one of those command line tools pretty shortly. So when I say command line tool, I mean actually applications that run in our command line where we don't have a traditional user interface. Things like NPM that we'll be learning shortly. And then native apps, that's one that's exciting for a lot of people. We can build applications that run on our machine, including VS Code, which we know and love at this point. It's written in JavaScript using Node. So actually the real VS Code, the one that we use all the time, in this course at least, is a Node application. It's written in JavaScript, but we don't run it in the browser, right? We're running it just as a native application. In fact, other apps like Slack are written in exactly the same way. Slack, a super popular app, is written in JavaScript, and it runs both in the browser as a web app and as a native app. And the way that those two companies build their apps is using something called Electron. We're not going to go into it, but it is a pretty interesting topic. It allows you to write JavaScript code to make a single app that runs both in browsers and as native apps. So that means with a single code base, you can have code that will work on Macs, on Windows machines, it will work in the browser, and lots of companies use it, as you can see here, Twitch, WhatsApp, VS Code. Anyway, it's pretty cool that we can write JavaScript to make native applications. That's something we could never do before. Everything had to be in the browser. And then something else that's kind of interesting is games. Video games can be built with Node. Now, it's not that common because there are lots of game development frameworks, things like Unity, and those tend to attract a lot more game developers. But just as an interesting example, there's this game called Crosscode that a couple of years ago really hit it off and was a pretty huge success. It started, I think, as a browser-based game. You can actually see and play the demo in your browser. It is written in JavaScript, but it's also a native app you can install with Steam. And it's since been ported to Switch and PlayStation and Xbox. And this game has sold hundreds of thousands of copies. And I don't know how big the team was that made it. I'm sure we can find that out. But yeah, the team did very well, let's put it that way, from building a game with Node.js and with JavaScript. So maybe Node is not the top choice for building games, but this is a pretty cool success story. All right, so there's a lot of stuff we can do with Node. I didn't mention, you can write software for drones. You can control all sorts of things with Node. We're not limited to the browser anymore, so we can do a lot of really interesting things. But for our purposes, we care about that first bullet point, creating web servers with Node. So that's what we're going to focus on. All right, it's time to install Node. So this is a pretty easy install, hopefully. You should always check to see if you have it first. So if you go to your terminal, open it up and type Node and hit enter. If you get command not found or some other error kind of similar to that, then you probably don't have Node installed and we're good to go. So we're going to install it now. And I actually don't have it on this machine. Usually I just sort of fake it when I make these videos, but I actually don't have any of the tools we need. So you're going to watch me install it. Well, you probably won't see the whole thing. I'll fast forward. But if you just go to the Node.js homepage, and then select the download that makes sense for your machine. I think it just chooses it for you. I'm on a Mac, 64-bit architecture, so it suggests these two. And we're going to go with the stable build. We don't care about the latest features really at all for now. So we're going to go with 12.18.3. If you are on a different version, which by the time this course comes out, you almost certainly will see a different version, there's not going to be any significant differences that impact what you're learning here. Okay, so I'm going to download that. And then I'm going to open it up. Here it is. Continue, agree. Select where I want it to install. Install. Okay. Little fingerprint there. And, what do we talk about here? Oh, there we go. Finished. Okay. So I'm just going to move that to the trash. And now I should be able to, I might need to make a new window. Oh, nope, I don't. I type Node and I see welcome to Node.js. All right, so if you see something like that after installation, you may need to quit your terminal or open a new terminal window. But if you see this eventually, you're good to go. We have Node installed. So now what do we do? Let's talk about that in the next video. All right, so in the last video, we installed Node and then I just disappeared. We didn't do anything, which I feel bad about because I didn't tell you how to get out of here. If you try and type anything in here, we're now in a different world where our terminal commands don't actually mean anything. Like ls it's not going to do anything for me. To get out of here, you can press Control-C twice. So I pressed it once and it tells me press it again, or Control-D, or you can type .exit. All right, so now we're out of it. So what was that we were just in? That is something called the Node REPL. Now, if you remember very early on, I talked about this term REPL, REPL, read, evaluate, print, loop. The JavaScript console in our browser is a REPL. I can type some code in, it will read it, evaluate it, and then print something back to me, and then it loops. It continues going. Unlike how we typically execute a script, where it just runs one time, right? We include a script in an HTML file, we open that in the browser, it executes it, and it's done. REPL is continuing to just listen and wait for us to type something in so that it can evaluate it back. So we typically use a REPL. If I just type node again and hit enter, we typically use this to debug or to play around with new features or new tools that we've installed. But we can type JavaScript in here. We are now in a world of JavaScript. Think of this as the node equivalent of the JavaScript console in Chrome. It's the same concept. Now we do have some other features. For example, it's telling me type .help for more information. And now it gives me some commands that I can do. For example, .exit. We've got .save, where I can save whatever I've done in here to a file. .break, .clear. Okay, so there's these different commands that we don't have access to in the JavaScript console. But let's just try some basic stuff. This is good old JavaScript. 1 + 2, we get 3, right? How about hello plus world? Just what we expect, right? We still have strings. We've got numbers. This is JavaScript. Now, it's not exactly the same. We don't have certain things that we do have in the browser. For example, we don't have any of the DOM APIs. We don't have the window. We don't have the document. Those are all browser-specific concepts. So if I try typing document, nope. Document.getElementById, document.anything, it's not there. Window, the window does not exist either. Now, if you remember in the browser, the window is the global object. It's like the top level of everything. It represents a browser window, hence the term window. And it's where a whole bunch of functions and things like alert are stored, or where they live. It's a global scope. We do have a global scope here, but it's not called a window. Instead, it's actually called global. And if I type global, I can actually see it here. So this is where things like set timeout, set interval, all those functions live. But just like with JavaScript in the browser, where I could just call set timeout, right? I didn't have to do window.setTimeout. I'll actually call it here. I can do the same thing. I'll just call set timeout. I don't need global.setTimeout. But let's do a function here that just console.log. So we do have console.log, even though our console is different. Console.log, hello. And we'll do that after, how long? Maybe 3 seconds. And there we go. Hello prints out after 3 seconds. Okay, so just a quick example. I did not have to do global.setTimeout, even though that's technically where it lives, right? I can do global here if I type global.setTimeout. I do have autocomplete, by the way. Hit tab. Right, so I didn't need that. Anyway, global is the global object. It's what everything lives inside of. It's the top level bubble that we live inside of when we're using Node. So those are some important distinctions. The syntax is pretty much all exactly the same, but we don't have any browsery stuff. But we do have a bunch of other stuff that doesn't exist in browsers. There are built-in modules that help us do things like interact with files and folders in the operating system. Those are things we can't do in the browser. We're not going to go into them in this video, but just know that there are things that we do get in Node that we don't get in the browser. So that's the REPL. It's just a place we can open up at any point. We can close with .exit, open it with just Node, type your JavaScript code in here, just like you would in the Chrome console. So just like we don't use the Chrome console to type full applications, we use it to play around or try new things out, or in educational contexts. Same idea here with the Node REPL. All right, so .exit or Control-D. Whoops, I didn't hit it. There we go. Or Control-C 2 times in a row. 3 different ways to quit. Okay, so using the Node REPL can be useful, but it is definitely not the way we'll be writing code and executing code, just like we don't use the Chrome console to type our applications and to write long scripts. What we do instead is write our code in a JavaScript file. So let's do that here. Let's make a new JavaScript file. If I can type, microphone's blocking my keyboard. What should we call it? Let's do, I don't know, how about just first script.js. All right, then I'm going to open it up over in VS Code and put some JavaScript code in this file. So something simple. We can use a console.log as we saw previously. Hello from first script. Maybe let's use a loop for let's I equals 0, I less than 10, I plus plus, or something like that. We'll repeat this. All right, so some very basic JavaScript in a file, a .js file. Now, how do we run it? Well, normally in the browser at least, I shouldn't say normally, but with what we've done so far, we would create an index or some sort of HTML file, include a script referencing this file, a script tag referencing this JavaScript file, and then open up the HTML file in the browser. But we don't need to do any of that. I can simply run, I'll make this larger, node, and then instead of hitting enter, type a space, and then the name of a JavaScript file, firstscript.js, and there we go. I just executed it, and it ran as JavaScript, it ran as Node. That's exactly what I'm saying to do here. I'm saying take this file and execute it as Node code. So if we have errors in there, which of course we could, how about something like console.ldog? I'll run this again, and now we get an error, and it says console.ldog is not a function, and it points out where the problem is. Okay, so that's a very basic idea of running a script. You make a file, .js, just like before. We put some code inside of it, and then we execute it with Node and the file name. So let me fix that, and then firstscript.js. So of course you need to be in the correct directory, or you just need to reference the correct path to it. So I could do something like, let me just clear this, Node, and then I think I put it in a folder called 25 Node intro, and then / firstscript.js. That's fine too. You just need to make sure you reference the file correctly. So you can't just type the file name anywhere. It needs to be in the folder you're in, or you need to reference the full path relative to where you are at the moment, and we execute it with Node. All right, Node on its own opens the REPL, and Node with a file name executes the script using Node. So keep in mind that we are really approaching Node from a web development perspective. And even then, it's a pretty limited web development perspective. We could spend 30 or 40 hours at least just talking about web development with Node. Then there's a whole other universe of things we can do with Node that could be another 30, 40, 50-hour course on top of that. So I bring this up because I want to be clear that we are not going to learn much about Node on its own. Just Node without things like Express, which we're going to learn shortly. So Node itself comes with quite a few different pieces. Now, if we go into the documentation, which to get here, go to the Node homepage, go to Docs, and then we need to select the version that we're on, and I'm using 12 point something, and if you ever are unsure, there's a couple ways of finding this. Whoops. You can do Node and just look at what version shows up there, or I believe you can do Node-V. There we go, 12.18.3. One thing I didn't go into just for time's sake and keeping things simple is managing Node versions. In the real world, you may want to have multiple versions of Node on one machine. You can use something called NVM, Node Version Manager, but again, we're not getting into that. Okay, so we want 12.x. I think I just clicked 11. Here we are. And as you can see, there are quite a few different topics and different things to learn about with Node. If we just take a look at one of them, the one we're going to start with here is something called process. Process is an object that's available. It's in the global scope anytime we're using Node, and it includes information, according to the docs, about and methods that provide control over the current Node.js process. So this includes things like the version of Node. It has methods that allow you to get input and write to the standard output, basically write to your console. What else is in here? Stuff about memory usage, information about the current working directory that a user is running the script in. There's a whole bunch more. If we actually just head over to Node and I type process, it's always available. It's this big old object. So it has a bunch of methods, a bunch of properties. I mean, just as an example, I'll do process.version. Process.release is in here. This is the specific Node release that I'm using. But then there are methods, things like Node, what am I doing? Node process.current working directory CWD. This is the path to where I am currently working, or where I'm currently running Node. And this can be useful. We'll actually see an example. If I wanted to make a file relative to this path or make a folder or something like that. There's a whole bunch of other things, in here. And the one I want to focus on right now is something called process.argv. And this is not going to be terribly useful when we run this from the Node REPL. But if I make a script, so I'm going to get out of here, .exit or Control-D. I'm going to make a new script. So I'm in the same directory. We'll call this touch args.js. Well, we won't call it touch args, but we'll touch args.js. And then in this file, I'm just going to do something very simple to start, console.log hello from args file. All right, and I'm going to execute this with node args.js. Okay, then I'm going to print inside of the same file process.argv. All right, that's what we saw up here. Where was that? Right there. And it was an array that contained a string. We'll talk about what that is. But now if I run it again, this time, what do we see? Well, we see that same string at the beginning and a second value in this array, the path to the file, args.js. All right, so what is this? Let's go to the docs here, process.argv. It returns an array containing the command line arguments passed when the node process was launched. The first element will be process.exec path. That's where the node executable is, I believe. Yes. Then the second value is always going to be the file that we're executing. Now, any remaining elements will be additional command line arguments. So I can pass in arguments to a script, not to a function. But it's a similar idea. I can pass in arguments to a script. Just like I would write, it just as an example here, ls-a or make directory, and then I pass in some argument to make directory. That's not node specific. That has nothing to do with node. But I can make my own node scripts, like I have here, args.js, and then pass arguments like puppies and chickens and I don't know, hello. Separate them by spaces. And they're all added to this argv array. So the first two things are always going to be, well, they're not guaranteed to be the same, but they're always going to be the executable path and then the path to the file that you're actually running. So we can ignore those most of the time. But if we look after those first two elements, we have arguments that have been passed in. So I could make a really simple script. This is going to be very stupid. We'll call this greeter, okay? And greeter, let me just touch that here, is just going to take any number of arguments that we pass in. So it would be, node greeter.js and then Colt and Rusty. And we're just going to say hi to each argument that you pass in. So I'm going to open up that file. And then in here, we're going to look at process.argv, but we don't care about those first two elements. So what I'm going to do is slice after or at the index of 2 onwards. We don't want index of 0 or 1. So I'm going to call this args, and then I'll just loop over args. So for let arg of args, we'll just greet each one. We'll console.log, and let's do hi there, comma, and I'll do a string template literal, and then we'll put that arg right there. So let's see if that works. Greeter.js, Colt, Rusty. Hi there, Colt. Hi there, Rusty. All right, so I could pass in as many people as I want. Tammy and Chicken Face. Hi there, Colt. Hi there, Rusty. Hi there, Tammy. Hi there, Chicken Face. So this is all silly, of course, and we're not really going to be doing much with argv at all. I'm just showing it to you as a taste of Node because remember, people use Node to create very complicated command line scripts and tools for the command line that have nothing to do with servers and web development. And this is just one of the tiny pieces that you can use to get arguments from the command line. So the first two things we always ignore. Well, I shouldn't say always, but if we're looking to see custom arguments that have been passed in, we ignore those first two elements in argv. All right, so just a quick intro to this process object. It's always available in Node. It's in the global scope, and it contains a whole lot of stuff, most of which we're never going to touch. Next up, I am going to show you one other piece of Node that has nothing to do with web development and servers, just as an end cap to all of this section, but it's just a little taste. So that's coming up. So I mentioned that Node comes with a decent amount of built-in methods, different properties. So there are things, if we look at the docs, that have to do with cryptography, for example. We're not going to go into this, but there are methods that exist here to help you create or to encrypt data and decrypt data. We have things like HTTP. These are methods that are built in that help us make HTTP requests, as you can see here. Here's an example. So this is built into Node. And again, these don't exist in the browser. Now, the one that I want to show you in this video, just as a little taste, is called FS. It's the file system. And it's something called a module. We'll be learning more about that in the next unit, next section, whatever we call them. And this module has to do with the file system. So there's tons of methods on here to read files, to create files, to add to files, to create new files. I already said that, didn't I? To create new directories, to open and close files. There's just a lot of stuff in here. Change permissions. So we're not going to cover more than like 2 or 3 of these methods. So I'm thinking we're going to make a little Node script that when we run it, it's going to create our standard HTML, CSS, and JavaScript files in a new folder. So for example, I would run it like this, Node, and then what will the file name be? Maybe, I don't know, boilerplate.js, and then the name of a folder we want it to make for us, like app or project. And then when we run that, I want it to make a project folder for us. And then inside, I want it to make an index.html, a CSS, and a JavaScript file, just blank files for me. That's something we do pretty commonly, right? We make a new folder and we put our basic 3 files in there, whatever we name them. But I'll go with this. So if I wanted to make a little script to help me do that, it's still not going to be all that helpful, but just as a demo, I need to be able to make a folder. I need to be able to make files and put them inside that folder. So I'm going to create a file. Here I'll call it boilerplate.js, and then I'll open that up over here. And there are quite a few different methods that we can use, but let's start by making a new folder. So the method I'm looking for is makedir, but you'll notice actually that there's another method called makedir_sync, or we have opendir, opendir_sync. We have things like readdir_sync. So I don't know why I'm saying dir. It's directory, so it should be readdir, makedir, but I always just say dir. I don't know why. Anyway, what is this sync thing? Well, if we read a bit about it, I think they show it here. Yes, all file system operations have synchronous and asynchronous forms. The async forms always take a completion callback as its last argument. Exceptions that occur using synchronous operations are thrown immediately and must be handled with try and catch, or may be handled with try catch. So what it's saying here is that there are 2 different ways of reading files or making folders or deleting files and folders, or whatever the methods are. There's the async version and then there's a synchronous version. So remember that synchronous, if we use a synchronous version, it means do this thing and wait until it finishes before you move on to the next thing. So it's going to block, I'm pretty sure they talk about this somewhere here. Here we go. The synchronous versions will block the entire process until they complete, halting all connections. So it's going to stop any other code from running, but it is a lot easier to follow logically. We don't have to deal with callbacks. So that's what I'm going to use for now, the synchronous versions. And again, this is really just a taste. We're not trying to be experts on the file system module here. So we're going to use fs.makedir_sync. Here it is. All right, so here's the documentation. And on the docs for the synchronous versions of the methods, it tells you to look at the asynchronous version. Okay, so it explains, here's what we need to do. fs.makedir, we can just copy this if we want to try it. But we're going to run into a problem immediately. If I try running this, node boilerplate, it's going to complain, fs is not defined. Now, this is the first thing that we need to fix, which is that fs is not a thing by default. Unlike process, for example, which is always in scope if we're using Node, fs is a module that we need to actually require. And this is something we haven't seen before. We don't require files and folders and scripts and all of that on client side or when we're writing client side JavaScript. This is something we'll learn more about in the next section, but basically what we need to do, you can find examples of this if you just go to the very beginning of the docs. I hate how they organize this, just one massive page. But we need to require this module. So require fs. And then we can save that in any sort of variable if we want, any name, but usually we do fs. So require fs. So we don't need to download fs or anything. It's already here. It's just not in scope. It's not available by default. We have to go tell Node we want to use it. So now this should work. I'll zoom out here. Maybe I'll make this a bit larger here. And I don't think I want to do that. I think I'm just going to do a console.log fs and verify that it does work. Okay, so you can see we do have this fs object here with a bunch of different methods. Append file sync, access sync, chain or chmod, chown sync, all that stuff. So now let's take a look at this make dir method. And this is the asynchronous version, right? So if I put something after here, console.log, I come after make directory, and then I'll make a directory in here called, how about just dogs, okay? And then if there's an error, we throw that error. So this callback will be called upon completion. So I can do something like console.log after, or how about in the callback? Let's do that. And I'll write this as I come after make dir in the file. All right, so I'm going to execute this now. I shouldn't have console.log that, but you'll see I come after make directory in the file. So this line printed out first because this is asynchronous. And then when that make directory finished, when the directory was actually created, then this callback ran. So we should verify too that the callback, or that the directory was created, and there it is, dogs. So it's empty. I'm going to just delete it, rm dir dogs. Or I could do rm-rf. Okay, so that's the asynchronous version. Now here is the synchronous version. Can just do this, fs.makedir sync, and then I'll just do cats this time. And I don't need to pass in a callback. We also don't really need to care about this argument here with the options we can pass in. I'm just going to ignore that. So if I do make dir sync for now of cats, I'll say I come after make directory in the file. This should do the exact same thing. It should make us a new folder called cats in this case. And you can see it did do that. It made cats. We don't really have proof, right, that it was synchronous here, but just know that it is. And it's easier to follow sometimes if we're just doing a couple of things in a row. And we, like, for example, if I needed this directory to be definitely created before we add something into it, then the synchronous version is easier because I can just create the folder and then add stuff into it. And we'll be guaranteed that this code runs after this. Whereas if I just had two of these in a row, this one might finish first. They're doing the same thing, but let's say I'm making a file. This could potentially run before that, and so then it's just a nightmare. Anyway, again, don't feel too bogged down here. We're just barely scratching the surface. So let's make that directory, but let's not call it cats. Let's actually accept an argument, right, when you run the script. So that's going to be argv. So we want process.argv of, and remember we want index of 2 if we want basically the first thing that you type after, so node, boilerplate, and then, you know, project. Let's say that's the name of the folder I want you to create for me, or I want it to create for me. So project 1, that is the third argument. First one is the executable path. The second one is the path to the file. And then the third one at index of 2 in argv, as we saw previously, is the first argument passed in. Okay, so I'm going to save that to a variable, const, folder name equals that. And then we could provide a default. How about, if that's undefined, maybe just project. Okay, and then we're going to make a folder with that name. Folder name, just like that. So why don't we begin there and just see if that's working for us. So I'm going to execute this with a folder name of chickens. And it made me an empty chickens folder. If I just take a look in there, it's empty. If I try running it with nothing, it should make me a folder called projects, hopefully, or project, and there it is. Okay, so now what I want to do is to create those 3 files inside of this folder, whatever that folder was. And to do that, we have a method to make a file for us. There's quite a few options, but we're going to go with write file. Where are you? Here we go. Write file sync is really what we want. It's going to write data to a file, replacing the file if it already exists, meaning it will create the file for us if it does not exist. So for now, we're not going to bother with putting anything in the file. We'll just make 3 empty files. So we just need to provide the file name. Alrighty, so we're going to do fs.writeFileSync, and then the file name, I don't want to just do index.html. What I really want is to go inside of that directory. So we can use a string template literal, $, curly braces, and then folder name / index.html. And then I'll just repeat that. And we don't really need this to be synchronous, but that's fine. Here we'll do app.js or something, if that's the boilerplate we want, and then app.css or styles.css or whatever we want to call this. So our 3 basic files, and they go inside of whatever that folder was that we just created. Now we don't have any error handling. There's potential that things go wrong, so we should add a try and a catch, but let's just see if this works anyway for now. All right, so I'm going to try, why don't I just remove these directories first, cats, chickens, project. All right, and now I'm going to run it again, node, and then boilerplate, and I want this to go with, go inside of portfolio. Okay, so let's take a look at portfolio and check it out. Our 3 files were made for us inside of that folder. So that's all I'm really going to do here. I just wanted to show you that. There is one thing to be aware of, which is that if I go out of here and I run this script from a different location, for example, I can run this boilerplate JS from out here. It's just located inside of a different directory. So if I do node and then the folder, which is 25 node intro, and then boilerplate, and then I want it to be called lizard project, and I hit enter, I'm just going to clear that. My lizard project file, or the folder, was made in this directory right here. So if I cd into lizard project, there are my files. So what I'm trying to show you is that it was made where I ran the script from, where I was actually located, not where the script itself lives. Anyway, we should add a try and a catch in here just in case something goes wrong, because there's no error callback or anything like that, like we have for the asynchronous forms, which are definitely important to know that they exist, especially if you're doing any sort of intensive stuff around files. Callbacks in general are pretty common in Node. But here, just for simplicity's sake, we're using the synchronous versions. So we'll have our try and then our catch if there's an error. And if there is an error, it'll be pretty boring. Console.log, something went wrong. And then we'll print the error as well. Okay, so I think that's pretty much it for the intro to this FS module. Remember, we have to require it in order for any of this to work. Save that in some variable name. It's up to you. You need to be able to remember it and reference it whenever you're using it. When we do this, we get an object in that variable. It has a bunch of methods, quite a few methods, as you can see here, a lot. And we just saw 2 of them. I guess technically we saw 4 because we saw the synchronous versions and the asynchronous versions to make a directory and to write files. So we could also use this to add contents to the file. So you could modify this if you wanted it to, add the boilerplate HTML content, like the standard doc type and the head and the body and all of that. And you could even have it so that it linked to the app.js as a script tag and a link tag for your CSS. But we're not doing that. But you could, if you provide another argument here, that content will be written to the file. It will create a file and add content. So there's a lot more that we could cover. But remember, our goal is to get on and to move on to web development and Express and creating servers and all of that. So this is just a taste of Node on its own, pure Node. And some people love doing this stuff. Other people, in my experience, some students don't care for it and just want to get onto web dev. So that's what we're going to do. It's a whole big world out there. And I think this video has been excruciatingly long. I'm sorry about that, especially for a video where I said multiple times it's not that important. But I feel like if I just don't even mention any of this stuff, people yell at me. So I'm mentioning it. Okay, goodbye. I'll see you soon.